Welcome back. In this video we will start our installation series, and yes, those installation videos are most of the time a little bit boring, but if you're new to Android app hacking, this might be very helpful for you, because at the beginning there are a lot of things which might be a little bit confusing. The Android Studio, the Virtual Device Manager, the SDK, those platform supports and more. So therefore I would like to include it over here. In case if you already have experience in Android app hacking, you might want to skip this right now. Maybe have a quick look at the emulator path, because at the second half there might be some new stuff, but otherwise feel free to skip this. In case if you haven't done the installation of an Android Studio before, then this video series is dedicated for you. So therefore, let's go. Okay, so here we are now back on our host system, and first of all let's insert some music, because with music it isn't that boring anymore, alright? And then let's hit up our virtualization of choice. Alright, we start by setting up our hacking system, and this one will be in basic Ubuntu VM, because all of these tools are working probably fine on this Ubuntu VM. So therefore we go into our virtualization of choice, VirtualBox, VM player, or whatever you want to use. And then we create a new virtual machine. We select Ubuntu 64-bit, then legacy UEFI, and we create a new virtual disk. Alright, we save those settings to a virtual machine and name this Android app hacking. And now we want to modify a few settings. First of all, we definitely want to increase the RAM of this virtual machine, because this is maybe the most important aspect of our VM. So we go into processor and memory, and here we increase it to at least 8000. So in my case, I'm choosing 8128. Alright. Beside the RAM, I also increase the processor cores to 4. Okay, and then let's see. At this point, you also want to increase your hard disk. I have forgotten this point, unfortunately, right now, but that's not a big deal. In the emulator part, I will show you how you can easily extend it afterwards. So that's really no problem. But if you have the choice right now, then please do it right now. So I would suggest 60 GB, because the Android Studio, those Android images and the Virtual Device Manager, they require a lot of disk space. So 20 GB will be easily full. And later on we will also install some additional tools. So therefore I recommend 60 GB. This should be absolutely fine. Alrighty? Okay, back to this one. Alright. One thing we definitely want to make sure is that our USB and Bluetooth settings support USB 3. Later on we will connect real smartphones and also additional devices regarding to our man-in-the-middle setup, and some of them require an USB 3 connection. So this is something we definitely want to make sure. Therefore we go into USB and Bluetooth, we click on Advanced USB options, and then we select USB 3.1. So this is a very important step. Okay? Alright, now we've gotten compatibility to USB 3. Right now we want to proceed with installing our operating system, so therefore we need to insert it as a virtual disk into our virtual machine. And therefore we have to download this ISO first. To do this, we simply open our web engine of choice, and then we are searching for Ubuntu ISO 2004. And here we can see we've got it over here on ubuntu.com. So that's a trustworthy site, and we will download it from here. 2004 simply means this one has been released in April in 2020. And you might think right now, isn't this a little bit outdated? Well, not at all, because we can see this LTS stands for long-term support, which means 5 years. So we can talk about this in 2025, alright? Okay, so let's click on this one. And then we hit this download button. And let's see. Yes. The download is now being started, and we can see we are downloading the 2004 desktop AMD 64, which means 64-bit version. This is exactly what we want to have. So now we need to wait until this download has been finished, and this might take a while. Let's see. Yes, 4 minutes, I mean, it's okay regarding to this internet connection, so I'm not complaining too much about this. But nevertheless, relax a little bit, get some coffee and tea, and then I will see you after the download has been finished. Alrighty? So see you in just a moment. Okay, download has been finished. Back to this one. So now we go into CD, then we select our virtual disk, and then we select the ISO which we have downloaded just right before. Over here, please make sure that Connect CD DVD drive is being enabled. Otherwise the virtual machine wouldn't have a drive and we couldn't start from this one. Afterwards, we start the system, and yes, we can immediately see that the system is now booting from the CD, so from our Ubuntu ISO, okay? We wait until the boot process has been finished, and there we have it. So now we've gotten desktop, and we can use try Ubuntu, which means we try the system out, or we can simply install it. In our case, we want to install it, so I click install Ubuntu. Then we select the language. Here we want to make sure that we have the minimal installation, because otherwise the system gets blown up with a lot of trash software. And we also want to make sure that install third-party software is being enabled. Okay, here we can see right now the graphics is being resized, so now we've gotten better resolution. Okay. We click on continue, and here we want to make sure that we select erase disk and install Ubuntu. Okay, then we click install now, and there we get a warning or an information that all those data will be deleted, but that's perfectly fine because we haven't any data on the system right now. So we click continue. We select our time zone. And now we need to define our username. So in this case, app. The system name will be hacking. The username is app, and we have to provide a password. All right. And that's all. So the system is now being installed, and this might take a while. So we have to wait until the process has been finished. So you will definitely have some time to grab some tea or coffee and turn back to this one. Okay, I will fast forward this process right now. There we go, installation complete. Now we can click restart now, and the system will reboot. After the system has been rebooted, there should be this login screen. There we have it. Now we enter our credentials, and this is our system. So we have set up our Ubuntu VM. The first time we run our system, we get a bunch of pop-ups. For example, connect online accounts. This is something we definitely want to skip. Then we've got live patches. Okay, we click next. Then we've got some stats, but we do not want to send anything out there. So we simply click no, don't. And then we click next. Privacy, no location services enabled, perfect, next, and that's it. So here we've got now the ready to go and some recommended software packages from the Ubuntu side. We will install some of them, but we will do this by the command line. So therefore we can click done. Okay, the first thing we want to do is updating our repositories. So those packages that we fetch the newest versions of them. Therefore, we open a new terminal and we are running sudo apt-get update. We insert the user credentials. Okay. And now we can install some additional software. So by updating it before, we can make sure that we are fetching the newest repositories. So for now, at least I want to have ZSH, Git, and Vim enabled. So let's install all of them. Okay. We click yes. Now we have them installed, and next I want to have a nicer terminal view. So I like the OMITE ZSH template for this one. So let's open Firefox. Okay, and let's search for OMITE ZSH. Here we have the Git repository, and if you scroll down, we can find the basic installation part with a curl command. Let's simply copy this curl command, inserting it in our terminal over here, and oh well, I haven't curl installed yet, so therefore let's do this right now. Apt-get install curl. Okay. Now we can use the upper arrow key to repeat the last command, this one. And now we can see ZSH is being installed. Over here we can see, do you want to change your default shell to ZSH? And this is something we want to have, because our default shell is the bash, and now we want to have this ZSH. All right. We insert our credentials, and here we have it. This is now ZSH with the OMITE ZSH template. Okay, let's tune some settings in this terminal. So within preferences colors, let's play around with the background. So we start maybe with a solarized dark and then make it a little bit more dark. The text terminal a little bit more bright, so a little bit white. And then we also change all these other colors. So we want to have them a little bit lighter right now. Okay. Then we enable transparent a little bit, just a little bit. There we go. Okay, this looks nice right now. Perfect. Let's also change the desktop background. And I do not know why they have disabled it, but we cannot choose in solid color anymore. Therefore, we simply make a screenshot of a black box, drag it onto our Ubuntu VM, and then select this as background. Okay, and here we have it. The last thing I want to add, and then we have the basic configuration done, is a shortcut for our terminal. So opening this on the left side with the mouse is a little bit annoying, and we will use quite a lot terminals. Therefore, we create a shortcut. Within settings, we go into keyboard and shortcuts, and here we're searching for terminal. And this one already has one, but we changed this to Control and T, at least for my preference, and choose whatever you like. But now I simply can start a new terminal by hitting Control T. we can see the ZSHRC has not been selected yet. We can run this manually with a ZSH. Here we can see, yes, it's working. But if you want to have it right now, we could restart or simply log off from this current user account. And then we start a new session and everything should be fine. So let's do this. We log out. We log in again and let's open a new terminal, Control T. There we have it. ZSH is working, perfect. Now we can move on with installing the Android Studio. To install the Android Studio, we simply open the Firefox, which has been already installed on the system, but feel free to install the browser of your choice. And then we are typing Android Studio into Google. Then we click on the link https://developer.android.com. So this is our trustworthy source where we want to download the Android Studio. And here we have it. Download the Android Studio. Alright. Afterwards, we have to read carefully through those terms and conditions. And in case if we agree, we hit this checkbox and download the Android Studio. Save file, and there we go. Alright. The Studio is now being downloaded and it's about 1 GB large. So this might take a while. I will fast forward this process that we do not lose any time on this one. Alright, the Studio has been downloaded. Would be absolutely nice if it's always that fast. So by simply clicking on this, those files will be decompressed. This might take once again a little bit of time. And here we have it. Now we select this one, extract, and yeah, we select for example this downloads directory. Alright, these files are now being extracted. These are now 2 GB large, so we can see our disk space needs to be really big. Okay. So once again, let's fast forward this process. Okay, now we can click on show the files. So this is now our Android Studio with all these binaries. Okay, let's create a new directory within our home directory where we can put it in afterwards. So within the home directory, we create a new one, we name this tools, and then we simply drag and drop it into this one. Alright, we do a little bit of cleanup because we do not want to waste 1 GB in our downloads directory right now. And then we want to proceed installing the Android Studio. So we simply go into this Tools Android Studio directory. And here we can now do a little bit of a trick. We can do a right click, open a new terminal. This will open a new terminal in this current directory. So we do not have to change this path until we end up in this one over here. That's super handy. Okay, then we go into this bin directory and we launch the Studio by typing in bash studio.sh. And there we go. So the Android Studio is now being launched. We can see we can import existing settings, but we haven't it installed yet, so we do not have any existing settings. Okay, we click on next. All right, now the installation process finally begins. Data sharing? Nope, don't send any data. Next. Here we want to choose custom because we want to be in charge of what is being installed and what not. So therefore we choose custom. Next. Here we can now define a Java runtime environment. So regarding to Java, this is a little bit ridiculous. If we have an application written in Java, it needs a runtime environment. So we need to have Java installed on our system. So far so good. But regarding to new Java versions, there will be also new classes and old ones gets removed. So it could be the case that our Java runtime environment is not compatible to the Android Studio runtime environment. And therefore the Android Studio is shipping its own environment where the developers of Android Studio make sure that everything works perfectly fine. So in this case, we definitely want to use the Java runtime environment which comes shipped and not the ones which might have been already installed on our system. Alright, so we leave this as it is and simply hit next. That's definitely the best option. Alright, and now we have to make this difficult choice, Dracula or Light. I mean, for you there might be only one choice available, but I choose Light, because within the Light version we can see certain buttons or text a little bit better. So it's easier to follow there. And then clicking next, and here we have now the SDK component set up. So we can see the Android SDK is already being checked, and please make sure that that's also the case for you. It's about 300 MB and that's the most important part in our Android Studio right now. So these are all the tools which we will need to access our device and play around with this one. That's the SDK. Then we can see there's also an SDK platform support for API version 32. We leave this checked, and later on we will also install some older version platform support. For example, for Android version 10, 9, 8, 7, things like this, that we have a pretty good backwards compatibility. For now, we have only this one, and that's good to go. Last but not least, we've got the Android virtual device. In my case, it's already being installed with the Android Studio. I guess this happens if we install the newest version of the Android Studio. If this is not being checked, then please check it. If you forget it at this point right now, don't worry, we can also install it later on. Alright, so we simply have those two enabled. This, by the way, the Android SDK platform, this box cannot be checked. So the check is within this RP32. Okay, and then we click next, and here we've got an overview what is being installed. After clicking next once again, we can see license agreement. So we have to read carefully through this license agreement for the SDK and accept it. And we also have to read carefully through the Android SDK build tools license and accept it. Okay? Then we click finish, and now all these things are being downloaded. Once again, this might take a while, so I will boost up my internet connection that it's pretty fast and fast forward this process right now. Okay, unzipping, here we have the finish screen, perfect. Let's click finish, and now we've got the Android Studio up and running. But we are not done yet. We want to install some additional tools. So therefore we go into more actions, SDK manager, and here we have now some additional platform support. So if you want to write applications, then it's good to have a far backwards compatibility. In case if you're using a real device, which is Android version 7, for example, you want to make sure that you have platform support for Android Nougat enabled here. Right now, I will only enable 12 and 11. Afterwards, we will install the additional ones, for example, 10 up to Marshmallow, which is version 6. And then you have the comparison against the disk size, how much space this requires right now. So that's the only relevant factor. In case if you have enough disk space, you can also enable them down to Android Marshmallow right now. Alrighty, and then we go into the SDK tools. And here we want to enable NDK. NDK, this is the native development kit, which means our Android applications are normally written in Java. We will have several videos on this later on. But Java might be a little bit slow regarding to certain actions. For example, in mobile games, graphics rendering and things like this. Therefore, we need native code, C++ code. And having this NDK box enabled means the Android Studio will also fetch this native development kit, which means we are able to write in C++ code. But this requires a certain toolchain, which is this NDK over here. So having this box NDK enabled over here means the Android Studio is fetching this native development kit, and afterwards we will be able to write our own C++ code. So this one will be compiled afterwards into a certain library. But these are things we will have a look into later in this course. Right now we simply want to make sure that the NDK box is enabled, that we have this type of support. Okay. Then we want to definitely check the Android SDK command line tools. So this is maybe the most important part. These are the command line tools, for example, the ADB, which will be used to interact with this device, or fastboot, which will be used to interact with the bootloader of this device. So that's the most important tool suite we will have in our Android Studio. Alright. Last but not least, we also enable CMake. So this makes the compilation of certain parts of an Android project a little bit easier. For example, we can check out the Android open source project and compile certain projects out of this one. Alright, then let's see. The rest can be skipped. SDK update sites, nothing interesting over here. Alright, I guess we're good to go. So these are the bundles we want to install. We simply click apply, and here we can see the estimated download size is about 1 GB, but if we extract those files, we will require 4 GB of disk space. And now you know why 20 GB might not be sufficient enough right now. Okay, then we click OK, and I will boost up my internet connection once again. Alright, download has been finished, so let's click on finish. And now I also enable platform support, let's say up till Marshmallow. Alright, here we can see the estimated disk size is 4 GB. So having a platform support back to Marshmallow just requires 4 GB. I guess that's a fair deal right now. So click on OK. Once again, boosting up these internet connection. Okay, and then we can click finish, apply, and OK. Okay, and that's the installation process of this Android Studio. So now we can start writing our own applications or play around with existing ones. But to do this, we have to do a little bit of a setup first. By the way, over here we've got things like the plugins, which we will use later on in this course. I mean, I'm not using much of them, but a few are pretty awesome. But we will perform the installation when we require them. For now, we are done installing the Android Studio. Okay, let's close this one. So, as already mentioned, within our home directory, there's now a new directory, the Android directory, and this one has this SDK toolset being downloaded and installed. Over here, we will find all these binaries which we're going to use during this course. For example, in platform tools, we've got this ADB binary. This is maybe one of the most important ones over here. If we want to run this binary, we would assume that we simply can open a new terminal, type in ADB, and we're good to go. But here we can see the command has not been found, which means the ADB binary is not visible for our terminal right now. If we want to start this, we have to provide the full path for this binary. And we can do this by performing a right click, open new terminal, pwd to get this current directory. Then we copy this, we insert it over here, and then we append ADB. Alright, here we can see the ADB shell is being started, but this is super inconvenient to memorize. Also, if we're using later on some scripts, we have to insert this path in all of our scripts, and this is something we do not want to have. What we can do is we can include this directory in our path variable, which means if we run a command, for example ADB afterwards, the path variable is looking into all these directories which are listed in this path variable and searching for an ADB binary. In case if it finds one, it will execute it. And in case if there is not, we get this command not found like we have seen before. By having this included in the path variable, we do not need to insert the whole path all the time. We can simply run ADB from our terminal wherever we are right now. And this is super convenient, right? Absolutely. So let's do this. The things we need to do is we need to copy this path, and then we are opening the ZSHRC. I'm using Vim, but you can also use Nano, Gedit, Visual Studio Code Editor, whatever you like. Alright, then within this file we scroll down. And now we insert export path, which means we will export a new path variable, and we have to include the existing ones. Otherwise, we will overwrite all the existing directories which has been already included in this path variable. Alright, this looks a little bit crazy, but what we are doing over here is we are exporting this existing path variable to a new variable, which is the same name, but now we can extend additional directories. And therefore we're hitting colon, slash, and now we are inserting the path which has been copied before, but we need to make sure that we are including this directory and not this binary. So we need to delete this ADB, and there we go. So what this line over here does is the following. We're taking the existing path variable, $path, then we append our new directory, the platform tools directory, to it, and then we export all of them into a new variable named path, which is identical regarding to the old one, which means we simply append or extend this variable by the platform tools directory. Alright. Doing this will give us access to all these binaries in this platform tools directory right now, which means we can open a new terminal and simply run ADB from this new terminal, and everything works perfectly fine. Nice, isn't it? But before we do this, let's also append another directory which has some useful binaries in there. And this one is within the SDK directory, build tools, and then 3200. Alright, once again, right click, open a new terminal, pwd, copying this path, and please make sure that there's a colon separating those two. So this is the separator for our path variable. Okay, and then we simply insert it directly afterwards, appending and slash, and we are good to go. Alright, so then let's close this file, and we can do this by hitting escape, :WQ. Yes, that's the way to leave Vim, absolutely crazy. And now let's try if everything works. So by typing in ADB, we should get, what? Command not found? Yes, because this path variable has not been updated for this current terminal yet. If we open a new terminal, it would work. So we could simply open a new one and then type in ADB, or we can simply update this path variable for the terminal we have already opened. We can do this by simply running source and this one on ZSHRC, which means the ZSHRC will be refreshed for this terminal, and this means the path variable will be extended with the 2 directories we have inserted before. Alright, so let's see, running ADB, and there we go. So here we can see we can now start ADB wherever we like. So we do not need to mesmerize this whole path or going into this directory first. Alrighty? Okay. And this is all. So we can close everything and finish this installation video over here. Okay, so this installation video did become quite long, and I'm not sure what happened over here. So if this was your first time, then I guess it's really helpful to have this view into the SDK tools, setting these path variables and stuff like this. I guess the other installation videos won't take that long. In case of any questions, please drop me a message underneath this video, and otherwise I'm looking forward to see you in the next one. In this video, we want to install our emulator, and installation videos can be a little bit boring, so I try my best to reward you afterwards with some nice features we've got in our emulator. Alright, so therefore, let's go. Back at the Ubuntu VM, let's start installing our emulator. But maybe before we do this, let's insert some nice music over here, because an installation video can be super boring, so I try to make this as exciting as possible. There we go. Now we've got nice background music. Alright. To install an emulator, in my opinion, the easiest way is doing this via the Android Studio. So let's open up a terminal and let's go into this path. If we want to start the Android Studio, we have to type this whole path all the time in our terminal. And this is a little bit inconvenient. So therefore, let's create some shortcut for this that we can simply run it via Studio. And then the Android Studio will be started. How can we do this? Well, we can create simply an alias for this whole command. So the alias will replace this whole command, and this can be inserted in our ZSHRC. So we copy the whole path, and then I'm opening the ZSHRC, and we create a new alias. We name this Studio, and then we provide this full path. Every time we type now Studio in our terminal, the whole command will be executed. Alright. To leave Vim, all we need to do is hitting the :WQ, and then we are out of this one. Alright, if we would run this command afterwards, it wouldn't work. So the command Studio would be unknown because we need to update this ZSHRC first. We can open a new one, or we can simply use source and then providing this file name, which will update our current terminal with all these commands. Afterwards, we simply start Studio by typing in Studio in our terminal. Alright, and here we can see Studio is being opened. Then we go into more actions and we select Virtual Device Manager. Okay? Oh, what's this? Your CPU does not support requires VTX or SVM. Alright. This means virtualization needs to be enabled in our virtual machine. As mentioned in the beginning, running a virtual machine within a virtual machine, it's not the best performance we will have. But regarding to the emulator, this will work. So we also need to enable a hypervisor for our virtual machine over here. How can we do this? Unfortunately, we have to power it down, so we need to close everything over here. And then we go into virtual machine, settings, and then we drag this to the left, okay? And then within processor and memory, there's an advanced option over here. And here we can enable hypervisor applications in this virtual machine. All right, by having this checkbox enabled, we can run or we can virtualize another virtual machine in our virtual machine. Okay, exactly what we want to have, at least for this setup right now. So after enabling it, we can start this once again. The system will be booted up, and there we have it. Okay, now we log in, and now we simply open a new terminal and run our command, our alias in Studio. And there we have it, and now the Android Studio starts once again. All right. Then we go into more actions, Virtual Device Manager, and now the error message has been gone. Perfect. We can now create a new device, and here we've got a huge list of possible devices. If we scroll down a little bit, we've got devices like this Pixel 4 over here, and we can say this one has a Play Store enabled. Having a Pixel 4 device as an emulator sounds absolutely amazing, but keep in mind, the more powerful this device is, the more resources it drains. Therefore, I recommend a different device. So the Nexus device, it's not that powerful, which is good regarding to the emulation. And it also has root access as default enabled. So this is definitely our device we want to have. So let's search this. We scroll down a little bit. And here we have it. The Nexus 5 device also has a Play Store enabled and comes with different resolutions. So I take this one over here, the HD version. This is perfectly fine. Hello guys, it's me from the future. So at this point I realized I made a slightly little mistake. Having an emulator image with the Play Store enabled automatically removes the root access. So we are only having root access on those devices which comes not shipped with the Play Store. So my recommendation would be, instead of using this Nexus 5 image, please use the Nexus 6 image, because this device does not come with the Play Store and therefore has automatically root enabled. In case if you do not have a real device, I still recommend getting one emulator image that has the Google Play Store enabled, because the other image, the Nexus 6 image, does not have things like the Play Store or a Chrome browser or things like this. It's not required during this course, but if you want to start your app hacking career, then you might want to have such a device. Alright? To sum this up, during this course, the only device you need is the Nexus 6 image without the Play Store. So I will highlight it over here. You can also get the device with the Play Store, but then you are not having root access. The Google Play Store itself will not be required during this course, so you can perfectly move on with this Nexus 6 device without the Play Store being enabled. I will now move on with the installation process for the Nexus 5 device, but I mean this makes not a difference regarding to the Nexus 6. Nevertheless, please choose Nexus 6. Also in the next video when we talk about the emulator options, there's no difference or it's not device specific, so we can simply move on over here. Alrighty? Okay. So sorry for the confusion over here, but I guess it's not a big deal. Let's simply move on with the installation part. Alrighty, let's go. Okay, and then we click next. Here we have now the system image, so the operating system we want to have on our device. In my case, I'm choosing the RP version 30, which is Android R. But you can also go for the RP version 32, because this course has been designed to work on the most up-to-date versions right now. So therefore, you shouldn't encounter any problems. Alright, then the download is being started and, oh, what's this? Load disk space. Alright, I have forgotten to increase the size of our hard disk. So I guess we are running on 20 GB right now. And Android Studio and all these emulators, they require a lot of disk space. So therefore, unfortunately, I have to resize this partition real quick, but that's not a big deal. We simply click this away and unfortunately we have to cancel the current download. Then let's close everything over here and we have to power down the virtual machine once again. Then within virtual machine settings, we now select hard disk and we increase this to, for example, 60 GB. Okay, resize successful, that's good. Now let's start the system once again. The boot process is running right now. Alright, we log in once again. And now we have to resize our partition, because our partition is still only 20 GB large, but we've got now 40 more available. To do this, we simply go into the activities and then we are searching for disks, okay? And here we can see we've gotten free space of 43 GB. So our partition is still only 20 GB, but now by clicking on this one and then going on those settings and resize, we can now adjust those 40 GB on top of our 20 GB. Alright, we have to insert our credentials and also for the second part over here. In settings, resize, and then let's pack everything on top of it. Alright, now we've gotten 64 GB partition. Let's verify this. Opening a new terminal, disk-h. There we go. We've got now 39 GB of free disk space available. Alright, that's all. Perfect. So now we can move on with our installation. And the good thing is, it should immediately start where it did stop. So let's open Android Studio. Once again, into more actions, Virtual Device Manager. Create a new device. And please keep in mind choosing the Nexus 6, besides seeing me selecting Nexus 5. And then Android R. And we can see, yes, it proceeds where it did stop. I have tested it, it did work for me. So even if the download got cancelled, the system is running and yeah, booting fine. Okay, so let's wait until this download has been finished. Alright, we click on finish and then next. And here we've got now the verify configuration. So we've got our AVD name, the system we have installed and things like this. I like to rename this real quick to Nexus 5 only. Okay, and then I hit the finish button. Perfect, here we have it right now. All we need to do is simply pressing this play button and then the emulator will launch. And here we get this warning. Emulator is running using nested virtualization. This is not recommended. Yes, I agree with this one. I also do not recommend it, but it works. So I have tested it for this virtual machine and this emulator, and yeah, we encounter a little bit of a lag, but it works perfectly fine. If you want to have a really nice user experience, then install the Linux system on your host system and then using this emulator directly on your host system. Then you avoid this nested virtualization. Alrighty? Perfect. Okay, let's move on. We simply click OK, and then we can close all these other windows. And now starting the emulator the first time might take quite a while. So grab a tea, grab a coffee, and yeah, sit back and relax a little bit, because the first time the system boots, it takes a few minutes, but afterwards it's just a matter of seconds if you want to reboot it once again. Okay, and here we can see the pixel is starting and we do not have to insert certain accounts or stuff like this. The smartphone is now ready to use. Nice. Alright, and now we are done with the installation part. In the next video we will have a look into those features of this emulator, and we will also perform a little bit more of a setup. So we will create shortcuts that we can easily run this emulator without running Android Studio all the time. Alright, so I'm really looking forward to see you there. In the last video we did finish our installation process, so our emulator is now running. In this video we want to create a little shortcut that we do not have to start the Android Studio first, and we will also have a look into these features. And we will also discover a little bit a hidden one, which is super awesome. Are you ready for this? Then let's go. Alright, here we are back at the Ubuntu VM, and let's first create some kind of shortcut. So in the last video we did start the emulator in the following way. We did start our Android Studio, and then we did go into more actions, virtual device manager, and here we have it. Starting the emulator in this way is still recommended if you encounter some errors, because the error handling in the terminal is not as good as we are having it here right now. And for example, if the emulator couldn't be closed, there's some kind of log file which we need to delete manually. Over here we get this notification if we try starting it, within the terminal not. But generally speaking, we do not need to start the Android Studio to run this emulator. Alrighty? Okay. So therefore, let's create our shortcut, and if you're not encountering any error, then this is the more easy way. Alright, and let's close this. So our Android SDK comes with this emulator binary. Therefore, we're going into Android SDK. And here we have now this emulator directory. And if we run this emulator binary, let's do this. Yes, that's the way to go. So over here we can see we have to specify a device name. So we need to run our emulator and then add and the device name. Okay, let's see how we can find out what's the device name. So therefore, let's make this a bit larger. And we are simply using the -- help option for this one. All right, this is a lot. So some of these options might be really useful. But for now we are only interested in, let's see. Over here, for example, we can set an emulation camera. Pretty nice. Okay, but back to the topic. Here we have it, at the beginning, of course. So list AVDs. And let's do this. Emulator list AVDs. Yes, here we've got now the name. All right, if you want to start this via the terminal, we have to go into the following path. Then we have to run this emulator binary, and then we have to apply add and then Nexus 5. So these are a lot of steps. Let's add this emulator binary, this one, to our path variable. And then we can simply start this emulator without going into the directory first. So we can run this from the terminal wherever we like. We could also create an alias which directly starts this Nexus device, but in case if we are having multiple, then it's not that useful anymore. Alrighty? Okay, so let's make this a bit smaller. Alright, so that's the path over here. Let's open a new terminal, and once again, I'm using Vim, and we're opening the ZSH-RC shell. Here we've got the path variable, so let's see. Okay, let's do it this way. So here we can see path, and we we are assigning the path itself, all right, and then these additional directories. So every time we start a binary, the terminal is looking into those directories for those binaries. And in this case, we have to add this one, that this binary will be found by our terminal, okay? So let's copy this. Let's go at the end of the line, pressing I for insert, already done, then colon, and we add this path. This is all. Now I hit escape, colon, WQ. Now it's being saved. So normally this should work right now if you run emulator. In this case, not. The reason for this is the path has not been updated yet. If you run a new terminal, emulator, then we can see it works. But this one over here needs to be refreshed. We can use a new terminal, or we can simply use this one with the source command and update it. Now the ZSHRC will be updated, and we can run this command also in here right now. All right, let's get rid of those and let's focus only on this one. So now we are running emulator, list AVDs. Okay, we've got Nexus 5. So to start this one, we can use emulator, emulator this way, add Nexus 5. So we need to provide this add in front of the name. Or we can use -avd and then Nexus 5, but that's easier for me right now. And there we go. All right, this is all to run this emulator right now. Setting it up once, okay, now we can repeat this over and over again. Oh yeah, something I didn't mention yet is if the smartphone stays black, then we have to hit this power button over here. So this is our first introduction into this emulator right now. By hitting this power button, we are not powering it up. It has been already powered, but we can see now the smartphone is returning. So this is the same if we lock this device and simply press this power button once again. All right. And now we are directly kicking into the usage of this emulator. So we can use this mouse over here, which is absolutely awesome. And we use this as a finger to drag and drop and click on certain things. For example, if we click on the button and drag this upwards, then we get back this menu over here. We can also open applications by simply clicking on them, for example, those settings. And we can see it's lagging a little bit, but it's not too bad. In case if you cannot afford a dedicated device or a dedicated laptop to perform all the stuff, you can still move on in the course by having this one over here. So this is perfectly fine. If you have a dedicated laptop, I highly recommend using this one. So for example, getting in Linux onto this and then running the emulator directly on the host system. This is way more powerful, as we will see later on. Okay, but back to this one. So the usage, yes, with the mouse, okay. And now's the question, we've got no buttons over here, how we get back. Those buttons are now on the right. So over here we've got those three buttons. We've got a back button, we've got a home button, and we've got this, what's the name? The overview button, all right. So this one will show all the applications which has been put into the background. None of them are available yet, but later on if we have some apps open, this is pretty useful. Then we've got the zoom button over here, so we can zoom into certain things. Not sure if this is really useful. We've got the take screenshot button. This might be useful, but we could also do this on our laptop screen. But nevertheless, we've got it over here. The location will be saved to the desktop, I guess. We will find this out later on. This one is handy because later on we have some mobile games which needs to be rotated, and here we can easily rotate the screen. We make this back, okay. Then we've got volume down and volume up, and this one we have already seen, this is the power button. So these are some shortcuts for this device, but more important are those three dots. So these are the real settings. Let's open this one and we already start. The UI is not responding, but I guess it's okay. We can try closing this. Yes, it will simply restart it. So I guess we're good to go. All right, so here we've got now the main menu of this emulator, and here we've got tons of amazing things. For example, this location over here. So let's see. Yes, here's a location already inserted. We can delete this one. And we can also insert a new one by simply clicking onto this map, and then we can say save point. Here we get those latitude, longitude coordinates, and we can also make a description. In the roots, let's see. Yes, we can import saved locations. So it needs to be in a certain format. And then we can play it back so that we are traveling this route over here. But I mean, this is not like faking those GPS locations. I guess in the older versions it did work, but we're using a different trick. And later on we will also spoof GPS locations based on some other stuff. So we will do a runtime manipulation with Frida, and then we will directly override those methods. But more on this later. So right now this is not that useful in my opinion, this location over here, but it's handy to have this map and getting easy access to those coordinates and things like this. And then we've got displays, and this is even more useless. I guess I haven't used this once right now. So we can add additional displays. All right. Not that interesting, but now it's getting really funny. Cellular. So here we've got now the mobile connection of this device, and this sounds absolutely crazy, right? So let's enter the main menu. Now I see what the problem is. So the menu over here is missing. Yes. Okay. So I need to restart this emulator. All right. Then let's do this. How can we restart this easily? Let's see if we click long on power down. Yes, then we can hit restart. So let's do this. Okay, so let's restart it. And we might encounter a problem, which is good to show right now. I mean, it was all planned in this way. Let's see. Yes, here we can see right now a snapshot operation for Nexus is pending or timeout has expired. So this error message is not that useful right now. So therefore, let's open it once again with the Android Studio. Oh, we have a shortcut for this one. I forgot about this one. Okay, and then within more actions, AVD, Virtual Device Manager. And here right now, if we click play, then here we get now this notification. AVD Nexus is already running, but it's not. It seems to crash in a certain way. So we need to delete the following file. All right. Let's delete this file. So new terminal. And then I guess the best option would be using a file browser. And then let's see, where is this .log file? Oh, we've got multiple .log files. Okay, so let's see. So normally I would do this by the command line, but yes, if you mistype there, then you might delete your whole disk. So that this would be absolute unfortunate. All right, so this one is the file we need to delete. Let's delete this one. Okay, those other two also need to be deleted. So now we have those log files deleted, so we can close this. Now we can try running it once again. And we can see, yes, now it's starting. So the easiest way to get rid of this log files is simply using rm and then this command over here. But please be careful, because otherwise you might delete wrong files. I mean, it couldn't be too bad because it only deletes files with the log extension, but we never know. All right, so now the screen still is turned black. So let's start it once again. Yes, we can see the UI is still missing. So it seems not to be closed correctly. Let's power it off right now. After powering it off, let's do a cold boot. So the state gets saved, but if there was an error, the error also gets saved. It's a little bit of a downside, but we can easily fix this by going on to the right over here and then, let's do a cold boot. Okay, so now the smartphone is being booted up once again and does not rely on a snapshot right now. So let's see. Okay, so now we can see this might take a while. If you hit this power button, yes, it's not immediately turning back. So it really needs to start right now. So it's the same like we have it after the installation process. So unfortunately, we have to wait a little bit until the smartphone has been booted up. Okay, here we can see the smartphone is now booting. So you simply really have to wait a little bit. All right, so now the device is up and running. A little bit unfortunate, but now you also got everything you need to know about troubleshooting. I mean, things like the code boot might be also available via the terminal, but having it in this way in the graphical view, it's way easier. So that's the device manager of the Android Studio. In case of any errors, try starting it by the Android Studio and powering it off, close it over here, and then simply perform a cold boot that the saved broken state gets overwritten once again. Alrighty? Okay, perfect. So the thing I would like to show you where I did stop was this one over here. We were talking about cellular. Alrighty. And here we've got now Wi-Fi and mobile connection. And this is super awesome because this device over here, I mean, it has no SIM card in there and also no access to a Wi-Fi access point right now. So all of this is being emulated and we can see this over here. So this one is now network type edge and we can see the signal strength is poor. We can set this to great and then this will change over here. So as a developer, this is super handy. We can simulate certain circumstances, but also as an attacker. Let's say the application behaves differently regarding to Wi-Fi or a cellular network. We can emulate and simulate this right now over here. We can also go up to 5G, whatever full means, not sure, but I guess 5G is now the highest rate. Yes, should be the highest rate. So this can be easily done with a mouse click. So this would be absolutely awesome if it would work in reality, right? So we could easily get a better signal by just clicking this over here. Unfortunately, in reality not, but on this emulator, it's pretty easy. Okay, next we've got battery. And over here we can play around with the battery level. And this is, I would say this is really important. Okay, maybe not really, but it's more important right now. Because later we will talk about broadcast receiver. Broadcast receiver are some kind of messaging system in an Android application, and some of them react on certain events, like for example the battery level. Let's say the battery level is going down, and we can observe this directly on the smartphone that the battery is running pretty low right now. And there we go, we get this message. So this is a broadcast which will be sent out to all those applications. And those applications can react to this event. And for example, they could say, we're running out of battery. Let's save our data real quickly before they get lost. So we can force file saves by draining the battery. And it could be also used to charge your phone pretty easily. So let's see, full speed charging in 3, 2, 1. There we go. All right, back to 100%. We can also play around with the battery health. Yes, here we've got it. So we can say this one is dead, failed, or things like this. So pretty cool. Okay, next we've got the camera. So here we can provide virtual scene images. For example, we can provide images for our virtual camera in our smartphone. So, I mean, it has a camera back and front. Let's open this maybe over here. And this one is simulating some views. All right, we can see it's a little bit laggy. Yes, so here we have it. So that's the front view, and we can also have the back view. So this is some simulated stuff over here, but we can also apply our own virtual camera, or we can apply images to this one. I mean, we could use this, for example, to scan QR codes or things like this, and this would be easily possible. Next, we've got phone, and this is maybe the most amazing feature, because we have seen, let's go back, we could use this on this button. So we have seen that we've gotten Wi-Fi and a cellular connection, but both of them are emulated, which means also phone calls and SMS can be emulated. And this is exactly what we have over here. We can select any number we want here, and then we can call this device. So all of this is of course virtualized. There is no real phone call happening, but this means we can also define the caller by ourselves. For example, let's say we've got this number 1337. And now we can call this device. And in just a moment, here we have this icon over here, and here's this call. So now we can see we can also answer it, and we can talk to this based on microphones. Right now I'm doing in this line. If the application is performing some phone calls, this might be super handy to emulate. For example, if there's a certain SMS from a certain number triggering an event, we can emulate what's happening over here. So we can spoof any number we want to have based on SMS or a phone call. Awesome, right? And it doesn't cost anything. That's even better. Regarding to SMS, we've got this here. So let's send an SMS. And this app hacking course is absolutely awesome. I mean, that's the truth, right? Of course. Let's see, send message. Yes, I can see this icon over here. A little bit laggy, as many times mentioned right now. Oh, it disappeared. And let's open this one. So that's the SMS manager this way. All right, I guess I agree. No, without chat features. Yes, here we've got this SMS. So I guess it has been displayed, but it might be too laggy to show right now. But we can see this app hacking course is absolutely okay. Awesome. Right. So we have received this SMS over here. Okay. Next we've got this one. This can be ignored. That's not really useful right now. Microphone. I mean, we can insert a headset and then we can also call ourselves and have some voice interaction, or for example, having some voice interaction with applications if they enable those microphones. A fingerprint, something I haven't really used. So I find this not that important in the emulator. Virtual sensors. Here we've got tons of sensors. For example, we've got pressure, temperature, light, or also magnetic field sensors. So all of them are being emulated, which means we can manipulate all of them. For example, we can enable this light sensor or other stuff. Decrease or increase the temperature. Things like this. And then bug report. Okay, I mean, we can send a bug report. Let's ignore this. Then we've got snapshots. So this enables quick boot, which means the state of the device gets saved, which is absolutely awesome if we do not have any errors, like we have seen this at the beginning of this video. But if we do not have any errors, we can, for example, freeze the current state. Then we can install certain things, play around, create user accounts, and then revert back like this wouldn't have never happened. So this is pretty cool. And it also enables starting this device quite fast. We have seen also at the beginning that running in cold boot will take several minutes. And within the quick boot, it just takes a few seconds. So maybe 20 seconds to device to boot up. What's here? Yes, okay, that's just an additional settings menu. All right, and then we've got record and playback. This one is cool. Okay, I basically say this to every option right now, but here we can create a screen recording. So we can say start recording. Okay, and then we can perform some awesome actions and show the customer how heavily we have hacked this application, and then we can stop this recording. And then we can play it back again. Okay, so simply screen recording. Here we've got macro playbacks. This is also cool, but we will use this differently later on. Okay, first let's talk about this one. So macro playbacks or macros are predefined actions that can be used in this device. And for example, if we open the camera, we can, for example, play this macro here, and then this one will be inserted into the camera stream. So let's play this, and we can see this one is happening right now. So we can also create our own macros, which means we can perform certain interactions with this device, record them, and play them back again. Sounds absolutely useful, and it is. It absolutely is. But we will use a different approach. We will later write our own automation script for a mobile game. So we will keep playing this game without even interacting with this one. And this approach is a little bit better in my opinion because it gives us more flexibility and it also works on real devices. So therefore we are not using this one, but I mean, it's cool to know. Okay. Over here, by the way, we can see it seems like we cannot record our own macros, but I will show you a hidden interface in this emulator, which can be used to also record our own. More on this later. Google Play. Yes, we can also have, I guess we have a Google Play Store. Yes, we have one, but we need to log in into this one to use it. So if you're opening this one, all right, here we can see, yes, we have to sign in, and then also this one would be working over here. I'm not going to use this, but in case if you want to create an account, feel free to also have this Play Store enabled and downloading these applications. Last but not least, we've got these settings, and this one might be the most important one. Emulator window theme, we can change this to dark. All right, awesome, right? So here we can see this is also the screenshot save location. It's the desktop. And most of the stuff is not that interesting anymore, beside one. Let's go back. Okay, into the settings, network and internet. Yes, and here we've got the Wi-Fi menu. And most of the courses, if they perform a man-in-the-middle attack, recommend inserting and proxy within this Wi-Fi menu over here. So within this Android Wi-Fi, go into settings on this one, and then let's see, advanced option, proxy. Okay, so why is this a bad idea? Well, if we insert our burp suite or a man-in-the-middle proxy as a proxy in our Wi-Fi settings, we encounter a lot of issues. The first one is this emulator has several network interfaces. For example, this cellular and also this Wi-Fi network interface. And in the past, I have encountered this quite often, that the device is switching between them and it's not clear when this is happening. It could be the case that the emulator is splitting this internet connection between the Wi-Fi and also the cellular connection. This means we are missing information because only the Wi-Fi connection, this connection type, will be intercepted. And this is something you definitely do not want to have. You want to have everything within this network connection. The other reason why this could be bad is applications can determine if there's a proxy in there, for example in this Wi-Fi settings, and then they can make a decision if they want to send those data or not. In case if the application do not want to be proxied, then the application is simply not sending these data, which means this application is behaving differently and it might not send all the data out. Also there, we are missing those data. And last but not least, we could have some not that common network requests. For example, SSH, SQL, or regarding to IoT devices, which is pretty common, MQTT. So these are not that common TCP protocols, and those might not be intercepted by a proxy within those Wi-Fi settings. And even if they are, things like UDP are definitely not. And this is absolutely terrible regarding to our analysis. Therefore, I have prepared a dedicated setup within the man-in-the-middle section where I go through all of these topics. And there we will also figure out how to intercept a connection, how to establish a man-in-the-middle connection to fetch everything. TCP, UDP, ICMP, or whatever protocol or type would be sent over here. Alrighty? Okay. In case if you want to perform a quick setup, I've got a solution for you. So therefore, let's have a look. Okay, so the key takeaway right now is please do not use this one. In case if you want to quickly set it up and perform a man-in-the-middle for a simply mobile application that is just doing HTTPS or HTTP network requests, then we can go into those proxy in these settings over here, and then we can choose manual proxy configuration this way. And here we can now insert our stuff. We will do this later on in the man-in-the-middle section. So this one is more like a system proxy, and this will fetch both network connections, cellular and also Wi-Fi connection. Alrighty? Okay. And this is all regarding to those settings right now. I guess we have covered the most important ones. Feel free to play around with this one. And now we want to have a look into more hidden interfaces of this emulator, because these are even more powerful that we've got over here right now. So how can we connect to those hidden interfaces? I mean, they are not that hidden. Let's see. Okay, to connect to them, we need to figure out something first. So therefore we are opening a terminal, and then we are getting root privileges, and then we are using netstat and this one. Oh, okay, we have to install those net tools first, okay. All right, and now we repeat this command. Let's make this a little bit larger. Let's swap this a little bit. Okay, so here we can see we've got several QEMU ports where the system is listening to. So our local host is listening on 5555, 5554, and this one. So QEMU, that's the emulation framework of this emulator over here, which means these are services provided by this emulator. And let's have a look into this one. So that's the port 5554. So let's make a connection to this one. I open a new terminal, and then telnet, localhost, and then 5554. Let's close this. All right, and here we can see, oh, interesting, Android console authentication required, okay? we need to type out in this auth token to authenticate. And where can we find this auth token? Well, it's over here. So this one has been created. Let's copy this and cut this token out. Okay, and now we select everything beside this percentage sign. So this one is not being selected. Let's call it false positive that it has been marked over here. Okay, and now we can authenticate to our emulator by having the secret key. Okay, so we have successfully authenticated, and now we have some additional commands. So by typing in help, we've got a lot of additional commands. For example, this geo command. Let's see how this works. Help geo. Okay, here we can send fixed GPS coordinates to our smartphone. Or let's say the smartphone is receiving or fetching fixed GPS coordinates which are provided by us. Let's get some. So let's find some out. So this is where this location comes handy. Let's search for Greenland, for example. All right, and let's take this position. So here we can see this is the position. Let's save this right now. Set location. Okay. And now let's take those coordinates. Save point. In Greenland. That's the newest one, so we can delete this one. Okay. So let's see edit. Okay, here we've got now the latitude and the longitude. So let's see how this command works. Let's put this a little bit more to the right. Help geofix. Okay, all we need to do is we need to apply geo, fix, and then longitude, latitude. We can also define satellites and things like this. So regarding to GPS, we're having 4 satellites. 3 are regarding to the position, and the 4th one is regarding to the time. It's super awesome to get a view into this, but I guess this is not required right now. Okay, so let's see. The first one is the longitude. This is this one. Oh, I cannot mark it, so let's insert it in this way. Okay, if there's a little typo, I guess we still stick in Greenland, so it should be fine. And then the latitude. Okay, and let's insert this. Okay, now we have defined some fixed GPS locations. So if we now go back into those Google Maps, and if we now click on this one, which should fetch our current position, let's see. Okay, so for now I only see white. So let's see if we are in Greenland right now, because this might be the case if we are in Greenland, right? So let's double click on this one. And there we go. We are in Greenland at this location, exactly like we have pointed this out in our smartphone right now. Awesome, right? So this is a way to easily spoof certain GPS locations, also for Google Maps and things like this. So this is pretty awesome. Within this menu, we will find some additional things. For example, we've got automation. Yes, automation. Sorry, this way. So this is what we have seen before. And let's do this. And here we can see if the command is not known, we are getting KO. All right. Help automation. Yes, and here we can use automation record, and then we can perform our macro record, and then we can stop and play it once again. But as already mentioned, we will use a better approach. Okay, so I guess we had an extensive view into this emulator, those features, hidden menus, and what else? Troubleshooting. Yeah, also the troubleshooting guide. I mean, this was a little bit unfortunate, but I guess this is very helpful for you in the future, because this is something you will encounter sooner or later during this course. Alright, so this is all for this video right now. In case of any questions, please drop me a message. I have also included a troubleshooting guide within the cheat sheet, and otherwise I'm really looking forward to see you in the next video. Welcome back. Just for completeness, let's also have a look into installing the Android x86 VM. I mean, the most preferred setup is using a dedicated device, a real device. In case if you cannot afford one, no problem. Then please try running it on the host system, the Android Studio, and use the emulator on the host system. So you could also use this Ubuntu system into a virtual machine, but the emulator at least of the Android Studio should be running on your host system. In case if this option is also not possible or available right now, then you might want to have this Android x86 as a separate virtual machine. So that's the only reason when you should use this, if the other two options are not available. During this course I will work a lot with this, but having the emulator running on the host system is a way better user experience. Nevertheless, let's find out how to install this Android x86 VM, because there might be some pitfalls in there which can be a little bit tricky to deal with. So therefore, let's find this out, let's go. Okay, and first of all, we need to download the ISO image to install this on a new virtual machine. And therefore, I'm just searching for Android x86, and here we have it, https android-x86.org. Okay, let's click on this one. And here we have now several download options. So let's hit this download button. There we go. So we can download this ISO image from FOSSHub or also from some other Miro sites. For example, SourceForge or OSDN. FOSSHub, yes, had a breach in 2016. But for now, I haven't heard of any. So I guess downloading it from FOSSHub should be okay. So let's do this. And there we go. So here we can see we've got several different ISO files. We've got a 64-bit version, we've got a 32-bit version, and we also have a 64 once again. But this one is 9.0 R2, and this one is K49. So these are different. So this one is the preferred file for us, this one. 32-bit or 64, I mean, this really doesn't matter because we're not providing 8 GB of RAM to this virtual machine, so you can choose whatever you like. I go for the 32-bit version over here. Okay, so let's click on this one. And we can see this download is being started. 700 MB shouldn't take too long right now. What we also want to make sure is checking the signature, but in case if a site gets breached, and the attacker is changing this file, the attacker might also change the signature. But I mean, this is all we can do right now regarding to proving if this file is valid or not. And so let's see, I have downloaded the 32-bit version. So let's open the signature. Here we have them. We've got an MD5 in SHA-1 and also in SHA-256. So let's go for the SHA-256. That's a hash sum which gets generated over this file, and this is a mathematical one-way operation. So it couldn't be reversed, which means we put some stuff into this algorithm and we get back those hash digest over here. So if you're doing the same operation on this file, we should always get the same hash digest. So that's some kind of proof we can do, but as already mentioned, an attacker can of course also manipulate this file, change those digests, and then yeah, we wouldn't see any difference. Nevertheless, let's do this anyway. So the download, has been already finished, cool. I open a new terminal. Alright, so on a Linux system we would type something into the terminal like SHA-256 sum, and on a Mac it's something like SHA-sum and then -A256, I guess. Let's see. So let's build this hash sum over this ISO. This might take a while. It's not taking too long, but it's a mathematical operation which requires a little bit of time. Okay, and here we have it right now. So let's see, we've got 91CE. 91CE, yes. And at the end we've got 0 to 1. 0 to 1. And let's also pick something in the middle. For example, 41479. 41479. Alright, so this hash sum should be identical, and therefore it is at least the file mentioned on the website. So that's all we can do right now. Alrighty, let's install this. So therefore I'm using VMware, but you can use VirtualBox or whatever you like. Okay, so over here I create a new one, and then I select Create Custom Virtual Machine, continue. Then I'm choosing Linux, and I'm having a 32-bit version right now. So in my case, what's the kernel? Let's see, I guess it's an 4 kernel. Yes, let's choose this one. Okay, in case if you have downloaded the 64-bit version, then also please choose a 64-bit kernel. But for now I have downloaded the 32-bit version. So I click continue. Here I choose Legacy BIOS. Create new virtual disk, and this one is now, so this doesn't need to be large, so 8 GB should be well enough for this one. Alright, and then we click customize settings because we want to have at least a little bit more RAM. So Android x86. Okay, processor and memory, and we increase this to, let's say, 2048. And maybe 2 cores. So this should be well enough. Back to this one. I mean, USB Bluetooth connection, we do not have to enable USB 3 for this one, but nevertheless, let's do this over here. Okay, and then we have to insert this ISO here. Connect the CD drive, and then let's choose this ISO we have currently downloaded in this one. All right, with an advanced option, no, that's good. Okay, so this looks good. Let's close this one. And now let's simply hit this play button. Okay, so the system is booting, and here we have it. We've got 60 seconds to react to this screen right now. And what we need to do is simply using the arrow down key to go into advanced options. And then let's see, we want to use the auto installation to specified hard disk. Yes, this one. Okay, and then we click enter. All right, a lot of terminal. You have to choose auto installation, will erase. Yes, that's okay. We want to erase everything. I mean, regarding to this hard disk we have currently set up, not regarding to our main system. Okay, these files are being written, and that's all. Amazing, right? So this is the whole installation process for this one. But now we face a little bit of a problem. If we click, for example, reboot, and let's do this. Then we can see, okay, we've got now the Android x86 in version 9 here. Now it's booting from this one, and there we go. This is the console, and we are stuck at this point. I mean, this console, let's see. Yes, it's working, and we've got access to the system, but we want to have an emulator with graphical UI and things like this. But it seems not to be available right now. And the reason for this is, I guess, within the legacy BIOS. So there's some little issue with the with some graphics configuration, but we can fix them easily. And to do this, we simply hit reboot. Okay, so here we have to select the down arrow key a little fast because we only have 4 seconds, and then we go into the debug mode. All right, let's start this once again. A lot of text appearing on the terminal, but that's okay. Yes, sometimes it stacks a little bit and we have to press enter that the terminal appears over here. Okay, so now we've got the terminal. What we want to do right now is creating a certain grub entry. And this one enables some graphics option that the device boots in this UI mode and not this fancy terminal mode over here. All right, so therefore we need to mount this disk first, and we can do this in the following way. So let's first clear the screen. Okay. To do this, we need to remount the mount partition first to make it read-writable that we can modify this file. And we can do this in the following way. We can use mount-o remount, then comma, rewrite, and this mount entry point. Yes. Okay, now we have remounted the partition, but it's read-writable. So therefore we can also modify those files. And the file we want to modify is the grub menu list. So the grub is the bootloader, and this one starts the system with some kernel parameters. And there we want to add a certain one. So we go into the mount directory, and here we have now this grub. And here we have now a file, where is it? Menu list. There we have it. So we can print this out. And yeah, these are the entries we can see in our grub, but now we want to modify this. And to be honest, it's getting a little bit dirty because we do not have nice graphic editors on the system right now. But we can do this with VI, and I will guide you through this. So we are opening this file right now with VI. So VI menu list. Okay, and then we need to go into the first entry, and we need to scroll down to the end of the line. So now we need to go to the end of the line, okay, and then space. And then we want to add some additional kernel parameters, no mode set, X-Force Visa. All right, this will add this no mode set and X-Force Visa entry, which will load some additional graphic support, which means the system can then start the UI without crashing it. All right, okay, to leave this menu, we need to hit the escape button. Then colon, escape, colon, there we go, WQ exclamation mark. All right. And now let's print this file once again out to see if our entry has been taken place. Yes, no mode ZX was, okay. This looks good right now. So what we can do is simply hitting reboot. Okay, a reboot seems not to work. Restart, no. I guess it's power off and some additional command, but we can also do this over here. So I click restart the system. Yes. And now if we start the first entry, the additional kernel parameters will be loaded, and let's see if our system boots up in a graphical view, because we do not want to interact on this device on the command line. And there we go. Yes, perfect. All right, and this is all we need to do to install the system. It takes, I guess, just a minute to keep it running. And yes, this is all we need to do to install the system. So now, yes, we have it over here. Let's guide through this real quick. So that's the installation routine. We can use the mouse to interact with this one. Okay, this is something I want to skip. Just a second. All right. On date and time, let's hit next. Oh, this is something, no diagnose, no location stuff. All right, accept. Here we can choose a pin pattern, but not now. We do not want to lock the system. Skip anyway. And there we have it. Here we can now select a home app. I use Quickstep. This is just regarding to, let's click always, regarding to the launcher. So how this UI should look like. Okay, and here we have it right now. So this is our Android x86 virtual machine running right now, and we've got something nice, this terminal emulator, which makes interacting with this device a little bit easier. So this is now a terminal running directly on this virtual machine without having the need to interact with this one via ADB, but more on this later. All right, I guess for now it's enough. I have also included these steps in the cheat sheet, so what you need to do at what point, and provide some additional information what exactly these options are for. Okay. In case if you have some problems, feel free to write me a message underneath this video, and otherwise I'm looking forward to see you in the next one where we finally start hacking and mobile applications. So thanks for all this patience during the installation process, and now let's have some fun. I'm really looking forward to see you there. Alright guys, welcome back. After all this annoying setup, we want to do some more interesting stuff. In this video, it's perfect to begin with this one. So in this video over here, we want to release our smartphone. So how can we do this, and what do I mean with releasing the smartphone? Well, let's have a look. Here we've got our laptop and we've got a smartphone. For example, this one over here. But this one, it's a consumer device, and therefore some features are not being enabled by default. Those features can enable us as a developer to perform or investigate certain things. And these features, I mean, they are core features if we want to do some app hacking. If we enable them, then our smartphone will become unlocked. So this one has then more powerful features to inspect and interact with certain applications. And this one, I mean, it's a core feature to perform Android application hacking. To enable those developer options, this can be done within 3 simple steps. The first one is we have to go into the settings of our smartphone. And then we've got something like About the Phone, and within About the Phone we have to hit 8 times this build number. I mean, it hasn't to be that fast, it can be also a little bit slower. But after hitting this 8 times, we have now enabled those developer options, and we can find them within our settings. The question is now, what makes them that amazing? So what's that important about those developer options? Well, let's have a look, because I mean, these are really underrated. The most important feature is of course the ADB shell, so the USB debugging. We can attach a USB cable to our phone, and then we can start debugging, interacting with those applications. But those developer options have some really underrated options in there. For example, we can select a mocking location. Okay, might be not that interesting. We can spoof GPS location for applications. Sounds nice, but maybe not that interesting. All right, I get this point. Then we've got things like select and debugging application. Okay, it's getting interesting. Then we've got pointer location, and this is freaking awesome. I mean, we can get the exact coordinates of a view of our application, and we can interact with this one. We have a nice example regarding to this one. But I guess the most underrated option is the Bluetooth HCI Snoop Lock option. So what is this? Well, if our application communicates via Bluetooth, for example, Bluetooth low energy, then we can log every single byte into a file and we can analyze this afterwards, for example, with Wireshark. So this one is freaking awesome and absolutely helpful. Alright, so after all this hype up right now, let's start releasing our smartphone and then let's have a look in those amazing options. You ready for this? So let's finally start hacking something in our smartphone right now. Let's go. Alright, so here we've got the smartphone right now, and after enabling those developer options, all those things will be more handy. We can also replicate the screen on our laptop, but for now we have to enable them first. So let's see how we can do this. So all we need to do is we need to go under settings, and I've put on my glove that you do not see my fat fingers everywhere. Alright, and then within about the phone, so we might have to scroll down a little bit. There we have it. We scroll down until we can see the build number. There we have it. So let's zoom in a little bit. Alright, so here we have it. And all we need to do is we simply need to hit 8 or I guess 7 times, not sure anymore, this build number. So let's do this. 1, 2, 3, 4, 5, 6, 7. Now we are developer. I mean, we are not a developer, but we have enabled those developer options. Where can we find them? Well, let's zoom out. Alright, and now let's go back one menu. And within System, we've got now this Advanced. And here we can see now developer options. So these are our developer options. Okay, let's open them. And here we have it. So we can see those developer options are on and we can now use them. Let's zoom in a little bit. Alright, the most important option for me right now is the USB debugging option, because then we can access this device via USB. So let's enable them, because then we get a lot of useful features. So let's see, we scroll down a little bit. Here we have it, USB debugging. So let's enable this. Alright, and we already get a warning, because I mean, enabling them, it gives us access to certain features of a device, and this could be of course critical. This is also the reason why I would like to use a dedicated device and not my real private device for app hacking stuff. Okay, that's a dedicated device, so I simply agree. And that's it. So now we've got USB debugging enabled. Let's zoom out. Alright, so this is the whole picture right now, but this picture on the smartphone, it's not really convenient. Let's get this picture on our laptop screen. The only thing we need for this is this USB cable. So we plug this USB cable in, and then we are using our ADB, our Android debug bridge, to get this screen on our laptop, because then we can browse through all the other features. And yeah, this is all way more convenient. Alrighty, let's do this. Alright, so let's see how we can get the screen of our smartphone on our laptop. And the things we need are a smartphone, this USB cable, and some tool. Let's have a look. I plug this in. Okay, so the first thing we need to do is we need to make sure that the device is connected to our virtual machine. And therefore we have to go into the virtual machine settings, then USB. And here we have to make sure that the device, in my case it's a Google Pixel 2, is connected to our virtual machine. So we can see I can disconnect it. It means it's being connected. All right? Okay. After this device has been connected, we can open a new terminal and then we simply type in ADB shell. ADB, we have set this up in the installation video, and if you have skipped this, I mean, I can fully understand that you have skipped this installation video, but maybe you want to rewatch the last half of it, because there we set up the Android SDK, and if this is new, this might be very helpful to you. All right? Okay. So after setting up the ADB, so the Android debug bridge, we can now use Android debug bridge and we execute the command shell. And now we can see, we're getting an error. And this one says ADB servers ADB vendor key is not set. So if we look on our smartphone right now, then we can see some kind of screen we have to accept. So this means allow USB debugging. The computer RSR key fingerprint is the following. Do you trust this computer? I say yes, always allow connection from this computer. And now we're good to go. So after making sure that the device is being connected via USB and that we have given those permissions, it should work. Let's see. Yes, so here we can see the terminal changes. This one, the fancy color stuff, is our Linux system, our Ubuntu VM. And this one, Walleye, is now the Pixel device. So that's the shell of the Pixel device. We have now access to this device over here. All right, there could be a case that you get an additional error. And this error is regarding to the USB data transfer. So maybe let's get the screen on the laptop finally, and then let's have a look into this one. So how can we get the screen? We have to use a tool which is a screen copy, so SCR copy. I'm using apt-get install. By the way, if we use exit on the Android debug bridge shell, then we enter our system once again. So at the beginning, it's a little bit confusing, those different terminals. Remember the color one, this is our Linux system, and the just white grayish one, this is our device. And we can also see this code name of this device. Pixel 2 has code name Walleye. Pixel 3 is, I guess, Sailfish. I'm not sure about this one. Nexus is Hammerhead. This is something I know for sure. Okay, so, but we want to install something. So let's see. apt-get install SCR copy. Yes, we need root privileges. So we add sudo. We enter the password. And now, yes, it's going to be installed. Okay. So SCR copy is a tool which is using the Android debug bridge to print the screen on our laptop. Let's do this finally. We simply start this tool by typing in SCR copy. I clear the screen and make this a little bit larger. There we go. All right. And here we have it. This is our device. Perfect. So now I can show you all these things a little bit better. In case if you get an additional error, this might be regarding to USB and data transfer. So if you normally just plug in your device, it might be only charging, which is, I mean, perfect. In case if you just want to charge it, then there is no need to transfer data to give someone access to this device. But regarding to this one, access is required. And we can set this part if we drag this down. So that's absolutely fancy. We can use the mouse right now to show all of this. And then here we can see Android system charging this device via USB. Okay. Tap for more options. Let's open this. Yes, you might want to set it to file transfer, Android Auto. Okay, we can see it's restarting right now. And now we get this message that we are reconnecting this device. I say yes, connect this device to my virtual machine. Always keep this connected. Okay, and this should solve your error. So now if you're opening the ADB shell, then the other error should be gone. All right? Okay. So this is all for this video right now. And let me close this, put this on the left. All right. What have we done? We have enabled developer options. Oh, one last thing maybe, one fun fact. If we go into settings and then within system, there's an Easter egg in here. Is it within system advanced? No, sorry. It's about the phone. Yes. The Android version has some kind of Easter egg in there. So if we press or tap this a few times, oops, this one, then we can see, hey, we got something. I'm not sure if that's useful, but I mean, it's an Easter egg. And if you notice, then you might sound or look like absolute legit right now, right? Absolutely. So in case if you have another version, those versions are named after sweets. It did start with cupcake. Then we've got something like version 6 was marshmallow, nougat, and stuff like this. So it's A to Z, and it's always sweets. All right? Okay. But now, back to this one. So what have we done? Besides playing around over here, we have enabled those developer options. So within System, Advanced, we have now those developer options. And yes, here we have them. So in the next couple of videos, we will figure out what is important and interesting for you and what can be skipped. I mean, there are some really cool options that you might not be familiar with, and those can be super useful to hack games or analyze Bluetooth applications or do other amazing stuff. Alrighty? Okay, so therefore I'm really looking forward to see you in the next videos. Welcome back, guys. In the last video we have enabled these developer options, and in this video we want to have a closer look on them. I mean, we go briefly over most of them, but two are very special. One is the pointer location and the other one is the Bluetooth lock. So for this video right now, we start with the pointer location, which is absolutely underrated. And in this video, I will show you why. So let's have a look. Alright, here we are back at the Ubuntu VM, and yes, we have enabled those developer options. So what we need to do is simply plug in an USB cable into this device. Let's do this. Alright, and then we are opening a new shell and we type in ADB shell to make a connection to see if everything is working. Let's see. Yes, alright. If the screen changes from this fancy color to walleye, then we know now we are on the device. Perfect. This one is working, which means we can now establish we can now transfer the screen on our laptop with screen copy, because this one is using ADB. Alright, here we have it. In case if you encounter some errors, there is a huge section in the cheat sheet which describe, I guess, most of these errors I have encountered in the last 7 years. The things that might occur right now is a screen appearing on your smartphone, because if you do not check this box, do not always trust it, you have to accept it all the time. The other one could be that USB 3 is not enabled on this device. I have encountered this causes some problems. And the last one is that USB charging is enabled. So simply go into the data transfer option on your into the USB option of your device this way. Here we can see charging device via USB. And sometimes, I do not know why, we have to select file transfer and then we also get access to the SD card and things like this. Okay. Alright, in my case, it works with no data transfer, but I have encountered some issues with this. So please try this out. Alright, back to this one. So let's have a brief look into some useful developer options and then a closer look onto the pointer location. Alright, so system, advanced, developer options. Here we have them. I mean, the first one is memory usage bug report. It's regarding to developers, so that's not that interesting. This one, enable Bluetooth HCI Snoop lock. This will be a separate video afterwards because this is super amazing. And we will use this to analyze a mobile application that communicates with a Bluetooth low energy device. Then we will create this lock and see what information can we get out of this, and also how we can use them to hack another application. The tempo is really fast regarding to the beginning right now, but don't worry. This is only in this section where we get introduced to this device and all these options. Later on, if we perform some exercises, we start very slow and then increase further more. Because I do not want to get too fast into one topic. So after this section, after the device instruction, I guess it will be more convenient curve into all this Android app hacking. Alright? Okay. What's also interesting is this OEM unlocking. So the bootloader is already unlocked. The bootloader is being protected, but we can unprotect it by unlocking it. And this means we can now flash custom ROMs on this device. For example, Lineage OS, or also a custom recovery like a TeamWin project, I guess, TWRP it's the short term. So this one allows us to flash a certain binary on this device. For example, the Magist binary, which enables root access on a device. I do not want to go too deep into rooting a device because it's different for every manufacturer, for every version, for every device model and things like this. So it cannot be summarized in one video. But nevertheless, you will find a rooting example for most common devices in the cheat sheet. In case if you have certain questions, write me a message. I try my best to help you out on this. But keep in mind, if the rooting goes wrong, you might brick your device. And rooting is not required for this course, because all we do with root access is already enabled in our virtual machine. So you do not need to brick any device for this course over here, okay? In my case, I had 2 hard bricks. So there is a soft brick, which means we can recover it via software, but a hard brick means we do not get access to this device anymore. And yes, I bricked 2 in my last 7 years. So it was at the beginning, you can really make quickly a mistake, and therefore, be careful if you're doing this. Alrighty, then what else do we have? The rest not that interesting. USB debugging, I mean, this is the key feature. Let's see. Select debug app. This is also pretty cool. we can debug applications on our Android device. And if we select this one over here, it means if we start this application, then a debug port will be enabled, which can be used to attach to it. So we can then attach to this debug port and inspect the memory, change variables, pause and halt on certain functions, and yeah, do a lot of funny things. We will have a chapter on this at the end of this course because debugging, it's a little bit more complex. All right? Okay. If we talk about debugging, then also this wait for debugger, because if we start this application and if we try to attach to this, the application needs to pause immediately. Otherwise, we lose the information if the application has been already started and executed some code. So that's what this one is being used for. If this is being enabled, the application starts, but it doesn't run. So it immediately halts after starting this app, and we can then attach to it and we have the whole code in front of us. All right? Okay. Then let's see. The rest is not that interesting. Wi-Fi stuff, okay. Yes, here we've got the pointer location, but I guess we missed this mocking location, so where we can fake GPS coordinates. Let's quickly scroll up before we dive too deep into this. Okay, for whatever reason, I'm not seeing it right now, but I mean, this is why we have this search button over here. So let's use this, and we are searching for mock. Select mock location app, and here we have it. All right. So this one is also pretty handy. We can use this to fake GPS coordinates for certain applications, but there's a little downside to this one because this does not work for all apps, which means, for example, the Google Maps application doesn't rely on this one. We cannot fake GPS coordinates for Google Maps. It also may affect other applications, but don't worry, I have a better solution for this one. In the Frida section, where we talk about runtime manipulation, we will hook into the memory of our application, or let's say into the memory of our smartphone, and then we can exchange classes, methods, variables, instances, objects, all this kind of stuff. Absolutely amazing, right? So we will use this to exchange the information in the method that retrieves the GPS location for a smartphone, which means every time an application fetches GPS coordinates, we can make the decision what coordinates should be transferred to this application. Which means we can be everywhere on this whole planet for every application on our device. This is absolutely awesome, and yeah, this is what we're going to do in the Frida section, okay? Alright, then back to the pointer location, and let's scroll down, or let's simply use the search. Let's use the search. Pointer location. Alright, here we have it. So, pointer location, screen overlay showing current touch data. You might ask yourself the question, why should this be that hypey right now? Is hypey even a word? I guess yes. If not, we are creating this right now. So why should this be absolutely hypey? The reason for this is we can use this in many ways. For example, if we are testing banking applications, then we have to insert a lot of data all the time. Large numbers and things like this into certain form fields. By having the pointer location, we can address these form fields in our own scripts. We can write short scripts that fill out several form fields, perform events on this device, and yeah, other amazing things. But before I keep talking, why not simply figuring this out, right? So let's enable pointer location, and now we can see we've got a new touch bar over here. So let's go back, now it's a little bit more visible. So here we can see X, Y, XV, YV, and some other stuff. If we now perform and click on our device, we can also simulate it with the left mouse button. And then we've got those lines, which shows us the exact position of our cursor. And on the top navigation, we can now see the X and Y coordinates of our mouse button. If we now drag around, then we can also see where our mouse has moved. So these are very useful information to also hack certain applications, for example, online games. But keep in mind, manipulating online games to get an advantage is not allowed. So you are not allowed to do this unless you have the permission of the author. I couldn't find an author that gives me the permission to do this, therefore I have created my own app. And if I show this right now to you, you might ask yourself the question why I'm still doing app hacking and not app developing, because this application is absolutely awesome. So therefore, let's have a look into this one, because this is a mobile game where the principle this game is based on is used in a large amount of mobile games out there. So let's see how we can manipulate this. All right. Now we have a lot of new topics thrown into this video, and the tempo is really fast right now, but don't worry. During this course, we will start a little bit more slow on new topics, but I just want to give you some impressions what we are going to do in this course right now. I mean, it's not even close to be the final level, but I guess it's already fun at the beginning. Okay, so if we go into the attachment of the section, we will find mobile game. I have already downloaded it. And here we have it. It's named App Game APK. Sounds absolutely promising, but nevertheless, let's install it. So here we've got an APK file, and an APK file, it's a mobile application bundled into this file. This is now a real app. Normally we do not see those files because we install it by the Google Play Store, and therefore we are not seeing an APK. But if you're not installing an application, if you write our own, then we will output it into an APK, and this one can be now installed by the ADB shell. So without having the Google Play Store even on our device. How can we do this? Well, let's see. I'm doing a right click, open in terminal. Later on, we will have an extensive view into all these ADB commands, but for now, I just want to provide you some impressions about this app hacking course. Okay, so if you want to install it, we are using ADB install and then the name. We need to have an ADB connection, so maybe you need to perform an ADB shell to see if everything works, then you can exit out and install it in this way. Otherwise, if you run ADB install, it should automatically happen that an ADB connection will be made to this device. Okay, so yeah, that's all. The application has been installed. Let's see. Yes, here we've got this clicking game, a wonderful, I hope it's visible, a flower. This should be a flower. Let's open this one, and here we have it. Does this look amazing? Absolutely right. So let's close this part. Okay, so what is this game about? I mean, the principle is super simple, and if you look at this, you might think, well, this is absolutely dumb. But I can name you 10 games which exactly rely on this principle that have millions of downloads. Okay, so let's see. We've got some fancy looking apples over here, and yeah, what we need to do is we need to collect them. If we click on an apple, then we can see the score increases, the apple turns gray for a certain amount of time, and during this gray phase, we cannot click it once again. So our aim right now would be reaching a score from about, let's say, 500,000. Okay, let's see how quick we can get there. All right, we are collecting all of them, and we can see they disappear randomly. So there's a random number generator that blocks this apple for a certain amount of time. Okay, I'm at 2,000. You know what? Okay, I give up right now. This is absolutely dumb to play this to level till 500,000, right? So let's try automating this process. And this one is super easy with the pointer location. So here we've got the coordinates, X and Y. And what we can do is we can send touch events based on coordinates. We can also send text and other stuff, but for now, touch events would be right enough. Okay, so let's see. Here we can see the coordinates are 556, 527. We do not need to be very precise because this area is pretty large where we can click on. So I would suggest 520 to 548, for example. Okay, now's the question, how can we send this touch event? And the answer for this one is once again the ADB shell. So let's go back into this one. ADB shell. Okay, I put this on the right side that we can see it. The command we're using is input. And this command looks a little bit complex, but I guess it isn't that complex. So we've got input. Okay. Then we've got the sources, and the sources are D-pad, keyboard, mouse, touchpad, gamepad, joystick, touchscreen, and so on. In our case right now, we want to send an event to the touchscreen. Therefore, we are using simply just the touchscreen. Okay. Then we've got display ID. This can be ignored. Then we've got a command. Commands will be found over here. And then we've got the arguments for this command. So therefore, let's have a look. Input text would mean default location is touchscreen. We can send a text to a touchscreen. This is absolutely handy if you test banking applications, that you have to fill out 10-digit numbers, and yeah, always typing in them on the screen is super annoying. Therefore, you can write your own script based on this one. But we do not want to send text, we want to send touch events, and this is what we are having here, tap. Tap is a touch event on the screen. we can also send swipe commands, which is also pretty amazing. So here we have to define the starting point of the swipe command, for example here, the end coordinates of the swipe command, for example over here, and then the duration, how long we should swipe. So let's say 500 milliseconds, then we would have something like this. Can be useful in games. We will definitely use this later on in an application. I mean, later on in an application, I'm super excited to tell you already about this. We will hack an app to be invincible, invisible, get infinitive lives, coins, high score, things like this. And then we will use the swipe command to fully automate this game. Sounds absolutely ridiculous, right? So we will hack a game and then we will automate this game that we do not have to play it anymore. Yes, it doesn't make it that much fun anymore, but it's really exciting to watch. So this is what we're going to do later on in this course. All right, but for now, let's get back to our game. We want to send input tab and then we need to provide those coordinates. I got a little bit too hyped up right now. Sorry for this. Okay, I focus right now on the topic. So input tab. Let's try this out. Let's get, for example, this apple. 750, 756, okay? 750, 756. We have to wait. Okay, now it's ready again. So I'm doing this in 3, 2, 1. Amazing, right? So we can see the apple has been pressed. What we need to do is simply getting all these coordinates and then performing this in a while loop and we're done. Let's do this. And to do this, I also want to introduce an code editor, which is super handy. The code editor is Visual Studio Code, and this one has some nice features like multi-cursor, which are super handy during this course. To download it, let's simply search for it. So simply Visual Studio Code, and if you go into code.visualstudio.com, then we already get this Debian package. I have downloaded it, and now we simply install it. So over here, I've got this Debian package, and now I'm performing right-click, open in terminal, and now it's, oh yes, I was already typing adb install, but I mean, we are here on the Linux system. So to install this package, we need root privileges and dpkg-i and then the package name. We're inserting our password, and now this Visual Studio Code editor will be installed. All right, it took a while, but we're good to go. So let's close this. And now on activities, we simply can search for code, and here we have it. So now let's open this one. We create a new file, and then we can also select the language on the bottom right. So I mean, we could select, for example, shell script. But our shell script is not that huge that I'm not sure if there's even an syntax highlighting for this one. All right, but before we go into shell scripting, let's first collect these data and then write the script, okay? So we need to get those coordinates. Let's do this once again. 746, 748. 746, 748. This one is 20545. This one is 25664. This one is 134, and this one is 900, 170. Yes, this should be fine. Okay, so now we've got these coordinates and we need to insert input tab in front of all of them. And now we can make use of the multi-cursor highlight. So we can, for example, hit Ctrl F, and then we can provide this one, this asterisk, which means we can play around with regular expressions. I know, I'm also not a big fan of regular expressions, but a few of them are super handy. For example, if you want to insert a text in front of every single line right now, what we can do is we can say, please select me the first character of every line. And all we need to do is hitting this one, which is the beginning of the line. And oh, that's already enough. Amazing, right? So that's already enough. We do not need to have this dot. Yes. So that's enough. Okay. And now I'm hitting Option Enter. And we get this blinking cursor. So now I can simply select or type in input tab. And we have selected or inserted a text in front of every line. So we have now the half of our script already ready. But first, let's see if the coordinates are correct. So let's copy them. Now let's go back into our ADB shell. And now let's insert them. Okay, 2, 3, 4, and 5. Perfect. All coordinates has been hit. We have get a lot of points, but we do not want to repeat this over and over again. We want to have this in an infinite loop. And yes, I'm not even being close a good bash scripter, but at least some basic features are available for me right now, and these are enough during this course. I guess we are not using bash during this course anymore. Yes, we are not using it because later we rely on Python. But keep in mind, if we are performing something with ADB, if we get the Python framework on our laptop, then we can also use this in a script. But all the time an ADB connection is being made, the command is being executed, and we have to wait. So therefore, in my opinion, the best option to run a bash script for this device is running it on the device, like in this shell over here. Okay, so that's the best performance, even if the performance is at all not that good. All right, but back to this one. So how can we put this into an infinite loop in bash? One option is looking on Stack Overflow. I guess this is also the best option, but I mean, this is something which is not too hard. So we can simply say while true, and normally I would immediately add this colon, but this is Python syntax, not bash. So while true, then we have to tell where the loop begins. We are doing this with do, so please execute those commands. And then we need to tell when we are finished, so simply done. And that's all. So this is our whole script to hack this game over here, which can be applied to other online games, but therefore you have to ask for permission. All right, so let's copy this. Let's put this on the right, and then let's start this in 3, 2, 1. Oh, nice, isn't it? So now we can lean back and relax while this app is being played by the script over here. So this principle, I mean, it doesn't look that nice, but you can imagine a lot of games where exactly this one is required. Sitting there for hours and hours and simply hitting your screen to collect certain things. Alright, so this is all for this video right now. You do not have to wait until you hit the 500,000 points to move on in this course. If you want to stop this, we can simply hit Ctrl+C and then the script simply stops. As already mentioned, at the beginning, the tempo right now is a little bit high, but all of this, take this as an impression and not as a learning experience. Regarding to the next video, we will have a look into the Bluetooth low energy connection, and this one might be also a little bit overwhelming at the beginning. I just want to show you some tricks to analyze this, and during this course, it's not longer being required. So during this course, we will perform some really awesome and complex hacks, but we will explain them very deeply. So we will start slow and then we will raise this curve slowly and steady, okay? So yes, as already mentioned, take this as an impression, and otherwise I'm looking forward to see you in the next video. Welcome back, guys. This video will be absolutely wild. I mean, you can see this already regarding to my hair, but in this video, we want to do something which is not 100% related to Android app hacking. But I mean, nevertheless, come on, let's have some fun over here and let's have a look how we can analyze a Bluetooth low energy connection. Why is this important? Because normally we've got our device, in this one for example, and this is making an HTTP or HTTPS request, I hope it's HTTPS, to a web server. So this device is using the Wi-Fi connection or the mobile carrier network to perform this network request. And this is something we can easily sniff. We will have a look into this in the man in the middle section. But nowadays, we are not just dealing with apps and servers, we are also dealing with a lot of IoT components. For example, this toothbrush over here. I mean, you can see, I'm not using it very often, but it would be important to use this. So this toothbrush got an app, and they are communicating via Bluetooth low energy. The question is now, how can we analyze this connection? I mean, this is not in web traffic right now, this is Bluetooth low energy, and we cannot have a look into this connection because these are radio waves. An easy solution for this one would be logging the traffic that the application is receiving and sending to this toothbrush on the device. And this is exactly what we do in this video over here, and then we can use this knowledge to also extend this to other devices. For example, to this one over here. This super annoying fluffy little Furby. So are you ready for this? Then let's have a look. Alright, back at the Ubuntu VM, the first thing we want to do is enabling the HCI Snoop log in the developer option. And therefore we need to have a real device. I mean, not to enable this, but later on to communicate with a Bluetooth low energy device. Because this is something we cannot use in an emulator. the Bluetooth protocol cannot be emulated and sent out to a real device. That's not possible. So in case if you want to play around with a real Bluetooth low energy device, I mean, you nevertheless have to get a smartphone, right? Yes, absolutely. Okay, so let's do this. I plug this into the computer. All right. And then I can use the terminal to show you the screen on the smartphone. So running screen copy, there we have it. Oh, by the way, I did change the desktop background. So let's put this on the left. So the black background was not that nice to view regarding to the smartphone. So therefore I have chosen it a little bit brighter. Okay, so let's enable the HCI Snoop lock. We go to settings and then within, let's see, the system, advanced, developer options. So here we have them. And then I'm searching for Bluetooth. Okay. HCI. There we have it. Bluetooth HCI Snoop lock. Let's click on this. And here we can see it's being disabled. So let's click on it. And here we have now two options. Enabled filtered, but we do not want to have filtered. We want to have everything. So we choose enabled. All right. And that's all. The only thing we have to check is that Bluetooth has been enabled. Yes. So this is all we need to do to create this log file. So now all these Bluetooth connections will be logged into a certain file, which we can then later pull from this device and use it within Wireshark. Awesome, right? So let's see. As already mentioned, I've got this toothbrush over here and this one has an application. And no, I'm not getting paid by Oral-B to show all of this. But I think having this toothbrush over here illustrates this pretty nicely. So this is let's say an IoT device, and this one is communicating with a real smartphone based on Bluetooth Low Energy. Alrighty? Okay. So if I open this application, let's see. We are greeted and we can see connect to a toothbrush with this app and brush like a pro. I mean, this sounds absolutely awesome. Let's do this. Let's click start. First, allow location services, of course, but this is unfortunately something that comes with Bluetooth Low Energy. So that's unfortunate and permission we have to use quite often regarding to this one. Okay, only this time. And connect your toothbrush. All right, start. And now all I need to do is pressing this power button. Found. So we can see this toothbrush has been now connected to this real smartphone over here. Amazing, right? Okay, so we can go ahead. Oh, let's see. Terms. I'm at least 18 to brush my teeth. All right, sounds pretty ridiculous. Let's brush. Okay, now if I press this power button, then we can see this pop-up appears and it's super annoying loud. So we can see pause brushing, session ends in something like this, and we can also, let's see. No, it has to be on. Okay, so I'm re-enabling this. We can see reduced pressure. I'm brushing way too hard my teeth right now. All right. So all of these information are being transferred via Bluetooth Low Energy to this smartphone application, to this one over here. And yes, now we want to analyze them. So we have logged every single request right now, and now we can pull those data from this device and analyze them in Wireshark. Awesome, right? So let's see. Okay, to do this, we need to get the HCI Snoop log file from the device. And unfortunately, this is sometimes a little bit ridiculous hard. So it depends on the manufacturer, the device, and also the version where this file is being stored. But I've got an easy solution for you. The easy solution would be creating a bug report, and this bug report includes this file. This bug report also contains a lot of other information which is not really necessary or relevant for us right now, and it costs a little bit more time generating this, but at the end it's the easiest way to fetch this file. Alright? Okay, so let's see how we can do this. Oh, I need to brush my teeth a little bit longer the next time, but I'm even glad that I'm using this device right now, so this application shouldn't complain. Alright. So let's open a new terminal, and then I'm using ADB bug report, and then I need to provide a file name. Let's call this brush.zip or brush_report zip. I mean, as already mentioned, this is not just the Bluetooth HCI Snoop log report right now. This is everything. It's also interesting to have a look into this one, but I guess right now let's focus only on Bluetooth. All right, let's hit this and yes. I also got a little vibration on the device, but it automatically starts. This might take a few minutes because a lot of information are now being gathered, and I will fast forward this process that we do not have to wait that long. Alrighty? Okay, so here we are back. I guess it's finishing pretty soon. But don't get fooled by this status bar over here, because it immediately jumped to 93% and then it got stuck for a few minutes right now. Okay, so let's see. In this file, by the way, there we have it. If we are using ADB bug report and then the zip name, this one is being executed from our host system. So the ADB command is connecting to this device, creating this report and automatically fetching it on our host system. So wherever we have started this ADB bug report, there should be now a file named brush_report.zip. And let's see. Yes, here we have it. So we can see it's 5 MB large. Let's extract this. Okay. And here we've got now tons of information. So this is sometimes also useful for applications because we can find a lot of things. We can see crashes, application states, and much more. Right now we want to focus on the HCI Snoop log, and to be honest, I guess it's within FS, but I'm not sure where it is here. So let's see. Proc, by the way, yeah, that's the memory. So every ID, it's the process ID, and we will find memory information of this process. So pretty awesome, but back to this one. So I'm now in the FS directory, and I'm simply searching for HCI. And here we have it. It is within data misc Bluetooth logs. So let's go into this directory maybe. Whoops. Data misc Bluetooth logs. Yes. So here we've got last and we've got this HCI log. This is now a file which can be directly opened with Wireshark. So therefore let's see. Let's perform a right click, open a new terminal, and now let's use Wireshark on this file. In case if you do not have Wireshark installed, it's pretty easy. We can simply run sudo apt-get install Wireshark, and then it will be installed. I guess the only question that you have to answer is if you want to allow capturing packages for root users or also for normal users. So normally I start Wireshark with root privileges and therefore I select just for root. But running Wireshark as root can be also pretty dangerous. Wireshark is a package parser, and if you run this in a not trusted environment, it can be possible that an attacker sends a crafted package and compromises your host based on Wireshark. In the past there were some exploits which demonstrated this behavior, but in my case right now I'm running this on a virtual machine in my trusted environment, so therefore I'm pretty confident starting this as root. All right? Okay. So after installing Wireshark, we are now using Wireshark on this BTN Snoop log. And here we have it. Awesome. So this is now the whole communication between this toothbrush over here and this mobile application. So all these packages that has been exchanged between those two are now in front of us, logged in this file, which can be opened in Wireshark. Absolutely awesome, right? So now we can investigate which data has been exchanged, and we might be also able to manipulate or interfere with them. Let's have a look. All right. So if you're looking at this file, it looks a little bit strange because normally if we are opening a file with Wireshark, we expect some IP addresses because this is where we normally use Wireshark regarding to analyzing network connections. But now we are not analyzing a network connection which has a source and a destination IP address. We are now looking at a radio protocol at Bluetooth Low Energy. But the good thing is that all these bits and bytes which has been exchanged between those two devices can be interpreted by Wireshark. So Wireshark is fetching all these bits and bytes and passing them into those Bluetooth headers, which makes the analysis a lot easier. All right? Maybe not, but nevertheless, let's have a quick look into this one. So the good thing is everything between host and controller can be simply ignored. Nice. So we have to scroll down to find our connection. And let's see. Here we have it. All right, let's scroll up a little bit to find the first package. Okay, I guess it's this one. And it's even more amazing because Wireshark is showing us that this one, this is now the source, this is our pixel device. How does Wireshark know this? Well, we can see HTC and then we can see 3 bytes. So the MAC address consists of 6 bytes. And the first 3 are regarding to the vendor ID, which means in this case HTC. So Wireshark knows, okay, that's an HTC vendor, and this one is, it's known for a pixel device. The last 3 bytes are being shown over here. So these are just the last 3 bytes of our MAC address. And the same, of course, for our toothbrush. But now it's a little bit strange. Why do we have Texas inst over here? I mean, we can see those last 3 bytes, but what is this? Once again, this is the vendor ID, which means this toothbrush has most likely a chipset in here from Texas Instrument. So Wireshark doesn't know that this one here is a toothbrush, but Wireshark knows, okay, the chip in here is from Texas Instrument, so therefore it's displaying these information. Also pretty awesome. I mean, without opening this device, we now know that this one has a Texas Instrument chipset in here. All right. So further investigation, we simply just replace in our mind Texas Instrument with toothbrush, okay? Okay. But now it's getting a little bit rough. I mean, this course over here is designed regarding to Android app hacking, finding and identifying vulnerabilities in mobile applications. We are now looking at the Bluetooth Low Energy connection, which is not 100% related to this course. But nevertheless, Bluetooth Low Energy is all around us nowadays, and it's often used in IoT devices, and those IoT devices often also have a mobile application. So it could be the case that a vulnerability within this mobile application can be exploited based on a Bluetooth Low Energy connection. And therefore I would like to cover it in this video over here, but only on a high level. So we do not dive too deep into this. I just want you to enable to understand what's going on over here in this connection, that you are able to identify and also exploit this on your own, so that you can identify those vulnerabilities and send them to the vendor that they can be fixed. Okay? All right. As already mentioned, Wireshark is able to pass these packages while we get all this information within this info tab. And this is absolutely nice. And for example, over here, we can see the source, pixel device, destination, toothbrush, and this one is type request. So our smartphone is requesting something from the toothbrush. We do not know what, but we know it's a type of request. Okay. Then we can see we've got get primary service declaration. And this is something I would like to discuss on the graphic tablet in a little bit more detail, because there I can explain it way better than here right now. For now, get simply stands for generic attribute profile, and it's working in the following way. If we're having a mobile application, this mobile application is asking this device, hey, what services or characteristics you offer. Those services and characteristics are simply just information. For example, the information how long we are brushing, the information if we are brushing too hard, the information if we have switched the mode of our brushing routine, and things like this. So these are just data which can be requested. Okay? All right. And then let's have a look. Everything between controller and host can be ignored. And this means here we are having now as source the Texas Instrument, so the toothbrush. And this one is now responding to our request. So this is the response regarding to our request. And this one is now answering with all these information we have asked before. Okay, let's scroll down a little bit. Because here we can see those packages. I mean, we've got the timeline on the left. Those packages will be sent more frequently, which means this could be the routine where I have actively used this as a brush. So therefore, okay. This one, for example, source is the toothbrush. This one is now sending a response, and let's make this a bit larger. Yes. So here we have now a lot of things. So we can see we've got something with get, characteristic declaration. We will have a look onto this one on the graphic tablet. Then we can see properties, write and read. So we can write and read from this characteristics. And then we've got this long UUID. So if we understand this package right now, I guess we have a good understanding about the Bluetooth Low Energy. Therefore, I do not want to dive deeper into those packages. We just take those information with us on the graphic tablet. We can see we've gotten get characteristics. This one has some properties, write and read, and we've got this long UUID. We can also open this one, but yes, it's not providing any more information. We can just find a service UUID beside this characteristics UUID. All right? Okay. And now let's switch to the graphic tablet, and now let's have a look what all of this information means right now. So therefore, let's go. Back at the graphic tablet, I really had to get rid of my sweater because now we are doing some hot stuff. Okay, no, I'm not going to make this joke till the end. All right, so back at the graphic tablet, now let's have a look at this connection. On the left, we've got our well-grown smartphone, this one. Smartphone. Okay, and on the right, I mean, could it be even more exact? I give you this example. Could it be even more exact than this one? Absolutely not. So no further label is being needed, but nevertheless, let's also name this toothbrush. It just took me, I guess, 1,000 attempts, and we have to deal with this one right now. Okay, so the Bluetooth Low Energy connection consists of a server and a client. The server, this one, is advertising its existence to the client, which is in our case right now, the smartphone. But during a connection, this could also change. I mean, the server can also interact as a client in the same connection type. So it doesn't mean to be that the server always stays the server. But let's make this not more complex right now. So the server is advertising its existence via 3 different channels. This is important. Okay, why is this now being important? Well, if we're using a smartphone, it isn't. But if we're using an external device, for example, this one over here. This is an Bluetooth, and we can see it has a large antenna because the Bluetooth Low Energy is on 2.4 gigahertz. So this device is capable of sniffing Bluetooth connections near around me right now. So I could listen to those connections, and if they are not being encrypted, then I can see all the data and also interfere with them. The problem by using an external device is having those 3 advertisement channels. Because if we are listening on the first one, on this one, with our Bluetooth, that's an ear by the way. Okay, it's definitely an ear. So if you're listening on the first one and the devices are using the second advertisement channel, then we are not sniffing anything. Which means we need to get 3 of them to make sure that we really fetch this communication between those devices. Or what I did in the past, I did run 20 times the same task to make sure that at least one has been successfully completed, captured. If we are using a real smartphone, we can completely ignore this. This is just a hint if you're using an Bluetooth device and sniff a Bluetooth connection and wonder why is there no package in here. Okay? Alright. So luckily we are having a real device, and therefore we do not need to take care about those 3 advertisement channels. By the way, beside these 3 advertisement channels, the Bluetooth Low Energy protocol is in total using 40 channels. Which means 3 are being used for the advertisement. 37, quick math, are left for data transfer. Okay? Okay. So right now we do not need to take care about this one. But this information is super handy if you want to sniff in connection with an external device. Alright, let's clean this. Okay, so now we have our smartphone and the toothbrush, and the way the communication works on a high level is as follows. So if we turn on this toothbrush, here we can see it's being pressed, then this one is advertising itself and telling everyone, I am here. Alright, the smartphone, which is the client, needs to scan for those devices. So the smartphone needs to look if a toothbrush is near around us. I mean, we can identify those toothbrushes based on the vendor ID right now. But it could be also the case that we are having a different device with a Texas Instrument chipset and it's not being a toothbrush. Therefore, we're getting this information within this mobile application. If we are really connecting now to our toothbrush, it could be also a different device or another toothbrush. So this information over here. Okay, after connecting to this device, the smartphone is now requesting information from this toothbrush. So the generic attribute profile. And profile within the toothbrush, it's just a known set of information. For example, this toothbrush has a profile. So this is the profile. Okay. Within this profile, we are now dealing with services. Services. And within those services, there's only one left, then we are done. Within those services, we are now having characteristics. Okay, so I hope you can still read this. And characteristic is simply just a data type. So it could be the information about the brushing time, the brushing mode, the brushing pressure, and things like this. Everything related to brushing could be summarized within a service. So to make this a little bit easier on the right, let's write this in the following way. So let's clean it first. Okay, so we are now having several characteristics. For example, one could be brush mode. One characteristic could be brushing time. And one characteristic could be also the brushing pressure. So brush pressure. Okay, so this one, it's pressure. Okay. All of them have something to do with brushing. So they can be now categorized, or let's say summarized, within a service. So a service can have many characteristics, and a characteristic is just a set of data. For example, brush time. So these are now those characteristics. Okay, if the smartphone is now requesting data from the toothbrush, for example, about the brushing time, then it has to ask this characteristic. And to ask this characteristic, we are having this UUID. This UUID is this long identifier based on hexadecimal values. So, and so on. So this is just a unique identifier for this characteristic, and it also has to be unique. So we can define our own custom characteristics, but they are not allowed to interfere with existing ones. So some of them are documented and defined as a standard, and some of them can be also defined by yourself regarding to certain sensors and things like this. So if we want to fetch data from a characteristic, we need to provide this UUID. So the smartphone is now simply telling, okay, I want to have this brush time, and this brush time has this UUID. So the smartphone is simply sending this request, okay, give me some data regarding to this brush time. And then the toothbrush is answering with those information. So we can have different type of access groups. So for example, this characteristics can be only read. This is just a read permission. Okay, then we can also have write. This means the smartphone is able to change those data in this characteristic, so within this toothbrush, or we can have something like notify. Notify simply means the client has to be configured for this, but notify simply means every time a value changes, the toothbrush is automatically sending this information to this client, and the client can fetch this. This is quite popular regarding to certain sensors, or could be also the case regarding to brushing time or things like this. Okay? All right. Beside this, we have a lot of more options. For example, we've got requests that require a response, requests that do not require a response, and other stuff. But I guess for now, it's okay to have a high-level overview like this one right now. So over here, we have now summarized everything. The smartphone is asking the toothbrush, okay, what services do you offer? And the toothbrush is answering with the following, for example. If we want to fetch data from a service, we have to address this by the UUID. Addressing this UUID also requires certain permission. For example, this read, write, or this notify permission. Okay, so this is Bluetooth Low Energy in a nutshell. The key takeaways are, if you're using an external device, like this Ubertooth, then you have unfortunately to set it up 20 times to make sure that you definitely have fetched this connection. But if you want to analyze a mobile connection, then you do not need to worry about this. Regarding to our toothbrush, we do not know what those UUIDs means. What is the UUID for the brushing mode, the pressure, and things like this. To find this out, we have several possibilities. The first one is simply searching online for those UUIDs. So simply just take the hex string and put this into the search engine of your choice. Sometimes they have been documented in some SDKs and things like this, and you can find additional information. In our case, it is exactly this the case. So Oral-B, the vendor of this one, is providing an Android SDK where developer can write applications to communicate with this toothbrush. And this SDK has additional information, or let's even call it exact information, about the characteristics and their purpose. So I will show you afterwards within the Wireshark dump that we can match them regarding to the documentation online. In case if we cannot find any related information, we have to try harder. So what we need to do then is we need to repeat certain actions over and over again. And for example, turning it on and switching between those modes. And we have to do this quite often, really often, and then identify certain patterns. Often just a single byte changes, or we are requesting the same characteristic over and over again, and then we can figure out, okay, this UUID is serving the following purpose. All right? Okay. Weaponized with this knowledge right now, we will have a look into the existing Wireshark dump, but then we will also start hacking something. And the thing we are going to hack is this one. This fluffy, annoying little Furby. So this one is also communicating via Bluetooth Low Energy, and I will show you a really nice mobile application which is capable to fetch all this information, these generic attribute profiles and those UUIDs characteristics, and also gives us the possibility to send data to them. All right? Okay, so first let's have some quick look onto this toothbrush and then on this Furby. Let's go. Back at the Ubuntu VM, we now understand all of this a little bit better. And for example, we can see we've got here in response, and it's an attribute list. Okay, this is something we do not know right now, but we can see, okay, we are returning the following service UUID. This has the following characteristic UUID, and we can also see, where do we have it? Here we have it. Properties, notify, and read. So we are not allowed to write to this service or characteristic. Right now, we still have no clue what this one is doing. So as already mentioned, we can figure this out by ourselves by repeating those actions over and over again, or we can simply look them up online. Oral-B is providing an SDK for Android developers. Unfortunately, it's not available anymore. So on developer.oralb.com, we can see that the store is currently unavailable. But if we take a look into the Internet Archive, which is a pretty good source regarding to things like this, we will find out that in 2022 only one state has been saved, and this is exactly what we're having here. So if we go back a little bit, for example in 2018, then we can see we've got a few saved states. So let's have a look at this one. Let's click on this snapshot. And now the Internet Archive is showing the site which has been stored at this given date. And there we go. The Oral-B developer program will be shut down on 15th of April. So I guess it won't be available pretty soon right now. Sometimes we can also find some cached files. For example, this SDK. Unfortunately, this time we are not that lucky. So if you're opening this link, we can see this URL has not been archived. The web archive itself, it's an amazing project and very helpful. So I have encountered some lost firmwares in the past regarding to the help of the Internet Archive. So you should definitely check this out if you're looking for something and the current link is not available anymore. Alrighty? Okay, back to the video. Okay, without having the SDK, do we still have a chance to identify what these UUIDs are? Yes, because if you're searching online for this, we can still find some references to them. For example, this UUID. So let's see. I do a right click and then copy value. Okay. Here I already have downloaded such a reference. And if you're now searching for this one, then we can see this one is now this service. And this service summarizes several characteristics. For example, this handle ID. But I mean, we do not have an exact definition what this handle ID is really doing. We do not have a certain description, I mean just handle ID, But here we can now see all these UUIDs and the things they are good for. For example, this one, if we read and value from this one and smiley appears on our smartphone. This is something we could trigger by ourselves with an external device, like the Ubertooth, which has been shown before. Okay, nevertheless, let's see if we still can identify this by ourselves. So within the introduction of this mobile application, I did brush my teeth very hard. So there were a lot of warnings regarding to the pressure of this toothbrush. So let's see if we can find this information in the Wireshark dump. Okay, and therefore I guess we have to scroll down, because these packages, they should be sent quite often if we turn on this device and brush our teeth. So let's see. Here we already have many, but I guess that's, yes, okay. Here we had quite a few. Yes, all right, this looks good. So we can see all of them are regarding to the following handle. So this UUID, and we can see we are sending the value C0, okay? C0, 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 all right. Yes, 0 and what was the other one? 05. Is it the exact? No, this is a different handle. We need to be very careful regarding to this one. So we can see C0 and yes. So, whoops, sorry, on the left. So far, yes, okay. C0 and 00. So these are the two values we are sending to this characteristics. So let's see, oh, sorry, this service. So let's see what this UUID is good for. Okay, copy and then value. And let's look this up. And let's go down. Unfortunately, it's not regarding to this one. Oh, yes. Are those two the same? I guess not. Let's see. Yes. Okay, sorry, my bad. We can see perfect pressure sensor. This one is the service UUID and this one is the UUID we are sending those data. And if we have a quick look into this one, they look identical because these UUID, they have a certain prefix and everything also is pretty identical. Most of the time, just a single byte in there changes. Let's see. Copy value. I make a new one. This was the first value and let's also compare it with this value. And, well, okay, here yes, I've got it. This character. Let's see. Yes, just one single character. Instead of 0, it's B. So we need to be very precise when we look at those information. Okay, so here we can now see, yes, this is now the pressure sensor, and by getting maybe the value 0, everything is fine. And by getting C0, we are brushing way too hard. Okay? If we now want to attack this mobile application, we have to think in the following way. We've got our smartphone, which is running the mobile application, and we've got our device. So we could impersonate our device and then send arbitrary data to the smartphone. Or we could have a device and we can pair with this device and sending arbitrary data to this device. So we have to analyze both endpoints regarding to vulnerabilities or exploits in there. Okay? All right. In case if you have any questions regarding to this topic, please drop me a message underneath this video. And now I would suggest let's have some fun. Let's hack this super annoying little Furby. All right? Okay, let's have a look into this one. Alright guys, so here we have now our Furby together with our smartphone, and I would suggest let's simply start hacking this. So the first thing we need to do is we need to wake this Furby up, because after waking up the Furby is advertising itself to this area over here and we can pick it up. Okay, so let's do this. Okay, so I'm just pressing a button on this Furby and the Furby becomes quite loud. I hope it's not that hearable, otherwise I have to pick up a separate microphone. So let's see. Okay, so the Furby is now waking up and we can now connect this Furby to a mobile application. Unfortunately, this mobile application is also not available anymore, but that's not a big deal because some people have reverse engineered this whole protocol and have created their own app which can talk to this Furby, even if this Furby is talking all the time in the background. Yes, okay, so let's switch back to the desktop and have a look into this mobile app. All right, so let's log in. Here we have it right now. So that's a mobile app. You can find this on pdjstone.github.io. So the whole Furby communication hack has been identified by a German student, which nickname is Jaja. But some people have extended the things he has discovered and yeah, have written some awesome apps. For example, this one over here. So now we are clicking connect. By the way, this is just a Chrome browser, but the Chrome browser is also able to do Bluetooth Low Energy. And we can see we've gotten Furby over here. Awesome. Let's pair with this one. And there we go. So now we are paired and we can see, yes, the antenna colors of this Furby have changed quite often. So now we've got this mobile app and we can now change the antenna color over here. For example, to red, green, blue, and white. Red, green, blue, and white. Red, 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 red. Okay, so I guess we have enough data right now. Let's disconnect from this Furby. Let's put him asleep. Let's put him asleep once again, that it's not that annoying anymore. All right, and now let's fetch the data from the smartphone and analyze it within Wireshark. Okay, so let's switch back to the desktop. Okay, and now open a new terminal, ADB bug report Furby. Once again, this report will fetch all the data, not just the data related to Bluetooth Low Energy, but sometimes this file is not accessible on smartphone and I would like to provide you a solution that works all the time. Afterwards, we will have a look into the Wireshark dump and we will try to identify the concept behind this antenna color, and then I will show you some really awesome things that we can do with this Furby. All right? Okay. Do not get fooled by 93%, this will take quite a while. So I will see you in just a moment. Okay, so here we have it right now. So let's put this on the left. I guess we can close this right now. All right, and let's investigate this. So here's our Furby zip. Let's extract it. Within FS, data, MISC, Bluetooth, logs. We've got now the Bluetooth, the BT Snoop HCI log, and this is the last log. So the last time we have used this one. So let's open a new terminal, right click, open a new terminal and open this file in Wireshark. Guys, sometimes it takes a while until you realize that the camera is blocking all the important stuff you just wanted to show right now. So therefore, let's have a look into this file once again. We are still talking about the Bluetooth Low Energy capture between the smartphone and the Furby application. So we have changed the antenna color from red to what was it? Green, blue, and white. This, I guess, a couple of times. And then at the end, we have changed it to red a few more times, right? Absolutely. Okay, so let's have a look. The good thing is we can still ignore everything between host and controller, so we can scroll down. Okay, we have to scroll down quite a lot. And here we have it. So let's scroll up again. Yes. So here we can see HTC, last 3 bytes of the MAC address. This is our Pixel 2 device. And here we have now the full MAC address. So the Furby is broadcasting its name. Okay, this is awesome because now we definitely know that this is the Furby device. But the vendor of this MAC address is not known to Wireshark. I mean, it's not a big deal. We have already identified this device and I guess there isn't another connection in there. So we can be sure that this is our Furby device. All right, let's have a look into this one. Once again, the smartphone is sending a request and asking for the generic attribute profile of this Furby. And here the Furby is responding with this one. Yes, here we can see generic access profile. So the smartphone is simply asking the Furby, hey Furby, what services do you offer? And the Furby is simply responding with a list of characteristics and services the Furby offers. For example, the antenna color. Okay, so let's see if we can find this package regarding to the antenna color. And let's scroll down a little bit because we have seen the exchange of information. It takes quite a few packages. Okay, So what I'm looking for are packages right now from the smartphone to the Furby. So let's see. Yes, I guess here we've got a bunch of packages which comes from the smartphone. Okay, let's investigate this. So here we've got now the Pixel 2 device and our Furby, and we can see we have a write command. This sounds absolutely interesting because the smartphone is telling the Furby to change the color of the antenna. So it's most probably an write command, this one. Okay, so we can see, yes, we are sending this to the Furby, write command on this handle. Let's open this one. And this is now the service UUID, and this one is the characteristics UUID. So I guess they are different once again. So we are writing to this UUID this value, 14FF0000. Okay, let's have a look into the next package. What is also interesting over here is that the write command does not await a response. So we are just simply sending a command to this Furby, but we are not awaiting that the Furby is answering to this one. And so we can see we've got a bunch of requests over here, but none of them has as a source the Furby in here. So we're just sending requests from the smartphone to this Furby. Okay, now I would suggest let's have a look into the other packages and let's observe how the value over here changes. So let's take this package. Okay, it stays the same, also the same, also the same. All right, and let's go up a little bit. What do we have here? The same. Now it changes. All right, it changes from FF0000 to all Fs. Okay, this one. Oh, it changes once again 0000FF. This one once again 00FF00. Okay, so we already got a good feeling that this one is related to the antenna color. And if we think of the steps we have done, let's open this one. So we have sent the antenna color red, green, blue, white, red, green, blue, white. Maybe once again, not sure about this one, red, green, blue, white. But then we did send red, 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 red. And then we didn't disconnect. So the last packages in our connection regarding to an handle, which has been requested quite often before, should be our antenna color red, right? And let's see. Okay, so here we are having the handle 0026. Okay, this is now the value 2006. Okay, and let's see. This one is 14FF0000. Okay, let's go up a little bit. 14FF00, 14FF, 14FF. Okay, so this one seems to be the code for changing the antenna color to red. And now it's up to you. Can you already figure out how this code is being constructed? That, for example, we can send an antenna color which is not included over here. Let's choose an antenna color like yellow. All right? Think about this for just a moment and then I will provide you an additional hint. Alright, in case if you could already solve this, perfect. This is how you analyze Bluetooth low energy connections and also, play around with this one. So to identify patterns and reconstruct what these bits and bytes could mean. In case if you couldn't figure it out already, absolutely no problem. We have just observed one package, but we have access to many packages. So let's see. Before we did change to red, we have used white, which means the package, when it changes, it should be the representation regarding to the color code white. And let's see when this happens. Okay, here, nope. There we have it. Okay, here changes right now the value, which means this is now the representation of white. So maybe one more package. If this one is white, the package before should have been blue. Let's see. All right, and I guess with this information, it might be clear right now. So we've got the 14 in front. Okay, and then we are having 3 bytes regarding to the color. Might this be RGB? So red, green, blue? I guess it is. Let's see. If this one is blue, then before we had green, which means if those 2 bytes are red, then we should have 00, FF for green, 00. Let's see. Perfect. So it's simply just a color code in RGB format. The 14 in front means the addressing of the antenna color, because the last package we have seen over here is regarding to the same handle but has a completely different structure. All right? Okay. So our task right now would be sending something which is not included in this application. For example, the code regarding to yellow. So do you know which bytes we need to send to this characteristics? So to this UUID. So how these bytes should look like? Think about this for just a moment and then we will do the solution. But I guess you already figured it out. So let's see. Okay, so here we are back right now. So if you want to send the color code for yellow, we have to use red and green, which means the package should look like as follows. 14 FF for red, FF for green, yes, and 00 for blue. So it's sometimes a little bit hard to memorize all these color stuff, but yes, a 14 FF FF 00 should be the color code for yellow. And I mean, this one is not being included in this application. So if this works, we have additional features which has not been implemented over here. Absolutely awesome, right? And this is how we analyze in Bluetooth Low Energy connection. I mean, those service UUIDs and also those characteristics are now well documented and we could look them up. But this is something you can do afterwards if you want to play around with this one. I mean, you have to get the Furby, but this is something which gets super fast, absolutely annoying. So therefore, I'm not sure if you want to have this. All right, right now, let's try this out. Let's figure out how we can enumerate those characteristics on the Furby and most importantly, how to send data to this one. Are you ready for this? Then let's go. Let's finally start hacking this Furby. Okay, so the application we need, or I recommend, is the application from Nordic. So this one over here. I will also provide you a link regarding to this one, NRF Connect. Let's open this one. Okay, we can see it's immediately starting scanning, if Bluetooth is enabled, of course. And we can also see here we've got our Furby. Perfect. Let's connect to this Furby. And here we can see we've got client and also server right now. If we go back to the client, then we can see we've got now generic access, attributes, and also unknown services. Let's enlarge this. Perfect. Here we can now see all those characteristics and we can also see notify, read, write, no response, notify and read, and so on. So the only thing we need to do is we need to identify the UUID DAB91 over here, and then we need to write this value 14 what was it, red 14 FF 00. I guess this was the value. So let's see. First, the hard part is identifying this, because we have seen it could be only one byte making the difference between this UUID and another one. Okay, so first of all, we can also navigate around, because this upper arrow key means we can write to this characteristics. So therefore we can already ignore things like this one. Okay, so is it this one? No, it's not this one. Yes, I guess I have found it. So I would assume it's this one over here. Let's see. Okay, now we have to be very careful, because we are writing now to a characteristic and we could damage or break this Furby if we are not knowing what we are doing. Okay. So I really hope you know what we are doing. Let's see. 40 FF 00. And now let's observe the antenna color of this Furby. Let's see if it turns yellow in 3, 2, 1. Perfect. Nice. We can see this antenna color, this antenna color this way has turned yellow. So this feature is not being enabled in the application over here, but yeah, we have identified this on our own by analyzing the packages we have sent to this Furby. It immediately turned off, but I guess this is, if we send it again, it should stay. Let's see. It should Furby FF 00. Okay. Send. 3, 2, 1. Yes. Okay. Now it stays active. Not sure how long, but we can see, cool. We can interfere with this Furby and also, yeah, perform certain action that has not been defined in this way. Nevertheless, JADX already did an amazing job and has a lot of nice features found in this Furby. For example, this one over here. And let's get back to this application. This, by the way, is not the application that JJ has written. JJ has written this in a Blue Fluff application, but this requires Node.js, and this one can be used even within Chrome browser. So let's see. Let's connect back to the Furby. Okay, let's connect to this one. All right. Beside those antenna colors, we've got some other amazing features. For example, we've got debug. And here we can, for example, turn off the eyes of the Furby, 3 to 1. And we can also enable this once again. But no, the most amazing part within this Furby is the debug command, because this one, it's the command db. We can also send this on our own. And this one will print out a terminal interface on the eyes of this Furby. Sounds absolutely crazy, right? And it is. So therefore, let's zoom in a little bit, have them side by side, and then let's see how it looks like. Okay, now we have them side by side. Let's see. I'm pressing debug in 3, 2, 1. There we have it. Awesome, right? So we can see a terminal screen appears on those eyes. Let's zoom in a little bit more. Awesome. So we can see wellness, fullness, and things like this. We can also cycle through this debug command. There we have it. So now we are getting even more information. So this is pretty cool, but it can be even cooler because beside these features, we also got something like actions. And here we can see legendary, it's a predefined action, which is already included in the Furby. So the Furby is capable to do some animation in their eyes. For example, regarding to a chili pepper or regarding to stars, a melon, things like this. This is a special file format which has been created by Hasbro, so the vendor of the Furby. And yeah, some people have reverse engineered and created their own files. Before we go into this one, let's play the existing file. So over here, let's do this in 3, 2, 1. Furby, how is this course?
Legendary!
Absolutely. So Furby is screaming out that this course is legendary, and I'm pretty. These are predefined actions which can be triggered by a Bluetooth Low Energy. And now finally, let's flash a custom file, a custom DLC file to this Furby. This file has been already created by some guys from the Context company, and I'm just reusing it. So no credits to me, all credits to Context, but this one, it's pretty nice. So let's do this. Let's zoom out a little bit. There we go. And now let's choose something really cool. So this one, this hacked one, it's a DLC file, a custom one from the company Context. And this one, it's an animation, eye animation, and also an audio file. So let's do this. And 3, 2, 1. There we go. Isn't this amazing? So the Furby is now displaying hacked and screaming some weird stuff. And also those motor rotations are being enabled. So this is freaking awesome, right? Absolutely. Okay, and this is also the end regarding to our Bluetooth Low Energy journey. Those 2 videos have become quite long. Yes, but I guess having this explanation helps quite a lot if you want to analyze some Bluetooth Low Energy connections. Also the developer option, this HCI Snoop file, is super helpful regarding to this whole process. Okay, so thanks for all the patience and thanks for going through this. In case if things are unclear, don't worry, you do not need to have this knowledge to move on in this course. This was some kind of bonus section regarding to Bluetooth Low Energy. Alrighty? Okay, therefore I'm really looking forward to see you in the next video. Alright guys, welcome back. This is the final video in our installation process. Okay, it depends on how much I'm talking because I might have to split it up into 2 parts. But after this video we will receive our first belt. And after all the patience, you absolutely deserve this. So in this video we finally want to talk about the Android debug bridge because this is maybe the most important command line interface we are facing during this course. Alrighty, so let's have a look how it works and what we can do with this one. Alright, let's go. Okay, so here we're having our smartphone and the laptop. And the Android debug bridge itself consists of 3 components. I mean, it's not related that you know how the Android debug bridge works, but if you're using a tool, I would like to have at least a basic understanding what's going on over there, okay? So therefore, I would like to give you a really short introduction into the inner working right now. So the first component is our ADB server, and this one is running on our Ubuntu VM on the local host on 5037 as default. So this has been already being installed during our installation process of the Android Studio and setting up the SDK. If the server is not running, it will be automatically started when we are triggering a command. For example, the ADB shell command. Alrighty? Okay. Next, we've got the ADB daemon, and this is in service running on the device. Once again, we do not have to set up anything. This is being done by the manufacturer and your operating system. So this daemon is running as default on your device. The ADB server is handling the connection to the real device or also to an emulator or this virtual machine. It could be one connection to a real device, or it could be also several connections. For example, if you also have enabled or started an emulator and a virtual machine. The last component is our ADB binary, so the binary which is within the SDK directory. And now if we're starting this ADB binary and we're calling in command, for example ADB shell, this one will make the connection to the ADB server and forwards this command to the ADB server. The protocol, by the way, the ADB protocol is simply just a text-based protocol. So we can sniff this, and I guess we will also do this later on. Yes, we will have a quick look into this one. I mean, it's nice to see, but we do not get much value out of this, okay? All right. So back to this one. The ADB client has sent this command to the ADB server. The ADB server is then handling the connection to the device, for example, this real device. So it sends it there. The real device is executing this command and replies back this response to the server, which forwards it back to the client where it gets displayed. In our case, we're having an ADB shell running afterwards. So this is the Android debug bridge, their components, and the inner working in a nutshell. I guess this is all we need to know right now. Once again, we do not have to worry about installing something or setting it up. It has already been installed. All right. Next, I would like to talk about the connections to those devices, because this can be sometimes a little bit tricky. The easiest way to get a connection is using a real device, plugging it in via USB, and then executing ADB shell. Afterwards, we get our prompt and we are good to go. Perfect. This also works for the emulator. So let's say it's using an emulated USB interface in there. The point where it's getting problematic is if you're having multiple devices. So if you have an emulator and a real device being connected to the same system and we are triggering a command, for example ADB shell, then the command or the ADB server does not know which device we are targeting. I mean, even I wouldn't know which device I would like to target. I have to tell this to ADB. And this can be easily done with the serial number. So we can get the serial number by running ADB devices. This will fetch those serial numbers. And then we can simply use the serial number to address this device. So if we are having multiple devices connected, we need to call ADB-S, the serial number, and then the command we want to execute. If we are getting the order wrong, for example ADB shell and then the serial number, we are getting an error in there. So we have to take care about the order. Last but not least, there's one connection type which is also possible, and this is TCP/IP. So for example on a real device via Wi-Fi, or also if you're using a virtual machine, not the emulator, if you're using the Android x86 virtual machine, then we need to use the TCP/IP connection. And this is also not that hard. So the thing we need is simply just the IP address of this device, and then we can use ADB connect and entering the IP address. So this will make the connection, the ADB connection, based on TCP/IP. Okay, and I would also claim that these are all use cases we could require right now. So at this point, I mean, it seems like we are done. So we know how the ADB is working and how we can make a connection to this device. But the ADB, the Android debug bridge, is capable of more. And there's a really nice topic which I also want to include, which is port forwarding. So let's also dip into this topic right now. So port forwarding comes super handy if you want to access a certain port on this device. Let's assume we've got the device and we've got a mobile application running on this device. This mobile application is opening in port. For example, this one here, 31,515. 415, this way. My counting is not that good. So 31,515, yes, this way. Okay. If you now want to connect to this port, it won't be possible because this port is only available on the local interface of this device. So if you try to connect to this port from our Ubuntu VM, then we're getting a denied. This port is not available for us. And this is the point where ADB forwarding comes super handy. So let's say we've got the following use case. We've got an application which performs some analysis on this device. For example, Drosa. Drosa is such a framework which assists us in analyzing mobile applications. And Rosa consists of two components, an application, which is running on the device, and also a client interface, which is running on our Ubuntu VM. Right now, we do not have the possibility to exchange those information. So Rosa is not able to connect to this application, to this certain port right now, because it's just listening on the local interface. To enable this port to be accessible from our Ubuntu VM, we could use the ADB forward command in the following way. So by typing in ADB forward TCP 1337 TCP 31415, we are using the existing ADB connection to this device to make this port accessible. So the command would do the following. It would enable a port on our Ubuntu VM, so on localhost, the port 1337, and all the packages we are sending to this port would be forwarded to the port 31515 on the device. By having this set up, it enables us to talk to this port even if it's not generally opened to the outside world. So we are enabling some kind of local proxy on our Ubuntu VM, which has the ability to talk to this port. And by having it in this way, we can now interact with a service on the device, which is normally not being exposed. So this is pretty awesome. And I mean, we also require this during this course. When we talk about Rosa, for example, or generally speaking, if we want to have a port accessible from the device to our local machine. So this is the use case of ADB forward. The first port is therefore the port on the host system. So we've got the protocol TCP and then 1337. So this will be opened on the local interface. And the second port is the port on the device where we want to forward this traffic to. So in this case, 31415. Yes, this time I counted correctly. All right. And then we could also have ADB reverse. And this might be now a little bit confusing if it's not already being confusing. But if you're doing some examples, I guess it will be more clear afterwards. Okay, let's also dip into reverse. So reverse simply just means the reverse process. I mean, yes, as the name already suggests, but what does this mean? How does this work? So this time we do not want to access a port on the device. This time we want to access a port on our Ubuntu VM, on our local system. So let's say we are running a web server on the local interface on port 8080. This web server is once again not reachable from the outside world because it has been bound to the local host. We can now make this port available to the smartphone based on the ADB reverse connection. But to be honest, this is something we are not going to use very often. So I guess I have used it 3 or 4 times within my whole career. So within the last 8 years of Android app hacking. Therefore, you already got the feeling that this one is not really required often. But nevertheless, let's have a dip into this one. So now we want to make this port available on our smartphone. And once again, we are using the existing ADB connection to this device to make this port available. But this time it's a reverse connection. So let's have a look into this one. Okay. If we are running ADB reverse TCP80 TCP8080, what happens is the following. This time it's the reverse direction, which means if we are now accessing the local interface on port 80 on our smartphone, then the web server will appear over here. So ADB reverse will be used to enable a service which is running on our local system or on our Ubuntu VM to the smartphone. So this is what reverse means. We are enabling a service which is running on our Ubuntu VM or on our local host to the smartphone. If you think back of forward, forwarding means we are enabling a service on the smartphone to our local host. Okay? So yes, if you haven't been confused, you might be right now. But if you're taking a look at, let's say, the reverse example, I guess the whole principle will become clear. Alrighty? Okay. And therefore I would suggest let's have a look into a practical view into this whole ADB topic, because theory it's okay, but a little bit boring. Therefore, let's start playing around with this one on our Ubuntu VM. You ready for this? Then let's switch back. So here we are back at Ubuntu VM, and now let's play a little bit around with this Android debug bridge. So therefore I'm having this real device over here, and I'm plugging this in via USB. Something I guess you have not seen before, right? And smartphone being plugged in via USB. Okay, so it seems like it has a connection. Perfect. Now let's open a terminal and let's execute this command adb shell. And here we can see daemon is not running and it's being now started on the TCP port 5037. We can also see daemon has been started successful and we are now on this device. Voila, that's the code name for this Pixel 2 device. Everything works perfectly fine. So let's also have a look into this service. If you open a new terminal, we can use netstat with those parameters. I put this on the left to make this a bit larger. Let's zoom out. There we go. Okay. Here we can see we've got something on localhost listening, and this one, yes, this is the ADB server right now. So this one is listening on port 5037 on our localhost interface. Let's also observe this connection maybe. So let's have a look into this one with Wireshark. Let's see. We want to listen on this loopback interface. Yes, I have to start it with root privileges. Let's do this. All right. And now if we open a new terminal, because you can never have enough of them. And if you're now typing this command adb shell, so this command will be forwarded to the ADB server, which is sending this to the device, which executes it and provides us back the result, right? Let's see. All right, and we have seen a lot of packages appear in the background. Let's have a look into them. Okay, let's scroll up. So here we've got it right now, and we can do, I guess, a right click, follow TCP stream. So then we have it, and I mean, yes, okay. As already mentioned, it's a text-based protocol, and yeah, there isn't that much going on over here, but now you have also seen this right now. So this one is, I guess, the request, and that's the response. So we get an okay back. All right. Let me see. If you're not using this stream, I mean, we could also use different streams. Yes, then we can see a little bit more action is happening over here. So within this stream, we also got a second one, a third one in this case. Okay, I guess, yeah, you can have a look into this one. Here's the result right now. All right, but for now, enough from this one. So yes, we have seen the service running on our system. Now let's also have a look into the service on the device. Is there really a service running? So let's figure this out. PS-A, and I guess, yeah, these are a little bit much. Let's clear this. So let's search for ADB, and let's also get 2 lines after and 2 lines before, so that we're not just having one single line in here. And here we have it. This is the ADB daemon running on this device. Okay, and yes, these are the 3 components interacting with each other. So we've got our ADB daemon on this device. We've got our ADB server, I guess already gone. Our ADB server running on localhost. So let's do this once again. This one, and also our ADB binary, this one over here. Alrighty? Okay. Next, let's make this a little bit more challenging. So let's add another device and then interact with those devices. And therefore, we are using the emulator. So let's see which devices we've got available. Nexus 6. And this, by the way, was the moment when I realized, oh, we need some root privileges, and this Nexus 5 with this Google Play Store does not have root privileges. Therefore, I switched to this device, which works perfectly fine during this whole course. Okay? All right, so let's start this one. Emulator. Add, and then this name. Okay, and here we have it right now. Cool. If we now open a new terminal and typing in ADB shell, then we're getting an error because we are now having our real device, this one being connected, and this emulator. And the ADB server does not know which device we are talking to right now. So therefore we have to provide the serial number, and we can get this with ADB devices. Got a little bit too exciting right now. Here we have this, perfect. So this is the serial number of this emulator, and this is the serial number of our Pixel 2 device. So if you want to execute a command on the Pixel 2 device, we have to use adb-s serial number, and then, for example, shell. Here we can see, yes, we are now on Walleye, which means this is, yeah, as already mentioned, I guess you have heard it quite often right now. It's the code name of this Pixel 2 device. Okay, I stop it right now. So if you want to execute a command on this emulator, which serial number do we have to use? Well, it's really this one over here. So this whole string, adb-s, shell. There we go. So now we are on the emulator. Let's see. I mean, not sure if you have remembered all those processes and IDs, but this is now the emulator right now. We can also see x86. Okay, this is how we can handle multiple devices. Now let's also have a look into a TCP IP connection. So let's boot up our virtual machine, our Android x86 virtual machine, and make a connection to this one. Because there we might have some trouble doing this. And this is something I really would like to show you. So let's boot this up. Okay, so here we have the virtual machine now up and running. And if you want to make a connection to this one, we need to have the IP address. And this could be already the first issue. So this virtual machine is using a network adapter. In my case, I have set this to NAT. And if you want to connect to the virtual machine from our Ubuntu VM, we need to be in the same subnet. And so please make sure that both machines are sharing the same network adapter. It could be NAT or it could be also host only. This doesn't really matter. It just has to be the same. All right? Okay. After eliminating this error, we can now fetch this IP address from this virtual machine. So how can we do this? Well, there's already an installation being installed which assists us on this. So if we drag this upwards, then we can see we've got a terminal emulator. And this one is super handy because this one is really a terminal on our Android x86 virtual machine. So we can now use a command, for example, IP address, and then we get those interfaces. And here we can see we've got a loopback interface, and the IP address should be normally being assigned to this WLAN 0 interface. And this sounds now a little bit ridiculous because it's a virtual machine. How could this one have Wi-Fi? And yes, it does not have Wi-Fi access or not real Wi-Fi access. But it's using a virtualized Wi-Fi to connect to the network adapter. So in my virtualization, I have chosen a network adapter from type NAT, and this one is now providing a virtual Wi-Fi for this virtual machine. All right? Maybe not, but I would suggest let's have a look into this one. Okay, so let's get into the home menu, upwards one again, and then within settings, let's see. Okay, within network and internet, we can now see Wi-Fi has been turned off, so it cannot work this way. Let's enable it. All right, let's enable it here. And now it's searching for Wi-Fi networks, but of course, not the one around us, so the physical networks. And here we can now see it has found a virtual network. So let's connect to this one. Okay, so now we can see it's connecting and obtaining IP address. Perfect. So this one is now using a virtual Wi-Fi, which is using the network adapter to communicate with the outside world in case of NAT. Or if you're using a host adapter to at least communicate with one network interface. All right? Okay, so perfect. This means we should now have an IP address. Let's see. Back to the terminal. Let's repeat the last command. There we go. We can see 172.16.240 and 133. If everything works out, then we should just remember the last three numbers over here because we should be in the same subnet because we're using the same network adapter on our Ubuntu VM. So we just have to remember the last octet of this IP address over here, 133. Let's get back to the Ubuntu VM and then finally let's make our connection to this one. So, okay, we have to log in once again. Okay, and now let's see, ADB devices. We still got our real device and this emulator, okay. And now, if we are using ifconfig, yes, we are within the same subnet. So we can now use ADB connect 172.16.240.133. So this one is the IP address of our Ubuntu VM and 133 is the IP address of our Android x86 virtual machine. All right, let's see. And we are now being connected. Nice. If we are executing ADB devices once again, here we can see we've got now 3 devices. This one, our Android x86 VM, our emulator, our real device. All right. So now we have been, 3 devices attached to this one. Let's make this a bit larger. Okay, let's clear the screen. All right. So now if you want to make a connection to our Android x86 virtual machine, what is the serial number? I mean, we are having the IP address and it seems like a port in here. Is the IP address really the serial number? Well, let's find out. ADB shell, no, not this way. ADB-S, serial number, and then the command. Let's see, 321. Perfect. Now we've gotten a different prompt, x86. Perfect. So now we've got the third prompt right now. And this is now the prompt for our virtual machine, our Android virtual machine. We can verify this by typing in ifconfig, because here we should get the IP address of our virtual machine, which is 133. Let's see. And yes, here we have it. Perfect. So this is how we can interact with all the devices. But to be honest, this makes things unnecessarily complex. So what I like to do is having one device attached to this machine where I'm working with. And it's not really required most of the time to have multiple devices at the same machine right now. All right. But nevertheless, you are now well prepared to interact with everything. Okay? Perfect. Then let's get back. Okay, so we have seen the inner working of ADB. We have also seen how to handle those connections. Oh yeah, one thing which is also pretty cool, if we enable or allow this access to a certain device, for example, this real device, you remember this pop-up, this one? Yes, you do, of course. So this is some kind of acceptance that this laptop is being allowed to connect to this device. And these information are being stored on our local system and also on our device. So within the home directory, we've got a hidden directory. Let me show this to you, but don't tell anyone, okay? So if we press Ctrl H, then we can enable or see all those hidden directories. They've got a dot in front on a Linux system. Let's hit Ctrl H once again, that no one sees them, okay? So now if we are entering this Android directory, which should be also available on your system, then we can see we've got ADB key and ADB key pub. Okay, so let's print this file out maybe. And this one is now the public key of our ADB key. So it sounds a little bit complex, but this is simply just asymmetric crypto. I know, simple and crypto in one sentence, are you crazy? But I also do not want to start talking about cryptography right now. So this is a topic I'm talking about within the man in the middle section when we have a look into HTTPS. Right now, I just want to show you, okay, we are having here a public key and we are also having the corresponding private key. So let's also print this one out. This, by the way, should kept private. I mean, for me right now, it's way too late, but you should keep your private key private, because if someone has this key, this person can connect to those devices. I mean, right now for me, it's not a big deal because these are testing devices or emulators running on my local system. But if you're using a private phone, which I also do not recommend, but if you're using it, then this could be really bad if you lose this key. So someone with a USB cable or also on the same network can get access to your device, okay? So keep your private key please private and do it not the way I do right now. So just forget about this. Okay, so this is now my ADB key and we can also verify this key on the device. So let's see, ADB devices. Let's take this emulator. ADB shell, ADB-S, serial number, shell. Now we need root privileges because certain directories cannot be accessed from the ADB shell context, which is user ID 2000. So we need root privileges. For example, this data directory. Here we get permission denied. Okay, getting root on our Nexus device is no problem. We simply type in SU and we're good to go. Okay, now we can also enter those directories. And within data, I guess MISC, ADB, yes. Yes, here we can see we've got now this file ADB keys. Let's print this out because this time it's not my private key, of course. This time it's the public key. So if we compare those two, let's do this once again. ADB key pub, yes. Okay, so if we now compare those two, let's do this real quick. Oh, let's print it out once again. There we go. Then we can see these are identical because the public key is being stored on the device, and by having the private key, we can verify that this connection, everything works fine. Cryptographic magic happens in the background. If you are interested in this topic, I will explain this in the HTTPS section, how asymmetric cryptography works, okay? Right now, starting this course, we are not interested in doing some cryptography, alrighty? Yes, okay. So we have also seen this one, and I guess let's have finally a look into some useful commands of ADB, and then we are good to go. I hope this video hasn't become that long, but yeah, let's see that I do not miss something. Oh yes, ADB forward and reverse. But first, let's have a look into this one. Yes, let's pull the smartphone a little bit more right. Okay, let's scroll up. Let's see what do we have here. Yes, we've got a lot of commands. So this is the serial commands, things we have already seen, okay. Devices, also something we have seen. Connect, also. Forward and reverse. We will have a look into a reverse example. All right. Yes, file transfer, push and pull. This one is important. So if you want to interact with this device, we need to push and pull files to it. So up and download files to it. And this can be done with push and pull. So for example, let's see. This is a test. So now we have created a new text file. Test. And if you want to upload this to our smartphone, we can use ADB push test. This is our local file. And now we need to specify the destination where we want to upload it. I make this a little bit larger, then you can see it better. Okay. So the only two directories which are available on the smartphone, which can be accessed easily from our host system without root privileges, are the SD card and the temp directory. The SD card is the more interesting one because this one holds all your photos, videos, music, downloads, all this kind of stuff. And this is it's a public available directory, so we can use this. By the way, do not get confused by SD card, the name. SD card, it's not a physical SD card. SD card is the eMMC, which stands for Embedded Multimedia Card. Yes, this way. So this is simply just a chip which acts like an SD card, and therefore it has this name over here. Okay, so it's not a physical SD card. This one is your internal memory of the smartphone. All right. So this is the way to upload this file. And once again, if you're just having one device connected, then it's a little bit easier. But now we have to use -s and then the file we want to upload. Oh, sorry, the command push, then the file we want to upload, and then the destination where we want to upload it to. Okay, 3, 2, 1, push. Okay, if you're now performing ADB shell, once again, I guess I will unplug it in just a moment. So let's see. Okay, I really will unplug it in really just a moment. So now we are on the emulator, and within the SD card, yes, we can see we've got now this text file. Let's print it out. Okay. If you now want to download a file, for example, this gray PNG, we can use ADB pull. Let me clean this up a little bit that you can see it a little bit better. Okay. So now, let's see. Let's make a new directory. Oh, there's already one. Let's go into this one. Okay, let's delete those old bug reports. Okay, now we want to download a file which exists on the smartphone to this directory over here, okay? And therefore we can use ADB pull, and now we have to define the source, which is now the file source on the smartphone. So in this case, it's within /SD card, and then this one, for example, gray PNG. And now we need to define the destination where we want to download this file. In this case, it's the current directory. Once again. Okay, let's repeat this whole command. Okay, let's open the directory. There we go. So now we have downloaded a file from the smartphone to our system. So this is super handy and we will use this quite often during this course. So the SD card is some kind of free zone where we can store files and up and download from them from the host system. All right. Okay. Back to the help. Let's see. Okay. Push and pull. Install, something we have already seen. This is the way to install applications. Bug report, also something we have seen. And Java debug via protocol, this is something we will handle in the debugging session. It's pretty at the end of this course. Loghead. This is also pretty important. So the loghead, it's the device log. And this is something you should keep open all the time during an analysis of an application. So what I do is running loghead, then opening the application, playing around with this one. And after shutting down the application, I will close this loghead. So I will store this into a separate file and then investigate this. You will find a lot of useful information in there. For example, user credentials, API tokens, or you get also assist if you want to circumvent some security features. For example, certificate pinning. If the developer has implemented such a security feature, sometimes some useful information being printed out to this device log, and this can be absolutely helpful in bypassing it. Sounds crazy, and to be honest, it also is. Also things like user credentials or token. Those information shouldn't be stored in the device log, even if it's not possible anymore to read this out by third-party applications. Okay? All right. Then verify, but this is just for user debug builds. Keygen is generating a new public-private key pair for our ADB. Let's see. Sideload. Okay. Reboot. This is maybe also cool. We can use reboot to boot this device into a certain state, for example, into bootloader or recovery. This is super handy if we perform some rooting of this device, because we can boot this into the bootloader and then flash certain partitions and boot from them afterwards, if those security features has not been enabled. So we need to unlock things like this. But this will wipe data from the device and make things complex. Okay, so you can play around with this one, but you need to be very careful that you do not break your device. Alrighty? Okay. I also provide you some additional information in the cheat sheet. So there you will find an, let's say, most likely safe way to perform some actions. Okay. And then we've got ADB root. So this was a thing, I guess, 10 years ago. So we can use ADB root to restart the ADB daemon with root privileges. Let me show this to you. So what I do right now is I unplug this device and I also power off the virtual machine, that it's getting a little bit more easy. Okay, so now we should only have one device. Let's see. Virtual machine seems to be still powered off, but yeah. We can also do ADB kill server and then ADB shell once again. All right. This will automatically start the server and we can see perfect. We are now connected to this one. Whoops, sorry. Okay, so if you're now doing an ID, we can see we are accessing the ADB shell as UID 2000, which is the shell access. All right. If we now execute this command ADB root, then we can see the ADB daemon on this device will be restarted with root privileges, which means if we're now doing an ADB shell, we instantly have root privileges, this one. At the first view, it seems to be not a big deal because we had root privileges anyway. We could connect to this device and then perform SU and execute our command. So yes, this is possible. But having this ADB daemon running as root enables some more convenient options. For example, if we directly want to pull an file which is within the data directory, for example. If we are not having this ADB daemon running as root, we cannot execute this command directly from our host system. We first have to log in, getting root privileges, copying this file to the SD card, and then downloading it from the SD card. So 3 or 4 steps are being involved during this process. Having the ADB daemon running as root, we can simply use it directly from our command line on our host system. So this makes things a lot easier. But it can be also a little bit tricky sometimes, because having certain detections like root detections, this is something you might overlook. So therefore, I'm not going to use this during this course, but feel free to do this, to restart your ADB daemon with root privileges, then you can directly access those files, okay? All right. Then let's see, let's clear the screen. ADB help once again. Okay, logcat root. Here we can see restarting the ADB server with USB or TCP IP, but this is not really required. If you're performing in Connect, it's automatically switching to TCP IP. Kill server, also something you have already seen or seen right now. This simply restarts the server, and this is the most recommended troubleshooting guide. So if you encounter some issues with ADB, simply run ADB kill server and then ADB shell once again. So restarting the server, turning it off and on again resolves so many problems. In case if you still encounter some other issues, I have provided you a whole list about errors and their corresponding solutions in the cheat sheet. So please have a look into this one, and of course you can also write me if you encounter something new. Alrighty? Okay. So regarding to ADB, I guess we have covered most options right now. Let's have a final quick look into the reverse, into ADB reverse, that this topic is a little bit better to understand, because if you have seen reverse, you also get a better understanding what forward means, and maybe also get a better understanding what's the difference between those two. Because for me, it took quite a while until I realized what they are doing. Okay, so let's see. Let's stay in this directory and let's create a little website which we can then forward to this smartphone over here, okay? Enabling and service from our Ubuntu VM to the smartphone requires ADB reverse. Enabling and service on the smartphone to our local machine requires ADB forward. So let's create a site and then let's see how reverse works, and then I guess we're good to go. Okay, so let's create an index HTML, and now I need some insane HTML skills. So doc type. All right, let's run this web server. So Python 3 and then HTTP server. Okay, now we're having an HTTP server running on our interfaces on port 8000, and here we can see perfect ADB reverse, wonderful site. Okay. So now let's make this service available to the smartphone. I mean, it's listening right now to all interfaces, but we could also limit this to localhost. Okay, how can we do this? Well, if we're using ADB reverse and then TCP, because it's a TCP protocol, let's say 1234 and then TCP 8000. Yes. This means if you're making a connection to localhost on the smartphone on port 1234, this one will be reversed to this one. So it will appear on our smartphone, this web server which is running on port 8000. Okay, let's see. We've got no browser, but we've got a web view. This should also work. Okay, let's open HTTP 127.0.0.1 and then 1234. So this should print out our website, which is running on our Ubuntu VM to the smartphone. Let's see, 3, 2, 1. Yes, I already see those requests and we can see reverse and we have no title, but we can see yes, this is the page. So this is what reverse means, and forward is simply the other way around. Forward enables a port or service which is available on the smartphone to our system over here. Okay? All right. I know it already got late, but let's sum this up with a short slide and then you finally reserve your first belt. Okay? So let's do this real quick. Okay, here I have summarized some important commands. ADB install to install an application, push and pull to interact with files on our local system, uploading them to the smartphone, vice versa. ADB input touch, something we have already seen. What is also pretty cool is ADB input text and swipe. So ADB input text will automatically fill out this form field with the text we provide via this terminal. ADB logcat, something you should always keep running during your analysis. ADB shell, IP, and so on. I mean, that's a shortcut if you want to easily retrieve the IP address from the virtual machine. Bug report, also something we have already seen and which is also pretty cool. I mean, that's the easiest way to get the HCI snoop log file, so the Bluetooth Low Energy log, from this device for many devices. ADB connect if you want to make an TCP IP connection, so Wi-Fi for real devices or our virtual machine, and also ADB backup. This one will back up our applications, any corresponding data in there. It depends on the developer what is being included, but sometimes this can also lead to security issues if you can simply fetch the secrets of this user account based on a backup. All right. Now, after all your patience, I'm absolutely grateful and I'm super happy to provide you your first build. There you go. Oh, there you go. So this is the end of our installation process, and from now on we will do some really amazing app hacking. And to be honest, we have already seen some cool tricks, so the touch or Bluetooth Low Energy, but the next things, they will be way cooler. So this is something I definitely promise to you. Alrighty, so I'm looking forward to see you in the next chapter. Alrighty guys, let's start with the Android file structure, and this topic is, it consists mostly on a theory part, but I try my best to make this as practical as possible that it doesn't get too boring. But this is really important, so you need to understand the file structure of an Android application, because if we later on reverse engineer all those files, we need to know which files are interesting for us and which can be skipped. And therefore I would say let's go, and we start with our Android application itself. So here we have our game APK file, and the question is, what is this APK extension? So for example, on a Java file we've got .jar, on a picture we've got .png. What is the file type? APK. And the official announcement is, let me get this, application/vnd.android.package-archive. And I've only read this once in a very good book, which is the Android Security Internals. And to be honest, I never used it. Because an APK file, we can treat this simple as a zip archive. We put our zip sticker on this and we treat it as a zip archive. Therefore, we can simply open our terminal and run unzip on this. So we can simply unzip an APK file. And then we get all those internal files. And now's the big question, what are all those files? And we do this now step by step. So we go through all of these files and I will explain you what they are used for. And therefore we need to download our first APK file. So what I normally would do is I would get my device. I would also download the APK from the Google Play Store, then connect the device to the laptop and use the package manager to retrieve this APK on my laptop. In this case, it's not that necessary because I provided you this APK file already. So you find this in the download section. Therefore, please go into the file tab of this section and download this APK. We will also learn how to do this approach later on, but for now we will focus only on the important part in the section, which is the file structure. All right, here we are now at our Ubuntu VM and I've already downloaded this application. It's right over there in the downloads directory. Now I copy paste this one, go into apps, I create a new directory, name this SpacePang, and I insert it here. Then I use right click, open in new terminal. And then we are directly in this directory over here. So if I do pwd, you can see we are directly here and you do not have to open a new terminal and browse through all those files. All right, now let's run unzip on this one. And here we can see I'm gonna enlarge this. It's extracting all those single files, and all those single files make this application what it is, this Android app. And now we dive into those files and figure out what they are for and if they are interesting for us or not. We start with the assets directory because this is the first one over there. And the assets directory is really important for us because the assets directory contains all those nice resources. But it does not contain only pictures or things like this. Developers can add additional files. For example, if you face certificate pinning or things like this, you might encounter that this directory over here holds the certificate which is used for the certificate pinning process. We will also take a look into this later on. But you can store your resources and external files over there. And in this case, we've got some splash images and some music files and things like this. So this directory is always worth taking a look at. Next, we've got the com directory, and this one does not contain any interesting data for us. We can find some XML files or some fragments, but I do not take too much time on this one, even if I do my reversing approach. So you can skip this one for now. Then we've got the lib directory, and this is really important again, because here we can see we've got ARM EABI, v7 and x86. So the lib directory contains the shared object files. In this case, we've got the libjdx.so. And a shared object file is the C code compiled into this file. So normally you write your Android application and this part is done in Java. And if you compile your Java code, you will get a new file, which is the classes.dex. We will also take a look into this file later on. But Java is not performant enough to do some complex tasks, for example, some rendering, 3D effects, shadowing, and things like this. Therefore, developers also have the choice to include C code into the Java code. And this part is now compiled into those shared object files. And why is this really important? Because these are processor dependent, which means your smartphone over here, this one, has an ARM CPU in it. And therefore we've got those two directories. So these libraries are compiled for the ARM platform, which is the platform of the original device. And this one over here is the x86 platform, which is, for example, our virtual machine. And if we take a look into the lib directory, we can immediately tell if this application runs on our virtual machine because it has the x86 dependency, or if we only can use this application on our native device because we do not have an ARM emulator right now. If we would like to use the ARM emulator, we have to stick to the Android Studio AVD device, but this is super slow and I would like to circumvent this as long as possible. We have to use this later on, but for now, we stick to the virtual machine. We just need to know, okay, these are shared object files and this is C code compiled into those files. And these are definitely worth taking a look at because C code is hard to reverse engineer, or at least it's harder to reverse engineer than Java code for most people. And therefore developers try to hide sometimes things in C code. And we will learn also during this course how to deal with this. But for now, we need to know, okay, this one is a C code file and it is dependent on the architecture of the CPU. So we have to take a look into this to figure out if we can run this on our virtual machine or if we have to use a real device or the AVD manager, which is the case for those two. All right. Next, we've got the meta-inf directory, and this is regarding to the signing process. Every Android application needs to be signed. We've got I guess 3 or 4 videos about signing because this is a rather complex topic, and we will dive into this later on when we talk about the meta-inf directory. For now, you just need to know this one here is the signature of your certificate, this one here is a signature file, and this one here is a manifest file. And those contains hash sums over all those single files in your app. So this is also important for us because sometimes developers use those hashes as kind of tamper protection. We will learn later on in this chapter how to calculate those values and how to deal with those files. For now, you just need to know meta-inf directory contains the certificate and some additional infos. It's regarding to the signing process of the application. Okay, then we've got the res directory, and this one is pretty similar to the assets directory, but a little bit different. So here we have our icon, for example, and this one is a bigger icon because this one is regarding to tablets, for example. If you install this application on your tablet, then you will pop up with this icon on your screen. And if you install this on your smartphone, then you have a smaller icon over here, for example. And the resource directory can also contain additional files. So if we look for additional files, we can look in the assets directory and in the resource directory, also regarding to images, audio files, and things like this. Both directories worth taking a look at. Next, we've got the Android manifest XML, and this is also a section on itself because this file is really important, and yeah, we will dive into this in a separate video because yeah, it's really big. One nice fact is if we try to read this right now, let me open this in a terminal and I print this file out. We will notice, well, this looks not like an XML file. This is some binary crap over here. And yeah, this seems to be at least some strings. And the Android system does an own serialization process on XML files. So if we compile the application, the Android manifest XML gets serialized into this binary format. And we can reconstruct the original version with the APK tool, for example. And we will also learn how to do this later on in the course. For now, and we will also learn how to do this later on in the course. But for now, okay, we need to know that if we unzip an application, we cannot modify the Android manifest XML because it's in binary format and yeah, this is serialized. It's not really easy to edit right now. Just as a short note, the Android manifest XML contains meta information about the application. For example, it has a package name, which is a unique identifier for this application. It also contains the permissions that the app can use and other stuff, which we do later on a deep dive into this. So it's a kind of configuration file, but a really important one. It also declares if your app is debuggable or not, and things like this. Next, we've got the classes.dex file, and this is the most important file for us because this one contains our Java source code. This Java source code is compiled in some Dalvik executable format, and we will learn how to deal with this file format later on. We also got an own chapter for this, which is the Smali chapter, and there we learn how to read, analyze, and even write this Dalvik executable format. For now, I don't want to shock you that much, so we just keep in mind that this one contains the Java source code of this application compiled in some Dalvik executable format, and that's the file extension over here. In the next sections, we will also take a look into this file. We dip a little bit into this and figure out what's inside there. And finally, we have the resources.arsc, and this file contains information about, for example, strings in your application or color definitions and things like this. In my opinion, it's not really that important because I do not find that many interesting stuff in there because it's not the strings you are using in your application. It's strings you can define in this file for your application. For example, if you have multiple languages, then you can define all those strings over there and then you can just load different languages based on the country of the user who's opening the app. And I do not find this file really interesting, so I would skip this at the beginning. So it's not worth mention. And if you start hacking Android applications, maybe if you are looking for some really specific task and you cannot find this anywhere else, you might want to dip into this file. But for now, let's recap this real quick on our slide. Okay, here we have the great overview back again. So the assets directory and the resource directory contains images and additional files of the developer. Then we've got the libraries, which is the C++ code. Certificate and signing information are within the meta.inf directory. The Android manifest XML, which is a really important configuration file, is in a binary state if you unzip this application. Then we've got the classes.dex, which is the Java source code compiled in the Dalvik executable file format. So it's in byte format, which stores the Java code. And finally, we've got the resources ARC, which can be skipped as the COM directory. So those two files or directories are not important, but unfortunately the rest is important for us. Okay, so that's all for the file structure right now. I just want to provide you a quick overview about those single files and the purpose of them, and we will improve our knowledge during this chapter when we take a deeper look onto those interesting files and directories. So I'm looking forward to see you in the next section. Welcome back. Let's talk about the DEX and ODEX file format and also the difference between a normal Java instance and a Java instance on the Android platform, which is regarding to the ARM architecture. We do this on a very high level approach, so don't worry, we do not dive into single processor instructions, we just take this on a high level approach. Alright, on the left we have our Android applications, and those Android applications are written in Java, and this code gets loaded into the Java virtual machine. But on the Android platform it's related to the Dalvik virtual machine. And there's a difference between our normal Java and this type of Java. And this is something we want to figure out right now. So on the right, we've got the source code. And if we run the source code on our laptop, for example, and compile this one, we generate a new file, which is the main.class file. And this file stores our Java source code in some kind of byte format. Now, if you would take this approach onto our Android smartphone, onto this device, for example, right here, then we would have some troubles, because this Java approach would require a lot of more resources. And if our CPU on the smartphone requires more resources, it will heat up. And heating up will also mean we use more resources on the device, and we also drain the battery dramatically. And this approach is therefore not working on battery empowered devices. We therefore have on the ARM architecture something different. And what this is it's the Dalvik executable byte format. So we take the same Java source code, but we compile it for a different architecture, the ARM architecture. And therefore we also compile it in a different byte format. In our case, this one is now called the Dalvik executable format, and we will generate those classes.dex file. I know this animation is super sick. So those classes.dex contain also the Java bytecode, but now in the Dalvik executable format. And this format is designed to work on battery empowered devices on the ARM architecture, and therefore does not drain the battery that dramatically, and also do not require a lot of more resources. And this is the approach why And this is also the reason why pretty every smartphone is running in ARM architecture. And this is the reason why pretty every smartphone is running an ARM CPU and this is the reason why every smartphone device out there has an ARM CPU in there. There are of course disadvantages to this architecture, but regarding to a battery empowered device, it's absolutely brilliant to use it in this way. And this is the difference between x86 and ARM in a nutshell on a very high level approach. So what I would like to point out right here is that your PC or your laptop is running on a different architecture than your mobile device. And the reason behind this is that your smartphone needs to rely on a battery pack instead of your constant voltage or ampere out of a power supply. And therefore it has to be designed in a different architecture. And this is the reason why the Java source code has also to be designed a little bit different. All right. Now there's this ODEX file format. And what is this ODEX file format? Well, it's not that complicated. It's simply just an optimized DEX file format. And we can use a command to put this ODEX file format back to an DEX file format. And therefore this really doesn't affect us at all during our reversing process. So we just have to convert this from this ODEX, this optimized DEX file format, to a DEX file format, and then we are on our basic approach and can analyze this file. All right. Now there's also one last thing I want to point out, and this is something regarding to the classes.dex file. So your classes.dex file can only contain 65,535 methods. And if you would write more methods, then you will end up in multidexing. And you might have encountered or seen those files, because we've got a classes.dex, and in the same directory we have a classes2.dex file. And this is the reason for those split up Dalvik executable files. It's regarding to the amount of methods. And now you might think of yourself, wait, what? Whoever wrote 65,535 methods into one application? Yeah, I guess this is pretty ridiculous, but it also affects, of course, libraries, frameworks, and the Android system itself. So meanwhile, by importing some libraries, you really end up easily by having multiple DEX files, because all those libraries contain a lot of methods, even if you do not use them. And the important thing right here is, if we reverse engineer and analyze those applications, we need to make sure that we analyze all classes.dex files, because we cannot tell if our necessary information are in classes.dex or in classes2.dex, or how many files we get right there. Therefore, we need to analyze all of them. And now you also know why we have multiple DEX files. So we figured out the difference between a PC or laptop, which has a constant power supply, and a smartphone, which needs to rely on a battery pack. And this difference also affects the operation system of this device. And we also have learned that the classes.dex is also just a Java bytecode format, but optimized for this architecture, this platform. And we also know why there can be multiple DEX files. And that's all what we need to understand for this section. Alrighty, welcome back. In this section we take a look at the classes.dex file, because this is the file that contains our Java source code, and yeah, it's compiled into the Stylebig executable byte format. We just dip a little bit into this to give you a preview about what you will be able to understand after completing this course. So let's go. Here we are at our Ubuntu VM, and we go into the apps directory, space pane, and here we have this classes.dex file. The first thing I like to do when I deal with unknown files, I open a terminal and I simply run file on this. And here we can see this is a JADX file version 035. The next thing I like to do is I like to open this in hex editor, because here we can see some header information, and yeah, we can also identify if this file is compressed or if we can see some patterns and maybe some strings or things like this. Therefore I use ghex, but you can of course choose whatever hex editor you like. You can install it via sudo apt-get install ghex. I have it already installed, so I open this file with ghex right now. Okay, we can see dex 035, which seems to be the header, and this one is the version number that file did print out. We can also identify a lot of patterns over here, which means this section is not compressed. Now we know this file contains our Java source code, so let's find out if we find some strings regarding to Java in this file right here. Therefore I open this menu and I search for Java. You have to put it on the right side because the left is the hex representation of this string if you're using ghex, so you cannot type Java over there. We have to use it on the right. And yes, here we can see some Java references, and we can also see some strings, button has not been started, polygon, things like this, alien boss explosion, alien boss hit. So we can identify string references which seems to be part of the source code. And this is the amazing part about this Java bytecode, because we can reconstruct the source code pretty close to the original one by decompiling this file afterwards. We do this in a separate section where we learn how to reverse engineer and analyze those files. Okay, for now there isn't much more we can do with ghex. We get a nice view into this file, but we cannot disassemble or decompile it with an hex editor. Therefore we have to use a different tool, and this tool is named dexdump. And this one is super amazing, and it also comes pre-compiled with your Android SDK. So let me show this quick to you. Going to close this one, and dexdump is located at the SDK build tools 3003 dexdump. So I have added this path to my ZSH environment. If you have missed this part, you might want to get back to the installation process, but I'm gonna show this quick to you. So, okay, here we can see I have added the 3003 directory to the path variable, and I did append it with the colon. So this means if I run dexdump from this location over here, the space pane directory, the ZSH is looking into all those directories which are listed there in the path variable, this one, and tries to find the dexdump binary. And if it's located in one of those directories, it simply starts it. Therefore, I do not have to provide the full path to the dexdump binary to run this tool. Alrighty, let me clear this one, or let me maximize this first, clear it afterwards, and then zoom a little bit in. And now we run dexdump. Okay, here we have the options of dexdump, and this one is the most important one, the -d option, because dexdump is able to disassemble the code sections of our classes.dex file, which means we are going to make our first experience with Smali. And Smali is super amazing, and also the main focus in this course, because with Smali you are able to do everything. You get unlimited power over this application. What we do, for example, during this course, we write an APK packer. We have two apps and we pack them into one app. And we do this, we append our own debug server in this application, and then we have full memory access over this application, even if we do not have root access on the device, which is super great. We can also insert some debug commands or print out static AES keys in form of byte arrays. We can patch away certificate pinnings, routing detections, and we can also modify our game, which is also the main focus of this course, because this is the most amazing way to learn Smali, by hacking this application. And what we do during this course is we will identify how this code looks like, and then we will modify the game that we do not get hit. We extend our player shot that we do not have a double shot. We make it a 300 shot, for example. We disable our fire rate that we do not get interrupted during this, and all those funny things. Okay, after getting hyped up that much, I'm going to finally show you that Smali, that you know what you have to deal with during this course. So let's go. We use dexdump with the -d option and we use it on the class.dex, and I'm also going to pipe this through less because then we can browse through this file. Okay, you ready? There we go. Okay, this is your first impression about the JADX executable byte format, and you might think, wait, what? We are going to deal with this during this course? And I can tell you, yes, we will. But let me browse down a little bit because, yeah, we get a nicer overview about this one. All right, here we have now finally the Smiley code. We've got the byte representation on the left and we've got the Smiley code on the right. And this is the most important part because this is the Smiley code which we are going to learn, and after this course you will be fully able to read and write this piece of code. And this is super amazing, and if you now think, wait, what? I'm never ever going to learn this is way too complicated. Well, I have learned the stuff and I did it in the most funny way that's possible by hacking this application. And I'm also no genius, so if I can make this, you can make this too. And I promise you, I will guide you through this course that at the end you will be able to understand every single line right here. I've designed this course to have no requirements to go from zero to hero, to understand and learn and even write Smiley afterwards. And this section is designed to give you a quick preview in what you will be able to handle after performing this course. Okay, for now, let's simply just take this impression with us and yeah, we move on with the course. Therefore, I'm looking forward to see you in the next section. All right, let's have a look at decompiling an Android application. But before we can decompile an Android application, we need to get this from the device. Because last time we downloaded it via a third-party store, but this option is not always possible. For example, if we have downloaded an APK or an app from the Google Play Store, we cannot simply download the APK file directly from the Play Store. We need to retrieve this app from the device. So let's have a look how this can be done. Here we have our smartphone and also the app which is on the smartphone right now. The easiest way is to simply establish an ADB connection to this device. And then we open or connect to this device and we use the package manager to identify the package name, because the package name is a unique identifier for this application, and this identifier can be used with pmpath to retrieve the reference of this APK file on the device. So when you install an application, the whole APK still exists on the device, and with pmpath and the package identifier of this application, we can retrieve the path to this whole APK. And this APK can afterwards be downloaded via ADB pull. And the good thing is we do not need certain permissions or requirements. We simply can use ADB in a normal user context, so no root is required. These 3 steps, or 4 steps let's say, are regarding to getting the APK. When we have the APK, we come to the original topic, decompiling this application. And this can be done with a tool named APK tool. This is a simple jar binary, and we can simply run java-jar apktool.jar and we can interact with this APK file. With APK tool, we can decompile an Android application and we can also build it back again. In the structure path, we have already seen that an APK simply consists of single files which are compressed into one blob. And this blob, this compressed zip blob, is the APK. So by decompiling this APK file, we can edit those single files and then we can build it back again. Well, you might ask yourself, we already have done this in the unzipping path. Yes, but we will look at the difference between unzipping an APK and decompiling an APK, because those two are different, and you will see pretty clearly that decompiling an Android application is much more convenient and better to handle than simply just unzipping it. So I would say let's start by getting this APK from our mobile device. Therefore I switch to our Ubuntu VM. Here we are at our Ubuntu VM and I'm making an ADB connection to this device. If you do not know the IP address of this device, simply go on the virtual machine, swipe this up, open the terminal emulator and run IP address. Then you will find this IP address. And if this device has not assigned an IP address, make sure you are connected to the virtual Wi-Fi right here. Alright. If you still have issues regarding to the connection to the virtual machine to the Android device, please take a look at the PDF sheet which is attached in this course, because there's a huge troubleshooting guide which now consists or is based on 7 years of experience in this topic, and I faced a lot of problems and this might help you. And in case it doesn't, please drop me a message. I try my best, I will reach out to you and we will figure out and make this work, I promise you. After establishing the connection, we go into our ADB shell and we have downloaded the APK file, the SpacePang APK before, but we do this now again regarding to retrieving this APK directly from the mobile device. So this example shows you how to handle real-world targets. For example, if you have downloaded an APK from the Google Play Store, you do not have directly the APK file, you need to retrieve it, and this is how you can do this. Now we are on the device, we can see or verify this by having this x86 prompt right here. I'm going to maximize this and also make it a little bit bigger. Alright, we have the package manager, which is a binary on the device, and we can use this. This package manager has a lot of options and some of them are really useful, but we do not dig too deep into this. What we need is we simply just need to list these packages. So PM for package manager, list packages. And then we have all those packages, all those applications which are installed on the device. So we can look through all those packages right here, but we can also use a grep command to retrieve this application which we are interested in. And we know, okay, our application has the name space in it. So we say grep -e for ignore case sensitive. So we do not have to care about upper and lower cases. Here we can see the package name of our application, this one right here. And now we can say pm path with the package name to retrieve the path of this APK file. And this is located right here. It's under data app, SpacePang, some wired base64, which we do not care too much about this, and those base APK file right here. So we take this whole path, we copy it, we open a new terminal, and let's make a new directory. So we name this SpacePang decompile. And there I right click, open a new terminal, then we are directly in this directory here. And then I say adb pull and I use this path. And we can see, okay, 4 MBs has been downloaded in 02 seconds. And here's our APK. This is our SpacePang application, which has been installed on the device. In this section, we have seen how to download an APK file directly from the mobile device. For example, if we have installed this application via the Google Play Store. In the next section, we take a look at decompiling this Android application. We will therefore install the APK tool and we will also figure out some parameters of the APK tool. And we will take a look at the difference between unzipping and decompiling an app. So I'm looking forward to see you in the next section. Welcome back. In this section we take a look at decompiling an Android application and we directly move on where we stopped in the video before. So now let's install the APK tool that we can start decompiling this Android application. The first step is done, we have downloaded this file, but now we want to decompile this. So I open up Google Chrome and I simply say APK tool download. And the first one is the correct one, the ibotpeaches.github.io. And there we have the current version. And after clicking this, it will be directly downloaded, as you can see here. And now it says, oh, this might be a dangerous file because a jar file is treated like a binary file. And this file is not trusted for the system. I do trust this application, so I say, okay, keep this. And now we have in the downloads directory this APK tool right here. We can open a new terminal and simply say java-jar and running this APK tool. And then we get this prompt. But now we want to put this APK tool into a tools directory that we have a clean setup. And we also want to generate an alias name. I will come to this in a second. So let's clean the system up a little bit. We copy paste this into tools. We create a new directory named APK tool and we paste it in right here. So now if we want to run this APK tool, we have to provide this whole path. I'm open a new terminal and show this to you. So I would have to type in every time home app tools, APK tool .jar if we want to run this. And I really way too lazy to type this all the time. So what we are doing is we are creating a shortcut, an alias name, which when we type in this alias name right here in this prompt here, this whole command gets executed. And this alias name needs to be known to our bash RC or ZSH RC, because those are the configuration files for our terminal. It depends on what you're running. So I will show you how to do this for both, because then you should be fine with this. I'm open this in JADX because this is more convenient for some graphical users. Therefore I run bash RC, this one right here. And then we type in alias and we name this alias APK tool. So this is our variable, let's say, in this way, or our name. When we type in APK tool, we can say execute this whole command right here. And then we simply save this. And now I'm going to open the ZSH RC because I'm using the ZSH, the same. And we save this. You can also click save right here or simply hit Ctrl S. Now we want to execute this APK tool, but the command is not found. Why? Because this configuration file gets loaded when the terminal is being started. So therefore we have edited this file afterwards. We could close this terminal and open a new one, or we can use source on the ZSH RC. And now this configuration file gets updated in our terminal. So now we have this APK tool available. Look at the options of the APK tool. So the main options are APK tool D for decode. I will also say from time to time decompile, but I mean exactly the same. And we can decode or decompile an APK file. There, this is like unzipping, but with additional features. The other option is APK tool B for build, and we can build back an app path. So after decompiling an application, we get a new directory structure, and we can build this directory structure back again to a mobile application. Therefore, we can also modify this directory structure, of course. All right, some other useful options. One useful option, is the -- advanced, because this lists even more opportunities of the APK tool. Here we have now a bunch of options, and this is what APK tool is capability of. So we now focus only on the most important ones, because there's a lot of stuff and from time to time you need additional options, but we will learn this through the course. So let's focus on the main part. One important option is this one right here, the -r, which means do not decode resources. Well, resources are, for example, the resources ASC that contains some strings, collars and stuff like this. But also the Android manifest XML count as resource. Now you might think, wait, why should I not decompile or decode this Android manifest XML? Because afterwards we get some nice XML plain text file. The answer to this is there are some kind of decompiling mechanism. For example, a developer can put some really strange characters into those resources, and the functionality of the app does not get affected. So the app works perfectly fine. But if an APK tool, for example, tries to decompile those strange resource files, it fails because the parser gets overwhelmed or confused and the whole process stucks. In this case, the attacker might be only interested in changing the source code, the Smiley files, for example, and even doesn't care about those resources. Therefore, it's this parameter. So with the -r parameter, we do not decompile those resource files. But not decoding the Android manifest XML might be really bad, because this file is an important configuration file and we need to modify this in case of adding some permissions or making this app debuggable, setting the backup parameter or things like this. And therefore the developer of this APK tool have also an answer for this. So we have here the -r, do not decode resources, but we also have this forced manifest parameter right here. And this means even if the APK tool is not decoding those resources, it still tries to decode the Android manifest XML, that we can modify and view it. We also have the counterpart regarding to the sources right here. So if we are just interested in modifying the Android manifest and we face some problems with the source code, the classes.dex file in this case, then we can say, okay, simply just decode the resources and do not care about the sources. Okay, so these three options are pretty important. And yeah, these are the main options which I use most of the time, and that saved my day a lot of times. So let's start by decompiling this application right now. And then we compare those two, the unzipped version and the decompiled with the APK. Therefore I go into apps, spacepang, decompile. Yeah, this is where the base APK is stored. So now I run APK tool D for decode, or as I say, decompile, and I provide the base APK. Here we can see decoding Android manifest XML with resources and some other stuff. And now we have a new directory right here named base. I open this now in a file browser, and this structure looks pretty similar to the ones we have seen by unzipping an application. So let's put them side by side and compare them against each other. Let's have a look at what is identical, and then we can only focus on the difference between unzipping and the APK tool. Alright, identical is the assets directory and also the lib directory. There's nothing different between those two decompiling and unzipping mechanisms. The original directory contains the meta-inf and the original Android manifest XML. So these are also identical, but just in a different structure. Then we have the rest directory, and the rest directory is also identical, beside the case that the resources ARC gets decompiled into a new directory named values. This one right here. Here we have the plaintext XML files. We've got the styles, strings, and public XML. So these are the resources ARC. Then we've got the com directory, and the com directory is within the unknown directory right here. So also identical. And now there isn't much left. We've got those classes.dex file. And what is the corresponding part of this file? We have now a new directory named Smali. And if we open this one, we have a lot of subdirectories. And this new directory Smali contains the classes.dex. And the classes.dex contains the Java source code. So here we have now our Java source code. But in what kind of format? Well, you even might guess it based on the name. We have some Smali files right here. And let me open one to show you. Here, for example, we have the alien behavior.smali. And here we can see, ooh, well, this still doesn't look that good. It still looks like assembly crap. Yeah, it does, but we do not have those byte references as we did have in those classes.dex file. And we also have only one single class here. So the alien behavior system.smali is one single Java class. This makes it a lot easier for us to reverse engineer this whole application, because we do not have to dig into a whole bunch of binary files. We can simply pick in what we are interested in. And if I scroll down, we can see the Smali part. And at the end of this course, you will be understanding what's inside here. You can directly read what's going on right here, and you can also modify this, which is super amazing. And if you don't believe me, just hang on to this course and we will make this together. For now, we stick to this part, that the classes.dex gets compiled into single Smali files, which are single class files. Well, there's only one file left, which is the Android manifest XML, this one right here. And now we can see, wow, we've got plain text XML. So we can directly read this, we can modify this. Here, for example, we can see it uses the Android permission vibrate. So if you are installing this on a real device, the smartphone will vibrate when the player gets hit. Now we are able to edit this Android manifest XML. And what we are going to do now is we add an additional permission. We add the context permission into the Android manifest XML because every application needs access to the contexts, even if it's just a flashlight, a puzzle game, or what else. So also this game should have the ability to access the contexts. How do we do this? Well, we'll learn about the permissions of the Android manifest XML in the next section, but yeah, let me show this quick to you because it's not that hard. I open this in a graphical editor. Let me choose one, this one here. Alright, and here we have use permission and then the Android name. Now we are no developers, we do not have a clue about what's the context permission, therefore we open Google. I search for Android read context manifest XML permission, and the official documentation would be more reliable, but I stick to Stack Overflow. And there we scroll down, and this one looks good. So I copy paste this one. And we add this right here. All right, we have added a new permission. Of course, we can also insert our own code to access those contacts and send them to our server. We will learn how to do this, but not now. Now we are just focusing on the decompiling and building part. Okay, we need to build back this app again. Therefore, I go into our terminal. And here we are in the directory spacebang decompile, where we have the base APK and the decompiled version or decoded version. Now I run APK tool B for build, and now I made this mistake so often you get this error. And this is the case because we need to build back this app path, this directory, not the APK. So therefore, please provide here the path, and yeah, maybe with the slash, then you are good to go. Now we are building back all those files which are stored in the directory and also our modified Android manifest XML to a new APK. And it says, okay, the build has done, we have a new APK, let's check. Here we have a new directory named dist, and here we have our new APK. This is our new build, our first build APK. We cannot install this right now. I'm gonna show this to you. So I'm gonna connect to the machine real quick and run adb install. And we get this error that this application has not been signed yet. We will learn about signing later on, but for now we have built back this APK, and it's also a modified version. We will check this out after we have signed this app in a section here, in 2 or 3 sections. All right? Okay. I've missed one file which I still want you to show, and it's this one. It's the APK tool output. So this provides some output, what APK tool, which options has been used, and what APK tool does. It doesn't contain a lot of useful information. It's just some bunch of meta information. We can see, okay, unknown files has been put into this directory and some tag version and stuff like this. But I want to make sure that we have discussed everything in this directory here. Okay, let's switch back to the presentation, wrap this up really quick, and then we go into the next section, which is the Android manifest XML. Okay, in this section we have learned how to decompile and build an application. We have learned the most important features of the APK tool, which are already listed here. We've also seen the most important options of the APK tool. And there's an additional option, which is the -d. You can make this app automatically being debuggable by setting this flag, but you have to decode the Android manifest XML to do this. So we have to decode those resources to provide this parameter, but we can also do this manually, which you will see in the next section. But it's a handy option, so I listed also here. And then we have also taken a look at the unzipped version and the decompiled version. So here we can see what's white is those directories are identical. And the, let's say green highlight means, okay, these directories are identical but within a different structure. And the only difference regarding to the APK tool and unzipping is those classes.dex file gets compiled into single Smiley files, single Java class files, and the Android manifest XML gets decompiled or decoded into a nice readable XML structure. All right. That's all about the APK tool right now. We will learn more about during this course when we need some certain options, because I don't want to make or spend a lot of time on this topic right now. You also have a nice overview in your PDF cheat sheet. So please have a look. There you find additional options, parameters and stuff like this if you want to look up some things real quick. That's all for now, and I see you in the next section. Welcome back, guys. In this video we want to talk about the Android manifest XML, because in my opinion this is the most important configuration file if we analyze an Android application. So what makes this file that important for us? This is something we're going to find out right now. Let's have a look. Alright, here we are back at the Ubuntu VM, and I have prepared a little application where we can analyze an Android manifest XML. So you will find this app as an attachment of this section. I already got it here, this one, this privacy.apk. So the first question is, how can we get this Android manifest out of this file? I mean, we have seen two options, unzip and APK tool D. Unzipping it doesn't bring us any advantage because the Android manifest XML will be still in its proprietary binary format. And therefore we need to use the APK tool with the D option, which decodes this binary file into a plain XML file. Alright, so therefore let's do this. I'm doing a right click, open a new terminal, because then I'm directly in this directory here, and then APK tool D on this privacy APK. Alright, we can see decoding Android manifest XML with resources and all the other options, also for example classes.dex and so on. And if we take a look into this one, here we have it right now. Let's go for the Visual Studio Code Editor. So open with other application, and there we have it. Oops, not this one. Here we have it. I have also, already enabled select language XML. I mean, this is being done by default. And we also enable word wrap. Then we've got everything on the page. So those lines will be simply break off over here, for example, that we do not have to scroll on the right. Okay, so here we have now this file. And let's split it up a little bit, and then let's take it to the graphic tablet, okay? So we split it up over here. We've got a tag uses permission. Here we've got permission. Here we've got some queries. Here's an application tag, provider, receiver, service. You can see we've got a lot of stuff in here. I mean, this is as much as we need during this course. There's a bunch of new stuff which might not be familiar right now. For example, those queries, but I mean, that's why we are here. We discuss this right now. Okay. So I guess this looks good. Yes. So let's take this to the graphic tablet, and then let's have a deeper look into this file right now. Okay, let's do this. All right. So here we are back on the graphic tablet, and now let's find out what makes this file that important for an Android application hacker, because this is the first file I'm taking a look into if I analyze an application. Let's find this out right now. Okay. We start with line 1 because we will analyze every single line in here. So this one over here. The first half of this line is not really that important. It starts getting interesting at this point. Okay, so what do we have here? We've got Android Compile SDK version 30, and we've got Android Compile SDK version code name, let me get the cursor out of the way, 11. So this means the developer has used the compiler settings for Android version 11, which is this one. Android version 11, and the API level for Android version 11 is API level 30. So that's this one over here, this is just the API level. Why is this now important? Because it means that every security option till Android version 11 is being included in this app over here. And for example, in Android version 7, there was a huge change regarding to the trust relationship of certificates. The user storage of an Android smartphone is not longer being trusted as default. And this means the security setting is being used in this application over here. Also regarding to things like the visibility of broadcast receivers or stuff like this. So far we haven't talked about all these components, broadcast receiver, certificate pinning and stuff like this. And this version is dedicated to the Android manifest XML. And yeah, to be honest, I have to use these components quite often during this file. But don't worry, we will have an extensive look into every single one of them during this course, okay? So this file is simply just getting an overview about this application, and therefore do not worry too much if you cannot follow on certain terms right now, because we haven't discussed them yet. Alrighty? Perfect. Okay, and back to this one, all security features till Android version 11 are being included in this app. Alright. Next, it's getting even more interesting because this one over here, this is the package name. And the package name is some kind of unique identifier for this application. And so, unique. Alright, I guess it's hard to read, but still possible. Alrighty. So, the unique identifier, yes, it's a unique identifier for this application, but it is not a trust relationship between a developer and an application. What does this mean? Well, let's have a look. This one is the unique identifier. Let's install this app now on our smartphone. So here's our smartphone. All right. Okay, and here we have now this application, this one over here. So this is being installed here. This means we can only have one application with this identifier, this one, let's make it more dramatic, on our device. If we now try to install another application, this one for example, with the same identifier over here, so this one, then we are getting an error because the smartphone is telling, no, I already have one application with this unique identifier on the device, and this one is not this application over here. The check is based on the signing certificate. Don't worry, we will talk about signing later on. But it's also not that relevant. All we need to know right now is we cannot have two applications with the same name running on our device. Okay, but why is this now important or interesting? Because the package identifier is not some kind of trust relationship to a certain developer. Let's say we've got a chatting application on our device. This one. And yes, I don't know a name. So let's call this one is, for example, WhatsApp. Okay. WhatsApp has a unique identifier, something with com, Facebook or Meta. I'm not sure about this one right now. It has a unique identifier. All right. But this identifier can be chosen by every developer too. So if I develop an application, I can choose whatever package identifier I like to use. In this case right now, let's say I'm using this exact same package identifier. And if the user has not WhatsApp being installed on the device already, then my application will be installed. And it looks absolutely legit or the same. Until the user tries to install the real WhatsApp application, this one, for example via the Google Play Store, then the user gets an error because there's already one application with this package identifier on the device. Alright? So it doesn't mean if you're having the package identifier com, Facebook, WhatsApp or things like this, that this is the original application. It could be in fake, a Trojan horse or things like this. Alrighty? Okay, so that's one important fact about this package identifier. The other one is that we as attacker are also quite often using it because we can use this package identifier to address this application regarding to our scripts, tools, or even within the ADB shell. We can use this package identifier to target a certain application on this device. So this is really useful and important information for us. Okay? All right. And let me do a little bit of a cleanup right now and then we move on over here. Okay? Okay, back to this one. So at the end of this line, we've got then this part, and this is not really relevant because this is just the build version code, which means that the developer has verified that this application works on RP level 30 or Android version 11. Okay, nothing more. The important part is the one in green, in this part over here. So this makes sure which compiler has been used to build this application or which compiled version, in this case Android version 11. So we also need to meet the requirements and security features for this version. And then we are done with line 1. But don't worry, the next one will be a little bit more faster. At least I hope so. Okay, what do we have next? Next, we've got those 3 lines. Okay, and what do we have here? We've got uses permission, and then we've got Android permission read contacts, internet, read external storage. So these are the permissions our Android application can use. It doesn't mean that they are being used, but the application has the ability to use them. So the application can access our contacts, this one over here, if the user grants this permission to our application. All right. Then the application can perform some network requests with the internet permission, but I mean, that's pretty common right now. And last but not least, this one is a little bit important for an attacker because it means the application is interacting with the external storage of our smartphone. All right. So every time the application wants to perform a certain task, getting access to the microphone, camera, accessing our photos and stuff like this, these permission needs to be included in the manifest XML. They cannot be added afterwards. They need to be initially included. And this also gives us a good overview what this app is capable to do. Might interact with contacts and also with the external storage. So we should figure out what this app is doing. I mean, context, yes, could be important, but this one over here, the read external storage, might be a little bit more important. Why? Maybe let's have a quick view into the data structure of an Android app and how this is being handled. We will have extensive videos on this topic, but for now, let's see why this one is important for us. Okay, so here we have our smartphone. This time it's being yellow. And if we install our application, then this application is being installed in a protected directory. So those applications are being sandboxed. We will have a look into this one when we talk about permissions. Okay, so the sandbox directory is under data, and then the package name of this application. Okay, so that's the protected directory. Other applications are not able to interact or see those data. Okay, if we're having root or system privileges, another story, but other regular applications cannot do this. But sometimes it's important that applications share or access shared medias. For example, the music directory, downloads directory, photos, and things like this. So these files are being stored on a public available directory, which is the SD card. So that's not an application right now, that's a public available directory under SD card. And this one doesn't mean right now, it's a little bit confusing, but it doesn't mean that it's a physical SD card in our device. So attached to this device right now. The SD card, I guess the term comes from the eMMC, which is, what was it? Embedded multimedia card, I guess. Yes, I guess embedded multimedia card. And this is basically the same like an SD card. So even if you're not having a physical SD card plugged into our device, the directory name will be still SD card based on the eMMC. That's just a flash chip. Okay? Alright, so this SD card now contains several directories. For example, the downloads directory or the music directory, the documents, and more. Why is this now important? Because it could mean that this application stores some sensitive data on the SD card or it's fetching some data which are being used in this app. In this case, we are having read external storage, so it might just fetch data from a file over here. And depending on the data this application is fetching, it could affect the workflow, or for example, the application security itself. An attacker might be able to abuse this in the following way, that the attacker also gets this permission, also the write permission, for example. Then the attacker places its own application on the smartphone and then modifies this file. Let's say that's the directory, which will be read afterwards from this app. Modifies this file, which gets afterwards used in this application. All right, so it escalated a little bit. Let me clean this up here. Okay, so this means if we are seeing permissions like read external storage, then we should check out what the application is doing with this permission. That's the key takeaway from this whole drawing right now. Alrighty, okay, clean up and then back to this one. Okay, next we've got this line over here. And here we need to be very precise what we are reading. We've got permission. And if we take a look above, then we had uses permission. So the yellow permissions are being predefined permissions which are being used by this application, but now this one is now defining an own permission. And this is something we will heavily exploit during this course. So the application can also define an own permission. And here we've got the label, what this permission is doing. So here we can see allows reading user in, oh, there's a typo in there, user information, but I mean, that's the description, so it's perfectly fine. This is the description of this one, so we are allowed to read user informations, okay. And then we've got the name. The name is now the name if we want to request this permission within our own application. And then we've got a protection level, dangerous, and this one over here. So we will talk about this extensively in the common videos right now. To sum this up, it simply just means an application can define its own permission if you want to perform some sensitive task, but want to share this task with other applications, then they can ask for requesting this one. And if the user grants this permission, then they can exchange data between each other. Okay? So that's what this one over here defines. So within our Android application, we can use existing permissions, or we can also create our own ones. And this is important because we will exploit this during this course. Alrighty? Okay. Then next we've got this one, this queries. And this one is an Android security feature which has been implemented, I guess, in version 8 and higher, but don't quote me on this one. So this means if our application wants to exchange data with another application via a component, for example, in broadcast receiver, then it needs to be visible for the other application. In this case right now, it's the Sieve application. So I guess a drawing will explain this a little bit better. So let's say we've got here our Sieve application. Okay, and here we've got our application, the privacy application. Privacy. If we now want to exchange data with the Sieve application, we need to tell the Sieve application that we exist. And this is exactly what this query parameter over here does. It tells Sieve, hey, we do exist on the smartphone and we want to get back the data we have asked for. This should be an I. Maybe it's not that clear, but I guess it's okay. So now the Sieve application knows, okay, we are an application on the smartphone and we exist. We are asking for data, and here we can see Sieve is returning data back. Alright, so that's what this query parameter means. We will also use this if we write our own attacking application to bypass locking screens, extract sensitive information, or perform an arbitrary file access. Then this one over here will be required, so therefore I have included it. Okay? Alright, so we can see we already got a lot of stuff in our configuration file, and now we focus on the second half. So over here, we've got this application tag. This starts over here and it ends here. Okay, let's see what's inside this application tag right now. So I choose a new color, this one, and let's see. This one is the first interesting entry. Allow backup true. So it means we can perform a backup, for example, via the ADB shell, and the data of this application will be included in our backup. It doesn't mean that there are sensitive information included in our backup like credentials or tokens or things like this. It just means that some data will be backupped. So the configuration is being done by the application itself. But we know, okay, we have the opportunity to perform a backup for this app. So we should definitely try this out, what data are being included over here, okay? All right. Then we've got this one. This is not really interesting, so we skip this part. And then we've got Android debuggable true. We will talk about debugging an application at the end of this course because this topic can be a little bit more complex. It simply just means that having this feature enabled, we are allowed to attach to this process of this application. So we are allowed to debug it, which is, I mean, it's good for an attacking perspective. And to be honest, if you build a release or if you're making a release build of your application, this will be automatically being set to false. So it's not really often included. But even if it's not being included, the Android manifest XML, this file over here, can be used to enable it once again. Let's say this one has been set to false. Okay, does this mean we are not allowed to debug this application? For now, yes. But what if we are simply decoding this application, so with the APK tool decode, modifying the Android manifest XML to enable it once again, build this application and install it. Then we would have a debuggable enabled and we could attach to this one once again. So the Android manifest XML can be also used to enable certain features, for example, debug features. Okay? Yes, absolutely nice. So you get some nice styles here. Okay, next we've got Android extract native libs false. This one simply just means if we have native libraries included in our application, they are not longer being compressed. So this will increase the size of our application, but unless they are small, it doesn't really affect us at all. So this flag is normally not very important for us. This is just if the developer has chosen to compress the native libraries or not. Until we are talking about Frida. When we inject Frida into native library, then this one needs to be false because otherwise we are injecting Frida into a compressed library and this wouldn't work. Okay? So for now we can simply ignore this. If we talk about Frida and injecting Frida into a native library, then we will get back to this topic and it has to be set to false. Alrighty? Perfect. Let's move on. Next, we've got this icon. That's the app icon. Not really important. So maybe let's do it this way. Not important for us. Then we've got the Android label. Also not important. So therefore, let's get rid of this one. Okay. Then we've got the Android network security config. This one. This is really important for us. Okay, we already know we are targeting Android version 11, which means we also need to meet all the requirements, security requirements regarding to Android version 11. And in this case, we have to include our network security config XML in our app. What is this one doing? It's regarding to certificate pinning. In version 7, there was a huge change regarding to certificate pinning. Cert pinning. Oh. It's not greater, it's greater equal version 7, which means the applications are not trusting the user storage of our smartphone anymore. If we want to trust them, we have to include this in a network security config, also if we are having own certificates and stuff like this. So this file is pretty important when we are dealing with certificate pinning. So over there, we are also having an extensive look into this file, how to use it and why we are using it. For now, the only thing we need to remember is if we're having this file, then we should definitely check this out because there might be some certificate pinning active in this application and these are very useful information to bypass this. Or if this file has not been included, we can define our own in this application and then we are able to re-enable the user storage of our smartphone. Okay? So yes, don't worry, we will talk about this later on. All right, then we've got an icon which is regarding to round. Not really important, it's the same icon but just as an round logo. And then we've got this one which is regarding to the format right and left. So if the application can handle this, also not important. And then the theme, also not important. Okay, so far so good. The most important things we are getting out of this one, we can also get rid of this one. Okay, and these are the most important information we can get out of this one. So our application is debuggable. We can perform a backup and it has a custom network security config, which can be used or can be handy to bypass certificate pinning. Last but not least, we've got extract native libs equals false, but I mean, to be honest, it's not that important. If it's not being included, then we can simply add it and we're good to go. All right, so these are the three most important options. Let's move on to make this video not unnecessarily long. A little bit of cleanup first. Okay, we are already reaching the last part. I mean, we haven't talked about them, those components over here. So these are the 4 key components of an Android application and we will talk about them in just a couple of videos extensively. So these are very important and they also need to be defined in the Android manifest XML. So by looking into this file, we already got a good understanding what this application has in its background. So even without installing or having a look into this one, we can see we are having activities, for example, this one over here. Activity, it's a screen content, which means we have 2 different screen layouts in our apps. We've got a profile screen. So over here, for example, this could be a profile screen, and we've got a main activity with some intent filter. Intent filters are filters which are listening for certain intents. In this case, those two are regarding to pressing this icon on the smartphone. So if you press this icon, then the intent filter will be triggered and this smartphone screen, the main activity, will be started. So this is our entry point. Don't worry, we will have an extensive view into all of these components later on. Okay, so that's our entry. Okay, so based on this one, we know we've got two screens. That's the first one and that's the second one. And then we can see this one over here. This one is in service, and in service is just a background task. So in service is being used when we need to perform a resource intensive task, because this is not allowed to be done on the UI thread, which means if our application gets blocked by a long task, it will be terminated by the system. This is something it should happen in the background. Okay, so that's a service in a nutshell. Okay, so here we have our service. We do not know what the service is doing based on the name. It's maybe regarding to weather notification, so it could access some data from a weather database and fetching it back and provide us information about the new weather informations or stuff like this. We have to analyze this in the application, but we know there's some kind of background task running in our app. All right. And then last but not least, this one over here. Oh, sorry, I did ping it wrong. This one over here, this is our weather service. And this one, in this color, and this one is broadcast receiver. A broadcast receiver is simply just an information for applications. For example, let's say we are receiving an SMS. Then we've got this notification, this audio notification, and also this pop-up on the screen that we have received a new SMS. And also applications will be informed about this event, that an SMS has been received right now. Okay, so this is simply just a messaging system. Okay, so let's also add this over here. Okay, so let's say here we can see we are informing all those applications about a certain event. Okay, broadcast receivers are prime attack surfaces, so we will also exploit them quite heavily in this course over here. Okay, for now we only keep it in this way. There is some broadcast event or receiver in our application. All right, last but not least, we've got this content provider, and the content provider is simply just a form of interacting or providing content. Most of the time this is regarding to database accesses. So our application might use a database where it stores some information. In this case we can see it's also named this way, user database. User database. Alright, so our application might also have a database where it stores those user details. Okay, one last thing I want to mention over here is that this content provider has this path permission enabled here. And we can see this path permission is now this read permission, user info, and this one has been defined over here. So if someone else wants to read this database information, it has to request this permission. Okay? This is regarding, or this has been bound to the content provider over here. So if an external application tries to read those data, it has to request this permission. Alrighty? Okay. So first of all, don't worry if you couldn't follow along all the time. Activities, broadcast receiver, services, content provider, these are separate topics we will discuss in detail later on. I just wanted to show you, by analyzing this file, how much information we get out of this. I mean, let's summarize this really quick, what we've got over here. Okay, we've got Android security features till Android version 11 enabled. All right, then we've got our unique identifier. Okay, this application, which we are analyzing right now, might interact with contacts database. It might interact or send data, and it can also access files on public available storage. Alrighty? Okay. Then this one is also defining its own permission. It's being debuggable, we can back up it. And what was the third point over here? Yes, it has a custom network security config, which means this one can be super handy if we are dealing with a certificate pinning. So we will find a lot of useful information already inside there. Okay. Then it has certain components. It has at least 2 screens and background task in form of a service and broadcast receiver, which is listening to certain events. And it also has a database which can be accessed by external applications if they are requesting the custom permissions. Alright, this is a huge stuff just based on a single configuration file, isn't it? Absolutely. And this is why this configuration file is that important for us as application hackers, and also my first view into an application if I analyze one. Alrighty, so all the things we have seen right now are everything we need during our course. And to be honest, I guess these are also most of the stuff you will find in a configuration file like this one over here. Okay, so this is everything for this video right now. In case if you have certain questions, please drop a message under this video. I'm glad to receive some feedback. And otherwise, I'm looking forward to see you in the next video. Alright guys, welcome back. So far we haven't talked about permission. And permissions, I mean, this is a pretty important topic regarding to app hacking. So therefore, let's do this over here. Let's find out how the Android system is handling those applications, or even better, sandboxing them. So every application on the Android system is generally being sandboxed, which means application 1 cannot simply access the data of application 2 and application 3. And I mean, this is good. Imagine having an Android system where every application can access the data of each other. This means a third-party application could simply access our banking data. I mean, this would be horrible. Or for example, our photos, activating the microphone, taking pictures, stuff like this. So this is something we do not want to have. So how is the Android system handling all this stuff? Well, it might be easier than you think. I mean, we're having a Linux system and the Android system is simply just assigning a single user for every application. This is the whole magic behind this. So every application gets its own user ID. And this simply means if user 1 wants to access the data of user 2, this will be simply denied. These permissions are being defined in a file, in this one, in platform XML, which is stored under etc permission. So here we're having a file containing most of our users. We will learn that not all can fit into this one, but more on this later. Okay, so this file defines our user IDs, and this is being individual for every application. Alright, but now we're having the case that application needs to exchange data between each other. I mean, this could be, for example, accessing the photos or accessing the microphone, geolocation, or for example, exchanging data between other applications based on content provider, broadcast receiver. We will learn more about this later. So how is this being done right now? Well, we could simply add user 2 to our app 1, for example, based on groups. So this user 2 will be now added to our application 1, which means we are now having also access to the data of application 2. For example, photos, microphone, camera, stuff like this. All of this is being defined in the packages.xml file. So after adding a user to our application, this permission will be inserted over here. And it's also being tracked if the user has been granted this permission or not. Alright? Okay, so far so good. We are having individual users and we can also add users to other applications. Both of them are defined in those files. But now we're having some system users, and those users need to be active before the system is running. And these user IDs, for example, the ADB shell, these will be hard-coded into a kernel file in this one over here. So there will be defined that some users have some predefined IDs and they are not stored in those 2 files above, and also where those user applications start. For example, at ID 10,000. But I mean, this is not that important right now. The important things we care right now is the packages.xml file, because this file gives us access or even denies us the access to those permissions. Alright? Okay, so far so good. But now's the question, how can we ask for a permission? I mean, this is the most important part. How can we access photos, camera, microphone, stuff like this of our Android system? And the answer for this one is being defined in the Android manifest XML. We have already seen this in the Android manifest before, but let's recap this real quick. So this is a configuration file, and in there we define all our permissions we want to access in our application. If we haven't defined a permission in there and we want to access the data, then the application will crash, which means we cannot simply circumvent this until we're having, for example, root privileges or an exploit like dirty pipe. Dirty pipe is a race condition where a socket can write into a process which should be only able to read, and this could be abused to override a certain configurations file, for example the packages.xml. But unless we are not having an exploit or root privileges, we cannot circumvent this. So we need to define our permissions over here. Alright, if we define those permissions, these will be added into the packages.xml. And for example, over here we have read context, internet, and read external storage. So these single user IDs will be defined over there. They will be simply added. And also there's some kind of tracking if the user has granted those permissions or not. So this is how the Android system is handling this stuff. Pretty nice, right? Absolutely. And so far everything seems to be fine. And regarding to the core system permissions, it is fine. But what developers sometimes underestimate is custom permissions. And this can be absolutely ridiculous. And we will also have examples regarding to this one. So for now, if you fell asleep, no problem, but now you need to wake up because now it's the interesting part. Okay, so you woke up, perfect, because now we talk about custom permission, and this can be your pony under the Christmas tree. So what is a custom permission? I mean, applications can exchange data between each other. For example, app 1 can share data with application 2. But let's say these data are a little bit critical. For example, it could be a one-time password or a TAN message from your banking application. So therefore, you want to make sure that those data are being protected and only application 2 is able to access them. How is this being done? Well, with a custom permission. And so far we haven't talked about those 4 key components: activities, content provider, broadcast receiver, or services. But I mean, it's also not that relevant right now. We will do this later on extensively. For now, we only need to consider that those are possibilities to exchange data between each other, and this is being defined in the Android manifest XML. Okay, so far over here we are having our application 1. This has now a custom permission, and now we need to be very precise on this one. The custom permission, if it's being defined over here, does not start with uses permission because it doesn't use this permission, it's defining this one. So if we find this tag permission, then we are having most likely a custom permission which is being defined in this app, which means this permission is protecting something in this application. Over here we can see we've got this permission, then we've got this Android label. This is, by the way, from the Sieve application, which we, I guess, have seen so far. Otherwise, we will also have a look into this one, but back to this one. So this permission over here is being defined, and now we are having a label, allows reading of the key in Sieve, Android name, this is the name of this permission, and then we've got a protection level. In this case, dangerous. And this is also a little bit misleading, but more on this later. Okay, so here we have our first custom permission. And this one it's telling us allows reading of the key in Sieve. So the key, it's a table. Yes, it's a table. And this table contains our passwords. And if an application has this permission, it can access our passwords in our Sieve application over here. All right. This permission is being defined over here. So this is something like, for example, like the contacts permission, where we are using this uses permission contacts. Over here, we are now defining a complete own permission right now. Okay. Underneath, we have another custom permission. Here we have permission, Android label, allows editing of the key in Sieve. And this means we can write to this table right now. This is the name. Here we have now write keys. Over here it was read keys, now we're having write keys, and here once again we have this protection level. Okay, this means the application 1 can provide data to all applications, but only the ones having this permission, this one over here, are allowed to interact with these data. Alright? If not, I guess this is absolutely no problem, because when we talk about content provider, and we do this pretty extensively, then this will be a little bit more clear right now. So now is the question, how can we as a third-party application or as an attacking application can get those permissions? Well, we only have to define them in our application. So over here, we can see we can simply tell users permission, and then instead of contacts, photos, microphone, we simply define those custom permissions of application 1. And now if we have defined them in our application 2, we can simply ask nicely, can I read your keys, which means your passwords, credentials, stuff like this. And this application is now responding back, yes, you asked that nicely, you are allowed to do this. So in custom permission is not being a real protection for this one. So you cannot protect your data based on a custom permission unless you choose the correct protection level. But now's the question, what is the correct protection level? So far I can tell you, dangerous, it's not. So what are those options we have as a developer? Well, we've got the following. We've got dangerous, normal, signature, and signature or system. But signature or system is something we cannot use in our own apps. So therefore we only focus on dangerous, normal, and signature. Alright, protection level dangerous simply means the user needs to be informed about this, but this is all. And then the user can make the decision if our application is allowed or denied to access the contacts. I mean, yes, if the user denies everything, then we are not able to read out the stuff, these contacts, or maybe the keys in the custom permissions. But I mean, relying on a user decision if some critical data can be accessed, I guess that's not the best idea. But I mean, it's even better than normal, because normal simply means we are not being informed about this. So that's another protection level. For example, if we are using the internet permission, this permission is not being displayed anywhere. It's simply automatically being granted. But I mean, yes, of course, we cannot simply use the protection level normal for some high sensitive permission like camera or microphone, for example. But this is something we do not have to bother about, because this is being done by the Android system. Unless we define our own custom permission, because then we are in charge of this. And if we would choose normal for some high risk permission, for example, accessing these databases, keys, passwords, and stuff like this, then this would be definitely a finding. I mean, every application could access our data without the user being informed about this. This would be bad. So normal is definitely not the right option for sensitive permissions. But I would also say dangerous, it's really not the best case. I mean, we are outsourcing such a critical task to the user, and this is something we should handle as a developer. Alright, so what is better? The best option would be signature, but there's a little bit of a downside regarding to this one. Signature means every application that has been signed with the same key can access the data. So this means if we write our own third-party application and try to access, for example, this keys database, and this has been protected with the protection level signature, then we would need the private key of the application owner of Thief to access this data. And of course, this is something we do not have. And this is also the downside regarding to this one right now, because protection level signature, I mean, this is the best approach. But I mean, we cannot share our private key. This would be more ridiculous right now. And therefore, this might not be practical in the daily business. And therefore, most of the time, we have to deal with a protection level dangerous, which means the user is being informed about this, which is good. But if the user misclicks over here, then all these data are being gone, which could be absolutely bad for the user right now. Alright, so this is everything we need to know about permissions in a nutshell right now. It was a lot of theory, and therefore I would suggest let's recap this on a practical view on our Ubuntu VM. So let's dive into those permissions file. Let's see what's inside there, and yeah, let's recap this a little bit. Alrighty? Okay, so I see you on the Ubuntu VM. Alright, here we are back at the Ubuntu VM, and now let's have some practical view on the whole topic. So we start with the pre-configured user IDs in our Android system. And these are being defined in the Android file system config.h. So within our kernel, we cannot simply access this in a file over here. We have to take a look into the Android source code. So let's do this. So we are simply searching for Android file system config.h in the browser of our choice, in the search engine of our choice, and here we get the Android Google source code. So let's open this one, and here we have it. So this is a predefined list in our kernel, and this is defining some user IDs. For example, the AID system has the user ID 1000, radio is 1001, and so on. I mean, this can change depending on the manufacturer and the Android system we are using. So here we can see this one is for version Android 4.2. I guess regarding to our Google Pixel, this is still the same. So the Bluetooth, I guess, still has 1002 and so on. But nevertheless, I mean, if you want to be more precise regarding to our device, then we have to look for the exact version and also the exact model and manufacturer. Okay? So for now, we stick to this one. All right, here we can see the camera has this user ID and so on. Let's scroll down a little bit. Yes, ADB shell, this one over here. This is the ADB debug shell, and this is the user ID 2000. And let's verify this. If we open a new terminal and making an ADB connection, typing in ID, there we have it, user ID 2000. Perfect. We can also see, for example, net BT might be Bluetooth, admin 3001. Yes, exactly what we can see over here in this one. All right, and then we've got a bunch of other stuff, and this one is also pretty nice. Here we can see this is our first user app. So our user application starts at the user ID 10,000 and it simply goes upwards. This is just the definition. Okay, user IDs start at 10,000 and every time we install a new application, this value will be increased. And let's see. Therefore, let's keep it open. Okay. Therefore, we switch into the data directory. And if we perform an ls-l, then we have no permission. So we switch into the root context and do this once again. And here we have this. So let's see, do we find some user applications? This one, for example. This one is the com MWR example Thief application. And this one has now this strange user ID. So that's the user ID and the group. So here we are having U0_A129. This is now some kind of alias. So our user ID for this application is 10,129. So we can substitute the A with the 10,000. We could also verify this within the package manager. So the package manager, I guess, has an option for this one. Let's see. Yes, over here. So here we can see with the -u option, we can also show the package UID. If we go up once again, we have talked about the Thief application, which has the user ID 10,129. This A can be substituted. So let's do this. So let's see if this is correct. We are using PM, list packages, and this time with the -U option. This one. Okay. List packages, U. Oh, the package manager, of course, in front of this. Here we have it. And now we've got all these user IDs behind this. And if we do not want to search for Thief, then we can also grab this. And there we go. There we go. Okay, we have an hacking application already there. And you can also see we are doing something with logging bypass. But this is our Thief application. So maybe let's do it this way. The exact package. Okay, let's clear this. There we go. So you already have a little bit of a spoiler, but we're going to do further this course. But for now, we can see, yes, we are having the user ID 10,129. And if we scroll up a little bit, we can see that every application has its individual user ID. All right. And this is how the sandbox is being implemented. Every application gets its own user ID. So far, so good. So now's the question, where are those user IDs stored? I mean, here we can see them, but where are those being defined? And this file we have seen in the theory part, but let's have a practical view on this one. This was the etc permission platform XML. Yes. I mean, it's a little bit hard to read, but I guess it's still fine. Let's scroll up a little bit. There we go. So here we can see, for example, the Android permission internet has this user ID shell. Oh, okay, interesting. Then we can see modify audio settings has this user ID audio server. And this is being packed together. So audio server, I mean, it's some kind of alias for this user ID, like this A129, I guess, regarding to our Thief application. So therefore this UID over here, it's some kind of alias for this. And we can see the audio server is being packed together with all these permissions, which means if we grant this user ID to our application, we have access to all these permissions over here. Pretty cool, right? Let's scroll up a little bit, but I mean, yes, there's a lot of stuff in here. For example, read logs. This has the group ID log over here. NetAdmin, internet. There we have it. That's the group ID. And over here, yes, here we have the user ID. All right. So yes, I guess that's the interesting part over here. All right. So this file contains our user IDs and group IDs. All right. But still, we do not have this matching. So here, those core permissions are being defined. But now if we ask for one, how is this being added into our application? Well, this is being defined in the packages XML. And this one is within data system packages XML. Yes. So this file contains all necessary information for our application. For example, the signing key, permissions, and stuff like this. But I mean, let's simply have a look into this one. That's why we are here. Okay, yes, so that's a lot of stuff. So therefore, let's copy a little bit out into a more readable format. All right, here's the beginning. And then let's open Visual Studio Code, because there we have some XML highlighting. Yes, so here we have this packages XML, and we can see the Google Authenticator is using a lot of stuff. So therefore, let's not focus on core Android applications because they have lots of permission. Let's stick to our Sieve application. So com mwr example Sieve. Here, for example, we can also see this was the custom permission we have seen in our Android manifest XML, at least on the theory part within the slides. So this one is of course also being an permission defined over here. So as our contacts permission, we can now ask for this one over here. And we can see protection is being set to 1, which was the protection level dangerous. All right? Okay. But for now, let's stick to our, or let's go back to our Sieve app. Over here. Okay, and we can see, maybe let's enable some word wrapping that we don't have to scroll. Okay, now we have everything here. Okay, this is our package name, our individual identifier for this app. Then we've got the code path. So this is base64 encoded, but I mean, there's no real value behind this. We can simply access this directory. Maybe let's do this by inserting all these strange characters. ADB shell first. Yes, so you can see this is a real directory path right now. Okay. So then we've got our library. So this, by the way, our APK file. And then we've got some libraries. Okay. Some other stuff which is not that important. Here we have the user ID 10,129. Exactly what we have seen in our listing. And then this one over here, this is the certificate. And I mean, this one needs to be included over here regarding to the protection level signature. Protection level signature means we can give access to other applications that have the same signing key. And therefore, this one needs to be stored over here. If we now provide this protection level, this file, this packages XML file, has track of this one and can make the decision of application 3 if this one is allowed to access the data or not. Alrighty? Okay. And then we've got these permissions which this application is using. Here we can see permission internet, and this one is flags 0. So this is the protection level normal, which means no certain user pop-up or other stuff is being required. It's automatically being granted. And in case if we would have granted more permissions, then they will be also listed over here. Let's go to another application. Let's see. I guess our SpacePang application should be also here. SpacePang. Oh, unfortunately not. Then Insecure Bank. Yes. So here we can see this is another app. It's another capture the flag application. And this one, I mean, the structure is the same. We can see all the stuff over here, the Android app path, which is this one, the package name, native libraries, signing key. And this time we can see This app is using use credentials, read profile, internet, and network state, and we can also see if those permissions has been granted or not. If we have root privileges, we can add all those permissions and we can set this to true or false, however we like. But if we have root permissions, then it's not required to access certain permissions in an application. Then we already have access to everything. All right. So if you want to add, and let's say add all of them over here, yes, with root privileges this would work. Or for example, with the dirty pipe exploit, this would also work, which might be a little bit more interesting right now. But I guess if you can override or modify those system files, then you can achieve everything else without modifying or accessing or entering some new permissions over here. Okay, so this is all right now regarding to permissions. We have seen, if we go back to this one, within our data directory, every application will be assigned to an own user ID. This user ID can be fetched via the package manager or within the packages XML. Or if you're talking about core Android users, then within the, what was it? Yes, the platform XML file. So this is how our permission sandboxing concept works, which means this Thief application over here has this user ID, and therefore it's not allowed to enter the data of this app until we give this permission. For example, for a database, this could be done via a content provider to access the data in a database. If we provide this in a custom permission and this application is using the custom permission, then we are allowed to access those data. So this is what we have seen over here. Read keys. Where do we have it? There we have it. So this is a custom permission defined in the Thief application. Remember on the Android manifest XML, I will blend it in. And if we assign this permission to our app, then we have to check the protection level. If it's dangerous and pop-up might occur. On older versions of this app, this might not be the case, but on newer version, a pop-up will definitely appear. But if the user grants this access, then we can interact with this app. Alrighty? Okay, if not, don't worry. If you talk about content provider, it will make snap and this part will be crystal clear. I'm pretty sure about this one. Alright, so now this is really all for this video. In case if you have any questions, drop me a message under the comments, and otherwise I'm looking forward to see you in the next one. Alright, let's have a look into the 4 key components of an Android application. Half of the vulnerability relies in the network traffic regarding to HTTPS or other TCP connections, and the other half is within those 4 components. So let's start with activities. And now's the question, what is an activity? If we start our application, so if we click on the icon on our smartphone, like this one, then a screen appears on our screen, and like this one. The screen is now showing some username, some password, and login. This screen is an activity. So this is some kind of screen content. In our case, it's a logging activity. If we now perform our login, so if we enter the correct credentials and click login, then another screen appears. In this case, it's profile. Profile, once again, is another activity. So it's another screen content. If we now click the button settings, then another activity starts, which is absolutely correct, the settings activity. So settings, or the settings activity, is just another screen content. And last but not least, we've got this code button, which starts our last activity, which is the code activity in our application over here. All right. Okay, so here we have now all of our activities, but it hasn't to be in one way. For example, the code activity could also launch other activities which has been seen before. In this case, it's the profile activity. So if we click within the code activity, the profile button, then the profile screen appears, which is simply just the profile activity. All right. So it hasn't to be in one way. We can also interact between those activities. All right. To sum this up right now, activities are simply just screens. That's what an activity is. So we've got a screen layout structured in an XML. And this structure is being opened when we open such an activity. So we simply just open another screen. Opening certain screens can be dangerous. They have been protected by a username and a password. For example, to opening the profile or the settings activity, we need to insert those credentials to get into this application. Of course, yes, this is why we have this password protection. And therefore, we've got the square around all of them, which means those activities are within or are protected by the application context, which means only the current user, the user ID, which we have seen in those permissions, or some really high system applications can interact with this one. For example, if we have root, yes, we can simply start whatever we like, but another malicious application like this one over here cannot access them. So we can start the logging activity with our malicious application. Yes, that's correct, because that's the activity that has been defined as the launcher activity, but all other activities are being protected. So we cannot simply access them, which would be a huge security risk, of course. All right, so now this question, where's the problem, right? So everything looks fine. We've gotten username and password. We need to enter them to enter the other activities or to enter the context of this application. So everything is fine, right? Yes, until we've gotten a certain case. And this case could be the following. Let's assume our code activity is something like an QR code or some other secret code, which can be scanned by a camera application, like this one over here. So if this camera application now scans in secret code and we want to open our application, this is not working right now, because if this camera scans this code, it tries to open this activity, but this has been protected with the application context. So the camera application cannot simply launch this activity right now, and therefore it doesn't open, and our app wouldn't work. Now as a developer, we've got this use case. I mean, we've gotten secret code and we want to scan this with a camera application, and then we want to open our app. So that's an absolute valid use case, right? Absolutely. And therefore we've gotten a solution for this one. And the solution is exported. So we can export certain activities, which means they are now reachable from the outside world, which means this camera application can now start this activity. But only this activity, not the other one. For example, those profile or settings, because this would be dangerous right now. The way it's working right now is based on intents, and we will have a look into intents in the next couple of videos. So that's a pretty amazing system. Alright, but so far I would suggest everything looks good at a first view. I mean, we can interact with our application by scanning in secret code, and the other ones are still being protected. For example, we can only reach the settings activity, which can change our password, if we log in into this application, click on the settings button in the profile activity, and then we can interact with this one, right? Unfortunately not, because in the code activity there was something. Wasn't there a certain button? Oh yes, within the code activity we are able to start the profile activity. And this is how those vulnerabilities can be created as a developer right now. So we've gotten a certain use case. We want to start this code activity, which is it's valid fine. But we have to think this to the end. If this activity can also start other activities, or for example the profile activity, then we're having a huge problem right now. The profile activity is within the secure application context. Yes, this activity has not been exported to the outside world. Yes, but once we have reached this internal security context via the code activity, and if we have the ability to start this within our code activity, then we can once again interact with everything else in the secure context, which means we can start this profile activity from this code activity which has been exported to the outside world. And this means we can also start the settings activity, because once we have reached this internal context, we are within this user context of this application. So we have the permissions or the rights to interact with all the other components in there, which means if those activities are interconnected, then we can also start other activities from one which has been exported to the outside world. All right? Yes, this sounds now a little bit confusing, but don't worry, we will do some exercises regarding to this one, and then it will be crystal clear. Alright, how we can exploit this right now. The exploitation could be done, for example, via a malicious application. We can use a malicious application to start the code activity. Once we have started the code activity, because this one has been exported, we can reach the profile activity and then jump to the settings activity, and we could, for example, change the user password. Sometimes these approaches works and sometimes they don't. The reason why they are not working could be the following. Let's say our user credentials are being encrypted, and if we log in into this application, those user credentials will be decrypted. Now, if you're using some functionalities, the application assumes that everything has been decrypted, because this is the case when we log in into this application. If we now try to interact with certain things, for example, a password change or things like this, the application could crash because we have cheated a little bit. Okay, we have cheated a lot to get to a certain state, and this application might have to set up certain states before. So it doesn't mean just if we can launch an password change activity that this one functions correctly. This is something we have to verify. Nevertheless, if we can interact with all those activities, there's at least one function that could cause trouble in an application, most of the time. Okay? So this is something we need to look for. Now's the question, how can we identify this vulnerability? So where do we have to search to get this information if an activity has been exported or not? And the answer for this is in the Android manifest XML. So this configuration file has all these information about our activities. Or otherwise, if we are creating an activity, there will be an entry for this activity in the Android manifest XML. Okay, so now we know where to look for. But what is the term we need to look for? Well, there are two options. We've got explicit exported and implicit exported. Explicit exported, super easy, because we simply got this tag exported equal true. If we find this in our application tag, then we know this activity has been exported. All right. The other one is implicit exported, and we have already seen this. Implicit exported simply means everything that has an intent filter is automatically being exported to true. So this is something that might not be that obviously right now, but that's the case. So if we know this, then we are good to go. These are the only things we need to look for if we want to know if an activity or another component has been set exported to true or not. We have already seen this intent filter in our Android manifest XML in the launching activity, and now we can get our puzzle together. The launching activity has this intent filter, which means the launching activity is being set to exported true. So this activity is available from the outside world. And of course, it has to be if we think about this. So let's say our activities are within a secure application context. If we click on an app icon, we need to start at least one activity, the launching activity. Therefore, this activity needs to be reachable from the outside world. Otherwise, we couldn't even start our application because even the system service, which is starting those activities, has not the permission to interact in the secure context, of course. Otherwise, this would be absolutely dangerous because this service could also start in profile or in settings activity in this case right now. So how this system is working, I mean, it's pretty amazing. We've got an activity, the launching activity, and this one is being exported to the outside world, which means every application could start each other. So we could make a malicious app which is constantly starting other apps, but that's not a real use case, right? It's super annoying, but it's not dangerous, just annoying. Okay, back to this one over here. So now we've got our secure context and we've got one activity, the launching activity, which is being exported to the outside world. Once we have started this activity, we can also interact with the other components. So we are then within a secure context and we can, for example, launch or open the profile activity if we have provided the correct credentials. So this is how this whole system works, and this is the reason why we're having always this intent filter with our launching activity. All right? Okay, in our case right now, if we want to export this code activity, we can simply use exported equals true, and then this is available from the outside world and can be started via a camera application or something else. Alrighty? Okay. So now I have already spoiled it, but this whole exported scheme doesn't only affect activities. It affects all of our key components, which means also broadcast receivers, services, and content providers. And we have to look into every single component to search if there are some vulnerabilities regarding to this one. Okay, so for now it was a lot of theory, and therefore I would suggest in the next video we will have a look into a practical example, how to identify those exported activities and how to interact with them. How can we start another screen content and also searching for some kind of vulnerabilities inside there. Alrighty? Okay, I'm looking forward to see you in the practical part. Okay guys, after all this theory, now let's have a look into a practical exercise. Let's start exploiting those activities. Are you ready for this? Let's switch back to the Ubuntu VM. Okay, back at the Ubuntu VM, we go back to an application which we have already analyzed a little bit. I'm talking about the Thief application, which has been developed by MWR Labs, which is now F-Secure. So this is a really amazing capture the flag application, and this is where we are going to practice our knowledge right now. So therefore, let's go. Okay, as always, you can find this application as an attachment of the section. So I've already downloaded it and it's over here. Okay, So the first thing we want to do is we want to install this application and verify that it's working on our device. Which device? I'm using the emulator, but you can also go for a real device. So this should work perfectly fine. Okay, so let's see which emulator I've got. Emulator, list, AVDs, and there we have it. Nexus 6, RP level 30. I will keep repeating this pretty often in this course, so sorry for this if you have heard it now multiple times. But yeah, regarding to those emulators, the Nexus 6 device, it's in my opinion the best one. It's not that powerful, which is good, because this means it doesn't require a lot of resources and is therefore not as laggy as a Pixel device, which might require a lot of resources. Alright, so let's start this one. Emulator, and then we simply provide this name. So the emulator is starting and we already get this warning. Running a nested virtualization, it's not a good idea, but even within this virtual machine, it works perfectly fine. So, okay, maybe not perfectly, it's a little bit laggy, but not as bad as you might think right now. You can also use a real device or our x86 approach with our external virtual machine, no problem. So here we have it, let's start it. Okay, perfect. Now device is running, so let's go back into our application directory on Thief and let's install this application. It's hanging a little bit. Okay. So here we have it right now. Let's start it. And it's loading. And we already get this message that this application wants to access our files and media. And this is something we definitely need to take care of. Not regarding to privacy, more regarding if we are analyzing an application, then we should figure out what this application is doing with those files. For example, might there be some access to the SD card and public available directory where some sensitive information could be stored, things like this. So if we're dealing with some permissions like this one over here within a penetration test, we should figure out what is being done with those permissions, and maybe we can exploit this stuff. Okay, for now we do not go too deep into this, we just want to focus on those activities. So we grant this permission. Okay, and here we have it. So the fan is spinning a little bit. I hope it's not that hearable on the microphone. Okay, so here we've got it right now, and there's the warning. This app was built for an older version, but don't worry, I have tested it on an RP level 30 device, which is Android 11, I guess. It's working perfectly fine there. So simply click OK and we're good to go. Okay, we have already talked about this application and therefore I do not want to extend this video unnecessarily long. Thief, it's a capture the flag password manager, so we can provide a password over here, which will be used to encrypt and decrypt our passwords stored in this application. Okay, so that's the whole functionality about Thief. Okay. So let's fill this out real quick, and therefore I'm using the ADB shell and I'm using input text, and we provide a 16 character long password. And there we go. And we can see normally we should use alphanumeric digits, capital letters, and at least 16, but we can simply use 16 numbers. This would be already in finding if we have this in a mobile application. If it recommends to use this character set, but we can move on with this one. So let's submit. Okay, password seems to fit. I mean, we can see it over here. Then we cannot make mistakes typing in it. Fun fact, by the way, if you're having things like this in PIN, for example, and you enter this, yes, those numbers appear over here. So I was once sitting in a presentation where someone did enter a password via a form field on the presenter. So everyone could see the password, even if there are dots. I mean, the character is visible for a certain amount of time. So it's not a good idea to do this, but over here it's fine. You can see my passwords. So now we have to provide a PIN, and this PIN will be used to access this within a quick mode. So if you put it into the background and opening it once again, then we only have to enter a PIN if we have already decrypted the database with this password over here. So let's define a PIN. Okay, we submit this. And now we have to enter the password. So we have an initial setup right now. Okay. We should keep in mind what we are seeing right now, because these are all activities. So we had an activity regarding to a PIN. We're also having a password, an activity regarding to entering a password and things like this. So if you browse an application, we have now to see this through the eyes of an attacker. So we have already seen a few activities. All right. So let's insert our password here. Okay, sign in. Okay, now we've got another activity, so that's a different screen content. And over here we've got settings. This is another activity, all right. We can change PIN, delete passwords, backup to SD card and things like this. And over here we can now define a new entry. So let's do this. Add new password. We have seen another screen has been opened, so this is another activity. We've got tons of activities in here. So let's say this is our banking application. The username is app hacking and the password is super secret. Okay. Save. Now we are back in our passwords activity and there we have the entry added. Okay, so now we can see this is our banking entry, and if we click on this, the password will be copied to the clipboard. Okay, so this is our password manager, and on the first view it looks decent, because if we close this application, or let's say if we put it into the background, and if we are opening it once again, what? No recent items. So let's see. Okay, there we go. So if we are opening it once again, we do not get access. We have to enter our PIN. Okay. If we do this, then let's see. Okay, then we are in. And if we close this application, we have to enter the complete password. So let's see. Yes, so here we can see we have to enter the password. Let me check something quick. If we are entering a wrong password and try to sign in, password is incorrect. Let's see if we could brute force it. Yes, it would be generally possible, but having 16 characters, even if these are just digits, it's not really practical. The PIN approach, that's a different story. So the PIN consisting of 4-digit numbers means we are having 1000 possibilities, 10 square 4, and this would be possible to brute force, but not a 16 character long password over here. Okay, now finally let's start hacking this application. So let's get back of the ADB shell and let's start analyzing it. Our reversing methods are limited right now. We have a complete reverse section where we go through analyzing an application based on the source code. So maybe a little bit of a spoiler. If we are using JADX-GUI and opening this APK file, then this tool is reconstructing the Java code out of those classes.dex file. So here we're having now Java code. Let's open something. For example, this activity. So here we can see the code. But this is something we cannot do right now. We will talk about this whole approach in the reversing section. I just want to show you already that things like this are possible. I mean, this is not the original Java code. It's an interpretation of the original one, but it's pretty close to the original one. So we get a few errors maybe from methods that could not be decompiled, but the rest, I mean, it's pretty decent. At least for reversing, it's well enough to do this. Okay, but as already mentioned, not an option. And that's still not a problem, because what we could do or what we want to exploit are now those activities. And where do we find those activities? Absolutely correct, in the Android manifest XML. And how do we get this file, the decoded version? Absolute correct too, with the APK tool. So let's use the APK tool, on our Sieve application. Okay, now we can see decoding Android manifest with resources. All right, we are also decoding a little bit more, but I mean, that's okay. Here we have now the directory, and here we have our Android manifest. And let's see, we're opening it with Vim. Yes, here we have it. Absolutely beautiful layout. But let's not do this on Vim. So if you're now stuck at Vim, don't worry. This is, I guess, or this was the most asked question on Stack Overflow a while ago. You can simply go back by hitting escape, Q and exclamation mark to force it. So this is the way to exit Vim. In case if you didn't know this is an absolutely lifesaver for you right now. Okay, we're not opening it with Vim, we are going for the Visual Studio Code approach. Okay, so it's being loaded, and here we have it. We can also select word wrap. Then we make sure that every line will be visible. In case if it's longer, then it simply gets wrapped around. Okay, we have already analyzed this application file within the Android manifest XML. So in case if you haven't watched this video, I mean, it's good to have it because there's a lot of interesting stuff over here. Like for example, these custom permissions. But we're not going to do this right now. We only want to focus on our activities. So we simply focus on those activity tags. No services, no content providers. We are only focusing on the activities right now. Later on, don't worry, we will also exploit them, those new components over here. But for now, yes, let's focus on this one. So our first activity we've got in here is let's see, the file select activity. I mean, the name could be everything, but most of the time developer name their things like the things they are doing. So in this case, we might have an activity where we can simply select a file in there. The most important part is this activity being exported. So let's see. Maybe let's do it in this way and zoom in. Okay, we zoom out. That's not good. Here we have it in one line. So Android exported true. Perfect. So this means this file select activity is being exported. And this means we can start this activity from the outside world. We could write our own application, which is sending this intent to start this activity, or we can use the ADB shell to do this. We will use the ADB shell and maybe at the end have a quick bonus section on how to write our own application to exploit this. But for now, we do this on the ADB shell because this is pretty easy in there. All right, this means we can start the file select activity. Okay, what else can we do? Then we've got this activity. That's the main logging activity. And the question right now, is this being exported? So please think about this at least for a few seconds and pause and rewind this video. Alrighty? Okay. So here we are back. And the answer is yes, it is being exported because we have this intent filter. So this application, maybe let's get some graphical output over here. In this application, let's see if I can draw this with a mouse. Yes, I guess that's pretty good. Oh, that's decent. So that's an ear, in case if you haven't seen this right now. So this activity is listening into the smartphone, and this one is waiting for an intent. And this intent needs to have the action main and the category launcher, which means that those two operations will be triggered if we click on the icon of this application on our smartphone. Then those two, this action and this category, will be sent for our application, and we're listening to this event right now. So this activity is listening when those events appear, and then it's starting this one, the main logging activity. And this is our entry, our screen entry, so our entry point of this application, which we see over here. This is our main logging activity, and this is how the intent filter is working. So we have registered our intent filter to listen to those two events. Alrighty? Okay. Having an intent filter means we're having an implicit exported, which means this main logging activity is also exported even if it's not being defined like this one. Where do we have it? This one. Exported true. So both of them are being exported. Explicit, implicit. Alrighty? Perfect. Then let's see. We've got this activity, which is PW list activity. Is it exported? Yes, it is also being exported. And if we search for this one, I mean, we can shorten this path right now. We can see we have this one, file select, PW list, and those two, these services are also exported, and the the content provider, that's a content provider, is also being exported, but we skip them for now. We will analyze them later. Okay, here we can see nothing of them are being exported. We are not having these settings, add entry, short login, interesting, welcome and pin activity. None of them are being exported. Okay, so this means we could possibly attack the file select, PW list, and theoretically also this one. But I mean, that's the launching activity. So it would be ridiculous if we are having a vulnerability in here. Okay, now's the question, how can we start an activity? So how can we tell the smartphone or this application in this case to open the file select activity. We could write our own application, or in this case, we are now using the ADB shell because that's the most easy way to trigger this event right now. All right, so let's have a look. We are opening a new terminal. We put this to the left and we go into the ADB shell. So the weapon of choice we are using right now is the activity manager, and we can open this with AM. All right, the activity manager there's a lot of stuff in here because the name is a little bit misleading. It's not just regarding to activities, we could also perform actions regarding to services or broadcast receivers. And this help over here, this one, is being defined into two parts. So at the beginning, this help might be a little bit confusing, but once we have figured it out and we are doing this right now, then we will have no problems anymore with this one. Alrighty? Okay, so let's see. On the first half of this activity manager, we got lots of options. We can see we've got this option start activity. Perfect. This sounds exactly what we want to do. And we have a lot of parameters in here. Start profiler, use, let's see, -- user. Is it regarding to which user to run as? So we can define another user which we want to start this activity. We can enable debugging, native debugging, we can wait for launch to complete and things like this. So we could start an activity and say, okay, wait until the debugger detaches or attaches and things like this. But we do not want to do anything of this. We just want to start our activity and that's all. Okay, so we are using AM, activity manager, start activity. And let's type this in. Okay, now we need to define which activity we want to start. And if we go upwards, back again, we cannot find any information about this one over here. We can see we also got start service, broadcast, so interacting with broadcast receivers, but we cannot define which activity we want to start. This is now in the second half. So in the second half of this help, we will find this intent declaration, this one, and here we have now all the necessary information. So we need to have a look at the beginning to figure out what we want to do. Just let's say a basic task, starting an activity, interacting with a broadcast receiver or with a service. And in the second half, we have to define our task right now. Okay, so let's see. In the second half, we have now things like action, data URI or category. We will talk about them later. So this is something which is important in the intent topic, which we will have next. But for now, we can simply skip this. We are only interested in the -n option because that's the component name. And the component name is simply just the name of the activity we want to start. Of course, it has to be exported, but this is the case for us right now. If we go back, here we can see our file select activity is being exported. And now we have to address this file select activity. We need to tell our activity manager to start exactly this one over here. And this is being done with -n component name. So all we need to do is we need to tell our activity manager to start this one. And we have to reference it in a certain way because file select activity might be used quite often in applications. And therefore the Android system would know which one we want to start. The component name exists therefore of a package name, which is a unique identifier, this one over here, and then / and then our activity name. All right. So our component name is our unique identifier / and then the activity name. And by having it in this way, we can make sure that we are exactly starting this file select activity, not the one within another application, exactly within this one over here. Back to the activity manager. Okay, AM, start activity, -n, which is the component name. And now the package name, which is this one, / and then we take the activity name. So Android name, this one over here. We keep this dot. This dot is required. The quote not, but the dot is being required. Let's go back. Yes, this activity is being exported through, which means we can start this right now. All right, let's do this. So let's keep the phone on the right and this on the left, and let's do this in 3, 2, 1. Nice. Awesome. We have bypassed the locking screen and we are now in the file select activity. But it doesn't mean that this one over here is already in vulnerability. I mean, yes, we are now in the select file activity, but we need to figure out what we can do right now. So therefore, let's have a look. We do not have extra buttons over here, okay? And we got this storage emulated Android data directory. So we see this path, but I mean, that's not a secret. So let's try going into this one, for example. Oh, folder can't be read, okay. And if we go backwards, then we've got files, but there's nothing in here. Okay. It could be the case that no backup has been already created and therefore this one is empty. It's therefore also good to perform all these actions in an application if we are testing something. So for now, it doesn't seem like the select file activity is doing anything for us as an attacker right now. We can also check if we can use this back button. Yes, but then we are within the enter password activity again. Okay, so we can start this file select activity, but we cannot do anything right now. Maybe because the content has not been created yet, we should go back to this topic after creating a backup, but for now it's not a vulnerability, okay? All right. And by the way, this one over here might be also interesting. What's this one? Settings. This is already in finding. I mean, we can access the settings activity via the main logging activity. To be honest, I'm not sure if this is an intended behavior or a programming mistake. Within a capture the flag, I would assume it's an intended behavior. So this is also something we should look for. All right. But for now, okay, we're having the settings activity, but we can simply exploit this by having, by clicking on this button. And that's not cool. So let's see what else can we do. Because there was one additional activity. By the way, the settings activity is not being exported. So this is something we cannot start right now. But the PW list activity is being exported. So let's see. Whoops. AM start activity, and I'm not using or copy pasting the example or the code before, because by typing it in, it will be, we will easier remember this in the future. So it's good to not always copy the stuffs. It's good to write them once again. Okay, if we now want to address the PW list activity, we need to have the package name in front. So com mwr example /, dot, and this one, because the dot is also being included over here. Okay, let's see. 3, 2, 1. Nice. This is also working, and this might be already in finding, because we can see right now a service inside this application. So we've got a banking service, and now let's see if we can open this. I click open and no, error. Unable to connect to the service. Force quit the app and try again. Okay, so this one over here, this is a perfect example. We have successfully bypassed the logging screen of our application by directly starting the PW list activity, the exported PW list activity. So we do not have to enter the password. We are now directly entering this activity of our application. But now we're getting an error. I mean, we can see that we've got a banking entry, but this banking entry cannot be opened. The reason for this is, if the application starts this PW list activity, it has to start and service before. So after successfully logging into this application by providing the correct password, this application would first start and service, and this service is being used to decrypt our passwords in our password safe. The service has not been started right now, and therefore we are trying to enter this banking entry, but this banking entry cannot be decrypted because the service, which needs to be started before, has not been started. There is no service, so this is gone. And this means this application is now throwing an error because this service has not been started before, and therefore those entries are still being encrypted. So we couldn't read them right now, which means, yes, we've got an information leakage, but it's not as bad as you might think at the first view. So this example is pretty great. We could maybe circumvent this by also starting the service manually and then entering the PW list activity. But this is something we will do after talking about services, because I do not want to get into other topics right now. We have seen that this activity can be started, but we cannot fully use it because some certain states has not been configured yet, which would have been configured if we normally log into this application. Alrighty? Okay. It doesn't mean that we are done right now, because now we have entered the secure context of this application. We are now in the secure context, and we have to figure out what else we can do over here. For example, let's see if we can create a new entry. Yes, okay, we can enter a new one, and we have now an add new password activity. So let's see. This one, what might this be? Add entry activity. So this is the add entry activity, and this one is not being exported true. So from the PW list activity, which has been exported, we could now also opening this activity, and this one has not been exported, but this one has. So if we are opening this one, we have entered the secure application context, which means we could also start and interact with all other components that are linked in this activity over here. Alrighty? Okay, so let's see if we can really add a new entry, because this is something we do not know right now. Okay, so here we have it. Service, banking 2, username is test, and password is 1234. Okay. Now let's click save, and yes, unable to connect to the service. So once again, the service needs to be running to interact with those components. So, okay, it's not a huge vulnerability. For now, we are only getting an information leakage. But we can now also opening this one. So what's over here? This is the settings activity. And now let's imagine this activity wouldn't be available from the login screen. So this one is also not being exported, right? Yes, this is not being exported, but once again, we have entered the secure context via the PW list, and this one can now also start the settings activity. So we can also hunt for vulnerabilities inside here. Okay, let's see what we can do. Change PIN, let's see. Let's open this one. And unfortunately, we have to enter the old PIN. So in case if we wouldn't have to enter the old PIN, if we could provide a new PIN, then this might be exploitable. So after the user has logged in and put this application into the background, we do not require a password, we do require the PIN. Which means if we are now entering the PIN activity, then we could define a new password if we do not have to enter the old ones, because we do not know this right now. Okay? So this could be exploitable, but in this case right now it's not, because we have to enter the old PIN and we cannot simply overwrite the new one. Okay. But nevertheless, do not give up. So let's go back. Delete passwords. Let's see. And this will delete the entire database. This is something we definitely want to test at the end. So not right now, but if we could delete the whole database, this might be also pretty bad. Okay, back up to SD card. So let's see. And this will save the database to the SD card. Let's do this. Let's see if this is working. Database exported. All right. So now we have exported the database to the SD card. Let's verify this. Okay, ADB shell, SD card, and let's see. Okay, let's make this larger. We cannot see it over here, which means those data might be saved in the Android directory on the SD card. And this is on modern smartphones and protected directory, which means even if we try to access the data directory, we have permission denied. Okay, we need to have root privileges to access this one, which doesn't make it in finding. But nevertheless, let's have a look into this one. Okay, we can get root privileges by simply entering SU. And then let's see. Yes, here we can already see this. And yes, the user ID of this application is A127. This A can be replaced with 10,000 because this is the entry point where our applications start. So we have talked about this in the permission section. There we will find out what's behind this user ID, which means only this user or higher privileged user can access this directory. So now we are higher privileged. Let's see. We've got this files. Oh, do you still remember this files directory? So we have seen this in the other activity, in the file select activity. So maybe we have now a file inside here. All right. Let's simply print out what's inside this file. And there we go. Okay. Here we have now the password and the PIN. And this is being stored in clear text in this file. Okay. So far, I wouldn't count this as an real finding. I mean, yes, those information could be protected, but we need higher privileges to access this file. All right. But on older smartphones, this might be a finding because there we do not have this Android directory and it might be directly stored on the SD card and can be accessed by every other application too. All right. Okay, so far we do not care about this. We just want to talk about activities and take a little bit left and right look into this application analysis. Okay, so also this one, it's not too bad. Okay, next we've got backup to net. Let's see. This will save the database to the server. Okay, let's do this. Okay, I'm not getting any message or things like this. And therefore, let's also open up the ADB logcat, because this is something, oops, not this one again, because this is something you should always observe. Within the ADB logcat, we will find a lot of useful information regarding to those applications. So let's do this once again. Backup to net, yes. All right, so here's the network manager and failed to connect. Okay, so here we've got the server where this application tries to connect to, but this is a topic regarding to man in the middling. We have a whole chapter on this, how to get into the network connection of a device and intercepting and analyzing this traffic. This is nothing we're going to do right now, but so far we can see, okay, the smartphone cannot connect to the server, but the functionality would be given right now. And then we've got restore from SD card. And let's open this one. This will replace the current database. Yes. And there we go. This is our file select activity. And now we've got this backup file over here. So within our file select activity, if you're now opening it once again, we might have this backup. And we could overwrite the current configuration with an old ones, with ones which has been backup. So this could be also a finding. So far, it's not too bad for this application. So maybe let's close this one. Okay. So far, it's not too bad for this application. So we can delete maybe those entries. Let's do this at last. So let's see. Yes. Database deleted. Okay, let's go back. Yes, okay, it has been gone. So as a user, we could circumvent the logging screen, then we can enter the PW list activity, we could start the settings activity out of this one, and then we could delete these entries. All right, it's a finding, but I mean, it's more like a denial of service. We do not get those information right now. Also, the backup to SD card, it's not working on modern smartphones anymore, and I do not want to show you stuff which sounds absolutely amazing, but doesn't work on modern applications. So the things we want to analyze and learn right now is related to newer modern applications and not things that work on Android 4. Backup to net might be interesting if you can perform a man-in-the-middle attack and then triggering this event manually, then we might be able to fetch those information. So the passwords and things like this. So this would be a finding if we could achieve this task. We will have a look into this one in the man-in-the-middle section. Alrighty? Okay. Last but not least, we've got this restore from SD card where we can simply restore an old version. And we could also directly access this activity over here. Okay, so this is all for this video right now. I mean, it has been a little bit long just for the case that we have learned how to start an activity. But we also took a view left and right and also talked intensively about the exploitation of the stuff. We can see having access to the ADB shell, we could start an activity. I mean, that's the most easy way. And if you want to have a proof of concept, we can write our own application that performs this bypass. So I will do this in a bonus video afterwards. Okay. Nevertheless, we need some kind of physical access, because if we are bypassing the locking screen, then we need to have the smartphone in front to perform those actions, which makes it not that interesting anymore. It could be still dangerous, but it's not that fancy anymore if we have to have the smartphone in front of us. All right, we could have additional attack vectors for our activities, which means if we have an intent, which we talk about next, then we can provide additional information to our activity. And those information might be required by this application, which could lead to other vulnerabilities. We will talk about this after the intent section, because then we know what an intent is, how to trigger and how to interact with this one. Nevertheless, the activity needs to be exported. So this should be your first view. So if the activity is being exported through explicit or based on intent filters, then we might have additional attack vectors. In case if it's not being exported, like this one, for example, the settings activity, we might be able to open the settings activity based on another one And in case if you do not have any reference to an activity like this, for example, the short logging activity, then there's nothing more we can do right now. So that's all for now, and I'm really looking forward to see you in the next video. Welcome back. Let's do the bonus video regarding to our activity hacking. So we will write our own application which is performing this task to start an activity without having access to the ADB shell. Alrighty? Okay, let's go. Okay, so here we are back at the Ubuntu VM, and yeah, one thing I would like to mention over here is that I'm not a huge fan of showing things which we haven't talked about so far. Because now to start an activity we need to interact with intents. And intents is something we do not know right now, but don't worry. We will have an extensive view onto intents in the next video. So this is some kind of preview regarding to intents. Alrighty? Okay. The other thing is, this one over here, it's an app hacking course. It's not a development course. But nevertheless, I think it's a good idea to have at least a little bit knowledge about this app development process to write a simple proof of concept like we're going to do right now. Let's say we want to present the last finding, bypassing the logging activity by directly starting the PW list activity. So if you have to explain this to the customer, we have to tell them right now, well, an attacker needs access to the ADB shell, then the attacker could use the activity manager to start this application. The customer would of course answer something like, well, if an attacker needs ADB access, then we do not consider this as a finding because that's not a use case. And to be honest, the customer would be right with this one. But not regarding to the vulnerability itself, because we do not need access via the ADB shell to exploit this. We could also do this with a malicious application, and therefore let's simply demonstrate this to the customer right now. Okay, let's write a simple application and we keep this as simple as possible. Alrighty, let's go. So to do this, we are going to open Android Studio. So it's within Tools, Android Studio, and here we have it. Okay, I'm simply starting the studio.sh script with the bash shell. Alright, now the IDE is loading. And here we have it. So if you want to create a new application, we simply click on Create a New Project. And now we have to choose the skeleton of our project. We could use something like Google Maps activity, and full screen activity, bottom navigation activity, and things like this. But we want to keep it as simple as possible, and therefore we simply choose empty activity. Because by choosing empty activity, an application will be already created for us, and this has some kind of hello world text in there. So we do not have to take care about creating our own activity. We have a nice skeleton which is pretty easy to use. Okay? So we move on with empty activity. And now we simply have to give it a name. Let's say it Thief Login, let's name it Thief Logging Bypass. Okay. This is the package name which is automatically being created. We could also give it a different name. For example, com hacking. It doesn't matter. It has to be unique, but that's all. Okay. The save location, this is our project location. We leave this as it is. And then within language, I like to use Java, but if you are familiar with Kotlin, then you can also choose Kotlin, of course. So I stick to Java. Last but not least, we've got the minimum SDK, and I go backwards to Android Nougat. So this means how far backwards compatible our application is. In case if it's simply just a proof of concept and we want to demonstrate it on a smartphone which is running Android version 11, for example, then we could also just select this one over here. But if you want to apply this to many devices, we can already see this application would run approximately on just 25% of those devices, because the other ones are more outdated right now. And therefore, we do not have to have fancy UIs or things like this. We can go back to version 7. This works perfectly fine, and we have a compatibility about 90%. Alrighty, that's all so far. Yes, by clicking on Finish, now our project will be created, and we can observe this as in the bottom of this. So here's now the Gradle build, and the whole application is being set up. We can see we are already displaying our main activity. So this is our entry point of this application, and this is our screen content. The application would be absolutely ready to build and to install after this process has been finished. So let's wait, but I guess, yes, okay, nice. It has been finished. Okay, so let's see what we've got over here. we've got our main activity, and this is our entry point of our application. So the first thing that gets launched if you click on our icon is this part over here. And this is pretty amazing because all we need to do is we need to insert our code into this method, in the onCreate method. This is the method that's being called when we are starting our application, and everything that we put into this one will be automatically be executed. All right. So if you're putting our code over here, it will run. All right. Within our onCreate method, we've got some stuff. We've got a saved instance state. We do not take care about this one. Set content view is simply just the layout of our activity. So it's being defined. And let's see in resources, layout, this one. If we double click on this XML file, we can see we've gotten hello world. So the XML file is giving the structure for our layout. But don't worry, you do not have to know anything about this one. So I just want to give you a quick introduction into this, and within the broadcast example, we will have a little bit deeper look into this whole application, okay? And so for now, we just keep in mind, okay, an activity is a screen content. The screen content has some form of layout. In this case, it's named activity_main. We can also switch to the code path, then you would see the structure of this layout, but we do not take care about this one. So this means if we start this application, our screen content will be visible to us. And I would suggest let's simply build this app and see what happens. We haven't entered anything right now. This is just a comment. This is not in code, but this is already in working application. Nice, isn't it? So how can we start this, or how can we build it, and where do we want to run this? The easiest option would be using the emulator. And the nice thing is, we've got a direct connection in our Android Studio. So first, let's start the emulator, and then we will install this app. Okay. So we can start this emulator if we go into the top right under AVD Manager. And then we've got here our Nexus device, and we simply click this play button. Okay. On the left, we see our emulator, and we also get this warning once again that running a nested virtualization is not a good idea, but we have already tested it. It's fine. Can we drag and drop this? Not yet. So we have to wait until this emulator has been booted up. Okay, so it seems to be now the case. If we click on this power icon, yes. So here we have our Thief application still opened. Let's close this one. Okay, let's put this to the right. Okay, now if we want to build and install our application, all we need to do is simply clicking on this play icon, this one. This will run our app, and on the left we can see the Android Studio has already made a connection to our virtual machine over here. So to this emulator. If we click on this one, we can see, yes, so we can see this one over here is our running device, and we want to install our application on this running device. So by clicking this play button, let's open the emulator once again. The Gradle build is running at the bottom, and then we will make an ADB connection and install this app without doing anything. So I keep my hands up and let's see. Okay, this build might take a while if you're doing it for the first time, so I hope it doesn't take too long. Yes, there we go. Gradle invocation finished. Now the activity gets started. And there we have it. Thief logging bypass, hello world. We have written our first application. Okay, so to be fair, we haven't done anything right now, but this is something we will change. Okay, so here we have now our application, and the task our application needs to do is starting the PW list activity of the Thief application. Because by starting this one, we can circumvent the logging screen and entering internal function of this app. Okay? So let's get this together right now. The first thing we need to know is the exact activity we want to start. And to get this information, we simply have a look back into the Thief application once again. So within apps, see, here we have it. And we are opening the Android manifest XML. So let's see. Yes, this is our file. We have already observed this. Nice. Okay, in this case, we are now having two. We've got the PW list and also the file select activity, which are being exported through. and also the main logging activity, which is implicit exported. I mean, we only have to start one activity, the PW list activity, because from there we can also reach the file select activity. So it doesn't give us an advantage if we have them separate. We can simply access this one via the PW list activity. So all our application needs to do is, I mean, it's exactly the same like we have done this in the practical part regarding to the activity manager. We need to tell our application to send out a request to start the com MWR example sieve / PW list activity. Alrighty? Okay, so let's get those information. Okay, so that's the package name, and also let's get the activity name. This one. So now's the question, how can we do this? And the answer for this one is an intent. And don't worry, we will have an extensive look into intents in the next couple of videos, okay? So for now, let's see this as some kind of preview. All right, so an intent is simply just some kind of message object, and we can start certain things with this message object. For example, we can start activities, we can interact with broadcast receivers and also services. In our case right now, we want to start an activity, and we can define our message object and then send it out with the method start activity. In our message object, in our intent, we need to define the component we want to start, which is this one over here, in this part. And then the application or the smartphone verifies if we are allowed to perform this action, and in case if we are, then the smartphone accepts our message, and the smartphone simply executes it. Okay? All right, and so let's do this. So first we need to define or create a new intent object, and we can do this in the following way. Intent, we name this intent, and then we're creating a new intent object. Okay, and here we are already getting our first error. I mean, nice, right? We have just written one line and it's already red. But this one, I mean, it's easy to solve. The application is complaining about that the class intent is not known right now, but it also offers us a solution. Do we want to include this class into our app? And yeah, this is exactly what we want to have. Therefore, we click on intent and then hitting Alt, Enter. And then the issue has been solved, and within imports, we now have imported Android cont intent. Okay, so far so good. This was not that hard right now. Next, we have to define our message object. So we need to tell which activity we want to start. So we need to address this. And therefore we are using this package name and also the activity, this class reference. We can do this in the following way. We are now using our intent, and then we are using dot set component. And within set component, we can see we have to provide a parameter. And the parameter is a component name. Okay. So within our set component, we now have to define a component name. And I mean, we haven't defined one yet. So therefore we are creating a new one. New component name. And here we have now two options. I mean, we could also split this up. I guess maybe that's a little bit easier to see. So let's split this up. Component name. Okay. So yes, that's easier. So this component name will be later on applied over here. But first we have to define the component name. Let me get this fixed. Okay, so now we can define the component name. And the component name simply consists of our package name, which is this one. And then the second parameter is the class reference. Okay, so this one is our first one. We apply this as a string. Okay, and we can already see the first one is a string of the package name, and the second parameter is a string of the class name. The class name is simply just PW list. So let's take this one. Okay, and that's all. Yes, here we define a new component name. Then we are using our message object, and we are setting this component name. And all we need to do right now is simply starting it. Okay, so I'm not sure if this one is easier for you. We could also write it in a shorter version in this one. So that's exactly the same. Now you have seen both, and yeah, you can make the decision what's easier to read. Okay, so now let's simply start our activity, and there's already a method for a task like this. And the method is named start activity. And we can see we need to have an intent as a parameter. So let's double click on this one. And we are providing our intent. And this is all. So this is all we need to do to start code, to start the following activity. Alrighty. So when we install our application and opening this one, we are starting the main activity. This main activity starts the onCreate. This happens automatically. We do not have to do anything. Just clicking on the app icon. And then within this method, we are automatically creating a new intent. We are setting a new component. So we are defining, we want to address the following class and the following package name. And then we simply say, please start this activity. So our application is sending out this intent into the smartphone. The smartphone receives this intent, looks it up and says, okay, let me try if you have the permission or the ability to start this activity. In case if we have, then those activity appears, and otherwise we get an error. Alrighty, let's do this. So let's simply click this one, run app. So then the app will be built and it will be reinstalled. All right, let's observe this on the smartphone. And what should happen now is the following. Our app should appear, but then afterwards, directly the Thief application should be started. So let's see. This is our app and looks good. Doesn't look good. Okay, it doesn't look good. Let's see. We also got this logcat error, and I think it's related to the class name. I guess within our application code, this dot is not required. But let's observe this. Okay, so here we're having the logcat, and there was this, there are a lot of crashes. Okay, let's go upwards a little bit. Maybe let's search for our package over here. So com hacking. Okay, yes, if you're searching for this now, it's easier to find this error. So here we can see activity not found exception. Okay, unable to find explicit. We will have a look into this one, what this means. Activity class. And here we have it. Okay, so the PW list activity has not been declared, or it couldn't be found on the system right now. The problem is regarding to the dot. So I would have assumed that it works, but okay, it doesn't work. It means beside the package name, we also have to provide the full class name. This means this dot is simply just a reference for this one. So we need to append it, I guess, in the following way. This is the package name. Yes. And this one here is now the complete class path to our PW list activity. Okay. So let's see if this works. And let's run this and open the emulator. Nothing happens so far. Not sure. Let's see. Yes. Nice. Okay. The Thief activity has been started and we can see it's working right now. So all we have to do to demonstrate this behavior is simply closing this application once again. So here we are back. Unfortunately, the emulator did freeze for me right now and I had to restart it. But that's not a big deal. We simply restart it and then we are good to go. Alrighty, if we now want to demonstrate this behavior, we do not have to have Android Studio open or things like this. So let's close this one over here. Okay. We are now having everything on our smartphone. All we need to do is we show to the customer, all right, let's start the Thief application. So here we have now to enter an password and we do not know this password. So let's do this test. Password is incorrect. Okay, we cannot log in right now, but let's go back and whoops. And let's start our application, the Thief logging bypass application. So let's do this in 3, 2, 1. Okay, here it will be opened and we do nothing. Now we are in this application. So if we go, for example, into settings, then we can also execute all the stuff. Let's see. Restore from SD card. Do we have a backup already? I mean, we have created once, but not sure if it has been deleted. Yes. Yes, we can see we've got access to the backup. Okay, so we can see we can use this to bypass the logging screen even by not having access to the ADB shell. Alrighty? Okay, so this is all for this video right now. In the next one, we will have a deep look into intents because these are amazing, also if you have to exploit them. Alrighty, I'm looking forward to see you there. In this video, we want to have a deeper look into intents. So what is an intent? An intent is simply just some kind of messaging object. So we can interact with other components of an application based on an intent. Now we've got implicit and explicit intents. And the difference is it's very simple. Implicit simply means we do not know the destination application right now where we want to send this intent to. This sounds absolutely crazy, but this is a common behavior. And for example, let's say we want to open an email program. So we've got a mail to link and we want to start an email program. So our application doesn't know which email program we want to use. Is it Outlook, Gmail, or maybe some kind of third-party application on our device? We do not know this right now. We simply send out this event. Hey, we want to open an email right now. Give us an application that can handle this. And then those applications can react to this event. Okay? So implicit simply means we do not know the destination application right now. All right. Then we've got explicit. And yeah, you guessed it. Explicit simply means we know exactly what we want to start. In our case right now, let's say we've got a logging activity. After successfully logging in, we do not want to start a random application. We want to start the profile activity in this application right now. So this one over here. By clicking on the settings button, we want to start the settings activity. And then there's also this code activity. So within an explicit intent, we know exactly the destination, what we want to call. This can be an activity within our application, or it can be also an activity with a completely different application. This is perfectly fine if it is exported, of course. All right? Okay. Does this only work with activities? No, this also works with broadcast receivers and services, but it doesn't work with content provider. We will learn more about this in several topics, so within the content provider topic. Okay, so for now we know we've got implicit and explicit intents, and we can use intents regarding to activities, broadcast receivers and services, even if we haven't talked about them right now, but we will do this in a couple of videos. Now let's have a look into some practical example. How do they look like and what do we need to take care of? Okay, so we start with explicit intents. If we take our application, then we've got here those 4 activities. Explicit means we know the destination, what we want to call, for example, profile settings or code. And regarding to real code, it looks like this one over here. So this is the code how to start a new activity in our application. So what we need to do is we need to create a new intent object and we have to provide 2 parameters. The first one is our current context, the logging activity, so our source. And the second parameter is simply just the destination address. In this case, it's the profile activity class. This means we are now within the logging activity. So of course we have to check if the username and the password has been entered correct. But if this is the case, we can enter this piece of code to move on in our application. So we simply use this start activity and then we provide our new intent object which has been created just a line before. This is the way to start a new activity in our Android system. Alrighty? Okay, one last thing we need to know, and then we are already mostly done with our intent knowledge, is that we can also provide certain information to the next instance. For example, to the profile activity class. We could say, for example, we are logging in as a certain user because this information or all these information might get lost if we are starting a new activity. So our current activity gets destroyed and we are having a new screen content. Yes, we could store this in global variables, but I mean, this is not a really good approach. We could simply pass information from one activity to another based on intents. In this case, we are doing this for the username. Let's say we are logging in into this application as the user admin, this one over here. Now in the profile activity, it would be nice if we can see which user we are now logged in right now. And also the profile data and of course the permissions regarding to this user. We can pass this information based on an intent. And this looks like the following over here. So here we can see we are starting now an activity, but this time with parameters. We have exactly the same two lines. So we have our new intent object. We've got our source, our this operator, and then we've got the destination profile activity class. But this time we've got this intent put extra. And here we can now provide certain fields. For example, strings, Boolean values, integers, and more. So over here we can see we are providing a username and an admin, and then we are starting this activity. So after successfully logging in as admin, the information admin will be passed from the logging activity into the profile activity. How does this look like? Well, it's not that hard. It's shown over here. This is the code of the profile activity. And here we can see this activity simply gets this intent with the getIntent function. And then we can access those fields via intent get string extra username. Now we can assign this username, which has been passed from the logging activity, into a local variable of our profile activity. All right? Perfect, because this is everything we need to know about explicit intents. We know the destination address, what we want to call, and we also can pass certain parameters in there. Okay, so now let's talk about implicit intents, this one over here. So within an implicit intent, we do not know the destination address. And this sounds absolutely ridiculous, but this keeps happening all the time on our smartphone. Let's say we receive an SMS, and this SMS has this mail to string in there, like this one over here. If we're clicking on this, we have the opportunity to open a mail application, but in this case, we do not know which mail application. So the system is sending out this intent. So here we are having this intent. Hey, the user wants to open an email application. Which application wants to react to this one? And our mail application says, oh, that sounds perfectly fine for me. I am a mail application. I would like to open this link in my mail app. And then the mail application occurs on our screen. So this is the story behind an implicit intent. I mean, this will be more clear if we talk about broadcast receivers, because then it makes absolutely sense. But I do not want to spoiler that much right now and mix everything together. Alright, within an implicit intent, we have the same opportunity to pass certain information to this application. For example, in this case, the email address. And this is now also a little bit of a problem, because this implicit intent will be, let's say, broadcasted to the other applications, and they can react to this one. And so what we could do is we could create a malicious application that listens to this type of intents. So it's sniffing this, let's call it bus system, for those kind of information. And this is called intent sniffing. This means we are having something like a Wireshark on our intents and looking for which information are being passed between those applications. I mean, this is not a really secure channel. It could be secure if it's being programmed correctly, but this is not often the case. And so intent sniffing could be pretty dangerous right now if you share secret information via this system. All right? Okay, last but not least, we've got our intent filters. And then we have completed this topic right now. So what is an intent filter? If we click on this app icon, then our launching activity will be launched. I mean, that's why it's the launching activity. These launching attributes has been defined via an intent filter. So if we take a look into our Android manifest XML, then we can see we've got this intent filter, and we also got those two tags. We've got an action and a category tag. Action has the intent action main, and category has the category launcher. So an intent filter is really just a filter for our Android application. There are a lot of information being exchanged all the time on our bus system, which we have seen just right before this slide. And this filter is simply just filtering them out. So we are just listening to certain events. In this example, an intent with the action main and the category launcher, which means if we click on our app icon, then this intent will be fired and we can react to this one. So we can say, okay, now our application has been started, let's react to this one. And so it's simply just listening all the time to the bus system and filtering out. These information are regarding to this application, I need to react to them, and all the others, they will be ignored. This is what an intent filter is doing. Alrighty? Okay. Then we've got certain tags in an intent filter. For example, we've got action, we also got category, and we've got data. Data is not shown over here, but it can be also included in an intent filter. Alright, now's the question, what does they mean? And to be honest, this is absolutely confusing, and we will look them directly up right now because I keep forgetting them all the time. Okay, to do this, we simply type in intent Android developer into our search engine of choice, and then we can see intent within the Android developer documentation. So let's have a look. All right, and here we can see the definition of an intent. Okay, we have already talked about this, but where can we find now those categories in action? On the right, we can see standard actions for activities and standard actions for broadcast receivers. We haven't talked about broadcast receivers yet, but we can already see that they got different action names over here. Okay? You do not have to worry about this because you will anyway look them up, because no one can mesmerize all those actions. Like, we can see them on the right. It's absolutely ridiculous, but that you get a feeling what an action is. Okay, so let's have a look. Here we've got actions. Okay. Here we've got categories, and here we can see standard external or extra data. So these are our three main topics: actions, categories, and data. Let's have a look into activity actions. Okay, we can see here we've got the action main. Okay, and we can also see the most important and by far most frequently used are action main and action edit. Let's see what action main is. Start as a main entry point does not expect to receive data. Input nothing, output nothing, constant value. Alright, this is simply just the entry point of an application, like we have already mentioned this all the time. So we have already learned this without knowing this, that this one over here is it's an intent action. Okay, cool. What else do we have? Let's go back. Maybe let's see. Action call, action dial. So let's see. Action dial. Activity action. Dial a number as specified by the data. This shows a UI with the number being dialed, allowing the user to explicitly instantiate the call. So this is simply just calling a number. We've got an action for this one. And so by browsing through all of them, okay, maybe you do not have to take a look into all of them, but into some you get a feeling what this type of action is. As already mentioned, I also do not mesmerize all of them. I simply look them up. Another one which is also pretty nice is the action chooser. Activity action. Display an activity chooser, allowing the user to pick what they want to before proceeding. Okay. This can be used as an alternative to the standard activity picker. This is displayed by the system when you try to start an activity with multiple possible matches. So sometimes you get some screen. Do you want to open it with the browser or, for example, within a given application on your smartphone? This is the action chooser. So we've got a lot of actions for certain tasks, and this is how we can use them, or what they are being used for in this case right now. All right, maybe let's have a look into the categories. Well, let's see. We've got category launcher. So we have already looked up main is simply just the main entry point. And then we got this category launcher within our intent filter. So let's see. It should be displayed in the top level launcher. Constant value. All right. This sounds absolutely mysterious. So this simply means this activity should be visible in the main menu. So for example, the app icon should be on your screen. I guess this is how we can interpret this sentence right now. Okay. So the category is just a bonus. It adds additional information to our main event, our main action. And we can also look this up in the documentation. And for example, if we go back into the intent, so on the starting page over here, and then let's see. Yes, here we've got an overview. So action, the general action to be performed, such as action view, edit, or main. We have to look them up, but I mean, this is simply just get into the entry point of this application and things like this. Next, we've got data, which we haven't seen so far, but we've gotten good explanation for this one. For example, we could provide this content URI. We will learn about content provider in a couple of videos. So here we can see we can display information about the person who is identified by the record 1, for example. So we can provide this together with an action view, and then this information are being displayed. All right. But we want to look up categories, so category over here gives additional information about the action to execute. For example, category launcher means it should appear in the launcher as a top level application. Okay, we have already talked about this. While category alternative means it should be included in a list of alternative actions the user can perform on a piece of data, whatever this means. We have to go down the rabbit hole and figure everything out. So this description isn't that helpful right now, but we get a feeling. Action, it's the action what we want to do. Category are additional information, and data are simply just, a data that can be provided to our intent. Alrighty? Okay, I guess this is all we need to know. In the next video, we will do some practical examples, how to interact with intents, how to provide certain data, and things like this. So therefore, after the theory part, there's also some practical exercise we do together right now. So I'm looking forward to see you there. Alright guys, so once again, after all the theory, now let's have a practical view onto this topic. And let's do some exercises and practices a little bit, because otherwise it's really hard to grasp, right? Therefore, let's have a look. Here we are back at Ubuntu VM, and I have prepared a really nice application for you. As always, you can download the whole source code as an attachment of this section, because we haven't taken a look into reverse engineering yet. The application is fitting into our alarm system topic, and even if we are missing, let's say, quite a few features, we've got a use case which I encountered in a real-world application. So this is something I really want to show you in this, let's say, mocking application. Alright, let's have a look. So I've already got the smartphone running. Let's enable it. Okay, and if we scroll up, we've got this amazing app, Alarm Pin. So this time I have put some effort into the layout, and I hope it looks okay. So never mind. I mean, this color scheme, let's go over this. So we've gotten login, and we've got a username and a password. So I will tell you what these features are. The username is admin, and the password, it's a PIN. It consists of numbers, and I guess the initial password is 1337. But if you click login, yes, okay, it's still working. I thought I have played around a little bit too much with this one, but yes, here we have it. So now, after logging in, I mean, we have to verify if every PIN can be accepted, because I have written this application. But let's say the user has a PIN and we need to know this PIN, then we get into the next activity, which is now some kind of profile activity. And here we can change the PIN. We can also see that we've got this admin field over here, this one. So from the first activity, there will be already data passed into this activity, the username. And this also happens once again if we're clicking on change PIN. If we click on change PIN, then we can see the username admin will be also passed to this application. And now we can change the PIN for this admin. For example, 1, 2, 3, 4. And if you click send, PIN updated successful. Is there a typo? No, okay. Perfect. So now if we close this application, get rid of this line, and if we are opening it once again, let's see if my programming skills are really that nice. Username, admin, password, 1337, login, PIN is incorrect. Perfect. So you can see this even survives a restart of this application. So we are having some file content over here. Okay, let's enter this PIN. And here we have now the next activity. Let's take a look into the source code, because there we will see how those information will be passed from one activity to the next one. One question for this one: is it an implicit or explicit intent? Absolutely correct, guys. It's of course an explicit intent, because we know which destination we want to call. In this case, it's the profile activity. And here, if we click change PIN, it's the change PIN activity. So we know the destination we want to call. Alrighty. So let's have a look into the source code. And as always, you can find the source code as an attachment of the section until we talk about reverse engineering. Then you do not have the convenient source code anymore, because then we need to do this by ourselves. Alrighty. You can of course also start doing it right now with the JADX GUI or the other tools that are mentioned in the reversing section. But for now, we haven't talked about this, so we stick to the convenient source code. Alright, let's open this one. Not this one, this one. So the first view should be into the Android manifest XML. And here we have it. It's a little bit harder to read for me, but I guess we can still do this. You know what? Let's get out the graphic tablet and have a look into this one. Okay, so here we are back on the graphic tablet. Now let's have a look into this one. So let's see, how many activities do we have? We've got one over here. We've got one here. And this is another one. This one. Okay. We can see this one has an intent filter. And this intent filter is listening to the action main and has this category launcher, which means if we click on this icon on our smartphone, this intent will be sent. So this application is listening to our smartphone or into our smartphone and is waiting for this intent. So this is our message. Intent that appears when we click on our icon this way. Then we will start this activity. So this one is our first one. Okay. Let's get rid of my annoying drawings. And then we've got this user profile. There's nothing special about this one. It's not exported. It's simply just an activity showing our user profile. All right. Okay, so that was easy. But then we've got this one over here, the third one. And this one is exported true. And we also got an intent filter. So let's see. This intent filter is waiting for an action change pin. This is our action. And it also has this category default. This category default, I guess we have to look it up because I have already forgotten what this one does, but it's related to activities. So I guess if we want to start an activity, we need to have a category default to open it. Otherwise, if we trigger this action without having this category, the action or this intent will be sent, but the activity, this change pin activity, won't open on our smartphone. So if I remember correctly, this was the case regarding to this one. Therefore, with the category default, we also tell the smartphone, please open this change pin activity. And it's also exported explicit and over here implicit, which means we can trigger this from the outside world. This sounds absolutely amazing, right? Definitely. So we will have a look into this one. But first, let's start with the main activity and let's see what intents we've got in here. So therefore, let's switch back. Alrighty. So let's get rid. Yes. Okay. So we start with the main activity. Oh, yes. I didn't expect that much content right now. So yeah, as already mentioned, this is not an app development course. But nevertheless, let's talk about a little bit of this, because the more you see, the more you get familiar with this stuff, okay? Okay, so the little bit version did extend into a 1 hour long video, and I guess no one wants to watch this if you want to talk about intent filters. Therefore, in case if you are interested in reverse engineering this line by line, then simply drop me a comment under this video over here and I will upload the extended version also as a video, okay? For now, we really focus only on the most important parts right now, but nevertheless, we take a little bit of a look around all these Android components, okay? So therefore, let's go. Over here, we've got simply 2 variables. There's nothing special about them. It's simply just 2 strings. Okay, and then we've got these edit text fields, those 2. And this is a little bit interesting within an Android application. I guess it's a good idea if we take the application on the right. There we have it. And now, edit text fields are things like this and this. So these are fields where we can put our text into. And those texts will be referenced by those 2 objects right now. So this one is our user. And this one over here is our pass. Okay. Then we've got the context. And the context, I mean, it took me weeks to understand the concept behind this. But the context is simply just the red dot on the map, which tells us you are here right now at the moment. So the context is telling the application you are right now in the main activity, because this information is required if we are interacting with other components. For example, services, broadcast receivers, or content provider. Or also if you're having some UI interactions, then we need to know where we want to put this UI, on which screen we are putting this right now. And this is the context. So the context is simply just the reference. We are here right now. Okay? All right. Next, we've got the shared preferences. In the shared preferences, I mean, this is it's a file, a text file, an XML file, within the data directory. So our application has a protected directory within the data section, and within this directory we can store files like the shared preferences. So this file will be protected. It's not possible to access this from another application, this one for example, unless we are having higher privileges. Root or some system services are also able to access this file. So in case if we store some sensitive information, for example, user credentials, pins, password, things like this, I wouldn't count this as a vulnerability itself if we need higher privileges to have a look into this file. But in case if you're storing some generic values in there, then it's a different story. So let's say this file contains some default credentials, and these default credentials can be used to access other applications, so on different smartphones. This application, for example, this one over here, on another smartphone. Then I would count this as a vulnerability because this is an information an attacker has access to. Alright? Okay. Then let's see. Then we've got the onCreate method, and the onCreate method, let's clean this up a little bit. The onCreate method is simply just creating the screen content, and this one over here. So everything that's placed over here is being defined in the onCreate method, because here we've got the layout and we are also assigning now this stuff. And here, for example, we are assigning the context, which is related now to the main activity. And over here we are assigning those two fields. So this one in user and this one into the password variable, or in this case object. Okay, and then we've got an init pin method, but we do not take care about this one right now. Next, we've got the login function, this one, and now it's becoming interesting. The login function seems to be connected to this button. This means if you're pressing this button, this function will be triggered. And this is something we need to look up in the layout of this activity. So if you reverse engineer an application, we need to have a look into the activity main layout, this one, which is located over here. And then we have to look for an onClick method, or within the Java code for a set onClick listener. If you find this login method in there, then we know if you press this button, this one, this method will be triggered. Okay, and this is a method we are going to analyze a little bit further right now. So let's clean this up. Okay, so here we can see we are fetching the username from our, this one is our edit text field, and this one also. And we're getting now those two into these two variables. Okay, user and pass. And now we make a comparison. If our username, this one over here, is equals admin, okay, and if our pin is equals the return value of this method. This method is being defined over here, and this method is simply just looking up the value which has been stored in the shared preferences file. So within the data directory, the protected directory. Okay, so within there will be our pin stored, and we are simply getting this information. In case if we haven't defined a pin right now, so if we have simply just installed this application and it's our first run, then we are assigning a default value, which is 1337. So this is our initial pin value. And we can see over here, if you want to modify this file, the shared preferences, we are using shared preferences.edit, the edit function. And then we are using put string to apply our data. And if you want to read from this file, we are simply doing it in this way over here. So here we can see why we are using the context, because the context is now defining we want to access this file, this one, from the main activity of our, what's the name? The alarm pin application. So that's the data storage of the alarm pin application. And by using context get shared preferences, this file knows, okay, we want to access this file from the main activity of our alarm pin application, and we are allowed to do this because this one over here, this is the protected data directory of the application itself. So this is why we can access it. And then we call get shared preferences, and we call this for the string pin. So the values in this file are being stored in an XML key value pair. So this one over here is our key, and this key has a value. In our case right now, the key is pin, and the value would be now, for example, 1337. Okay, so we assign this whole key value pair now to the shared preferences instance, and we can now access this field, this string, in the following way. We are calling return shared preferences get string, and then we want to have the string of the key pin, which is 1337, or in case if no pin has been defined, default. So this is our default value over here, which means if no key has been found, then we are returning null. Okay, so that's the whole magic behind those shared preferences. Okay, but that's all right now regarding to Android app development, because we are interested in intents. But nevertheless, this is definitely something you should look for if you analyze an application. All right, so let's clean the screen and now let's get back. So if you're now providing the correct credentials, username admin and the correct pin, in our case the default pin is 1337. If the user hasn't changed this, we are entering this function. Otherwise, we are simply just printing out in text the pin is incorrect. Okay, but now within this function, we can see we've got this intent. And now it's getting interesting. So we can see we've got intent, new intent, and here we are defining now a new message object. So this message object will be sent from our this class, which is the main activity. So this is our main activity. And we are sending this right now, or we want to start the user profile class. So we want to start a new activity, which is the user profile. Okay, and this would be even enough. So this is our intent. And we could simply use start activity with our intent to trigger this. So our main activity would call the user profile. The main activity gets deleted from the stack and the user profile appears over here on the screen. But now we are also providing some information to our user profile activity. Let's see what are those information. Let's clean this up. Okay, the information we are providing are within intent, put extra. And we can see once again we're having this key value pair. So we've got this username, this is our key. And the username has the value admin. So these information are now being packed into our intent, and it will be also delivered to the user profile activity. So sorry for this one. Okay, so here we are now having our intent, and this contains now our username. Username, which is admin. And this information will be now passed to the user profile activity. Okay? So let's see what the user profile activity is doing with this information. And therefore, let's clean this up. And let's have a look over here. Okay, within the user profile, maybe we should log in. And then we can see this. Okay, so here we have now the user profile. And this one, oops, there we go. This is our user profile. And here we can see right now in this line. So here we are fetching the intent. This was the message object from the main activity. We are fetching this intent, and we are initializing our own intent with the values from this one. So we're simply calling the method getIntent, and then we are assigning this intent over here. So now we have access to the information which has been provided in this intent. And those information were, let's see, over here we can see we are assigning now to our variable username the value from our intent. So we're using intent get string extra, this part, and we want to have the string from our key username. So within our intent we're having the information, maybe let's take in better color, let's say green. There we go. So over here we've got the information username, and the value is admin. So username is our key. Okay, barely readable, but I guess it's still good. So this is our key, and this one over here is our value. Okay, and we are now getting the value from our key username and assign this to this one. And then we can see we are calling TextViewSetText for our username, which is exactly what we are seeing over here. So this is now our username admin, which has been passed from the main activity to the user profile activity over here. All right? Okay, so this is how we can pass information from one activity to another. And also over here, we are doing it once again because we've got the method change settings. This one is being connected to this button. And here we can see we are now passing from our user profile activity another intent with some information to the next activity, which is the change pin class. Which information are we passing to this one? Let's have a look. Once again, let's clean this up a little bit. Okay. Here we've got our intent, and here we've got intent put extra. So we are putting some extra information into our intent. And once again, we are forwarding the username, which has been assigned over here, which comes from the main activity. So the username from the main activity will be passed to this user profile class. And from here, we are also passing it to the change pin class, this part over here. Okay, and then we're calling this start activity intent, which opens now, or deletes the user profile activity and opens the change pin activity. So this is also the reason why we see this username in our change pin activity. So let's clear this real quick. Okay, and let's see. If we click change pin, then we can see this admin field over here. And if we go into this class, let's see, there's a lot of stuff. Yes, so here we have now some interesting behavior. Okay. So first of all, we've got this intent over here. So once again, we are getting this intent, which comes from the user profile class right now. And we assign this to our username. So we once again fetch the value for the key username. This is our key. And we're fetching the value, which is admin. And we store this into a local variable username. Okay. And then over here, we've got the change pin method. And what this change pin method is doing is the following. It takes the text from the pin. So over here we can see we're having edit text, get text to string. So we're getting whatever we have inserted over here into the variable pin. And then we are opening the shared preferences. So we're getting a reference to the shared preferences. And then we check if our username is equals null. If we do not provide a username, then let's see what happens. Only factory reset will be possible. So this means if we are not providing a username for this activity, the only thing we can do is the following. Here we are opening the shared preferences in an editor mode. And we are applying the default pin 1337 to our shared preferences file. And then we simply print out the message reset successful. So here we cannot define a new pin. We can simply just revert it back to the default pin. And this might be a pin that an attacker does not know. So it could be some kind of QR code printed on the back of the alarm system. The user has the information for this one, but not the attacker. This means an attacker, which is not providing a username to this one over here, cannot change the pin. The attacker can only do a factory reset for the pin, but this might not help further. So the attacker might not get an advantage out of this one because the attacker does not know the default pin. Alrighty? Okay. In case if we are providing a username to this one, then let's see. Once again, shared preferences editor, and then we are putting our pin, which has been fetched from this one over here. So from our edit text field, this is our pin right now. We are putting this into the shared preferences file, which is within the protected data directory. This is our new pin. And we have seen at the beginning of this application that this pin will be used to log into the application. So if we can provide a username to this file, then we can override the pin. It's now unclear if we have to provide a certain username because this is an else case. which means we could provide any username. It doesn't have to be null, but I mean, that's okay. If we are providing test, it should also work because there's only one pin available right now. Alrighty? Maybe not, but I guess let's try exploiting this right now. So maybe let's have a quick look into this function at the beginning, but I guess we didn't miss an important stuff. Yes, so here we can see we are just assigning those fields, an edit text, and text view, and a button. These are those fields. Let's see. This is our edit text. And this one. This one is our text view. And this one is, last but not least, our button. This we already talked about this part, and here we can see, okay, if the username is not equals null, we set it to username. Otherwise, we disable this button. So this part would be disabled if the username is null. But I guess this is something we can easily try out right now. Okay? All right. And I guess that's all for this, for this functionality. Let's see. Yes, this is the part we have already talked about. Okay, so now I would suggest let's try exploiting this. So let's see how can we exploit this. If we take a look into the Android manifest XML, we have figured out that this change pin function is exported. Okay, so the thought process behind this of the developer might be the following. We've got our main activity, and from there, if we log in with the correct credentials, here we've got our username and PIN, we are opening the user profile activity, in this one, and here we can now change the PIN, which opens the change PIN activity, in this one. So if we have been logged into this application, we are having a user profile, which means here we are now having this username, in this case, for example, admin. And if we hit the change PIN button, then we are changing the password or the PIN for our user right now, the admin user. In case if the user has forgotten the PIN, this one has been exported. So it could be also triggered from another application, for example, an PIN reset application. So let's say here we are having our PIN reset app. This PIN reset app can open the exported activity, but the PIN reset might not be able to provide a username for this one, which means if no username has been provided, we can only reset the PIN to a default factory value, which is not known to this application or to an attacker right now. So this might be printed at the back of the alarm system. This might be the thought process behind this, but of course this is not true. Because we as an attacker, we could simply, we could create our own application. This is our malicious application. And now we could also open this exported activity, but we can provide a username. Which means we are not using the reset function anymore. We are using the change pin function for this username. So this was a real world example, which I have encountered exactly like this in a real world application. So this is something that can happen. Okay, so from the perspective of the developer, if we are not able to provide additional information based on an intent, yes, then this approach would work. Unfortunately, this is possible, and this is something we are going to exploit right now. So let's see how we can do this. Okay, to exploit this, we are using the activity manager, and we are simply triggering this intent. So the action change pin and the category default. So let's see, we are opening a terminal, and we're using the ADB shell. And now within the activity manager, we've got all the information we need. So we know how to start an activity, am start activity. In this time, we do not necessarily need a component name. So we could provide a component name, which is regarding to this activity, but we can also do this based on this intent filter. So this one over here, this would be an explicit intent, and this one over here would be an implicit intent. We do not know the destination, which application wants to open this, but in case if only one application has been registered to this event, then yeah, it will open. Okay? So let's do both. We start with an explicit intent and we're calling the change pin functionality. So -n, then we need our package name, a slash, and then change pin. Okay, let's open the smartphone and let's do this in 3, 2, 1. Unknown command start activity. Let's see. Yes, there's a typo. Okay. Now let's do this in 3, 2, 1. Okay, and here we can see if no user has been selected, the pin will be reset. So if we click reset, then the pin reset has been successful. And yes, once again, we are having the 1337 pin. Let's verify this. Yes, okay, perfect, it works. So here we can see this is how we can reset the pin. And this one over here, it's an explicit intent because we have defined the exact destination we want to call. All right, now let's do this based on an implicit intent, which would be the following. So yes, let's make this a little bit smaller. We are now defining an intent and we do not describe the application which is executing it. We are just describing the intent, which is this one over here. So this application is listening into the smartphone. Okay, I guess my ears are getting worse right now. It's listening to the smartphone and it's waiting for an action change pin. So this is a custom intent right now. We can see this based on the package name. That's not an Android specific one, it's a custom one. And beside this action, this intent also needs to have this category. Okay, so let's see how we can do this. Okay. So we are calling AM start activity, and this time we are using this information provided over here. So here we can see this is how we can define an action -a. Here we have this -d for data URI, and here we've got this -c for category. So if we want to trigger this intent, all we need to do is simply use AM start activity -a, and then let's see, let's copy this. And this change pin. And the category is over here. Okay. And now if we are opening our application, so let's close this maybe. Okay. So we are within the login right now. And now we trigger this implicit intent in 3, 2, 1. All right, same behavior, but different intent. In the first one, we have exactly defined which application or which activity we want to call. In this case right now, we have defined the intent, and this is the only application which is reacting to this one. So to this action com app hacking change pin with this category. I'm not sure if we require this category, to be honest, but I guess the activity won't be open. Let's see. Oh, it's still working, so we can see it's opening. It is enough to address this based on an action. Alrighty. So this is the difference between an explicit and an implicit intent. I have another example afterwards, but first let's exploit this right now. So how can we do this? In the change pin activity we have seen, we're using this intent get intent. And here we have seen we are fetching this key. So within our intent, we are fetching the key username and we are assigning the value to our variable, which will be checked in our code over here to provide this as a text, and also over here to make the decision if we are resetting this app, so the pin, or if we are simply taking this pin into our shared preferences. Okay? And this is a decision we can influence right now because we can define a username for this variable. This will be assigned over here. So all we need to do is we need to put this information into our intent and key username with a certain value. How can we do this? The answer is over here. So if we zoom out a little bit, here we can see we've got this extra key, and here we can see by applying --es or simply just e, we can define a new key and a new value. With EZ, we can define a new key and a Boolean value. EI gives key and integer value. So the last letter defines what type we are defining right now. In our case, our username is from type string, so we are simply defining an string value for this one. Okay, so let's see. Oops, did I change something? I hope not. Okay, let's clear this, and now let's take the last command. Let's maybe opening the help here. Yes, okay. So with --es, we are now telling our intent, please pack some information into our intent. And we want to have a username. Those quotes are not required, I guess, but I keep doing it. So please don't ask. Okay, so this is our key. And now let's say, for example, test. Okay, let's put the smartphone on the right and let's do this once again. Nice, we can see now the application has behaved differently. So it did react to our intent with our additional information. The test is being printed out over here. I mean, we're not having some kind of injection point, so that's not we cannot insert stuff like this, reflected cross-site scripting, because this is it's not a web browser. But I mean, yes, we might be able to use this for some kind of phishing. For example, your password has been hacked. Please change it over here. So then the user might define a new password, but I mean, we do not get an advantage out of this because the user is just defining a new password for its own application. But nevertheless, this is how we can interact with this application. In case if we are having multiple intents or not intents, values in our intent, let's see. Yes, if we are having some additional one, let's do it maybe this way. Pin. Then we simply can put them together. So over here we are having this username. Let me close this in the background. Oh, these are those processes. Okay, let's close this. Okay, so now we can read this a little bit easier. So here we're having the username and test, and then we could also do this, for example. Okay, so this is how we can apply multiple strings, integer values into our intent. In case if we're having an integer, we have to use it in the following way. Alrighty? Okay. So yeah, if we are providing additional intents which our application does not react to because this is not originally included, then it simply just gets ignored. Okay, now let's see if we can change the pin over here. So we have this test. Maybe let's name it hacked. Okay. And now let's see, we define a new pin, which is 14789. Send. Pin updated successful. Okay, looks good. Let's close this application. And let's reopen it. Okay, I mean the username is now still admin, it's not hacked. But let's see if we have overwritten the pin for this user. 14789. Yes, nice. So we have overwritten the pin for this user because there's only one pin entry available, therefore the username doesn't matter anymore. It's just required. If it's null, then this won't work, but if we can apply any user value, then we are overriding the pin. Alrighty? Okay, amazing, right? So maybe let's have a quick look into this file. So within the ADD shell, root privileges, and then within data, com, app hacking, alarm pin. Intent sniffing is something we take a look into in a moment right now, so don't worry. Here we are now having the shared preferences, and here we're having our pin XML, and here we have it. Yes, we can see we have overwritten the pin. Alright, so that's the vulnerability in this application. And regarding to activities, I mean, it's not that it doesn't occur often anymore. It can still be possible, but it doesn't happen often. Regarding to broadcast receivers, this is a different story. So within broadcast receiver, this can still occur pretty often. This is something you should definitely check out, and this is also something we will discuss heavily in the broadcast receiver topic. Alrighty? Okay. One last example regarding to implicit intents, because I find this pretty ridiculous, sending out an intent without knowing which application reacts to this one. And let's assume we've got multiple applications. What happens then? Are opening all, or how is it being handled? This is something we are going to take a look into right now. And afterwards, within a new video, we are talking about intent sniffing. So therefore, we are still not done right now. Okay, so let's close this. All right. We have already seen this implicit intent. So within the Android manifest XML, we have sent this intent. And luckily, there was only one application which has been registered to this one, because this is a custom intent. But what happens if you're sending out an intent where many applications has been registered to? And let's find this out. So what we can do is we can do the following. Okay, so we are using once again our activity manager. And now we are sending out an intent which is used by many applications, which could be, for example, an action, Android intent action view. So this is a common action for an intent. Okay, and we can also apply a category, this one over here. So there are many applications which has been registered to this event. So let's put out or pull the smartphone in the let's put the smartphone in the foreground and let's see what happens if we are triggering this. I'm executing this in 3, 2, 1. And oh, interesting. So here we can see we've got one application, intent sniffing, which might have been used before, but also all these other applications has been registered to this event. So these are now all applications which has been registered, and all of them are telling the smartphone, hey, your request, I can handle this. And the user has now the choice to open the application. So it's about the user to make the decision which one should react to this event. For example, this calendar. Then the calendar app will be opened or will react to this event, and all others are simply just ignoring it. Okay? So that's the concept behind an implicit intent, sending out an event without knowing which application is going to open it. The other one is the explicit intent, and this is something we have seen over here. So let's see this one. So here we are defining the exact package name which should serve this event. And this is something we cannot sniff. So if we are calling an explicit intent, if we tell this application this change pin activity to open it, we can of course also provide some data. But this is an information that cannot be sniffed by another application. Regarding to implicit intents, like this one, this is a different story. Okay? So if the user misclicks, then the attacker will have the information. Alrighty? Okay. If you have any questions regarding to this one, please drop me a message in the comment section, and otherwise I'm looking forward to see you in the next part. Alright guys, broadcast receiver, we have talked a little bit about them, but now let's find out what they are, how they work, and most importantly, how to exploit them. Alrighty, and let's have a look. So those broadcast receivers on an Android system are pretty amazing. It's some kind of notification system for your applications. Let's say we've got a lot of applications running on our smartphone right now. I mean, maybe we do not have to assume this because this is most of the time the case. So we've got some mail, some calculator, and also some music application. We are now listening to some music within our music application, and we are connecting some headphones to our smartphone right now. This is an event, and the smartphone is receiving this event and is broadcasting this event to every application. This is a broadcast message. So every application will be informed that some headphones has been connected. The mail application, the calculator application, our music application, and the SMS application. Some of them might say, what the heck, I really don't care about this one, and simply ignore this. But our music application really takes care about this event because we can now react to this one. If we are now connecting some headphones, we can react in the onReceive method to this event. So within the onReceive method, we are saying, okay, if some headphones are being connected, then do something. We could, for example, pause the music, we could lower the volume, or we can tune it up to make it heavily loud, which makes absolutely no sense, but we could. Alrighty? Okay, so this is a broadcast receiver in a nutshell. An event happens on the smartphone is informing every application about this event, and within our application we can react to this one in the onReceive method. Alrighty? Okay, perfect. The time window we have is, I guess, about 5 seconds, but don't quote me on this one. After a certain amount of time, this broadcast event is gone like it has never happened. In newer versions, we can extend this time window because we can do asynchronous broadcast events, but this is nothing we have to take care about as an attacker. This is something the developer has to bother with. So now might be the question, what other types of events are we having on our smartphone where the smartphone is informing every application about it? Well, we've got tons of other events. Another one would be, for example, if the battery is running low. This is a system event which gets broadcasted to every application. And this is also pretty important. I mean, if we are now a developer and we have a huge stack in our application which has not been saved and the smartphone is running low on battery, we might want to save this right now, because if the smartphone gets shut down, we might lose some information in our application. And this is something we definitely do not want to have. So running low on battery is also an event which will be sent to every application. Besides this, we've got lots of other things. For example, if we are entering the airplane mode, if the Wi-Fi connection changes, if we are changing the time zone in the smartphone, if we are connecting something via USB, if we are doing something with the camera, if some package is being deployed on the smartphone, if we are dealing with Bluetooth, or if we are having a pairing request, things like this. So you can see there are a lot of broadcasts out there. So these are all system broadcast events, but we can also define our own custom broadcast event. So we can define our own sending and receiving method. And then we can use this to send out our own broadcast event. I mean, other applications might not react to this one because they do not know this custom event, but this can be used to exchange information between applications. We will have a look into this one in custom broadcast receivers in a moment. For now, let's talk about ordered broadcasts first, because this is also pretty important. Ordered broadcast events have some sort of priority in there, which means, let's say we've got these 3 applications. We've got our system SMS application, we've got our own application which wants to read SMS. This is absolutely perfectly fine if the user gives the permission. And we've got a banking application which is waiting for those TAN numbers. Now we can define a certain priority for these applications. I mean, this is being done by the developer, so the developer is putting some priority into a certain file. And the file we are talking about is the Android manifest XML. So here we are defining our own priority of our broadcast receiver. Okay, so now's the question, where's the difference? Well, let's say an SMS arrives at the smartphone. And this is also a broadcast event. But this time right now, not all applications are being informed about this one. Only the one with the highest priority. In this case, it's the system SMS application. So this one over here. And now there's this tricky part. This application which receives this event first can make a decision if it wants to forward this event to all lower privileged application. In this case, for example, our own application. If it does, then we have now the decision to forward it to the banking application or not. We can disline this event, then the banking application doesn't realize that an SMS has been received right now. So this is how an ordered broadcast works. We've got a certain priority that the developer is giving the priority by himself, and then the application can make the decision to forward this event to all lower privileged or not. So this can be absolutely ridiculous, and in the past it was. Because in Android 4.3, yes, it's super old, I guess 2010-11, but there was a huge vulnerability regarding to this one. Because within Android 4.3, you could make an application and you can set the priority to 999. Which was higher than the system SMS application. And now there's this absolutely ridiculous part. If the smartphone is now receiving this SMS, the attacker is having this SMS first, and the attacker can make the decision to inform the system SMS application about this event. So the attacker could disline this, and then the smartphone is not showing any evidence that an SMS has been received right now. There was no signal, no audio, and no pop-up regarding to this one. And now imagine at the given time what was possible. I mean, the attacker could read an SMS and it could also make the decision to forward it. Let's say we've got a banking application and the banking application is waiting for a transaction number, a TAN. The attacker is receiving this TAN right now And then the attacker could make the decision if the banking application should receive this TAN or not. I mean, absolutely ridiculous, right? If the attacker has also compromised the banking account of this given person, then the attacker could use this TAN and the user even doesn't realize what's going on over here. So the user might be ordering a second TAN, which the attacker could simply forward it to the user, and the user thinks, okay, something was strange, but now I've got my TAN, but this doesn't work anymore, and the money has gone. So this was an absolutely huge vulnerability, which has been fixed in Android 4.4. Those type of vulnerabilities might not occur that often anymore, at least for system applications, but they can be pretty likely occur in custom applications. So if the custom application is setting an priority in the middle, you as an attacker might be able to set a higher priority, and then you can tamper around with this one. I guess now it's limited to 100, but I'm also not 100% sure about this one. At least it's not 999 anymore. Okay, so far so good. I guess we've gotten a good feeling about broadcast events right now. We know if an event happens on the smartphone is informing those applications about this event. It can be all, it can be just a single application, and we can have an ordered broadcast, which means there's some kind of priority in this notification chain. Alrighty? Okay, the main question right now might be, where do we have to look for those broadcast events? So as an attacker, how do we find out which event this application is listening to? For example, this mail application might not take care about some headphones being connected. So where do we find this information? And the answer is over here, in the Android manifest XML. At least for Android applications till version 8. So in Android version 8, there was a huge change regarding to this progress, and this did catch me absolutely off guard. So this was a little bit pain. But don't worry, we are doing both. We are doing the old approach, which has been defined in the Android manifest XML, and we are also doing the new approach that you are well prepared for modern applications right now. Alrighty? Okay, perfect. Let's first look into applications which are lower than Android version 8. There we have to take a look into the Android manifest XML, because here we have now the definition as a receiver. So we've got our receiver tags. Within those receiver tags, we've got, for example, the Android name, my broadcast receiver. So this is the Java class where this broadcast receiver has been defined. If we are taking a look into this one, we will find the application code regarding to this broadcast receiver. Also the onReceive method, which is the most important method if we are analyzing a broadcast receiver. Alrighty? Okay, perfect. Next, we've got those intent filters, and these are pretty important in many ways. The first important thing is having those intent filters means we are having an implicit exported true. So this broadcast receiver is now being exported. And of course, it has to be exported because otherwise it couldn't reach or receive those intents. So it wouldn't even recognize that an event has happened. This is also the case why most or barely all broadcast receivers are being exported to the outside world, which might make them vulnerable to attacks. And this is why broadcast receivers are pretty important in our application analysis. So the intent filter is now exporting this my broadcast receiver to the outside world that it can react to those intents, and it's listening into the smartphone. And it's now waiting for those three actions. We've got action boot, log boot completed, and quick boot power on. All of them are regarding to the booting process of the smartphone. So when the smartphone has been finished booting, the smartphone is informing those applications, which are listening to this event, about this process. So the smartphone is sending one of them, three, only two of them to those applications. The question might be why we're having three actions for only one single task. And the answer for this one is manufacturers. Manufacturers can define their own broadcast events, and if we want to have an application which is compatible to many manufacturers, we have to include all of them. So there might be only one intent, for example, this boot intent being sent out, but yeah, it might depend on the manufacturer. So as an attacker, we do not take care too much about this, because this is also, again, the developer part. The developer has to make sure that this application is being compatible to other manufacturers and has to take care about all these different intents. Alrighty? Okay. We as an attacker, we simply look them up and then we know what this application is listening to. Alright, and yeah, this is all. So we're having the Java class, my broadcast receiver. We're having those intent filter, which means our Java class is being exported, and we're listening to three actions right now, to those three. Okay, beside those actions, we once again could have the following. We could have category, and also data included into this intent filter. But most of the time we are simply just dealing with action. So the action is the most important part over here. Okay, sending and receiving those intents can be also combined to permissions. So within our application, if we want to listen to this intent, we need to have the permission in our Android manifest receive boot completed, because this is something the user needs to be informed about it, because this could be easily used in malicious application. It doesn't mean if an application is using this permission that it is automatically being malicious, but this is some kind of auto task to run our application after a system reboot. So if we are having our attacking application, we do not need to wait until the user opens this app. We could define a service which will be started when this broadcast event will be received. And this service is running silently in the background, so the user doesn't realize that this application has been started. It's like running the auto task on a Windows system. So every time you reboot the system, the auto task is automatically starting or executing a program. And also over here, there can be absolute valid use cases, but of course, this can be also used regarding to malware. And therefore, we need to have this permission. Another example would be regarding to incoming calls. If you're not having this permission set in our Android application, but would have the ability to tamper with this in broadcast events, I mean, this would be absolutely hilarious, right? So an attacker could make an application which is not requesting the calling permission, but could tamper with this one. Therefore, this is of course not possible. We have to set this permission, and then we can also receive and interact with those broadcast events regarding to incoming or outgoing calls. Alrighty? Okay, so far we keep in mind, we've got our intent filter. Within the intent filter, we've got our actions, and these are those intents where we are listening to. Those intents can have certain permissions. These could be system permissions, or it could be also user permissions tied to them. So if you want to use them, we have to request those permissions. Alright, but this approach is unfortunately outdated till version 8. So this is not working anymore. You get some error, background execution is not allowed. Therefore, we have to define it in the Java code directly, and it looks like this. So within the Java code, we've got now this register receiver, and this is taking two arguments. The first one is the name of the broadcast receiver we want to register. In this case, it's my broadcast. The second parameter is an intent filter. So the thing we have defined in the Android manifest will be now defined in the Java code. So here we are providing as a parameter our action name, in this case boot. In case if you want to have more actions, of course, we could apply more actions in there. Then we've got our broadcast receiver, my broadcast, which is defining a new broadcast receiver. And then we've got again our onReceive method, which is containing the code. So this is now the new approach, and we have to deal with a lot of things right now. So the first one is the application needs to run, because if the application is not running, then we are not having our Java code registering our broadcast receiver. So background execution is not being allowed anymore. The second challenge is, if we're using automated tools, they might not have been updated regarding to this approach. So if they try to identify broadcast receivers, they might simply take a look into the Android manifest XML, but not into the application code, which means we could miss some stuff. And this is why we are here, because here we will learn the backgrounds about this one, and now we can deal with this on our own. So in case if the automated tool is missing something, we can look it up manually. At least in the reverse engineering section, we will learn how to decompile applications and have a look into this application code. And then we would be able to identify methods like register receiver or onReceive methods. Alrighty? Okay. So if you're using automated tools, make sure that they are working with the newest approaches. I mean newest regarding to Android 8. But yes, this might not be the case for all those tools out there right now. And some of them might not be even further developed. So therefore, using automated tools, absolutely no problem, but make sure that they are working correctly. Alrighty? Okay, so now we know how to identify the broadcast receivers for a given application. We need to take a look into the Android manifest XML or within the Java code directly to see which actions has been defined. So to which actions this application is listening to. Now is the question, how can we exploit them? And the answer for this one is, it depends. So if you're having a look into this one, triggering a broadcast receiver can be done by a malicious application running on the smartphone, or it can be done by the ADB shell directly. So for testing, the ADB shell is absolutely fine, but regarding to a practical attack vector, I would assume it has to be a malicious application, because if you have ADB access, you might not need to trigger a broadcast event. Alrighty? Okay. So if you're triggering a broadcast event, the question is, what can go wrong? One answer to this one is if we apply some sensitive information in our intent. So a broadcast event will be sent via an intent, which means we can also apply data to this event, like this one over here. So we can put some strings into this broadcast event, and then this would be sent out to every application. An attacker can listen to this one and is receiving this intent. And in this case, the attacker could simply fetch the token which has been transferred via this broadcast event. So one thing we have to look for are sensitive information being stored in those intents. I mean, we have seen this in the intent sniffing part. This is exactly what we are having also here. Another problem could be within the permissions. So the developer is defining a custom permission, which is required by an application to receive or send those broadcast events. We as an attacker could simply claim this permission if it has not been proper secured. It's only being proper secured if it's using protection level signature. Everything else is not in the control of the developer anymore. We talk about this protection level signature in the signing section. There we will go through what this means. So far, it simply just means that both applications have to be signed with the same key. And this is something the attacker cannot fake. So an attacker cannot spoof this permission, so the attacker cannot simply claim that the attacking application has been signed with the same private key. This is not the case, and therefore the attacker could also not tamper around with those broadcast events. Unless if the attacker has root privileges, but then we are having some other problems. Okay, to sum this up, if the attacker does not have root privileges and the protection level is being signature, then the attacker cannot interact with this broadcast receiver. But if this is simply just a custom permission, like this one over here, then the attacker can include this permission into its own application, and then the attacker would be able again to receive and send those broadcast events. So the vulnerability could be the following. The developer has included this custom permission into its own application and relies on this one that no one else can claim this one over here. So this is a misunderstanding that still happens nowadays. This custom permission can be now claimed by an attacker. It depends on the protection level. Sometimes it's being set to dangerous, which means the user has to accept this. But even then, I wouldn't rely on that the user does realize what's going on over here and never gives the attacker permission to perform this task. If the attacker has now claimed this permission, the attacker can trigger this broadcast event and cause the sensitive interaction. For example, regarding to an alarm system, disarm or arm a system. Or regarding to this one over here, read out a sensitive token. So the vulnerability depends on the application code of the developer. And once again, we only have to take a look into the onReceive method. There we will find out what is being triggered, and there we will also find out which input is being used from this broadcast event. And so for example, if it's using some tokens stored in its string, like this one over here. Alright? Okay. Last but not least, we could have something like a local broadcast manager. And this one is a broadcast event that only happens in the internal application. So this doesn't reach the outside world. It can be used to exchange information between certain classes, activities, services, stuff like this. So we can use broadcast events to exchange data within our application or to exchange data with other applications outside our application context. From our attacking point of view, we simply skip local broadcast manager because we cannot interact with them from the outside world. So these broadcast receivers are within the sandbox of this application. We cannot interact with them. Alrighty? Okay, so this was now a lot of theory and a lot of input. To sum this up, this will be super quick. All we need to know is the following. The only method we can interact with is the onReceive method. And there we have to take a look into what we can do. Having a broadcast receiver doesn't automatically mean there is some kind of exploit or vulnerability in there. If this onReceive method is simply just printing out an hello world, then we could trigger hello worlds, but this is not a vulnerability. We have to take a look which code is being defined in the onReceive method, and we also have to take care about the input this method is receiving. We will do all of this in a practical example afterwards, so don't worry if it's now a little bit confusing. All you need to know if you analyze a broadcast receiver, have a look into the onReceive method. That's the only method you need to take care about. Alright, Last but not least, to identify those broadcast receivers, we have to take a look into the Android manifest XML. And if there is no broadcast receiver defined, it doesn't mean that this application is not using a broadcast receiver. We also have to take a look into the Java code. I mean, we can sum this up, have a look into the Java code, into the onReceive method. This is all you need to do. We will learn about reverse engineering an Android application in the reversing section. So there we will talk about decompiling an application, restoring the Java code, identifying the onReceive method, and things like this. Okay, this is all for this video. So as already mentioned, it was a lot of theory, but we will sum this up with some practical example. There we will identify the broadcast receivers, and we will also see how to trigger certain actions and how to exploit vulnerability. Alrighty? Okay, so I'm looking forward to see you there. Alright guys, welcome back. In this video we want to do some practical exercises regarding to broadcast receivers. So this will be pretty amazing. We want to identify them in the Android application. We also want to see what they are doing in the onReceive method. And most importantly, we also want to exploit them. Alrighty? So therefore I would suggest, let's dive into this one. Okay, here we are back at the Ubuntu VM and I have prepared two applications for you. Within apps broadcast receiver, I've got the following two, and I have attached them to the section over here. So you can simply download them. We've got an Android SDK 25 version and an Android SDK 26 version. So this will show the difference between those two major versions. This one is Android 7.1 and this one is Android 8.0. So this means the intent filter in the Android manifest XML will work in this version, but not in this anymore. And this is something we will figure out by doing some practical exercises regarding to this one. Okay, so I mean both versions are identical regarding to the code or the Android manifest XML. There's no difference between SDK 25 and SDK 26. The only difference is that this one has a build version for 25 and this has the build version for Android 8 and higher. That's the only difference. The source code or the Android manifest is absolute identical. Okay, so let's have a look into Android SDK 25, this one over here. Now we're having a little bit of a problem because we do not know how to reconstruct or decode this application right now. I mean with the APK tool, yes, but we haven't learned Smiley so far and we also didn't learn something about reverse engineering those APK files right now. In case if you want to perform this, there's a video within the reversing section, so you can have a look into the JADX-GUI video and then you will be able to reconstruct the code, the Java code, out of this application. Also the code regarding to the Android manifest. So this is like having the source code next to you. I mean, it's not exactly the same source code because this is not possible. It's just an interpretation of the original code, but this is pretty close. I guess it's about 90% or maybe even higher. So you can definitely work with the reconstructed code out of this. Okay? All right. For all others, you do not have to do this, of course. I mean, you do not have to jump 10 videos ahead to perform this task right now. I have also attached the source code to this section. And yeah, I mean, it's simply just a text file. You can have a look into those text files and then you will be also able to figure out what's going on over there. Alrighty? Okay. And this is something we are doing right now. So I've got it already included in my Android Studio, which is over here. And I will show you how you can do this too. Okay, so I guess it has been finished loading. And here we have now the whole IDE regarding to this one. If you want to also include it in this way, what you can do is, because I have now already included it, but you can go into File, New, and then simply Import Project. And then you can select the source code directory and you would end up in the same structure over here. Okay, so the first thing I like to do when I reverse engineer an Android application is having a look in the Android manifest XML, because there's a lot of interesting stuff, and also here. First of all, we are using a permission, and we are using the receive boot completed permission. Alright, we already keep this in mind because this is maybe most of the time or all the time being used in combination with a broadcast receiver. So then we've got this application tag. We can see allow backup true. A lot of unnecessary stuff, but then we've got this receiver tag, and this means we are now having our first broadcast receiver. The name of this one is save data. It's being enabled, and we've got exported equals true, which is pretty interesting because underneath we're having an intent filter. So this one would already set this class to be exported. So this intent filter is performing an implicit exported for this class over here. This is the Java class, by the way, the Android name. This is the code for this broadcast receiver. Okay, now's the question why we're having exported true and this intent filter. And the answer for this one is compatibility. So therefore, we as an attacker do not take care about this one. The developer has to take care about this one. Alrighty, perfect. So now we've got this intent filter. So our application is listening to an event. Which event? This is defined in this action tag. We can see Android intent action battery low. So when the battery is running low, this application will be informed about this event. And this application is going into the save data class and reacts to this event. So let's have a look what's inside save data. So if we go into this one, here we can see we've got save data extends broadcast receiver, and here's our well-famous onReceive method. So this application is listening to this intent, to this battery low intent, and if it receives it, it's executing the code inside here, which is absolutely lame, this code. I mean, it's simply just a print out to the logcat output. Simply just save data, nothing more. But this is perfectly fine because first we want to have an overview about this whole system, about this construct over here. And then later on, I have prepared another broadcast receiver, which is performing some actions. So this is now looking a little bit lame, but later on it will be super interestingly amazing. Alrighty? Okay, so far so good. So this is simply just printing out text to the ADB logcat console. Alright, back to this one. What else do we have? Yes, this is all about this receiver. So our receiver is named save data. This is the Java class, and we are listening for a battery low event. Okay. Then we've got another receiver, reset system. Enabled exported set to true, okay. Intent filter. And this intent filter is listening to those two actions. First one is boot completed, which requires this permission. So if we are listening to this event, but we wouldn't have this permission, then the application wouldn't work. So it would crash or simply not working within the receiver tag over here. So therefore, this intent filter is being tied to this permission. Okay, so now we're listening to an boot completed and an log boot completed. So we are only having two actions right now because I will run this on a Nexus device, and therefore I guess I would only need this part. In the slides we have seen, we have three actions, but I mean, we do not need to have a huge compatibility if we are running this only on a Nexus device. Okay? Okay. So, and that's all about this one over here. And let's have a look what this code is doing. It's in the class reset system. So over here, reset system, oh well, I am that lazy. Another system out print line? Yes, I am. Because as already mentioned, here we want to learn how to trigger those broadcast events. And later on, I have a really nice example for you. Okay? All right. So here we can see if this broadcast will be received by this application, it's simply printing out system reset, nothing more so far. Okay. Back to this one, and then we've got an activity, which is in screen content, and this is also the entry point of our application. We can see main and launcher. All right, so far so good. We can see we're having two broadcast receivers so far, save data, reset system. One is reacting to battery low, one is reacting to boot complete. And now I would suggest let's simply install this application and see how we can trigger those events. Let's see how we can actively trigger battery low and boot completed. So let's go. Okay, to install this application, we first need a device. And I recommend using the emulator because there we can play around with the battery level pretty easily. So I go into my AVD manager over here. And I have prepared a Nexus 6 device. I can highly recommend using this device type, because it doesn't require that many resources, therefore it's faster than the other one, and it also has root access. So this is a pretty neat device over here. So let's start it. Okay, it's being started and we already get this warning. Emulators running using nested virtualization, so they have to share those resources right now. this is a virtual machine and this is also running in a virtual machine, which is not a good approach, but it will work for this Nexus device over here. So this is working probably fine. All right, so now we've got our device. Let's enable it. Okay, here we have it. And we can see these are all applications right now. Okay, let's install our app. So we go into this directory and I'm using the SDK 25 version first. So open a new terminal and then adb install alarm system APK. Okay, and back to the emulator. Here we have now this amazing icon. I mean, we've got an APK name alarm system. We've got this alarm icon. So let's see what this application might be. And there we have it. We simply just got an icon and some text over here which claims this alarm system has been disarmed. So the whole functionality of this application is, beside having those two lame broadcast receivers, we are having another one, a more hidden one in this application code. And this one is receiving a broadcast event and triggers an arm and disarm for an alarm system. This could be 100% in real-world applications in the IoT business. Okay, but before we come to this amazing part, let's first play around with those broadcast receivers, with those two. So let's see how we can trigger this event battery low. Within the emulator, this can be easily done. And this is why I really recommend using the emulator, because this is, it's super amazing. If we are opening this one within those three dots, we've got this battery tab over here. And here we can set the battery level of this device. So if we slide this down a little bit, then you can see this battery level is being drained. By doing this, we can easily simulate a device running low on battery. I mean, we also got states like battery health, failed, good, and things like this. So yeah, this emulator has a lot of nice features. If you're running this now on a real device, you might have to wait until your battery level drains low, or until we reach to the point where we actively trigger this event, which is in just a few minutes. But for now, let's keep it this way. Okay, so let's put this over here. Okay, and here we're using now the logcat output to observe this whole behavior. So maybe let's have a quick look once again into the application source code. So here we have the logcat output, and we are now triggering this battery low event, which means our application is listening to this event with this intent filter. And if it receives this event, it goes into the save data class and prints out this text on our ADB logcat console. This is all. All right, let's do this. So maybe let's make this a bit smaller. Yes, I guess this overview is nice. So we are draining the battery, and I'm not 100% sure when this event is being triggered. We can see there's a lot of output already on the logcat. So this might be regarding to broadcast receivers, or could be simply some other output right now. Okay, 50, 40, 30, I guess 20, 10%, something here. Let's see. 20, no, okay. Let's go further. 15, yes, 15. Battery may run out soon. So we get this notification and perfect. Over here we see this. Nice. So this is freaking awesome, right? The smartphone is running low on battery and is sending this event out there to all these applications. And here we can see we react to this event. We are going into our save data class and we react to this one by printing out, to save those data. I mean, we are not saving these data as a developer right now, but we print them out. So we can see we have application code reacting to an event occurring on the smartphone. Super awesome. All right. Now, okay, this is pretty cool. We can see we can supercharge our smartphone. There we go. And let's trigger it once again. There we have triggered it once again. Does it get triggered underneath a certain level? Doesn't seem like. But if we are reaching this level, so if we are charging our smartphone, and if we go back once again, then we can see it's getting triggered again. Okay, this battery low gets triggered at a battery volume or battery charge of 15%. Okay, cool. Now let's have a look into the other broadcast receiver. Where do we have it? This one, reset system. And here we're having now a little bit of a problem. Triggering and battery low, absolutely no problem in the emulator. But simulating in boot completed, this might be a little bit tricky. Boot completed means after the smartphone has been finished booting, this event will be sent. Okay, we could simply restart this emulator, but then it's not guaranteed that we are attaching at the right moment with our ADB loghead. So this event could be already gone. Therefore, we need to know how to trigger this on our own. And this is super easy in the ADB shell. So let's have a look. Okay, let me put this on. Let's hide this first. Okay, new window, ADB shell. So our friend over here is the activity manager. And if we go to the top, yes, here we've got this broadcast event. And here we can now see if we're using AM broadcast, we can send a broadcast intent. Options are user. We can apply an user ID, we can apply all, or we can say current. And now there is I guess there's some error in here because the description claims and specify which user to send to. So it means we can send this broadcast event to a dedicated user. This user ID, for example. Our applications all have user IDs, so we can simply find them out and send a broadcast event to a single application based on this description. But I guess this is a little bit faulty. So I will show you later on what I mean. Okay, if we are not specifying anything, then it's sending to all users this event. And this is perfectly fine. We as an attacker, we do not take care if we are sending a broadcast event to many applications out there. All we take care about is that our event will be fetched by this application which we want to target. Okay? So we can easily send this to all users out there. That's absolutely no problem. All right, so let's see. Now's the question, how can we send this event? Because here's no action defined. And yes, the action is being defined in the intent help. And this is a little bit annoying, but once you are familiar with this one, it's no problem anymore. So we now know AM broadcast will send a broadcast to all applications. If we are applying all, or if we are applying nothing, then this is the default value. The intent options are at the end. Over here. Oh, a little bit higher. There we have it. The specifications include these flags, and we can see here we have our action flag. Nice. We also got our data URI and our category. So these are those three main blocks. We could also apply a component name. Regarding to activities we have seen, we can trigger a single activity in our application. We provide the package name, so -n, package name, / and then the activity name. This is how we can apply a certain component. We could also do this over here. Maybe regarding to this one, save data, for example. But I mean, we do not have to target a certain component name. It also doesn't mean, I guess, that it's being sent to a single application out there. And therefore, we do not get an advantage right now. We could make a mistake regarding to this name, and therefore we are not applying this in our command. Okay, so what we need to do is maybe a little bit smaller. It was really large. All right, so let's get our puzzle together. What we need to do is we need to call AM broadcast and then our action -a. What's the action name? Well, let's see. Over here, let's call this part boot completed. So within this action tag, we've got this name. And yeah, we simply copy this part. All right, now let's open the logcat on the right. And let's see, we should see right now, sorry for the jumping, but we need to figure out what we are looking for. So within our application, we are looking for this event. And if this occurs, we go into the reset system. And within the reset system, we go into the on receive. And then we are printing out some lame text. Perfect. Let's see. I'm executing this in 3, 2, 1. And we're getting an error. What's the error? Permission deny, not allowed to send broadcast Android intent action boot completed from PID and the UID 2000. If we are performing an ID, we can see we are having the user ID 2000, which is the ADB shell. And the ADB shell is not allowed to send and boot completed broadcast. All right, this is unfortunate, but we've gotten workaround. So we simply type in SU, and then we are having root privileges. And the root user will be definitely able to send this command. So let's see. AM broadcast -A, this action. I'm hitting this in 3, 2, 1, and let's have a close look to the logcat. 3, 2, 1. All right, there's a lot of stuff going on, and like I would have made it in this way, our system reset is on top of it. So pretty nice, right? Absolutely. So we can see we are triggering this event actively right now. We do not have to wait until the smartphone reboots. We are triggering this event, Android intent action boot completed. So those applications think right now that the system has been rebooted, and this could be a little bit messy because those applications are reacting to this event and they might think, okay, the smartphone has now finished booting. I have to start a lot of stuff, which we can see over here. There's a lot of things going on, and it might be not wise to do this on real smartphones. I guess you do not break something, but yes. I mean, in an emulator, we are probably safe. Okay, let's see how often we can do this until something crashes. No, maybe not, but I mean, we could simply repeat this step now over and over again. And we can see our application is reacting to this one, like shown over here. So this is how we can actively send and broadcast. So far, so good. All we need to do is we need to use AM broadcast -A and then the action name. We can find the action name in the Android manifest XML over here. Okay, perfect. Now let me show you what I mean with this user type. So let's make this larger. Let's leave the root context and let's use AM once again. Okay, if we go upwards to broadcast, where do we have it? Over here. So the description claims that we can use AM broadcast with an user --user and an user ID. And it claims that it specifies which user to send to. If not specified, then send to all users. Okay, so based on this description, if I read it correctly, we would send this broadcast event only to the single user, to the single application with this user ID. How can we find out the user ID of our application? Well, this is super easy. If we go back into this one and using PM, the package manager, and then going upwards, there is something like PM list packages. And here we've got this option -U. Also show the package UID. So if we are performing PM list packages -U, then we are listing all those applications with the given user ID. And let's do this. PM list packages -U. Nice. So here we have now all apps and we've got the corresponding user ID at the end. Now I do not want to search through all of them, so I'm simply grabbing for app hacking because this is why we are here. And here we have our app hacking broadcast receiver with the user ID 10,124. Let's verify this. If we are getting root privileges and if we go into data, and if you're performing ls-some options on app hacking, so we're grabbing app hacking, then we can see we've got our application and this one has the user ID A124. This A can be replaced with 10 because it's being 10,000 from the user ID where our applications start counting from this ID, which means we are having the user ID 10,124, which aligns with this one. Perfect. So now we've got everything together. Let's try sending this broadcast event to this user ID. So we are using AM broadcast --user 10,124 and then our action. The action we are getting from here. Okay, and this is the whole command. Okay, or maybe let's do it this way. All right, so let's restart the loghead. This means we are now sending this action to this user application. This is our user application, so the alarm system application, which means we should only see this log output over here. Reset system, system reset. This is the only log output we should see on our terminal, right? At least this is my interpretation of this whole stuff. So let me show you what happens. We can see skipping broadcast intent, a user, this one, and if parent are stopped. This one is hanging right now, which I have no explanation for this one. But we cannot see any output. So the broadcast seems not to be successful right now. And to be honest, this -- user command is being used also in other commands, but in a different way. If we are typing in the activity manager once again, and if we go upwards, let's see, over here, for example, in the start activity, specify which user to run as. And I guess we read this quite often. And this is also my interpretation of this one. So I guess the description over here is simply false. And so what I have observed so far is if we apply this -- user, this is the user that executes this broadcast command. Let me show you this. I mean, this is not required right now, but in case if you try to send this to a dedicated application and you are relying on this one, then you might spend quite a lot of time with this. Okay, so if you're using AM broadcast -- user 10,124, I guess this was the user ID. Let's see. Yes, that's the user ID -a, and this is our command. If we are now executing this, we are getting the same behavior, okay? So we are not even getting that the current user has not the permission to do this. Okay, but now to show you that this one might be the current user ID, we are simply using the user ID 0, so that's not the dedicated application user ID. We try to execute this as user 0, which is root. And we're not having the permission, of course, to do this. So let's see. Yes, we're getting a permission denied because we're not allowed to send this broadcast from the user ID 2000 as the user 0. Last but not least, let's do this once again, but this time with root privileges. And this time we are not claiming to send this to this application. We are claiming that we are sending it as the user ID 0, which is, maybe let's do this once again. Here we can see, this is our user ID. Okay, so this command over here. And now let's observe the loghead output. 3 to 1. Oh, interesting, right? So here we can see we've got the system reset, all the other broadcast events related to this one. But yeah, I guess this is simply just an error in the description. So please do not spend some time sending it to a dedicated application based on this one over here. Simply go for the try hard approach. Send it to all applications. The only thing we are interested in right now is that our application fetches this event. All right? This is the only important thing. If you're sending out this event to other applications, we simply do not care about this one. This application needs to receive this broadcast event. Alrighty. So far so good. We have seen two absolutely lame broadcast receivers. Let's have a look back. And here, this is all we have in the Android manifest XML. We can see Android build version SDK 25, so Android build version 7.1. We can use those receiver in the Android manifest. Okay. In this application code, there's now another broadcast receiver, and this might be missed by automatic tools right now. So automatic tools might rely on the Android manifest XML to identify those broadcast receiver, and they might miss the following one. we only are having this one class main activity left, because these are all our 3 classes. We have seen reset system, save data. So now let's have a look into the main activity. And well, what do we have here? Let's see. Register receiver. So this is now the Java code approach regarding to broadcast receiver, which is required for Android 8 and higher. It will also work for Android 7, of course, but it won't work vice versa. So this approach doesn't work anymore in newer versions. This one will work in all. And this is why we are also talking about this one, because you need to be prepared for things like this. Okay, it isn't that hard. I mean, it's simply just a transformation of our code. So here we can see within the onCreate method of our main activity, we are having this register receiver. This is now our receiver we want to register. So this is our name of the receiver, alarm system receiver. Then we are having in parameter new intent filter, and this one is now the action. So this is equivalent to this one over here, and also this one over here. Okay, we get an error because that's not in class right now, but this is the equivalent if we are having this in our Android manifest. All right? Okay, let's undo this real quick. There we go. So now we are registering the alarm system receiver, and we are listening for this action. This is now a custom action. We can see this on the package name already. And let's see what this custom action is doing. All we need to do is we need to look into the onReceive method. And now's the question, where is this onReceive method? Because we cannot see it anyway. And this is regarding to this IDE. I do not know why, but if we click on this one, is it working? Then yes, then we get this whole context. So I was also searching quite a while until I figured out, well, it just have been overlapped over here. Okay, so now we've got the onReceive method, and then we've got everything together. We've got our broadcast receiver name, we've got the action, and here's the onReceive method. So let's see what's being doing. So let's have a look what's happening over here. Okay, we've got this time a variable name, so no system out and then leaving. This time we are having a variable name, and now it's getting spicy. This variable name will be assigned with the things we add to our broadcast. So our broadcast is taking some additional information in an intent. So we can apply a string to our broadcast event, and the string is being based on a key value pair. This one over here is the key. So we have to apply an intent with the key status, and then this status, this value of the status, will be stored in the alarm state. In the line underneath, we can see this alarm state will be compared against arm. So if the string is arm. So this means our key value pair needs to look the following. We need to apply a key status with the string arm, and then we would end up in this if statement over here. All right? Don't worry, we will do this afterwards, and you will see this is super easy to do. Okay, so within here we can see we are setting this text, we are setting another image resource, and we are printing out some text. So here we would arm the alarm system right now based on a broadcast event, which is absolutely amazing. What else do we have? If the state is not arm, if the state is this arm, then we are performing in this arm of the alarm system, all right? And in case if everything is unclear, because we are neither having arm nor this arm, then we have in status unknown. So here we can see we can execute or trigger certain parts in our application code based on the things we provide to this intent. This intent can be triggered by any application right now because it's not using a certain permission. There isn't a permission defined in the Android manifest XML regarding to this one. And there's also no certain permission defined over here. So an attacker could write its own malicious application and trigger this event from the attacking application. So we can arm and disarm a system, as we have seen so far. The only downside for this one is the application needs to run. Why? Because if the application gets started, we are starting the main activity, and this is our entry point, and this one over here. And this main activity is calling the onCreate method. And this onCreate method is calling or registering this intent filter. If the application is not running, we are not having an intent filter being registered, which means we cannot interact with this broadcast receiver because it simply doesn't listen to our events. This is the only downside right now, but imagine having an alarm system application which could be armed and disarmed via a malicious application. Absolutely amazing, right? Absolutely. So let's do this over here. Okay, let's see how we can apply certain information to our intent. Okay, so therefore we need to have normal privileges. We do not require root privileges anymore. And then within the AM, we've got this intent section over here. We have already seen this -a, and here we have now all these extra key, extra string values. So here we can see extra key, extra string, extra boolean, extra int, extra long. All we need to do is apply --es, and then we can append our information into this broadcast event. So we can simply say am broadcast -a, the action name. We fetch this out of here. All right. And then --es status. This is our key. The key can be fetched out of this one over here. Intent get string extra. So this is something you definitely need to look for. If you're having an onReceive method and there's something like intent get string integer boolean, then have a look into this one, what happens with this state. And then we can apply a value, for example, hacked. Okay, let's open the ADB logcat, also the emulator. And now let's execute this. And here we go. Status unknown. Nice. Maybe a little bit larger. Yes, here we have it. Alarm state status unknown. So we have now triggered this code path based on our broadcast event. Freaking awesome. So we need to analyze the application code, what happens with our input, because this is where a vulnerability can occur. Unfortunately, we cannot simply tell that having a broadcast receiver and providing some information to this one is a vulnerability. We have to see what could be triggered. In this case, it seems to be pretty spicy because we have things like arm and disarm. But first, let me show you some other stuff. If we go back to our smartphone, and if you're repeating this command and if you're not providing any intent, so we are simply just calling this broadcast event, then let's see what happens. A 3, 2, 1. Okay. Oh, and there we go. The application has been crashed, and we can also observe this in the ADB logcat output. So let's scroll up. And here we have it. Broadcast receiver alarm state. Yes, this sounds like us right now. So we have crashed this application. And the problem is null pointer exception. Attempt to invoke virtual method boolean on and Java string equal. So let's see. All right. So what we are doing over here is we are fetching the value from our status. So in this case, we are not having anything in here because we did not provide this intent. We are fetching this value into alarm state, and this is now being assigned to null. So it's not even assigned, it's simply having a null state. And then we are performing an alarm state equals arm. So we are performing null equals arm, which will cause an exception because, we are not having something like null equals. Based on the Smiley code, we would have some registers which are being compared, and those register, one of them is being null, which will throw an exception because this cannot be correct anymore. All right. This means if we're dealing with broadcast events, we also have to take care of what we are inserting and that we are being compliant with the code. Otherwise, we could crash the application, which might be also an absolute valid use case to crash a certain application. But right now, we do not want to crash this. We want to interact with this application. And now it's getting spicy. So let's try to arm and disarm the system based on a broadcast event. Are you ready for this one? Let's do this. Okay, we start with arm. So we have our status our key status, and we want to apply the string arm. Let's do this. Let me give me some more space over here. Okay, Locket is running. Smartphone is... Oh, we need to restart this application first, otherwise it wouldn't react to our event. Okay, and now am broadcast -a alarm state -es status. I'm not sure if we need those quotes. It might work also without them. Okay, our key is status and our value is arm. Let's do this in 3, 2, 1. Nice. We have armed this alarm system based on broadcast event. Pretty amazing. Let's disarm this alarm system. So instead of arm, let's call it disarm. 3, 2, 1. Oh, well, now we have disarmed the system. So this is how we can tamper around with broadcast events. We can also see this notification alarm system disarmed. All we need to do is we need to have a look into the Android manifest XML or the Java code. It depends on the build SDK version, and then figuring out what's the action name and what happens in the onReceive method. These are our steps to play around with broadcast receivers. And this is pretty nice because developers often underestimate the functionalities or the trouble a broadcast receiver can cause in the application. They are most of the time, barely all the time, being exported to the outside world. And as an attacker, we simply have to take a look into the onReceive method. This is all we need to do, and yeah, to figure out what we can tamper with this broadcast event. Alrighty? Okay, last but not least, let's have a quick look what happens if we try to trigger this broadcast event, which has been defined in the Android manifest XML, but the Android build version is Android 8 and higher. So let's see what kind of error message we get, because then we know what we need to look for if something is not working anymore. So, and therefore, let's go into the Android SDK 26. The code is identical, so just the target version has been changed. Okay. And now let's start this one. Let's open the ADB logcat. Maybe let's clear the logcat output, but I guess it will be, yeah, okay, it will be full anyway. So here we have now this application. I mean, this approach still works because this is being defined in the Java code. This is compatible to newer and also older versions. This is absolutely fine, this one over here. But if we now want to trigger, for example, the boot completed command, let's see. Okay, am broadcast -a. So over here, this one. And let's see what kind of error we get. Or maybe let's do this with the battery first. Yes. Okay, let's charge our phone up. Bam, there we go. And now let's lower the battery. Okay, so now let's take a careful look onto this one. All right. We cannot see our text anymore. Let's enlarge this. So there's no system out regarding to the batteries being low. And here we can see, yes, background execution not allowed, receiving intent within safe data. So this one is not working anymore. So if you encounter things like this, background execution not allowed, it's not the problem regarding to your setup or the actions you try to trigger. This is regarding to that the Android version is too high right now. So the developer has not updated the code in the Android manifest regarding to this one. And to be honest, this is something that can easily happen. But now you know, if you see this, then you do not have to search for a bug in your code or in your setup. It is regarding to the application itself. Alrighty, maybe one last proof. Let's trigger this boot complete action with root privileges. First, let's charge the phone. Okay, it would be nice if this would work in real time. So ADB logcat, am broadcast -a, and then yes, I still got it. Okay, 3, 2, 1. All right, we can see the other applications are reacting to this event, but in between those log messages, yes, this is okay. This is something we have to do it differently. We are searching for app hacking. There we go. Yes, let's trigger this once again. Yes, here we can see background execution not allowed. So the Android manifest approach doesn't work anymore. Absolutely no problem. Then we know we have to look into the Java code for those additional broadcast receivers. Like this one. I mean, either way, we definitely have to look into the Java source code and look for those onReceive methods. So now we know how to deal with this. And this is why we are here, right? So if you're having tools that cannot perform this task, absolutely no problem. We know exactly what's going on. We've got the background information regarding to this one. And if we have to identify broadcast receiver, at least after the reversing section, we will be able to do this by ourselves. And then we do not miss anything in this application. Alrighty? Okay, so this is all regarding to broadcast receiver. Have a look into the Android manifest. Also take a look into the Java source code, if we have talked about this one in the onReceive method. And then, it depends on the code that's being stored in there. In this case, we can trigger an arm and disarm command based on broadcast event, which is absolutely dangerous. Sometimes you have some really nice things inside here, and sometimes, even by triggering them, it's not a big deal, like those two lame functions. Alrighty? Okay. So in case if you have any questions, please drop them in the comment section under this video. I will definitely answer them. Otherwise, I hope you had a lot of fun and I'm really looking forward to see you in the next video. Okay, before we move on with our services, let's have some kind of bonus video regarding to our broadcast receivers. In the last video, we have seen how to exploit a broadcast receiver based on the ADB shell. But this is something the customer might not accept. So the customer might think that the attacker needs access to the ADB shell, so physical access to this device, to exploit this broadcast receiver, which is definitely not the case. And therefore, in this video over here, we want to write our own malicious application, which is able to trigger this broadcast receiver to arm and disarm the alarm system. And to make this a fully proof of concept that no physical access is required, we would have some kind of network interaction. So the malicious application needs to send a network request to our server, so the server of the attacker, and then the attacker has the control over the arming and disarming process based on a network connection. But then we would dive too deep into this. Therefore, let's handle it with a simple application right now. Alright, let's go. Alright, here we are back at the Ubuntu VM, and the part we are going to do right now is not really related to the course, because now we are doing some app development and we are here to hack those applications, not to develop them. Okay? So in case if this is now a little bit much input, don't worry. You do not need to know this stuff. Nevertheless, I would like to show you how you can write simple applications to perform certain tasks. So for example, to make a simple demonstration app for this broadcast receiver, how to exploit it. Alrighty? Okay, so simply relax, lean back a little bit, and then I will show you how to write this application, okay? In case if you want to join me, feel free to do so, and in case of any questions, also regarding to app development, write them in the comment section underneath. Alrighty? Okay, let's go. So, the first thing we need to do is we need to start our IDE where we want to write our application, and this is our Android Studio. So within Tools, Android Studio, bin, we've got this studio.sh script, this one, and we're going to start this right now. Okay. Let's close this one. So the IDE is loading and this might take a while, so I will see you in a moment. Alrighty, so the IDE has finished loading and this is our old project. So we have simply included this one into the Android Studio. Okay, now we want to create a new one and we go into File, New Project. And then we are choosing empty activity. So this is simply just creating an activity with no content. I guess simply just an hello world or things like this. So we do not have overloaded code in our application. Okay, next. Then we give this a name. Broadcast hacking. And here we have to select Java. You can also use Kotlin, but I like to use Java. And then we have to make the decision our minimum SDK. In our case, or in my case right now, I go back to Nougat, but we can also go back way further. For example, to Android, Marshmallow and things like this. But then we have to download those SDKs. So I will stay with Nougat right now. Okay, We can also see this is running approximately on 90% of all devices. So that's pretty compatible. All right, and then we simply use finish. Yeah, this is all we have to set. Yes. Okay, we can close this one, but we keep it in the background because we will need those information. Okay, so now our project is being generated. We can observe this at the Gradle build. So it's now creating all those files, including the Android libraries, including or creating this main activity, the layout for this, and things like this. So I will see you after this process has been finished. Welcome back. So the process has been finished, and now we have our application code. We could already run this application because this is it's a working application right now. Let's try this out. Therefore, we are using the emulator, and this one over here. We are starting it. Once again, this warning. Okay, and here we now have the emulator. So if you want to build and run this application, we have to select our emulator over here, and then we simply hit this play button. Let's keep this in foreground. So now the application is going to be built. Then it will be connected, or the Android Studio is connecting to our device and automatically installing this application. So we do not need to do anything right now. Okay, Gradle invocation finish. And here we have our application. So this is the application we have created. I guess it's still loading. Yes, here we have it. Broadcast hacking hello world. All right. So now's the question, where's this hello world text being defined? Because we cannot see it over here. If we're having an activity, we're also having an XML layout regarding to this activity. So this XML layout is describing what's being shown over here. We can find this within resources, layout, and here we have it, activity main. Okay, we got this WYSIWYG editor, or we can use the XML structure. I like to do it in a combination of both. So it's way easier to change the text over here, for example, than doing this in the graphical output because it's a little bit laggy. Hacking broadcast receiver. So now if we go back to the design, then we have changed this text over here. Let's try zoom in a little bit. Okay, so now what we want to do is we want to include a button over here, and every time we are pressing this button, the application is sending out an intent. For example, arm or disarm. We can also make it more complex with text input fields and stuff like this, but yeah, let's keep it simple at the beginning. Okay, so on the left, we've got now our object. So we simply take this button and drag it into this one. All right, here we have now our button. The button has this arrow because this button has not been constrained to a layout, which means the application doesn't know where to put this button right now. I mean, for this resolution, it would work that it might appear like this one, but if you're having different display sizes, it's unclear where this button has to be placed. And therefore we have to tell this to the layout. So we have to make it fixed at a certain position. We can do this super easily. We simply go into this bubble, we hold the left mouse button, and then simply click this arrow underneath this one. So it's floating around a little bit, but do not get distracted by this one. Okay, this means now the button is under this text view. All right, so far so good. But the application still doesn't know, is it in the middle? Is it more left or more right? To do this, we simply have to put the left corner here, the round button, and drag and drop it to the left. Now it would be underneath this text on the left. And if you're doing the same for the right, then it will be perfectly aligned in the middle. Okay. It's now a little bit too near to this hacking broadcast receiver, so therefore let's add some margin over here, for example 40. All right, this is now our button. Okay, let's go back into the code part. I would like to increase the text size a little bit, so we can do this with Android and then text size, or let's say 28 dp. So dp, or I guess earlier it was named dip, which was density independent pixel, I guess. So please don't quote me on this one. It's simply just another format regarding to pixel. So if we are having pixels, then those pixels are, they are changing regarding to the resolution of our screen. They might be smaller or larger, but those density independent pixels, they stay the same. So if you're having text size 28, we're having the same large font on every display. So it's not changing in the layout. Okay? So yeah, I guess now you know why we are doing app hacking and not an app development. I hope this explanation is fine for you right now. Okay, so now we've made this text a little bit larger, and if we go back into the design, yes, oh, it's a little bit too large maybe. Let's go back to 24. All right, this looks good. Over here we've got the text for this button, and we can simply say, let's hack. Or we can also say, for example, let's give it a meaningful name, this arm. All right. Design, yes, this looks okay. To make this a little bit more hackish, we can also provide a black background. So Android background black. And we can also apply some new color to this text view. Oh, I didn't mention this, sorry for this. So this one over here, I mean, that's the text view tag. We can define all those attributes for this text view over here. Now the text is black and also the background. And this one over here, that's the tag for the button. Sorry if, yeah, I haven't mentioned this. Okay, so Android text color. And now we've got some predefined colors. For example, purple. If we click on this one, then we've got this, yeah, this purple color, which looks, I guess, okay. But I mean, it has to be some kind of green, right? So let's see. Green. Okay, green is not defined. Those colors are being defined in values, by the way. So if we go into values, then we've got those colors. And let's see, what do we have? Teal 200. This looks absolutely hackish. So let's take this one. Here we have the name, and that's the hexadecimal representation of this one. So we have to insert the name. Okay, now we've got this one. Okay, looks good so far. So now we've got our text, we've got this button, and now let's do let's connect this button to our code. Because if we're now pressing this button, the button doesn't know what to trigger. And this is now a little bit complicated at the beginning, but later on it will be, it is super easy if we once have understood the concept behind this. Don't worry if this is now a little bit much for you right now. So we are doing some heavily app development regarding to core concepts of an Android application in just a few minutes. So don't worry, you do not need to know anything of this regarding to the app hacking course. We will move on with the app hacking like this one over here has never happened. Alrighty? Okay, perfect. So let's go back into our application code. We have now defined a little bit of a layout. And over here we are now creating a new function. The function is simply named this arm alarm system. Okay. This is the function we want to trigger if we are pressing this button. And now we have to do following. The function needs to have a parameter which is in view. We need to include this view, so we can use Alt Enter, then this view will be imported over here. And now we can connect this button to this function. And that this function knows where it gets triggered, we have to apply this as a parameter, this view. So this view will be our button, and if we click this button, then this button will execute this function. So the only thing we have to tell our button is to execute this function when the button gets pressed. And we can do this in the following. We have to go back into our activity main layout. And then we have to go into the code path. And then we have to apply Android : on click. And here we have now the method. We have provided this view, therefore this can be triggered by this button. Okay. And this is all. So now if you're pressing this button, the button is executing the text over here. So we can do a log output, or we can already insert our code. Let's first do some log output. So system out, print line, button pressed. Okay. The nice thing is we do not have to install it once again. So we can simply hit this play button. Or first we have to stop this, and then we can run it once again. I guess we should be able to rerun this. So you might not have to stop this, but nevertheless. So yes, we simply could play, yes, okay, sorry for this. You could simply run this button once again, run app, this one, and then it would refresh. Okay, cool. Now we've got our broadcast hacking and looks absolutely hackish. And let's see. If we are opening now the ADB logcat, we should see our text being printed out. And so let's see in 3, 2, 1. Button pressed, here we have it. Maybe let's make this a little bit larger, then we can see this better. Okay. Perfect. So we can see it's working. All right. Now we want to trigger this broadcast event. So we can delete this one. Which broadcast event? Let's see. We have to go into the other application, this one. Within main activity, this is our broadcast event we want to trigger. And all we need to do is we need to create new intent, set the action at this one, and send out this intent. And we can do this all in our function right now. So over here we can do the following. Intent is new intent. Okay, then we include our intent. And then we are saying intent, set action. Now we are providing the action name we want to send. And of course, something I have missed so far, we also have to apply our extra string, extra key values. So how can we do this? Well, intent, and then let's see. Here we have get string extra, but I guess we would like to set it. So set, and no, it's not set. Was it put? Yes, put extra. Perfect. So here we have put. Well, we have to select the correct one. This one, put extra, string name, and character array. And character array is the same like in string, and therefore we should be probably fine with this one. Okay, so we want to set our status, and then we want to set disarm. All right, and then we simply have to send this broadcast. So send broadcast. Yes, we can also see we've got this ordered broadcast over here, but in this case right now we simply want to send out our intent. All right, this is all. Yes. So now we're having an application which is triggering this broadcast. It sets this status to disarm, and if our application is running and receiving it, it will be disarmed based on our malicious application. Let's find out if this one is working. So let's save this. And let's see. First, let's start our other application first. So this one over here. I mean, it doesn't matter if you're using the SDK 25 or 26 version, because both approaches are working over here. All right, so now it's disarmed, therefore let's try it with ARM. Okay, so now we are starting this application. Let's observe the smartphone. I mean, now our activity will be put into foreground, like we see this over here. And yes, if we are now sending this, let's see, ADB logcat. Let's make this a bit larger. All right, let's disarm the system in 3, 2, 1. Alarm system, oh, sorry, we have armed it. Alarm system armed. Okay, I guess regarding to a customer presentation, you need a little bit more prepared like I am right now. Okay, so now we have armed this alarm system. If we are switching back. Oops, this was not a switch back. There we go. And here we have it now. The alarm system has been armed. All right. We could also do this now, based on some input. So we can use an input field and we can say arm and disarm. Okay, so for now, this was a lot of input. So we have created a button, we have played around with a layout, we made it more hackish, we created an intent and broadcast intent. We have put some extra string into this one and send it out based on click event. So this was really a lot of input. Well, however, I mean, the point was not to show you how to write this application, that you can now do this on your own. I mean, if you have no experience with Android app development, this is definitely not possible by only seeing it once. For me, it took weeks to understand the concepts behind this. But as already mentioned, this wasn't the point. The point was to show you how you can trigger this event without having ADB access. so that you have a malicious application running on the smartphone, like this one over here, not this one. Our amazing looking hackish broadcast hacking application that can trigger certain events. For example, starting activities, starting services, starting broadcast receivers, interact with them and things like this. I mean, we could also do this even more try hard. So we could make a network request API that the application is fetching every 10 seconds in certain state from our web server and then triggering this intent. For example, disarm or arm this alarm system. Then we do not require any user interaction. But including this is really heavily app development right now. In case if you are curious about this and you definitely want to have an video regarding to this approach, I will extend this bonus video regarding to this one. But I guess we are now already too deep into this app development part. So in this video, we had a little bonus section regarding to app development, which is, I mean, it's not the topic of our course, but I guess it's nice to see. Nevertheless, we do not have to understand it right now. We have seen it, okay? We do not have to understand it. And now we can move on with our core concepts. Alrighty? Okay, so I'm looking forward to see you in the next section. Welcome back, guys. After broadcast receivers, let's have a look into services, which is our third key component in our Android application. So when do we have to deal with services? In our mobile application, we sometimes have to handle a lot of stuff. For example, in our game, we have to render all those graphics, keep track about those objects and things like this. Beside games, we might have to handle, for example, network requests or playing music, file interaction, complex operations, things like this. All of them require a little bit of time. And this is the problem. For example, if you're trying to make a network request in the main activity, so within the onCreate method, then we have to wait until this network request has been finished. And this might take a while. The problem right now is the application becomes unresponsive. Let's say for 2, 3 or 4 seconds. And this is something the Android system doesn't accept. And so after blocking the main UI thread, our activity thread, for a certain amount of time, the Android system is going to terminate our application. So if the operation simply takes too long, the Android core system is closing our application. And this is something, of course, we do not want to have. The Android system doesn't want to have applications that block the UI thread, and we don't want to have applications that's being closed. The solution for this one are services, because they run in the background. They are not blocking the UI thread, and therefore they can be used for time-consuming tasks. For example, like playing music or making some network requests. And generally speaking, we've got two types of services. The first one is the start service, and this is the most common approach, like we would have assumed it. We simply start our service, the service is performing some task, and then the service gets closed. For example, playing a music file, making a network request, things like this. Okay, this is a start service. Beside this, we're also having bound service, and now it's getting a little bit complex, but don't worry, not too complex. So in bound service is binding clients to the service, which means we could have other applications interacting with our service right now. The concept, I mean, this is pretty awesome that things like this are possible, but it is also a little bit tricky because those clients are being bound to our service. They can interact with this one, but we have now to wait until every client disconnects from our service until it gets shut down. Okay, so these are our two services. We've got a start service method and we've got an onBind method. These are the main methods regarding to these two services. All right. The downside of a service is we cannot make a UI update. This is not possible because, as already mentioned, the service is running in the background and it has no connection to our main UI thread. Therefore, if you want to perform things like this, we need to use broadcast receivers, but this is perfectly fine. We are already familiar with this one. So, a common service interaction has been the following in the past. We've got our Android application, and this Android application has registered a broadcast receiver to the boot completed broadcast event. So after the smartphone has been finished booting, the smartphone is informing the applications about this event with the boot completed broadcast. Now within our application, we could implement a broadcast receiver, and in the onReceive method, we could start our service, which is polling our server if there are any updates for this app. This means the user doesn't have to open this application. The smartphone has been finished booting, this broadcast event has been triggered, our onReceive method is fetching this event and starting in the background our service, which is connecting or is requesting our server regarding to updates. This was a common behavior till Android 8, because then we are not having this background execution being allowed anymore. Okay? So this is pretty awesome because all these Android components can stick together. They can interact with each other and they can perform a lot of interesting things. Also, of course, vulnerable things. Speaking of vulnerability, what do we have to look for in service if you want to attack it? And the answer for this one is already no. At least for the start service. Because the start service, so not the bind service, the start service is being invoked via an intent. And therefore we have to take a look into on start command method, because there we are providing this intent. Once again, we have to figure out which data is being passed into this function and what things we can trigger. Exactly the same like we have seen this in the broadcast receiver example. Alrighty? Okay. Regarding to bind services, it's a little bit more tricky because there we are having a different object. We are having a message object and we have to figure out what is happening with this message object. But I mean, the approach it's pretty identical. On the left, we are dealing with intents, and on the right, we are dealing with a message object. To attack in service, once again, the service has to be exported, and we need to have the permission to interact with this one. If it's using a custom permission, no problem, until the protection level becomes signature. Then we are having a little bit of problem. But unless the protection level is not being set to signature, we might be able to interact with this one if it has been exported. Okay? Perfect. Because this is everything we need to know about the service. Last but not least, content provider. And then we have finished our 4 key components of an Android application. Then we know everything in an Android manifest. Amazing, right? So let's have a look into this one. And content provider is simply providing content, as the name suggests. In most cases, or nearly all cases, we are talking about databases. For example, the contacts in a smartphone. These are being stored in a database and we have a content provider for this database, which means we can interact with them via a content URI, this one over here. The first part is simply just the prefix, which signals the smartphone or the application that we're dealing with a content provider. So we're having content : / This is, by the way, an excellent keyword if you reverse engineer Android applications. So if you search for this keyword, you may be able to identify those content providers pretty easily. Alright, next we've got the authority, and this is simply just a unique identifier for our content provider. So we cannot have multiple content providers with the same name. Let's imagine we're having Android contacts several times on our smartphone. We wouldn't know which one we want to call. Therefore, this name needs to be unique, and therefore a common approach is simply using the package identifier for this unique name. But it's simply just a name, it doesn't mean anything. Okay? Alright. After this one, we've got the table entry. So this is in this case the contacts table. And last but not least, we've got the /2, which means we are getting the second entry or the second row of this table. All in once, it would mean we're having the following. Here's our contacts database, and we are now selecting the second entry out of this database. So in this case, Peter Smith, phone, and the email address. Okay. The question is now, how can we interact with those content provider? Because if you remember, content providers are being excluded from intents. So we cannot simply use our intent approach like we have done this in the other 3 parts in activities, broadcast receivers, and services. Within content provider, we have to do it differently. The easiest way might be simply using the ADB shell, because beside the activity manager, we are also having a content provider in there. So we could simply use content query, and then we provide the URI of the entry we want to query. Okay, but what if we are not having access to the ADB shell? So let's say we want to write our own malicious application, like we have done this in the broadcast receiver section, to query a certain entry, to fetch these data. Well, then we have to do it in the following way. So here we are having now the contacts database, or the contacts application. And if we now want to query these contacts in our own application, we need to do this within content resolver. And this sounds now a little bit complex, but let's make this together. So we will master this part right now. Okay. In our own application, we need to define a content resolver. And this content resolver is now asking this content provider to provide the content to us. This is why the name perfectly fits, content provider. So if we are having the permissions and if this part is being exported true, then we can access this. So these are our two use cases which we have in all components right now. Activities, broadcast receivers, services, and also here. Okay, if the user has given the permission to our application to access these contacts database, then by asking it, the content provider is returning back a cursor to this database. And what this cursor does is, it's simply just a pointer to a database entry or maybe a database selection. For example, this one over here. So here we're having now a pointer to the first row of our database. Okay, the content provider must include the following methods, which can be now used by our application to interact with this database. So we can query, update, insert, or delete. We can also lock this down a little bit, but this is most of the time not the case. Okay, so this is the whole concept. In our own application, we are defining a content resolver. We are asking the content provider to provide an entry to the database, and then we can use the methods query, update, insert, delete to interact with this one. Alrighty? Perfect. One last note over here, if you're dealing with custom content providers, then those databases are being stored in the data directory. So we're having data, then the package identifier /db. There we will have the whole database being stored. And if this one has not been encrypted, then we can simply download it and analyze it with SQLite or SQLite browser, whatever you like. You can also choose other tools, but these are, I guess, the most common ones. Okay, and if this database is being encrypted, then we have several options. In case if it's being encrypted via an user provided data, for example, a password and key, PIN, something like this, then it will be hard. But if you're starting this application and the database is automatically being decrypted, then there needs to be all the stuff available in this application. So we need to have the algorithm, keys, certificates, whatever is required. And within the reversing section, we will have a look into an encryption algorithm, and very popular ones, which is AES. So there we will learn how to deal with things like this. Okay, so now I would suggest let's have a look into a coding example. So how does the source code regarding to a content provider looks like, that we know what we are dealing with. Alright, so on the left we've got our application, and on the right we've got our attacking application, which wants to get access to this content provider. If we ask nicely, then the content provider is returning this cursor and we can interact with this one. Okay, here we are now having the query method of this content provider, and we can see it's returning our cursor, alright, but within the query we've got now a lots of parameters. We've got URI, we've got projection, we've got selection args, and we've got sort order. So 1, 2, 3, 4, 5 parameters are in this query method. Oh well, so this sounds like an complex method. And indeed, it might be, but this one comes down to a single SQL syntax, which is super amazing. So all these 5 parameters are being transformed into an SQL statement, like this one over here. So we're having select projection, our second parameter. So this is our selection argument. From table name, this is our URI, where selection equals selection args. Both parameters are 3 and 4 are given over here, ordered by sort order. So all these parameters are being transformed into an SQL statement. And if you're talking about SQL statements, there's one type of attack that immediately catches me, which is SQL injection. And indeed, this might be possible in content providers. But to be honest, it's not that dangerous like we're having this in web applications right now. Nevertheless, let's talk about it. So here we're having now the select statement. Let's insert some values into our query method and see what happens. Okay, so here we have now our query. We've got this URI, which is our content prefix, authority name, and then the table name, which is news. In this case, we can already tell we try to query the table news. Maybe we want to fetch some news of our application. So simply just like, okay, what's up to date right now? The next parameter, our projection, is our payload, and we skip this for now. So we simply just handle this as payload. And the other ones will be filled with null. So If you're taking the SQL statement from the last slide, then we are having the following. We've got select projection from URI, where selection equals selection args, order by sort order. Let's insert all those null values because these will be irrelevant in our syntax. Alright, we are getting the following. Select projection from URI, and now we are having where null equals null, order by null. So everything after from URI is irrelevant. Okay, let's simplify this statement. This means we would get the following. Select projection from URI. So far so good. In our case right now, we are fetching news information. For example, some headlines, dates, timestamps, things like this. So now let's see how we can turn this one into a different query based on an SQL injection. Within an SQL injection, an attacker is able to insert own SQL code into an existing query and transform this into a completely new one. Let's say instead of the news, we want to access the user table regarding to usernames and passwords. How can we do this? Well, all we need to do is inserting the following payload. If we are inserting the following payload, our SQL syntax will transform into the following. Select asterisk from users semicolon, and those dash dash will make a comment out of everything which is following. So we are simply just saying everything behind this dash dash is a comment, and we end our SQL syntax exactly over here, which means instead of querying the news, we are now querying the users table. And yeah, in this case, we would fetch all this information. First name, last name, password, and email. Alright, sounds absolutely ridiculous, right? Yes, and it is, but there's a little bit of a downside. To be honest, I haven't encountered an SQL injection within a content provider which was really exploitable. Why? Because most of the time, the developer is giving you access to the database anyway. So if we get access to the news table, then we might have also access to the users table. It's pretty unlikely and super rare that developers are locking tables like this down. So therefore, if you would have critical data, they might be stored into two different completely separated databases. And having an SQL injection in the laying database doesn't provide us any further information. Okay? Nevertheless, it's definitely something we should check out. Okay, to sum this up, if you want to attack a content provider, we need to make sure that we're having the permissions. I mean, regarding to system permissions, okay, we can ask the user to give this. In case of custom permissions, we can include this into our own application, if it's not being protection level signature. Okay? Alright. Beside this, we also need to make sure that the content provider is being exported. I mean, here we are not having intent filters, we are only having exported equals true, because content providers are not being invoked via intents. If we want to interact with a content provider in our own application, we have to define a content resolver and ask the content provider to give us the content. If this is the case, then most of the time we get access to the whole database, which makes SQL injections possible, but most of the time not that useful for us because we can query those information anyway. Developers are separating these critical databases and do not provide us access to this. But nevertheless, these are all things we have to check if we are dealing with a content provider. Okay, besides interacting with databases, content provider can be also used in combination with files. So we can read and write to a file, and this gives us new attack vectors, which is pretty amazing for the attacker and a little bit unfortunate for the developer. So these vulnerabilities can be a huge threat to the application, and they still exist in common applications nowadays. So Google is of course aware of this and also of the threat of this vulnerability, and Google will deny the upload to the Play Store for those type of applications. So it might get less relevant in the future, but let's imagine how many apps we've got out there right now, and this might also take a while until Google is addressing this globally. Beside the Play Store, I mean, there also exist a lot of other stores, and they might not check those applications for this type of vulnerability, which means it can be still a threat also in the future. Let's imagine you've got some mobile application on a vehicle or within your IoT system or whatever else. So these applications might not be downloaded from the official store. They might have custom stores, and therefore This type of vulnerability, I guess it won't be fixed within the next 3-5 years right now. Okay, so now we know there could be a huge vulnerability in the interaction with files, and I would suggest let's find it out. Okay, here we have a music application which defines the following content provider. We can see it is exported, which makes it possible to interact with it from a third-party application. In our case, we are having our own application on the right. Okay, now let's assume we are having the following use case. The music application takes a file from our own application and starts playing it. Therefore, within the interaction of the content provider, we are providing an URI, which is addressing our file in the following scheme. Content : authority / file name. The music application is resolving this URI and accessing the file, and in this case, for example, playing it. Okay, so far everything seems to be fine, right? Well, not at all. Let's see it through the eyes of an attacker. If we can determine the file name, why not choosing a file from the internal directory of this application? So the protected context directory of this app. We're talking about the data directory. Do you still remember our alarm application with the pin XML file in the shared preferences? Of course you do. And you know what? We can now make the application opening this file for us. So we can simply provide this in the following way. So content : our authority and then /file. And now the file is simply just a path traversal which goes back one directory, entering the shared preferences and opening the pin XML. Depending on the code, the application is displaying this content or it's returning this content back to our own application, which would be even more amazing for an attacker right now, because this would be exploitable remotely. So we could use this content scheme to access every file in the protected data directory of this application. Amazing, right? Absolutely. So how all of this works, we will find out in the next couple of videos. So within the first one, we will perform our SQL injection. And in the second one, we will have a look into a path traversal vulnerability, accessing those files. And we will also have a look into a real-world example. So in 2020, Trend Micro did analyze a cardio application, and they identified exactly this type of vulnerability in there. I guess the data which was accessible was not that sensitive, but of course, this depends from application to application. Alrighty? Okay. So I guess we have seen everything in the theory right now, and yeah, let's exercise this a little bit. Let's find out how to exploit this content provider. So therefore, I'm looking forward to see you in the next video. Welcome back. Let's do some practical exercises regarding to our content provider. And we start with our SQL injection attack, which sounds amazing, but it's really not that common anymore. Nevertheless, exported content provider are still pretty dangerous, and we will find out why. So therefore, let's go. Okay, so here we are back at the Ubuntu VM. We've got our smartphone over here, and we once again install the Thief application because this one has a really nice attack surface regarding to content provider. So within apps, Thief, yes, here we have it. So we install the old version. I mean, not the old version. We're installing the APK and not the decoded version. Okay. And I guess we have to set it up first, which is a little bit annoying, and therefore I will fast forward this process. Yes. So we want to give access to files and media. And then, yes, we have to set it up. And we also get still this warning, but it runs on the smartphone perfectly. So I'm using a Nexus device in RP version 30, and this works properly. Okay, so I will fast forward this process right now. Okay, so here we are back, and we have already set up this application. Okay, so we've got the service in there, we've got a password, we've got a PIN, and a bunch of other stuff. So therefore, let's have a look how we can exploit this content provider in there. So therefore, we are having a look into the Android manifest. So within the decompiled version, we still got it over here. Here we have the Android manifest XML. Yes, and here we can see we have two content provider. This one and this one. Okay, In this video, we will have a look into this content provider, which is simply just a database interaction. And this one over here, this is a file provider, which gives us the possibility to search for path traversal vulnerabilities. All right, we will do this in the next video. For now, we focus on interacting with a database. By looking at this one, we do not know if it's a database or if it's a file provider. So we will have to take a look into the source code to figure this out. But before we do this, let's first discuss this here real quick, because there's a bunch of stuff which is pretty interesting. So therefore, let's get back on the graphic tablet. Okay, so here we have our content provider, this one over here. And we've got the authority name, which is this part. Okay, and then we've got exported true. Amazing. This means this content provider is available from the outside world. We can interact with this one. So that's good to know. Multiprocess will be ignored, and we've got the Android name. So this one over here, this is the class name. It has been defined in here, and this is something we want to check out later on. I mean, we haven't talked about reverse engineering yet, and therefore I will do the reverse engineering approach and provide you the decompiled source code. It's not the original code, I cannot find it anymore online, but it's good enough to perform our reversing tasks. Alrighty? Okay. So we know we've got a DB content provider class, and this is the authority name, which means we've got something like content : / and then com MWR and so on. Okay, and then we've got this part maybe also included over here. And now there's an interesting part, because we also got this line. And this line is now a path permission. So this one is telling us we've got now a database. This is our content provider. I mean, we do not know this right now, but this is something we will figure out in just a moment. So we've got a database. And this database has now different tables. We do not know how many, but we can already see one, because this one over here, this is the, oh, sorry, wrong color. This one. This is now the table, and let's clean this up, the table keys. Okay, to be more exact, the table name can be still different, but this is that's the scheme, the URI, to access the table. Okay, so we've got a table in here that might be keys, or it could be also named completely different, but we can access it via this URI. Okay, but why is this one listed over here separately, and what's about the other tables? Well, this one has been listed separately because we've gotten custom permission for this table. This means if we want to read or write to this table, we need to have this permission. This one and or this one. Depends on the action we want to perform, of course. And those two permissions are defined over here. So now we are dealing with custom permissions, which means the content provider is being exported. So this one over here, this is exported. But the keys table has been locked down. The keys table is being protected by those two permissions. We can include those two permissions in our own application. And if we ask the user nicely, then the user might grant us the permission, and then we can access this anyway from our malicious application. In this part. But we've got this protection level dangerous, therefore the user might get a pop-up. It depends on the Android version and the smartphone we are running, but normally speaking the user should get a pop-up over here, so there should be some pop-up. Do you want to give access for this app? And the user has to accept it. To be honest, I wouldn't count this as a big deal, because the user might easily get those permissions to our application, and then we might be able to access those sensitive data anyway. So therefore, inserting custom permissions with a protection level dangerous, I guess that's not a good deal. At least that's the way I see it right now. If the protection level would be something like signature, then we're talking about something different. So that's a totally different story. This would be perfect. We will talk about signature and the signing process in another topic. So far, it simply just means if we have an application and another application has been signed with the same key, then those two can exchange information easily. But this, of course, excludes other applications. So it always depends on the use case the developer wants to do, or on the data the developer is providing over here. So it always depends on the type of data we are sharing. If those data are critical, for example, if these are our passwords in our password safe, then protection level dangerous might not be sufficient enough. We should go for signature. But if they are being encrypted anyway, then dangerous might be still okay. Alright, so it depends on the data itself. Okay, but back to this one over here, which looks like a complete mess. So maybe let's clean this up and summarize it over here real quick. So we've got a database and we've got this authority name, this one. This is our class, which is defining the content provider. And this has at least one table. And this table can be addressed in the following way. Content slash then our authority name, and we've got this path keys. Wrong color. Let's be constant. And that's in capital K. Okay. This keys table is being protected with these two permissions, which is not a big deal. We can circumvent this. We will also do this later on. We will write our own application and include them into this application. But for now, at least, it is protected. So the user might have to grant this permission. Okay. So now I would suggest let's decode this app. So let's get back the source code and let's have a look into this class to see what's going on over here. Alrighty, let's do this. So I clear the screen and then okay, I'm using the JADX tool. If you want to follow this, let me get the help first. Okay, if you want to follow this, I recommend using the JADX GUI tool because there you have some connection between those classes. You can simply double click on something. But we haven't talked about reverse engineering yet, and therefore I will provide you the source code. I mean, it's the decompiled code anyway. So this will be our workspace, and therefore I go for the JADX command line tool. All right, so how can we do this? We've got JADX. We need to provide an input file, which is sieve.apk, and then simply defining an output directory, and that's all. So decompiled code. Okay. We could also limit it to just have the sources and not decompile those resources, but we stick all together. So all in this directory. Now we can open the whole directory with Visual Studio Code. Okay, so this is exactly what you will get from me right now. These two directories, the resources, which includes the Android manifest, and also the sources, which contains the source code. So let's see. Which class do we have to look for? We need to take a look into this one, DB content provider. So let's find this. Okay, it's not that hard, and there we already have it. All right. Yes, okay, and here we can already see we've got a content scheme. So exactly like we have written it down before. So by using this scheme in exactly this way, with this DB content provider / keys, we are addressing a table. But the table doesn't have to be named exactly like this one. So it could be keys, but it could be also completely different. This is some kind of alias for a certain table. All right? Okay. For now, we do not have to bother too much about this because we will figure out how to deal with this later on if those names doesn't match anymore. Okay, for now we can see we've got one content URI, so one alias for keys, and we've got another table over here, passwords. I mean, once again, it hasn't to be named passwords, but that's the alias name for this one. All right, so at least we're dealing with two tables, and now we already got something interesting. Our content provider is being exported. Keys has been locked down, but passwords is free. So at least we should be able to query this one, this reference, whatever's inside here, and get out these data, which is super amazing, right? If they are interesting, those data. So we will have a look into this one later. Okay, and then we've got a bunch of stuff. I mean, these are references, IDs, who knows? This one over here sounds interesting. We've got a PWD helper. So maybe let's get this a little bit out. Okay. Then we've got an URI matcher. So this matches our URIs from from here. Here we can see we've got URI pass. Okay. And then let's see. All right. And then we've got our familiar methods. So on a first view, it looks like a complete mess, but you do not have to bother too much about this. And let me get back the graphic tablet and then I will show you why. All right. So if you still remember the theory part, then we've got our content resolver on the client side, and the content resolver is asking the content provider to provide some access to the data. The content provider is returning back some cursor and also giving access to those methods. So here we've got the method delete, for example. So this is simply just deleting an entry in a table. Beside this, we also got insert, and this one over here. So here we can insert a new value into a table. And then we've got query. This is maybe the most interesting part right now, because here we can see we've got now all these 5 parameters. We've got this URI, we've got this projection, we've got selection, selection args, and sort order. So out of these parameters, an SQL syntax will be formed. So we're having something like select. And then we've got our projection from. And then we've got our this one, our in. Oh, wrong color. Let's make green. In. And then we've got where. And we've got all the rest. Selection, selection args, sort order. So out of these parameters, this SQL syntax is being formed, and this is exactly our injection point later on. This part over here, this projection. But we will discuss this later. For now, let's finish the discussion of this file over here, and then let's see if we can already reconstruct the database and also the tables based on the source code. Because if you want to perform an injection, we need to be familiar with the structure to name it correctly, otherwise it won't work. Alrighty? Okay. So let's clean this up and let's see. Alright, so yes, we have talked about the query and also about insert, and this one can be ignored right now. The part above has been also analyzed, and this one is interesting because here we are now having a method on create, but this time we are not having the activity on create method. We might have a creation of our database, and this one is pretty important because if we are creating our database within this part over here, then we can make some conclusions about the structure of our database. Which tables are in there, what are those columns, and how they are being interconnected. So this is something we definitely want to figure out. And therefore we will have a look into this one afterwards. Okay, after the query method, there's only the update method left, and this can be simply used to update our entries in a table. So all of this will be done later. We will play around with insert, delete, and also update statements, and of course our query statement to inject our own SQL syntax into this one. All right. Okay, before we can do this, there's only one task left, and this is this one over here. So therefore, let's figure out what's the structure of this database. Okay, so here we have the PWD helper. Let's see, PWD helper is over here. Okay, and this one, all right, this is defining the database name. So within the data directory, we're having our package name. And in there, we're having a directory named db. And this is the file in this directory. So this database will be stored in there. We could download this into our laptop, this file with a db pull. First, we have to place it on the SD card, but then we can download it. And we can use tools like SQLite browser. I guess it's SQLite browser 3. Or simply the command line tool for SQLite. And then we can access and query this database and can find out the structure anyway. But we can also do this over here because it might not have been initialized completely, or there might not be any value in there. So therefore, let's also do the reversing approach, but nevertheless, feel free to try this one over here out. Okay, so far there's nothing interesting until here. And here, once again, we've got another onCreate method. And this time we've got something PWD PW table this way. So we've got PW table, and here we can see SQL create entries. All right, and this one is not being referenced anywhere, so it might be in static field. And therefore, let's have a look into this class over here, and we can find this here. All right, let's open it. Perfect. This is the final structure of our database. So now we've got everything completed. We've got a database file which is named database. I'm not sure anymore. It doesn't really matter. So this is our database. Okay. The database name was part of the authority. So I guess DB provider. And we have to look it up in case if it's wrong. DB provider, that's the name. And here we can now see we've got table. Here's a table name, passwords. So we've got a table named passwords. And we also got a table named key. And this one is now interesting. Key. Because if you remember the content URI regarding to this key table has been referenced with keys. So the reference is this content URI keys. This is the way how we access this table within content provider. But if we are using it within an SQL injection, we have to use the correct name of this table name, which is key. So not the content reference, we have to use the correct table name. So this one over here, this is simply just an alias for our content provider to access this table. All right? Okay. Let me clean this up. Okay. And now let's see. What entries do we have? We've got email, password, service, username. And for now, we do not know if they are in password or in key. Here we've got password once again. Okay. Interesting, but they are also named different. Capital P, lower p. Here we've got PIN. And then, yes, this is what I was looking for. So here we've got now create table key. And we can see this table key has a column password, which is text, which is the primary key. And it also has a PIN, which is text. So this one has now two columns, which is password and PIN. And both of them are text. So this could mean that they are being stored in clear text. It could be also encrypted and base64 encoded, for example. Then this text parameter would also make sense. So this is something we need to figure out. But we can already see the structure of our table. So our table key has the columns password and PIN. Okay, and then we've got this create table over here. And let's see. Okay, this one is for our password. Yes, this is for our passwords. And this one has a lot of entries. We've got an ID, which is the primary key. So there will be in column name ID. There will be also in column name service. There will be in column name username, password. Interesting, once again password. Here lowercase, here capital. And this time the password is blob. So this means it's binary data. So this is most likely being encrypted. Okay, and last but not least, we've got this email. All right, and these are the things we have already figured out just by reverse engineering a few classes. So we know the database, DB provider. We've got two tables in there, and the most interesting one is the key table, but this is also the one which has been locked, so we cannot access this. All right, so far so good. Our attack vector is now the following. So the key has been locked. Okay, but the lock is only available from the outside world. So the DB provider has been exported. And if we come from outside and we try to access this, then we get a deny. If we are not having the permission to access this one. But if we are able to query this one, the passwords table, then we are already in. So this lock is not taking place anymore. And if we now can smuggle our own syntax, our own SQL query, Whoops, query is, I guess, written something differently. That's the way. If we now smuggle our own SQL query into this passwords, then we might be able to access this. So this is our attack plan. But before we do this, let's first find out how we can interact with this one. So how can we query those tables? And in this case, the passwords table, because the key table cannot be queried. And this is also something we will find out right now. All right, let's do this. Okay, so to do this, we are using once again the ADB shell. And this time we're not using the activity manager. This time we're using content. Let me close this one. Okay. Okay, so on the first view, it looks like a complete mess. Complex parameters, things we do not know right now, what is extra binding and things like this. But we can make this a little bit easier. Those lines over here, if the text starts over here, then we've got a new chapter. So this one is ADB shell content insert. So here we are dealing with inserting new data. Here we can see we've got update. And this one is delete and this one is query. And then we've got content call, content read and some other stuff. The second half can be simply ignored right now because this is regarding to file access, which will be discussed in the next video. There we will find out how path traversal will work. For now, we only focus on the first half of this one, interacting with a database. And now we know we are dealing with a database, at least for our content provider over here, in this one. Where do we have it? Here. This one, this DB content provider. All right? Okay. So maybe let's put this on the right. Let's close this. Okay. Okay, so now's the question, how can we access those tables? So within here, we are now having a database, which is stored in a protected directory, but the access to the database API, to the content provider, is being available because it has been set exported true. So to do this, it's very easy. All we need to do is we need to use content, and then let's see, query. And then we do not have to take care about all these complex parameters. I mean, we know what projection is, how and where statement works and things like this. But we do not have to take care about this because if we are not applying any parameter, then we are simply selecting everything from this table. Easy, right? Yes. So how can we address this table? Well, all we need to do is we need to provide content. I'll write this down as a comment over here. So content, and then the authority name, which is this one, and then slash and the table name. This is how to access this table. And we do not have to do this on our own because this is already being defined in the DB content provider. So if we scroll up a little bit, yes, here we have it. So here we can see we've got content, our authority, and then the table name. Perfect. So we simply copy this part and we are inserting over here. And this is how to perform and select all from the passwords table. Nice, isn't it? Let's do this in 3, 2, 1. There we have it. Nice. We can see we've got the service banking, username admin, password blob. We can extract the binary data out of this because now it's just saying, okay, this is binary data and it's not displaying it, but we can deal with this one. Nevertheless, those data are being encrypted, so we do not get an advantage out of this unless we can decrypt it, which is not possible right now because we do not know how to do this. And it might be also protected with the user password, which makes it even more impossible if the user password has been chosen correctly. So these are many what if cases. And this is something we do not want to discuss right now. We will have a separate section about this cryptography, but for now we want to talk about content providers, okay? All right. So last but not least, we've got this email, which is an information leakage. And if you take a look at the structure, _ID, service, username, password, email, this is exactly what we have reverse engineered. So all we need to do is simply following down the line of our content provider, because there it's being defined how to access the database and also how the database is being created. So there might be some reference to this. Alrighty? Okay. So this is a way how to interact with this one. And what happens if you try to access the protected ones? The protected ones is keys. And this one over here. So let's see. Now we want to query this one. And here we're getting now an error. Let's make this a little bit larger. Okay. Permission deny. What we expected. And here we can see we try to access the keys from which is this process ID. It really doesn't matter. All it matters is we are trying to access this from the user ID 2000, which is our ADB shell. And this one over here. So the ADB shell has not the permission to query this. If you would get root privileges, then of course this is possible. But then it's also not an attack vector anymore, because then we could simply go into the data directory and directly access the database. All right? Okay. So within the ADB shell, we are not having access because our ADB shell does not have those two custom permissions. These two. All right. So now let's see how we can still access this table based on an SQL injection. And to be honest, this might be the only use case where an SQL injection is useful, because otherwise we have seen this with the passwords table. In this one, so we could simply access those data if the content provider has been exported. And in most cases, the developer is separating this. So the developer is creating two databases, one which is being protected, so completely, and one which might be exported to interact with other applications, but then those data are not that sensitive anymore. And if we find a flaw in there, it doesn't matter because we cannot access the other database. All right? So this is the things we most commonly encounter, but nevertheless, let's talk about this, because if you have this case, then it might be an absolutely nice finding. All right. So how can we abuse this right now? Well, if you go back, and then we've got this query, and this one over here. So out of this query, an SQL syntax will be formed. And yeah, this is something I guess we should discuss on the graphic tablet once again. Okay, so I will discuss SQL injection on a very high level. In case if you're not familiar with this and you want to have an extended version with union, blind, time-based, stack queries, and even more error-based is missing. If you want to have all of them in a separate video, please drop me a message in the comments underneath this video and I will upload a bonus video regarding to SQL injection. But this is something which would extend this video very heavily right now, and therefore, yeah, if you are interested, I will split this and provide you those information. But if you're already familiar with this one, it would be super boring for you. So therefore, we just discuss this on a high level. Okay, so out of this query right now, with these parameters, this one, this one, this one, this one, and this one, an SQL syntax will be formed. And this one might look like the following. Select. This, by the way, is the URI we are passing to this one, and the URI we need to pass is passwords. Because this is the table we can access right now. Keys is being blocked, so therefore we need to access or provide passwords for this. Okay, and then we are having an where clause, which can be simply ignored right now, because over here those selection args and things like this would be normally used in an SQL injection, but over here we can directly define this projection part, which means we can directly insert SQL syntax into this query, which is absolutely amazing. So what we could do is the following. If we provide a projection something like this, projection and a single quote, then we are having select, oops, yeah, let's write it in this color, it's okay. Select, then we've got the single quote in this color, from, and so on. And single quote will interrupt the SQL query. So the SQL syntax is awaiting another single quote somewhere. Otherwise, this from will be inserted into some single quote, which means this might be treated as some string. And therefore, if we are only having one single quote, then we are getting an error over here because the single quote is missing. We are intercepting the original query and we are not closing it right now. So this will lead to an error. Let's find this out. So let's close this. Okay. Let me get this graphic tablet out of the way real quick. All right, so how can we apply this projection? Well, if you're using content and then have a look in the help menu, where do we have query? Over here. And then we've got this projection. So we can use -- projection to apply our projection. Okay, if we are applying this in the following way, then we can see the terminal over here is expecting to end the string right now. And exactly the same happens in the SQL syntax. So if we close this right now, then we are getting an error while selecting from passwords. The single quote, if we are inserting it in this way, it will mess up the terminal. Therefore, we have to use double quotes left and right from the beside the single quote. So this will now bypass our ADB shell terminal and insert a single quote directly into the SQL syntax. All right. Okay, so let's do this and let's see what happens. Oh, nice. Unrecognized token. Here we can see exactly like we have written it down before. Do we still have it? Let's see. Yes, so here we still have it. Select and this one. So here we have opened the query. And now it's complaining about this path that this one is not being enclosed. So we have interrupted the original query. All right, how can we use this? Well, this is now our point where we can apply our own syntax into the original syntax. And afterwards, we just have to fix the original query. And this can be easily done by applying a comment. Let me show this to you. So if we are inserting something like this in the projection, not the single quote anymore. So let's get rid of the single quote. If you're now inserting something like this from passwords, from key, and we have to take care about key, so how it's being written correctly. So uppercase, lowercase, and it's not keys. Keys is the reference in the content URI, but the table name is key. And here we have to be precise because we need to address the table name. We are not within the content provider URI anymore. Okay? So if we inject our own SQL syntax, we have to stick to SQL syntax, which means SQL needs to know the original values. Okay, back to this one. If we are providing projection, asterisk from key, and then 2 hyphens, this will comment out the rest, which will lead to the following syntax. And so here we are having select. And now we are inserting all from key hyphen hyphen. And this will lead right now to the following. So afterwards we are having, let's see, we are having from passwords. And where, and so on. So everything afterwards will be now commented out. So this will be simply ignored. And the only syntax that's going to be executed is this one over here. So select all from key. And this via the password table, which can be accessed because this one is not being protected by the custom user permission. Alrighty, let's try this out. Okay, so let's see. Over here, yes, projection, all from key. And this is all. 3, 2, 1. Yes, I'm missing the hyphen because then now we can see this perfectly. Select all from key from password. This is not valid SQL syntax. Therefore, we have to comment it out. It was on purpose, of course. So let's see. 3, 2, 1. Nice. We've got the password in plain text and also the pin in plain text. Amazing, right? So this is how we can circumvent the custom user permission based on an SQL injection. And to be honest, this is the only use case I can think of an SQL injection being useful in our Android app, because otherwise we would be able to query this anyway. right? All right. Nevertheless, I think this could be a pretty amazing attack vector in case if the developer is putting everything into one single database and providing partial access to this one. Beside this SQL injection, we are also having another issue. And this issue is over here. So this custom user permission is being defined for the path /keys, which means if you try to access this one, at the beginning, I guess. Yes. If you try to access this content URI with the path /keys, then the user permission will be checked, and in case if we are not having it, our access will be blocked. But this path has not been defined in a regular expression, which means if we are accessing these keys in a different way, for example, let's clear this. Content query over here. So this is the normal behavior, which gets denied. Oh, yes, --URI. There we go. Yes, access or permission denied. But what if we are accessing it in the following way? Keys / Then, oh well, we still get the password. So if the developer is not providing a regular expression, if the developer tries to block the access based on /keys on a hard-coded value, then we might be able to circumvent this. But to be honest, I am not sure if this is still possible regarding to writing an application like this and uploading it to the Play Store. So Google might deny the upload for this application in the official store. And therefore, I would assume that this doesn't happen often anymore. In case if you think, okay, we can simply use /keys and /keys/ as a path, this still doesn't work because we can apply many slashes at the end over here, and then we can still access this. So the only solution for this one is providing a regular expression and not just checking /keys. We should check /keys and then everything else. All right? Okay. So this is all for the SQL injection part right now. Now let's have a look how we can interact with a content provider. So let's see how we can insert, delete, update, and query we have already seen. Yes. Insert, delete, and update certain entries in a database. Because the syntax is a little bit complex, yes. But once you have seen this, it's also included in a cheat sheet. It's not that hard anymore to get back on this with the help menu. All right, so let's see. We've got this table's passwords, this one over here. Okay, so let's see how we can insert new values into this one. So therefore we are using content. So we need to use the help because otherwise this won't be possible. It's a little bit complex, but yeah, we will make this. Okay, here we've got content insert, and now we've got --URI. Okay, so we have to provide our passwords table. This user ID, I guess, can be skipped. Yes, we skip this. And now we've got this binding, and this is important. Binds a typed value to a column and is formatted in the following way. Column name, type, and then the column value. So this might look a little bit complex, but if we open the passwords, this one over here, then yeah, let's do this. Okay, we already start with insert for this large table, which is, I guess, the most complex syntax. So don't get frustrated. Afterwards, it would be way easier. All right. So nevertheless, let's do this. So if you want to insert a new entry, let's see, content insert. Okay, then we have to provide the URI, which is this one. Yes, I see my typo. Okay. And now we have to use this strange bind. And I guess there's always an example. Yes, here we've got it. So this one over here, name is the column name, type is string, and then we've got the column value, which is new settings. Okay, so if you want to insert a new entry, we have to do it in the following way. Underscore ID, this one cannot be used because this one is the index and its primary key, and it will be auto incremented. So this can be skipped. but then a new service has to be entered. Okay, so our service is the column name. Then we have to define the type, which is string. And then we have to define the value, which is the new value we want to insert. In this case, hacked. Okay, and then let's see, we want to define a new username, string, and the username is lead. And then we want to define a new password. Okay, now it's getting interesting. I guess it's B for byte, but I'm not sure. And we provide 0. And then I'm not sure about this one. Maybe I have to look this up later on, but let's try this first. Okay, and then we have to use email column name with the value string, and this is hacked at lead. All right, let's see if this one works. So let's enter this in 3, 2, 1. Okay, we are not getting an error, which is good, I guess. And to verify if this works, let's query this once again. Yes, nice. So we can see, yes, we have inserted a new entry. Nice. Unfortunately, it might not be helpful because this password is binary data, and if it's being encrypted and it cannot be decrypted when we are logging in because it's not a valid encryption, then we will get an error. Nevertheless, let's see if we can set this password to be empty. Maybe then it might work. So this could be also a way to entering the application. And let's see. To update this password, so if you want to change the password, we have to use a new query, which is the update query, which is pretty good because that's why we are here. So content update. Let's see how update is being used. Over here. Okay. Once again, we have to apply the URI. Whoops, the complete URI. Okay, and let's see, update. Update is nice because we have a where statement and we've got our bind. Okay, bind once again, column name, type, new value. So bind is the column name, which is our password. The type is B. And we are not applying any value. I hope this works in this way. So if you're not applying any value, I hope it's null. Okay, and then we have to define which query we want to update, which column. Therefore, we have this where statement. And here we have it. Okay, let's copy this. Okay, where, and now password. Oh no, password, this might be too risky. Let's say where ID is equals 2. So this is our row ID2, and now we want to update the password in there with a new byte value, which is nothing. I'm not sure if this works. Let's see. 3, 2, 1. Okay, no errors. Let's query it once again. Okay. Okay, so it seems to not work, unfortunately. It might be that updating the password in this way, we have to provide a new value. So to figure this out, let's change another thing. So let's change the service, which is in string, and we want to change it in this part. So that's the column name. And now it has the value hacked, and we named it hacked again. And we want to change the service, which has the name hacked already. This one. So let's see. Where service is equals hacked. And so this should definitely work. I'm pretty sure it works in this way. Let's see. Okay, content update 3, 2, 1. No error, but I mean we didn't get any error so far. Yes, okay, it is a problem with the password and the byte value because we can see we have changed the name. We can also change the name of the first account, which we do not have access. So service account hacked, where the name. So now we want to change the banking name. All right, let's see. Yes, it has been changed. So let's log in into this application and verify this. So here we have the app, input text, and then I hope it was this password. Let's see. Yes. Ah, nice. We have created 2. So this is interesting. Okay, here we can see account hacked and hacked again. So we can modify existing data in there, which is, I guess, not good because, yeah, even if the password is being encrypted, we might be able to apply some null value. I will check this out and provide this in the cheat sheet if there's a solution for this one. So yeah, by inserting a new account, we might be able to bypass this one over here. Oh, yes, I realize right now, even if we could insert a new account, this password is different. So that's not the password of the application, it's the password of the password safe. So sorry for this, I got confused by having those 2 tables with the same entry. My fault. Okay, so even if we could create a new account, we cannot circumvent the login screen because the login screen is being defined in the keys table, not within the password table. All right? Okay, not to confuse you, but to sum this up correctly. I mean, we could use our keys bypass to circumvent the login screen. And this is exactly what we're doing over here. So I have added this sequence right now. We simply check what entries are in our keys table by using the bypass. And then we can update or also insert new one. In this case, we simply insert a new entry. And then it's a little bit interesting because there's only one entry for this whole application because we cannot have multiple users. Which means we're now having 2 entries, but we can see the password which we have entered will be used to log in into this application. But if we can tamper with the keys table, then I mean, yes, we could simply read out the original password and log in into this. Therefore, I haven't counted as an login bypass at the beginning right now. And I still won't do this, okay? So reading out the password, then, I mean, we do not need to bypass this by entering or updating the old entries. Alrighty? Perfect. Okay, last but not least, we've got this content delete. Where do we have it? This one. Content delete. So how does this work? Okay, we just have to provide the where statement. Okay, this is easy. Let's get back the passwords. Okay, now let's delete, for example, the second entry, this one over here. Content, and then delete Yuri. Then we have to provide this, this Yuri. And I guess we need to be careful. If we hit enter, I'm not sure if you delete everything in there. Could be possible. And now let's see where. So content delete where, and then we simply copy paste this one. Okay, where, and now we need to identify this database entry. So yes, where service is hacked again. Okay, it should disappear, I guess. Maybe we have to refresh this view. So if we go into settings maybe and back. Yes, here we can see it has been deleted. All right. I guess I misclicked. Yes, I guess I misclicked. So we have seen how SQL injection works with content providers. We have seen how we can insert, update, and delete entries. And we have also seen that we should provide a regular expression over here. What we have not seen is I'll be using this part right now. And I guess, yes, let's do this in a very quick bonus video afterwards. So there we will write an own application which grants the permission over here and then simply access those keys. All right? Okay, in case of any questions, feel free to drop some comments underneath this video. And otherwise, I'm looking forward to see you in the second part of this video where we exploit this with our own malicious application. So, see you there. Welcome back to another bonus video. I mean, meanwhile, we are having more bonus video than regular videos, but yeah, this is why we are here. I would like to show you everything I know regarding to app hacking, and therefore we might have a lot of bonus content. All right. In this video over here, we want to exploit the content provider within our own malicious application. So we will perform all 3 attack vectors, which we have seen in the last video. The first one, the SQL injection. The next one, the path bypass. so the custom permission bypass. And last but not least, we simply ask for this permission and see if the user grants us these. If this is the case, then we can also query the internal passwords of our password safe. Amazing, right? Therefore, let's go. Okay, to write our application, we need our Android Studio. So within Tools, Android Studio bin, here we have it. So let's start this. We're still talking about the Thief application, and yeah, we will start with the SQL injection. So we will write our own content resolver, which is asking the content provider to provide those content in form of those methods, insert, update, query, delete. And then we will use the query method to inject our own SQL syntax. Yes, sounds absolutely complex, but if you have watched the last video where we did all of this in the activity manager, at the end it wasn't that complex. And within our own application, I mean, the approach is still exactly the same. Alright, so now let's create a new project. So new project. We choose empty activity because we want to have it as clean as possible. And then let's see, we name this Thief Backup. I guess that's a good application name. A language Java, and I go back to Nougat, but the target build SDK is RP level 30. And there we have to adjust a lot of things. So the whole privacy concept has changed in Android 11 and higher. And therefore I would like to show you all of this. How to write an own application which still can exploit those issues, even on modern smartphones right now. Because later, if we talk about browser and all the stuff, this will not work on modern smartphones anymore. In 2 or 3 years, this will be completely gone. We have to take the new approach over here, and yeah, this is why we are here, right? So therefore, let's move on. Okay, so we go back to Nougat, but we are targeting the version 11. Okay. And now we have to wait until the Gradle process has been finished. So this might take a while, and I will see you in a moment. Alright, 1 moment later, we are back. So this one over here, this is our workspace. We've got our main activity, we've got our onCreate method. What's missing? The interaction with the content provider, of course. So how can we interact with this one? Well, if we think back to the theory part, the content provider or the access to the content provider is working in the following way. We have to define a content resolver, and the content resolver is asking the content provider to provide the content. Afterwards, we get back a cursor, which is simply just let's say a pointer into the database entry. So with this cursor, we can access those data. All right? Okay, so how can we do this? Well, it's not that hard, to be honest. We just have to consider some things which has been new in Android 11 regarding to the privacy of an application. And this is also the reason why I would like to show you all the stuff. Because later, if we talk about tools like Browser and things like this, those tools won't work anymore in the future. So regarding to newer smartphones, RP level 30 and higher, so Android 11 and higher, there has been a lot of change in the privacy settings, and this will deny access for the browser application, for example. Therefore, we need to know how to do this on our own. And this is why we are here. And yeah, I would suggest let's simply do this for this content provider. So therefore, I would suggest let's simply start over here. So let's start by accessing the password table. The password table is included in the content provider, in the DB content provider, and this one has been exported, so we can simply interact with this one. If we can interact with this one and if everything works, then we can perform our attacks. Our SQL injection, our user permission bypass, and last but not least, what was it? Yes, it's not really an attack, it's simply just asking to give the custom permission. This one over here. Those two. If you're having those two permissions, then we can also access the key table. All right? Okay, but first let's see. How can we interact with the passwords table? This one over here. First of all, I mean, we have to get this URI. So this part can be simply copied out of this. And we can include it over here. And so we have to define a new URI. And this is our URI. Okay. And this is our alias to access the password table in the Thief application. All right, so the addressing, easy. But now's the question, how can we create our own content resolver? And this part, it's easier than you think, because there's already a method which is doing everything. So we can simply call get content resolver. Here we already have it. And then we can access those methods. We can already see query. Do we also have insert? Yes, insert, update, and things like this. So here we are getting, or we're defining our content resolver in our application. And then we are asking this content provider to provide access to those methods: insert, query, update, and also delete. So these are being defined over here, but we can access them with the content resolver if the application gives us access, which is the case for the password table because this has been exported true. Okay? All right. So therefore, let's see. Back to this one. Let's simply access the query method. So query, and here we have now two types of methods. So we've got one with projection string selection args. This is exactly the one we want to have. And this one, I'm not sure. Query args, cancel, it doesn't matter. We want to have this one. Okay, and now we have to provide all those parameters. I mean, URI, this should be clear, right? URI is our URI. Okay, then we have to define the projection arguments. And this will be later pretty important for our SQL injection, but for now we simply keep it null. Which means if we do not provide any projection args, everything from this password table will be selected. All right, we do the same for the selection, also for selection args, and last but not least, also for sort order. Yes. Okay. This method is returning back a cursor. So we need to get this cursor. We have to define it over here. Query cursor. Let's import it. And then we are already done. And this is how we can access the data from the Thief passwords table. Amazing, right? Absolutely. So to print this out, we could use it in the following way. System out, print line, and then we can use our query cursor. But here we are now having a little bit of a problem because our query cursor is an object. So it's a cursor object, and therefore we cannot simply print out an object. If we're printing out an object, we simply just get something like add and then this, for example, maybe. So this is just an address. This is the address of this object, but it's not the content. If you want to get the content, we have to use something. Oh, I guess it's database utils. Yes, it's database utils. And here we've got, let's see, cursor to string, something like this. Cursor dump, was it dump? Dump cursor. Yes, dump cursor to string. So this will take the whole cursor object, everything, every information that's included inside there, and will provide a string for us. So we can save this in a variable, or we can simply print this directly out over here. So query cursor. All right. So this is now everything. We need to access the passwords table and also to print it out in a readable format. All right. Okay, let's see if this works. We use run app. So on the left, we've got a smartphone in API level version 30, and we've got a lot of privacy settings in there. And this might be the reason. Let's see. Lockhead. Yes, if you're searching for system out, nothing is inside here. Let's see. No, there's no system out. So our cursor object is not being accessed. And indeed, if we print out this cursor, let's see. Cursor. And let's do this. Okay, I guess the lockhead seems to hang a little bit. Therefore, let's use the ADB lockhead. In case if we are using the ADB shell out of the Android Studio, we cancel the connection from the Android Studio. And yeah, we can simply use it on our own right now. So ADB lockhead, let's see. Okay, I guess we have to search for this. So let's clean the lockhead. And then let's search for system.out. Okay, make this a little bit larger. And let's simply relaunch this app. Yes, we can see the cursor is null. So the whole object is null, which means it seems like we're not having access. And yes, indeed, we are not having access. But now's the question, why do we not have access? Because The Thief application is running on the smartphone and this content provider has been exported. So that's everything we need to know, right? Unfortunately not, because in Android 11, as already mentioned, there was a huge change regarding to the privacy. So those applications has been automatically locked down a little bit. If you want to interact right now with the Thief application, we need to tell that we are visible for this application. I mean, this is not a big deal because we are the attacker or the attacking application and we want to access the Thief application. So therefore, if we tell the Thief that we are visible for this application right now, we do not lose any sensitive information. But we have to tell this in our application. And this is why I would like to show you all the stuff over here, because if we later take a look at the browser application, those approaches won't work anymore because browser is not aware of the app visibility in Android version 11 and higher. And it won't be because browser will not be supported anymore. And therefore, we need to be able to write our own applications to perform all these tasks. Alright? Alright. So now's the question, how can we make our application visible for the Thief application? And to be honest, this is also something I need to look up because, yeah, we have to define it in the Android manifest, but I'm not sure about those tags. I guess it's query and the package name. But before we are running in circles, let's simply look this up. So let's see. Okay, so the keywords are Android, app, and visibility. And we can see package visibility in Android 11. Let's see. Okay, changes. Let's see. Packages visible in Android. Okay, here we've got the generic information. Some packages are still visible automatically, might be system applications, not sure. And yes, I guess this is the path we are looking for. So we have to define those queries. Let's see. Yes, okay. Within the Android manifest XML, we have to define this query. Okay, so here we have it. Okay, yes, it's queries. So these are things I cannot remember, but I know that they exist and we can simply look this up. It's not a big deal. And then I guess the other attribute was a package. I even did forgot it. Let's simply take this whole. Okay, so here we have to define the package where we want to be visible for. So therefore it is the Thief application. And we can fetch the information from the package name out of the Android manifest of the Thief application. All right, and this is all right now. Yes, so this should work. Back to the main activity. Let's see if we can make a reconnection with ADB. Okay, so let's see. Let's open a new terminal and then let's restart the ADB server. Okay. So it's being restarted. And now, let's see. Okay, now we can select it over here and then we should have it back. Yes, looks good. Okay, now let's install this application. Over here, we are now printing the query object, so we should get an address, but yeah, we will see that it works if this one is not returning null anymore. So let's install this application. And let's search for system out. Yes, perfect. Cursor, and then we've got this cursor object over here. So here's the address of this cursor object. Nice. So we have now queried the passwords table of the Thief application. All right, let's print out the text because otherwise it would be super lame. Do you still remember how we can do this? How to get out a string out of this cursor object? Of course you do. DB, database utils. Yes, I guess you were right on this one. Okay, database utils and then dump cursor to string. I see it already here. Nice. All right, and let's see if this works. Run. So application is being reinstalled and over here. Perfect, nice. Here we have now all these data. We can see this is our cursor and here we've got the ID, service, username. Password is unprintable. We will deal later with the blob data and the email. All right. So these are the data out of the content provider from the Thief application, from the passwords table. Nice. But let's do a little bit of modification because we do not have access to the logcat later on. So therefore, let's print them directly out in our application. So therefore, we just have to make a little bit of an adjustment to the layout. I mean, this is not required right now, but it looks super fancy and therefore we do this. Alrighty, let's see. Within the resource directory, we've got this layout, activity main layout. And here we've got a text view already in there. We are using this text view to print out this data. I mean, this looks absolutely zero hexolite, and therefore this would be a nice proof of concept or demonstration for the customer. So how can we do this? Well, we go into the code menu and we have to provide an ID to this one so that we can address it later on in our code. ID and then ID text view. Yes, okay. So now we've got an ID for this text view and we can address this text view based on this ID. All right? Okay. Let's also change the background of this application. Android background. And let's make this black. And let's make this text over here. It's not hello world, it is hacking in progress. So that's the text that's normally displayed, but it will be pretty fast overwritten with our data we are fetching from those tables. But nevertheless, let's keep this as some kind of placeholder. And then Android color. And let's take this color. This looks cool. And then also Android text size. 28 dp. This should be good. And I guess we're good to go. Yes, good to go. Maybe let's add some padding, last but not least. Padding left. Let's say 100. Okay, now we are done. Yes, okay. So now let's take this part. So here we are having a text view. We name this text view and we have to assign this text view within our onCreate method. So within our onCreate method, we are fetching the ID from this text view and we assign this to this object. So text view, we are typecasting it and then we are using find view by ID and now we are using our ID we have provided before. Exactly like this. And then instead of a system out, we are using text view set text. Yes. Okay, one last little change. Within the manifest, let's get rid of the action bar on top because this is super annoying. And we can do this in here. Within the theme, we simply delete this part and then we are using theme design no action bar. Okay, let's install this application and let's see how it looks like. I guess pretty amazing. So those data should be now filled in the text view we have inserted in our layout or which has been already inserted over there. So our hello world, okay. Yes, we have to do a little bit of an adjustment. The text size is a little bit too large. So let's go down to 20 maybe. And also the padding is a little bit, it's way too high. Close, I would say close. Is it really just something like 14? This sounds so little, but I guess 14 is good. So let's see. Yes, okay, I guess we stick to this one right now. So nevertheless, I mean, it's amazing to see those data from another application on our screen right now. I mean, as an attacker, of course, we do not have to display them on a screen. We could also send them to an HTTP server via HTTPS, of course. So also the attacker should take care about an encrypted connection. And then, yes, we can simply fetch them. So therefore, no physical access for the smartphone would be required. But I guess this is good enough for proof of concept right now. All right, so now let's get back to our attack vector. Yes, let's simply comment this in here. This is query the passwords table. Verified, it is working. Okay, so let's take this part. And now let's adjust our things. So now what we want to do is the following. we start with the simple bypass, the user's permission bypass. So our application, the Thief application, normally requires those two permissions, but we have seen if we add this one at the end of our URI, then we can simply bypass this permission. So let's do this. And let's fetch this URI. Okay, and let's also describe this over here. All right. I mean, we do not have to change anything beside the URI. This is all. And this should work right now out of the box. Amazing, right? Let's see. We simply run this. And now instead of those password entries, there should be those clear text password and also the PIN. Let's see. Amazing, it works. We've got the password and the PIN. I mean, isn't this crazy? We are opening our own application and it shows the password of another application, of a password safe application. Absolutely right. Okay, but to be honest, I mean, this here was a little bit too easy, right? So simply appending this or also this. Yeah, okay, but it works. It works. Okay, this is our first attempt. Yes, of course, afterwards I will share the whole application code for this one. So let's get to our second attempt. And this one is now, what do we want to choose? SQL injection or what's missing? The user's permission. So therefore we have to go for the SQL injection. Okay, so SQL injection. We need to query the passwords table to insert our own SQL statement. The SQL statement will be inserted in the projection. So SQL statement will be inserted via the projection parameter. And we have to figure out what the projection parameter is, but I guess that's not a big deal. So the projection or the SQL syntax is something like select all from passwords, where, and then a bunch of other stuff. And we want to change this to select all from key. Remember, now we are addressing the table name, not the URI scheme. I do not have it anymore. This is the URI scheme. And this one is being referenced via keys, but the table name is simply just key. So therefore in the SQL statement, we directly have to address the key table, not the scheme. Okay? Okay. So we want to have something like select all from key, and then we comment out the rest, which means everything here, which is something like passwords, where, will be simply just ignored. Okay. This means our projection needs to be this path over here. So this path. Okay, and I guess that's all. So this is our attempt, and let's do this. Okay, before we perform our SQL injection, let's see if we can, access data via the projection parameter. So let's simply add a projection parameter, something like this. Because then we are having select all from passwords, and we should get back data. And if this works, then we can play around with this one. All right? Okay, so therefore we want to access the passwords table. And now let's see. What type is this projection parameter? It's a string array. Okay, so therefore we have to define a new string array. We also name this projection new string array, and we can define a new string array in this way. All right, and this is all. Yes, this should work. So if we start this right now, we should get back the same data like we have seen before with the passwords table, because now we are doing nothing different, but we are using our projection parameter in here. Let's see. Yes, okay, works, perfect. So now all we need to do is we need to insert our SQL statement here, which is all from key, and that's all. And this is our SQL injection. So let's see. Oops, let's run this. It would be also interesting if we are inserting in single quote if we get back the error message, but I guess not. Yes, nice. So we can see this is working. Now we're having our SQL injection via the passwords table into the key table based on a content provider. I mean, wow, it's pretty amazing already. And last but not least, yes, we are now accessing the keys table. Our third attempt is accessing the keys table, and we are using those two permissions. So we are now asking the user to give us these permissions. And if the user grants us these permissions, then we can simply access those data over here. So yeah, let's simply do this, right? Okay, so therefore we are copying those two. Or maybe let's define our plan first. So this is the second attempt. Works. My comments are getting less, even farther we go. Whoops, no, okay. And this is now our third attempt, and granting the custom permissions of the Thief application. The things we have to consider are the following. We have to define them in the manifest. Let me think. Yes, I guess we also have to, we have to do the asking. So we need to ask for them during runtime. So this has been included in Android version 6, and it's still common. So there will be this pop-up the first time we are using those permissions. And yeah, if we are not asking, then those permissions won't be granted and we cannot access the content provider. So we definitely have to ask for them. But I guess that's all. Yes, this is all. Okay. So let's do this. Within the manifest, yes, we have to change this. This is the definition of a custom permission. And if you want to use this, we have to use uses permission. Also here. Yes. Okay, regarding to this one, I guess we are having trouble because this is Android specific. Label and description needs to be defined in the strings. So we need to create strings for those. I mean, we could use them, or we could also simply delete this. Then I guess there's something like unrecognized. Okay, I will show you both real quick. So in case if you want to define a label, we have to go into strings, which is within values. Oops. Strings, and then we have to define a new one. String, and then name. And then let's see, let's call this permission description. And then we can insert the text here. Yes. And then we can address this in this way. So our label is now, let's see, I already forgot it. Perm description. There we have it. Okay. So yes, here we have deleted it. Here we have created this label. So let's use this label, but I'm not sure if this works anyway in this way. Okay, so now we have the permission included in our application. But if we install this app, it won't be automatically granted. Therefore, we have to ask the user to enable this. And we can do this in the following way. So first, let's get the code. Okay, so yes, we can do it in this way. And we want to query key this way. So this is being protected. Let's see, maybe let's see if this doesn't work, because this should be the case. Yes, the application seems to crash. Let's see. Where do we have it? I guess here. Yes, here we can see our application is the UID 10,124, and it requires to have those permissions. We have set them in the Android manifest, yes, but if you take a look at the application itself, whoops, settings. and we can see 2 has been denied. So these are our 2 permissions, allow editing of the key stuff over here. So those has been denied. Therefore, we have to ask the user to grant us those permissions. And we can do this in the following way. So we need to do this. Oh, let's close this. We need to do this over here before we are starting our content provider interaction. And this can be done in the following way. Oh, let's see if I can remember this. Add combat activity and then, okay, so maybe it is yes, it's activity combat this way. And then a request permission. And here we have now those 3 options. Okay, the first one is our activity. That's easy because this is the this object. This is the main activity. And then we are having the string of our permission. Okay, so this is this one over here. Let's simply just take read keys. All right, and then last but not least, there's this request code. I do not remember this anymore, so let's see. Okay, so here we are in the activity combat class. Let's see. Permission, request permission, this method. Okay, we've got an activity permission, and here we've got int range from 0 request code. Okay, let's see. Request code. Here we have it. Application specific request code to match with the result reported to. Ah, yes, now I remember. Okay, so if we are asking multiple times, then we can keep track on if this permission has been already granted or not. So we can take whatever value we like. It has to be greater or equal 0. Okay, perfect. So let's get back over here. Let's simply take it's over 9,000. So 9,001. Yes, the permission is, it's a string array. Okay, so let's define a new. I guess we have it already here. So permission, and now let's define new string array, and then we can use this here. Okay, so this should work. I hope so. Let's see. Run. Okay, if the application starts, there should be this pop-up right now because we are directly accessing. Yes, okay. Yes, allow Thief Backup to perform an unknown action. I mean, of course, what could go wrong, right? So let's say allow. And there we have it. Nice. So we can see this one is now the valid entry, even if the path, which has been circumvented in our first attempt, has been set correctly with a regular expression, then we can still use it in this way if we are asking nicely the user to give us those permissions. Okay, I guess it's better if we make a copy of this one because this works and we do not know if our second attempt will work right now, and then we've gotten fallback. Okay. So this is our syntax regarding to querying the passwords table. Okay, so now we've got this problem with this blob value. So let's run this maybe once again. Yes, so here we can perfectly see everything that's in string can be easily printed out within our database utils dump cursor method, but this password is consisting of binary data. And binary data cannot be printed out in this way, and therefore we just have this placeholder unprintable. And for example, if we open a new terminal and we want to print out and carriage return new line this way. If we print this out, then we can see, okay, here are data in there, but we do not know how many and which data. I mean, yes, there might be some new lines and it might be 2 new lines. By the way, if we're using echo without a parameter, it's automatically appending a new line. So if we're using echo with -n, then we can see there's only 1 new line. Okay, so now we know there's a new line character, but how many carriage return do we have? I mean, 1, it could be also 3, could be 4, we do not know. So therefore we cannot print binary data out in this way. What we need to do is we need to encode them, but more to this later. But first, let's see how we can get those binary data. So what we want to do is we want to fetch our rows So here we can see this row ID 0, which means the more entries we've got, the more rows we have. So this is 0, then we might also have 1, 2, 3. It depends on the amount of entries. And we want to go through every entry, and then we want to get all those password blobs over there to store them separately, because then we can use certain encoding to print them out. All right? Yes, this sounds absolutely complex, and to be honest, this is really heavy Android lifting right now. You do not need to know anything of this. So what we're going to do right now is we are writing this code that you have in reference for this. In case if you need some proof of concept from customer, then you can simply rewatch this video. Otherwise, you can simply just lean back and relax. If this part is interesting for you, perfect. In case if this is overwhelming you, don't worry. After this video, you can completely forget everything you have seen over here, at least regarding to this part right now, because this is absolutely not required to move on in this course. As already mentioned, is a bonus video, and this bonus video is to provide additional information. Not required in this course, but it's simply showing you how to deal with this stuff, which can come handy. Alrighty? Okay. So let's see. Okay, we've got one row ID, which is 0, and here we've got our columns. Underscore ID, service username, password. All right. So what we need to do right now is, this is our cursor object. And we need to first make sure that we are having a cursor object. So we can do this by checking if the cursor object is not equals null. We have seen if we are not allowed to query this passwords table, then we are getting back null. And the application would fail if we try to move on at this point. So therefore we check if we're having a cursor object, so if our app is visible for the Thief application. And then we're also checking if we're having entries in our database. And we can do this with query cursor, count, get count, yes, of course, get count. And then we check if it's greater than 0. Okay, so checking if we are having entries in our passwords table. Okay, now we need to make sure when we are reaching the passwords column. So this can be done in the following way. Let's assign an index variable maybe. Index, okay. And our index is now, let's see, our cursor. And then, yes, get column index or throw. And now we say, okay, we want to have the column index of our password column, because having the index field, which is, let's see, it should be, this one is 0, 1, 2, 3. So it is index 3, but it's the 4th entry because we start counting at 0. So now we have this index field. And this can be used to fetch the data. So we can address this column based on the index, and we can get out the data based on the index. All right. So now we've got this index, and now let's make sure if our index or that the index is greater equals 0, because otherwise we won't have this passwords table, this passwords column. And if this is the case, then we want to get out the data, the blob data. So query cursor, get blob, and here we can see we have now to provide the index, okay. And let's create a new array where we can store those data. So it's a byte array, password blob. Let's also initialize this with 0. Okay. And now, yes, I guess we can try printing it out. I mean, of course, this won't work. Yes, I guess we are getting an address or something like this in there, but we can already see if we are printing this out and how often we are printing this out. Maybe there's a logical error in there, so let's see. Let's rerun this application. Does it crash? I hope not. Okay, it's crashing. Let's see. Okay, the index is out of range. We are not having a typo in there. We are checking it and we are having this. Okay, maybe one thing we need to make sure is that we are at the beginning of our cursor. Is this the problem? Might be. So our cursor has a lot of entries and it depends on the position of the cursor. If we are using query, not sure if it gets to the end. So therefore we need to set the cursor back to the beginning. Yes, cursor stuff is absolutely complicated and this took me a month to understand. It's required in accessing contacts and SMS, for example. So those shady things. Therefore it's maybe good to know, but yeah, it's also a little bit, it's a pain. Okay, so how can we do this? We are using if and then we are using query cursor. Move to first. This is returning back a Boolean value, but it's also setting the cursor to the beginning. I find this absolutely confusing because we are doing 2 steps and it's not that clear over here. Good rhyme. Okay, so let's take this. I hope this was the mistake. Let's see. Observing everything here. Smartphone locket. Yes, perfect. So yeah, absolutely ridiculous. If you're querying this cursor might be set to the end, and therefore we are trying to access an index which is not available anymore. But now we can see we've got the system out, and here we have now our byte array. Nice, isn't it? Yes, it's just an address, so we cannot do anything with this one. We need to get back the values out of this one. Okay, how can we do this? Well, we've got a nice method for this, and the method is base64. So base64 is an encoding, and this can be used to print out non-printable ASCII characters. As already mentioned, base64 will be heavily used during this course because this is it's a common encoding, and yeah, it's nice to identify, and you can do a bunch of stuff with base64. In case if you're not familiar with base64, then please watch the bonus video regarding to it, because yeah, otherwise this video will be way too long right now. Okay, so let's see. If you want to print out those byte array, we can use base64. Here we already have it. Dot encode to string. Yes, this is exactly the method. So this is taking a byte array as input. Perfect. This is our password blob, and then we're having this flags. But this flags is simply just base64 has some, can be used in different type of encodings. So for example, special characters like underscore are not normally used in the RFC. There's a certain char set, and we simply just tell with the flags, we do not do any fancy. We are using the common char set, and we are not providing any additional characters to our encoding. So treat it as normal base64 encoding. And the flag for this one, for this standard value, is 0. Okay, so we are using base64 decode. Now I'm a little bit confused. Oh, sorry, encode to string. We want to encode it. And then password blob and 0. 0 is our flags, which is simply just common base64 encoding. All right. So now let's run this and let's see. This should work already. I'm a little bit excited. Nice. Here we have it right now. So our password, which is unprintable, is now being printed out over here. Amazing, right? So we can use this right now to get back those byte values. So if we are echoing this out, this time with dash, whoops. Okay, I'm not sure where this one has been catched. So if you're echoing this with not appending a new line, because we want to print it out exactly as it is. We do not want to append our own characters to this string right now. And then we can use base64 dash d. This is now the output, and we can see why our smartphone is saying unprintable. I mean, what is this? This question mark over here. This one. This one might be new line character. So what's this? We cannot deal with this one. But base64 can, okay. And now we've got the raw bytes. And to print out or get back the raw bytes in a hexa value, we can use XXD. XXD-P will take those bytes and will give us a hex representation of those bytes. So if we pipe this through XXD-P, then we have finally those raw bytes in there in a nice hexa representation. Amazing, right? Absolutely. So let's append this password also to our output over here. So not only there. Let's see. Okay, let's comment it out over here. And then let's append it to our text. So let's create a new string. Output. And this one is right now. Let's keep it here. So this is the first part. Oops. So this one is the first part. Okay. And then we are appending our base 64. Output, we are appending a new line character, and then password encoded equals, and we append this part. Okay, and then we are simply printing out this. We still got this cursor. All right. So now, at the end, there should be this password encoded and this base64 encoded string in there. So let's see. Okay, I mean, we could also directly print out the hex representation, but I guess this is enough Android app development right now. If you're having the ASCII values over there, yes, we have it. Perfect. So now we also got this password, which was before unprintable. So by having those, this base64 encoded string, we can simply use this and run it through XXD like we have done it over here. Alrighty. Okay, so this is the end for this video right now, and once again, it escalated pretty quickly. So therefore, let's summarize this real quick. Okay, so afterwards, I will provide you the source code of this application that you have everything. So we did start with simply querying the passwords table with a content provider. All right, then we have done some crazy Android app development. And over here, those were our attack vectors, the initial idea of this video. So how to interact with a content provider and to exploit a content provider. The first attempt was, I'm not sure anymore. Yes, it was bypassing the user's permission. Okay. Then we had our SQL injection to access the protected table via the unprotected ones. And last but not least, we added those users' permission into our own application and nicely asked the user to provide us those permissions. In case if the user clicked on this, all the passwords would be gone. So this would be the absolute worst case for the user. And the user just has to click it once. So we can use this as a pop-up over and over again. All right, so this is all for this video right now. All right, so this video once again has become a little bit longer than expected. Sorry for this, but I guess the things we have learned over here, they are really necessary or they are essential to deal with those stuff. Also newer applications. Otherwise, you have to figure this out by yourself, how to deal with app visibility, print out blob data in a content provider and things like this. Therefore, I would like to include all the things in this video to show you everything that I know that you do not have to search it anymore. Alrighty? Okay. In the next one, we will take a look at the path traversal vulnerability, and then I guess we are done afterwards with content providers. In case if you have any questions, leave a comment under the video. Otherwise, I'm looking forward to see you in the next one. See you there. Alright guys, welcome back. One thing we haven't talked about so far is a path traversal attack within a content provider. And then we are done with our content providers. So we have seen an SQL injection, and now the part which is missing is a path traversal attack. So this video we will find out how to exploit this, and most importantly, how to identify this type of attack in a mobile application. Are you that excited like I am right now? Then let's go. Alright, here we are back at Ubuntu VM, and I have prepared a really nice application where we can train this path traversal vulnerability. So as always, you can find this as an attachment of this section, and I have included the whole source code. So therefore, let's simply download it, import it into the Android Studio and have a look into this one. Alrighty? So I have already downloaded it, therefore I only need to start this. So I start the Android Studio, running the bash studio sh script. Here we go. All right, here we've got the welcome screen. And let's see, to import this project, all we need to do is simply clicking on import project. And then we are selecting this amazing music player, APK. So let's do this. Okay, let's finish. Oh, it's already finished. Nice. No tip of the day. Okay. So the first thing I like to do when analyzing a mobile application is having a look in the manifest, because there we get a good overview what's going on. So let's do this. Android manifest, and here we have it. So we can see we are using a permission, read external storage. All right, this is something we have to look for. Then we've got our application tag, nothing too fancy in here. And then we've got a provider. So here we've got the content provider, and this one is being defined in this class. All right. Here we've got the authority name, enable true, exported true. All right. So this content provider has been exported true. So this content provider is available to the outside world, which means we can interact with this one based on another application or within the ADB shell. All right. We do not know right now if we are interacting with a database or with some files. We will find this out by analyzing the code inside this Java class. But for now, let's keep it this way. So we know we've got a content provider and it's being exported. Okay. Then we've got an activity, our main activity, our well-known intent filter. So this is our entry point. It's listening for our click on the icon to get started. And then we end up there. All right. So far, so good. Before we analyze this code further, I would suggest let's have a look into this application, because I've got a feeling that this one, it's a really amazing one. So let's see. Here we've got our emulator. I have already started it. And to install this application, all we need to do is hitting this fancy run app button over there. Let's do this. And let's keep this over here. Okay. The Gradle build is now running in the background. Afterwards, the application will be built and transferred to the smartphone via ADB and automatically being started. So all of this happens magically in the background. And there we go. Does this look absolutely amazing? Yes. No, it doesn't? Okay, but let's see if the functionality is given, because I mean, that's the most important point, right? So let's turn up the volume. Oh, already max volume. So let's see. We've got a music player and we've got a play and stop button. So let's see. Cannot hear anything. Now. Yes. This is absolutely chilling, relaxing music. Ideal for attacking applications based on a path traversal vulnerability. Absolutely amazing. So I really want to thank the author or the musician, I would say, for this track, because it's being provided under a license which can be used in courses like this. So here are the credits for the author. Really thank you. All right, back to this one. So we've got a really nice music player, and I've got also a little feature in there. But first, let's see if the stop functionality works. Yes, music is stopped. Okay. So now we've got some kind of mixing application, because if we hit the play button, then this relaxing music starts once again. And now we can play it multiple times. For example, I need to hit the timing. Okay, completely missed it. Doesn't matter. Let's keep doing it. Okay, sounds absolutely horrible. And the stop doesn't work. Amazing. So let's close this real quick. Alright, so I have prepared it, of course, in this way that we can do this to make it a little bit more interesting. So now you've got a music application, and if you become once a great DJ, then please give me some credits back on this video over here. Alrighty? Perfect. Okay. So for now we know what this application is doing, at least, the main purpose. But let's figure out what's exactly doing. Okay. And therefore, I would suggest let's go into the main activity, because this is our entry point. So main activity, and let's see. So we've got in context, media player. I mean, we haven't talked about this one, but we can guess what this one is doing. Our onCreate method, text view, context, nothing too fancy. Oh, what's this? Create secret file. This sounds interesting. Let's see. Here we've got start and stop music. Okay, this might be those functions connected to the button. And yes, you can see this is not a programming mistake. I did this on purpose. All right. Okay. I mean, okay, the stop function, this is something I have messed up, but yeah, that's okay. So back to this one, we've gotten create secret file. So what is this doing? We've got two strings. This might be the file name and this the content, okay. Then we've got a file output stream. I mean, we do not know what this one is doing, but hey, okay, we've got an open file output. So, whoops, let's get this out of the way. So maybe we are opening this file, my secret file name over here, in the context private mode. And then it seems like we are writing this content to this file. So we are simply creating a file. And the amazing thing right now is this file is being stored in the protected data directory of this application. So this is within the sandbox, like the shared preferences, for example, which means a normal user cannot access it, right? Let's verify this. So let's make our ADB shell connection. And then let's see, we have to get root privileges. We will test it afterwards without. So then we have to go into data, then the package name. What's the package name? Let's see. Let's keep this in foreground. This is the package name. Okay. And then we've got directories, cache, code, and files. So let's go into files. And here we have my secret file. Yes, let's check the permissions of this file. Okay, this user or higher privileged users are able to access this file. All right, let's print it out. Is there something in there? Yes, this is my super secret text that no one should read. All right, I mean, this text has been included in the Java source code, so at least after talking about reverse engineering an application, we would be able to read this. But let's say it stores some user credentials. So there might be some initial credentials, okay, but afterwards the user provides a new password and the password gets updated in this file. Then we are not able to fetch this information based on the source code. All right? Okay, so now we need to make sure that really only this user or higher privileged one can access this. Therefore, we leave the root context and we're printing it out, printing it out once again. Let's see. Permission denied. Perfect. So this is exactly like it should work. We've got a file, context mode private. It's being stored in the internal sandbox app directory and no one else. Okay, this application and higher privilege can read this, but no third-party apps right now. Okay. All right. So this is the whole functionality of this main activity. It's creating a file and it has two buttons. So the interesting part right now is there's absolutely no other interaction. So we do not access our content provider in there, which raises the question, do we still have a vulnerability? I mean, we are not using this code. But before we talk about this, let's first have a look into this content provider. So here we've got the music file provider class. And this one is extending this content provider. And here we have now the methods. Most of them are not being implemented. So there are those to-dos, please implement this stuff. We've gotten delete, get type, insert, on create, query, and some other stuff. Yes, update. This looks like our database interaction, but it seems like we're not having a database interaction. But what we have is this parcel file descriptor, whatever this means, open file. So this one is also an overridden method, which means this one has been defined in this content provider. So now we are not dealing with a database anymore, we are dealing with file access. Content provider means providing content. Beside databases, we can also provide access to a file. Amazing, right? Absolutely. And here we can see we've got this open file. This one is now taking two arguments, an URI and a mode. The URI seems to be the file path because we can see we're creating a new file object based on this URI. And then let's see, is this being used? Over here. This one is being used here and we are opening this file right now and we can see this mode. I mean, it might be read, write, append. Not sure if append exists, but this mode is simply what type of access we want to have to this file, read or write. In this case, whatever we provide in this open file method, which is, by the way, exported to the outside world, so we can interact with this one. We can provide those two parameters. But this parameter, at least this mode parameter, is not being used. Even if we say we want to write to this file, it's not working because we've got it hard-coded over here in read-only. Okay. But let's do it not that quick right now. So here we are opening this file, okay, and it's being read-only, and then we are returning back this partial file descriptor. So this one is simply just a descriptor to this file. So it's some kind of, let's call it access to this file. I do not want to go too deep into the Linux system right now because it's not relevant. So we've got file descriptor and sockets, but at the end, I mean, what this means is we are getting access to a file. So we can interact with a file, and this file we can interact with is being opened over here, and it's being referenced via this URI. Okay? So we provide a file we want to open to this content provider, and this content provider is opening this file and providing us access to it. Okay. A use case could be, for example, sending a music file to this type of application. The content provider is opening it, and within the return function over here, it could also now put this into a music stream and start playing it, for example. But to make this as simple as possible, I have included only the necessary parts, so the bare minimum to make this content provider working and vulnerable to our type of attack. I mean, if we find now this use case, an exported content provider with this partial file descriptor open file URI, and this URI is directly passed into a file which is being opened over here, then we've got our vulnerability. You do not see right now which one? No problem. We will discuss this extensively right now. All right? Okay, so therefore, let's get on the graphic tablet and let's see. I make a little bit of space, and now let's directly write this over here. Okay, so let's see. We've got our application. This one. This is our music player. Let's make this green. And this one is now exporting this music file provider, which is a content provider, and this one is exported, which means this method is available from the outside world. Okay, so we can interact with this method. This method is now taking two parameters, an URI and mode. So the first question is, what is this URI? The URI is simply just a reference to a file, and it looks like the following. So if you want to reference a file, we can do this in the following way. Content, this is our scheme. Then we've got the authority name. I just named this AN right now. And then we've got the file name. So in case if you want to open, for example, something on the SD card, I guess it looks like the following. Content / our authority name, and then SD card music.mp3. To access this file, it's based on the SD card. I mean, we have to use this read external storage permission, but this app has this permission, so this would be fine. All right? Okay. So now's the question, how can we exploit this? Well, if we're now having this application, our third-party application, our malicious attacking app, then we can now provide a file which this application is going to be open, in this one over here. And instead of using the MP3 file from the SD card, we can provide, let's say whatever we like. But of course, this app needs to have the permission to open this. Okay? So what if we are not providing the SD card MP3 file? What if we are providing something like content / then our authority name, and then access to this my secret file. My secret file. Then this application is taking this URI, it's assigning this to a new file, it's opening this file, and it's providing back an access to this file within this partial file descriptor. So we send this to this application, and this application is now turning back this file descriptor, this partial file descriptor. Let's say it's simply access to this file. And now there's this clue, because the my secret file, this one over here, it's an underscore, nothing else. So okay, let's clean this. There we go. So now we've got an underscore. This my secret file is being stored in the data directory of this application. So this one, let's take another color. Oh, that's not visible. Let's take this one. So this one has in storage in our smartphone, data, and then the package name. And then we've got files. And then we've got my secret file. So this one is being stored in the protected data directory of this package. Which means if our application tries to access this file, we have seen this in the ADB shell with cut, access is being blocked because this user ID has not access to access this file, has no permission to access this file. All right. But now, if we ask this application, so we are asking, let's draw this once again to make this more dramatic. We are asking this application over here to open this file via this method. Then what's happening is this application has access to this file because it's being stored in this internal directory, and this user ID, of course, has access to open this file. And now this application is opening this file and providing back access to this for our application. So this one here will be now provided back an access based on this parcel file descriptor. All right. Okay. If not, don't worry. We will discuss this now once again regarding to the type of attack, and then we will do some practical exercises regarding to this one. All right. Okay, so here we've got this application and here we've got our application. So now we know we can interact with this content provider and we want to send a file access request. And for example, this open file here. All right, so we can define the URI. And now to exploit this path traversion vulnerability, we have to do it in the following way. I mean, we've got multiple options, but I show you one option right now that works all the time. And therefore you only need to remember this one and not the other parts, all right? Okay, so the problem right now is if you want to open this file, this my secret file, so we would have to provide the following path, content, / then our authority name, and then files, and then my secret file. We do not know the context of our file access. So this URI here, might prepend some additional stuff. For example, it could say instead of accessing or passing this URI directly to our application, it could append another directory first. In our application, we've got 3 directories so far. We've got cache, we've got something else I do not remember anymore, and we've got this files directory. Okay. Now let's say this application code has been designed that this one is the base directory. And if we now append this part, the application tries to access this files directory in this cache directory. And within there, this my secret file, which is of course not available. Because this my secret file is being stored over here. So we are now opening or trying to open a file in the cache directory, but this file doesn't exist because we are within the cache context over here. Yeah, let's call it context. So the application starts opening a file under this directory. So on the first view, it seems like we cannot access any other files beside those files in this cache directory, right? No, of course not. Because what we are doing right now is a path traversal attack, which means instead of providing files my secret file, what we can do if we are in this cache directory context, we could simply append in between those two. Oh, it's getting a little bit messy, but I guess it's okay. // Okay, it's too messy. Let's rewrite this. What this // is doing, if we are now in this cache context over here, we are getting back one directory. So we are going back one directory, which means we are now in the root directory of this application. Okay? And now we are entering the files directory. And this is now available because the files is over here. And now we have left this cache context. We are now in the files and we can open this my secret file over here. So this would work just by providing a ... Now we do not know in which context we are, and to provide you a solution that works all the time, what we can do is providing many ... attempts, which means we want to go back to a state where we know how the structure looks like. And the state, how far we want to go back, is the root directory. So if we are in the root directory of the smartphone, then we know we've got a data directory. This one has another data directory. This one has now this package directory. So the package name. And this one right now has this files directory. And in there we've got this my secret file. So if we go back, or if we have the ability to go back to the root directory, then we can always apply this scheme, because this never changes based on the root directory. All right? Okay. So how many ... do we need to go back to the root directory? The answer is we do not know this, because we could be in this directory, or we could be in a subdirectory, or even further. But that's not a problem, because once we have reached the root directory, we cannot go further back behind this root directory, because that's the starting point. So we cannot go further back, which means we can apply as many ... as we want. We just need to have enough to get out of every single subdirectory where we might be in right now to go back to the root index, and then we can follow along our path over here, this one. So this is how a path traversal attack can be easily exploited without having to worry about where we are right now, what's the structure, do I have to go one directory back or forward, and things like this. Alrighty? Okay, so therefore I would suggest let's simply do this. Let's try this out. So our attacking vector, let's clean this up a little bit. Okay, so our attacking vector would be something like this. Content / then the authority name, and then ... and so on. Another one, just one for good luck, this one, and last one. Okay, this is really the last one. And then we append our files, and then this my secret file. All right, this is the content we are providing from our application to this application, and nicely asking, hey, please open your secret file for us and provide us access to this. You might ask right now, why is someone developing something like this? But there are tons of really good use cases to do this. I mean, not in this way, of course. The mitigation would be simply filtering this part over here, this URI. But if this is not being filtered and we can directly provide our parameter into this one, then we can access those private files. And this happens quite often still nowadays. There were a couple of really, really insecure path traversals that lead to huge security risks of those applications. I mean, imagine how many sensitive data are being stored in the shared preferences or databases or things like this. We can access all of them if we are having this type of vulnerability. Amazing, right? So therefore, let's do this. How can we send this file right now? And once again, we do this in the ADB shell, and then we write our own custom application to perform this task. You ready for this? Then let's go. Okay, so first let's clean this up. All right, and let's also get this a little bit further, that we've got access to those things. Okay, and I would suggest let's open this application in the background. I mean, is it required to be open? I'm not sure. I guess not. We can try this out later on. But I really like this chill out music, and yeah, I guess we can play it because it's license free. So therefore, let's play this music in the background. All right, so now we've got some relaxing music to exploit this right now. Okay, a little bit volume down. Okay, cool. So if we want to interact with this content provider, we need our ADB shell first. And then what we need to use is content. And if you remember, okay, I'm not sure if you can still hear it, but for me it's fine right now. Okay, maybe one volume up. There we go. This should be absolutely perfect. So Yes, here we've got our content provider help, and we have talked about this, that we have split it into two paths. I guess we did split it over here, but this one might be, I'm not sure. This one might be, yeah, I guess we should split it up this way. This is file related, and this one here is database related, this help path. Okay. So this means we can focus on this one. And I mean, we've got ADB shell content read URI. Well, is it that easy? Let's find out. We've got read URI, write URI, and get type. I guess this is regarding to meta types. Not sure about this one, but yes. So I would suggest, let's see. Let's clean this up. Okay, if we now want to open a file, so I mean, what we have to do is content, read, and providing the URI. All right, what is the URI? Well, it starts with content, so that the content provider knows, okay, this is regarding to the content provider, or this application knows this is regarding to the exported content provider. And to say that it is for exactly this one, we have to provide the authority name, this one. Okay, and then we have to provide the file we want to open. So we have seen our MySecret file was under files, MySecret file. I guess this will work because we start maybe at the application directory. So let's see. No. Okay, it doesn't work, which is good, which means we are not sure in which context we are right now. So therefore, we didn't hit this file, but we know the file structure behind this. So let's go back to the root directory and then follow along our path. All right. So to do this, yes, let's first make sure that we are hitting the root directory. So we are applying lots of dot slashes. It doesn't matter the amount, it just needs to be enough to get back to the root directory. So it could be 3 or it could be 15. We have to try this out. But we cannot make too much right now. So therefore, let's add some additional ones. Okay. So now let's open another shell and let's verify this. So we are getting root privileges. Now we are hitting the root directory and then we're following along this path. So data, and now this package name, com app hacking music player. Then we've got files. And here we've got MySecret file. So this one is the path from the root directory. Okay, and then we just need to open this MySecret file. All right, let's see if this works. I hit this in 3, 2, 1. Yes, this is my super secret text that no one should read. Is there a typo? No, okay, perfect. I mean, this is how we can access arbitrary files in this application. Amazing, right? So yeah, I mean, this is how to exploit an path traversal vulnerability. The things we have to look for is, let's see, let's play it once again. Because it worked absolutely smooth based on this one. So the things we have to look for is a provider, which is exported to true, and which has this method be defined, this parcel file descriptor open file, and this URI is not being filtered. If this is the case, exported content provider, open file, unfiltered URI, then we've got a path traversal vulnerability. Amazing, right? So let's see how we can exploit this from our own application. Because I mean, having this in an ADB shell, it's well enough to show this application is vulnerable to this type of attack, and you do not need further proof. But in case if you have customers, then it would be absolutely amazing showing secrets, passwords, databases in your application, right? Absolutely. I mean, we also do not have to get physical access because we can do this remotely with HTTPS requests and things like this. But I guess a demonstration app where it opens those files in our own application, this should be well enough. All right, let's do this. I'm super excited about this. Oh, okay, still super excited because the code is not really much. So this just takes a few minutes. For me, maybe many minutes, but I do not want to extend this unnecessarily long. Okay, so let's create let's create a new project. Okay, we choose empty activity. And then we name this, how do we name this? Path traversal POC. Yes, I choose language Java minimum SDK, this one. I click finish. Turn down the volume a little bit. It's way getting too excited right now. All right, the build process has been finished. Here we've got our onCreate method. So how can we now perform the same task? This one, not this one, this one, this one. So no, this one also not. I hope I've got it still somewhere opened. Okay, then let's do this real quick. So ADB shell, content read, URI content, and I've got it maybe in the clipboard. Yes, looks good. There's 1/ too much. All right. Yes, okay, this is working, perfect. So this is the file, or this is the content request, this URI request we want to send to this application. Okay, so how can we do this? Well, once again, we have to define our, our content resolver. And we can do this with the get content resolver. And then we've got an open input stream. Yes, so this one is asking for an URI. Okay, therefore let's define this URI, and we have already seen this, how we can do this. So URI, new URI object, and then URI.pass and this. Yes, okay. What's this one returning? Let's see. Okay, it needs to be surrounded with try and catch because file access can go wrong. And what is this one returning? Can we see this? Okay, then I do it this way. Then we get an error because what's the return value? Input stream. Okay, so this one is returning an input stream. Input stream. Okay, let's name it in this way. And yes, this is already doing all the magic. So we are asking by this get content resolver open input stream, we want to have a stream to this URI, and we are passing now our path traversal attack to this application, which gives us back a stream to this file. All right? Okay. So now's the question, how can we print this out? And to be honest, wow, this is very deep in the Android programming. I tried to show this on a high level and then explain how we can print this out. All right, so just on a high level, and we do not go deep into this one. So let's get back on the graphic tablet. Okay, so to print out an input stream, let's see what's happening. So we've got our file, and this one is now returning back this part here. This is our input stream to this file. And this one is of course not simply just a string because it's some kind of stream. So we need to fetch data from this stream. Okay, what we need to do is we need to do the following. I guess I'm also not 100% sure. Let's say we are filtering this, or we are accessing this based on an input reader. So we need an input reader in front of this. Okay, then we've got here a reader which can read the stuff which is going from the input stream to us. So in this direction, this is our app here. And this one is the other application which is providing this stuff. Okay, and then in the input reader, I guess it's a buffer reader. In case it's not this, or is it read buffer? Buffer reader, read buffer, read buffer. Maybe it's this way, read buffer. Otherwise, we will look this up. And this one can now read certain parts out of the stream. For example, 1024 bytes all the time. And those bytes can then be transferred into a string. And we can append our string. And we need to keep reading from this stream until we are not getting any data anymore. So if these are our data, until this stream is not returning anything, then we know we are at the end right now. All right. Yes, this sounds absolutely complex, but I guess these are just 2 or 3 lines and a while loop. But we will find this out right now. So let's see. By the way, yes, this is not an app development course. So in case if this is now too much for you, lean back, relax, turn up the volume of the music, and then just watch me doing this. in case if you want to have a reference application, so in case if you want to show a customer, hey, this is how we can exploit this path traversal vulnerability and show the data in our own application, simply copy paste this code when it works. So if it works, then you can freely use this, of course, and you do not have to go through this, or let's say even understand it completely. But it's good if you have an basic knowledge about this, all right? Okay. So here we've got now our input stream, which means we now need our input stream reader. We need someone who understands what's going back. Input stream reader. And this one, let's see. We can, I guess, supply this part. Yes, this input stream has been defined in this try and catch block, which means if we are getting an exception over here, this variable is unknown for this part. Cannot resolve the symbol, exactly. Which means we simply create a variable over here. Then this application is aware of this and we make sure with our try and catch block that everything works fine before. Okay, now we've got the input stream reader. Now we need to read this stuff. And we need to keep reading until we are not receiving any data anymore. And this can be done within a while loop. So while, that's a good beginning. But now's the question, we need this condition when we are not receiving any data more. And I guess this is being done with buffer reader. Let's see. Oh, this is read buffer. Read buffer reader. Buffer reader, this way. Buffered reader. Sorry, now we've got it. Okay, but we need to assign this buffered reader first. And we can do this over here. So we are creating a new object, buffer reader. This new buffer reader. Whoops. So we are now reading from this input stream reader our single buffers. Okay, and now we've got this condition, buffer reader and ready. Yes. Ready sounds a little bit misleading, but this also means if it can be used as a condition if you're not receiving any data anymore. And it's also making sure that we can access further data. So our reading might be blocked during the read, but let's do not go too deep into this. So this is our condition. And we've got an error over here. Let's see. Surrounded with try and catch. Whoa, okay. I'm not sure if I like this code right now. So we've gotten while true and we exit out. Well, no. No. Let's make this different. So, whoa, okay. Let's get this try block over here. And then let's take our buffer reader as a condition. And let's see. Okay, there's this. Here we've got our try. Oh, there's this bracket missing. Yes, okay, now it's good. So, I mean, I'm not an encoder, but even this part was, no, this was nothing I would like to go for. Okay, so now we are reading our stuff with this buffer reader, and we can assign this now to our string. So we are defining a new string. This is the file input. Okay. I also do not like this way. Okay. So now we can use this file input plus equal and now buffer reader read line. Yes. Okay. So now we are reading one line out of our file and we are assigning it to our string, to our file input string. But the problem is right now, this read line ends at the new line character. And if we are reading this line, it will append everything in one line right now. So if our file has 10 lines, our string over here will have everything concatenated together right now, which is not really readable. So therefore, after this read line, we are appending a new line because then we know the line has been ended. Is this so far okay? So in case if we're having 10 lines, our string would put everything into one line. But after reading one line right now out of our 10 lines, we are appending a new line in our string, which means our string gets also split up, that we've got this nice format. Yes, and this is everything we need to do. Yes. Okay. I mean printing it out. System out print line. And then we are good to go. What's the problem? System out print. I'm out of this function maybe? Oh yes, I'm out of this function, sorry. Okay, we need to put that over here. All right. Now we're good to go. Okay, the only thing we are missing right now is if you want to use this code on modern smartphones, on Android 11 and higher, because then we have to deal with those privacy settings, which means even if this content provider is being exported, we are not able to interact with this until this application is visible for us. We as an attacker, we do not care about this because of course we want to be visible for it to fetch all the data. I mean, we do not have any problems with this. The application might, but in our application, everything is fine, all right? So therefore we go into the manifest and then queries. Let's see, not sure. Package, and then, there it is, Android name. Hui. This, I wouldn't remember this, and we could simply look this up, but having it in this way is better. So we need to have this package name, this one, and that's all. This should work right now. So our application should be able to fetch the secret file out of the other one. Let's see. So let's run this. And then we test if the application has to be in foreground, because I'm really not sure about this one. This will be interesting also for me. Okay, so our application starts in just a moment. Buckle up. There, I can already see it. I have seen it. System out. This is my super secret text that no one should be read. Amazing, right? So this is within our own application, the path traversal vulnerability. And you know what? Let's print this text out over here, okay? So let's print it out directly on the screen and let's apply our hackish scheme. I mean, this is absolutely not relevant anymore and you can, feel free to skip this right now. But I would suggest we do this real quick. It just takes a few minutes. Okay, so what we need to do is we need to go into our activity main XML layout within code. And then, I mean, we've got this hello world text view. So let's make a default text hacking in progress. Okay. Then let's make the whole background black, that it looks absolutely zero hexolete. So Android background, color black. Okay. And let's make this text kind of green. I mean, it's not even close being green, but I do not know the English term for this one. So let's make this teal. I'm not sure. Okay. And maybe adjusting the size. 14 dp, and also let's put it a little bit away from the left that it's not fitting directly at the screen. So let's apply a padding of 20 dp. I'm not sure if this is too much. Let's see. For this text it's okay, but let's see how it works. Okay. So then we need an ID for our text view to address this in our main activity. So we need to assign a new ID, add plus ID, and we name this simply text view like always. Okay. And then this is all we need to do. We have assigned an ID. We made this absolutely looking hackish. And the only thing we need to do right now is going into the main activity and assign this one. Okay. So over here we are creating a new text view. So we are having a text view in our application, and now we are assigning this text view. So this text view, I keep this typecasting even if it's not common anymore. So that's the way I am doing this. Okay. So now we need to find this ID and assign this text view, which has been defined in our layout, which is available in the onCreate method, to this text view. And this is easy. Find view by ID, r.id. and then this name. Okay, and then instead of system out, we are simply setting this text of this view. Set text, and we are done. That's all. Let's run this and let's see what amazing hackers we are. This is the wrong. Okay, there we go. Oh, this action bar. This is my super secret text that no one should read. All right, amazing, right? I mean, we can also append accessing my secret file. And then we can make it a little bit ugly, but I mean, it's okay. So let's get also rid of this action bar because this is looking awful. This can be done in the theme, in the Android manifest theme. So there we go into theme and then design our action bar. I mean, there's also in dark, I guess. Okay, but let's simply stick to this one. Let's see. Okay, our app is being loaded and there we have it. Okay, it could be a little bit more pretty, but I mean, as a demonstration, it's enough, right? So we can see within our application, we are accessing this file. And the thing I really would like to test, if this is working, if the app has not been opened. To be honest, I guess it is, because within our intent filter, we did get this error message that running in background task is not allowed, but this seems like not to be in background task. So let's see. Oh, I really need to apply some icons, otherwise it's getting a little bit annoying. This one, path traversion. So this app has been closed. Let's see. Is it still working? Finger crossed. Amazing. It is still working. So we can access this file anytime, as often as we want. Is this cool? It's absolutely nice. Alrighty, so this is all for this video. Once again, it did become a little bit long, but yes, I mean, the things we have seen over here are pretty amazing. And this is something which still works also in bug bounty programs. Because this type of attack, it's absolutely critical, and many people do not look for those type of vulnerabilities in mobile applications. So if you want to do some bug bounty program on this one, also have a look at the reversing section. There we will talk about mass decompiling applications, and then I hope you earn a lot of money. Alrighty? Okay, so next we have some practical exercise. So the Thief application has exactly this type of vulnerability in there. And this is something you can practice on your own if you like to. So the task would be try to identify the path traversal vulnerability and try to exploit this. I mean, I'm not sure. Yes, so for example, the shared preferences should be readable. I'm not sure what type of output we get if we want to try to access this database. But to be honest, I think this should also work. It might look a little bit gibberish, but yeah, the text should be there, okay? So try to exploit this in the Thief application to get back the passwords or the database. Alrighty? So good luck and have fun.